Hello guys. So in this video, we are going to discuss about the entire LangChain ecosystem. Now, along with the LangChain ecosystem, the first entire LangChain ecosystem. Hello guys. So in this video, we are going to discuss about the entire LangChain ecosystem. Now, along with the LangChain ecosystem, first of all, we really need to understand this two important question. The first question is why LangChain? Okay, why we really need to learn about this framework? Why LangChain? Okay. Along with this, the second thing that we are going to discuss about in this video is about the entire LangChain ecosystem. Right. So our entire video, we will be discussing about these two important points. And let me tell you guys, LangChain right now is the most common framework that is specifically used to build generative AI application. Okay. And in order to make you understand why LangChain, let me just go ahead and talk about a couple of years back what had happened, right? Or 1.5 years back. So I hope everybody knows about this OpenAI company, right? So OpenAI company is there, and obviously we also had Hugging Face, right? And these were the first two companies that probably came up with the concept of LLM models, large language models, right? It was not like OpenAI or Hugging Face came at first, but they were also Google were working with open source models. They were in Hugging Face, there were a lot of different open source models. But the popularity of LLM models and generative AI apps started when OpenAI came up with its own LLM model, right? Like GPT 3.5 Turbo, all those kind of models were there. Now, when we started, when these companies announced about the LLM models, many of the developers started exploring, right? And with respect to the documentation, OpenAI specifically had a different set of code. And what we do with this LLM model, if I'm providing any input, I will be able to get any output in form of any kind of response. Okay. Now, when we were using OpenAI Hugging Face, specifically if I talk about Hugging Face, right? We use different libraries. Some of the libraries that we use, one of the most common libraries that we use are transformers. And transformers, we have something called as pipeline, right? And with the help of pipeline, we are able to call any model that are available in the Hugging Face, right? Call it in our local developer generative AI application. Similarly, in the case of OpenAI, we really need an API key, and based on this, OpenAI have also created an amazing documentation where you can probably do fine tuning, you can create a generative AI application and all. And later on, when more companies came into this race, right? Let's say Meta with Llama 3, right? Google, they came up with this Google Gemini Pro. Now, when these all models were specifically coming up, different set of libraries were getting created so that we will be able to access these particular models. Now, again, so many different models are there, both paid, open source. You can also use this open source for commercial purpose. Now, what LangChain did is that, LangChain as a company, it created a common framework, right? And as I said, LangChain is like a common framework. I'll write it down over here. Okay. So what did LangChain do? It created this amazing common framework. It is a framework to develop Gen AI application, Gen AI app. Okay. Now, with the help of this particular framework, right? We were able to access, like, let it be OpenAI Hugging Face or Llama 3, Google Gemini Pro, whatever models you specifically want. So LangChain as a library provided all those specific features, right? So they were libraries getting integrated, and this entire LangChain, right? If I probably talk about this LangChain, all the modules inside this LangChain are open source, right? Now, when you have something like open source, definitely it will be very much in ease to create generative AI application, right? And right now, probably each and every companies, if you even go for interviews, they're specifically going to ask you about LangChain, how you can actually build with the help of generative AI application. Now, this was fine, right? LangChain was there, and with the help of LangChain, we were able to generate generative AI applications. But later on, more and more modules were basically getting added, and that is what we're going to discuss now about the entire LangChain ecosystem. Because now the question rises: if I probably go ahead and create the Gen AI application, right? So let's say that if I go ahead and create the Gen AI application, here we may be using any paid open source tools, open source models, LLM models, LLM models, or multi-model, right? But the main task is that after creating this particular model, how do I make sure, how do I perform some of the activities that we specifically do with LLM ops? Now, what are activities we do in this? Let's say in this we specifically do something like debugging, right? We want to probably do the evaluation, right? We want to do monitoring. How do we specifically do with this, right? So LangChain, what they did is that they started creating this entire ecosystem, right? So for this LLM ops activities like debugging, evaluation, playground, monitoring, and all, it created a new module which is basically called as Langsmith, right? And this Langsmith is specifically used for this purpose, right? The LLM ops part, right? So it's not like we just use a library to develop a generative AI application, but in short, what LangChain, what is the main thing that it did is that it created that entire ecosystem wherein it is integrated this additional module which is called as Langsmith, and through which you will be able to probably do each and everything which I've written over here, like debugging, playground, evaluation, annotation, monitoring, and many more, right? Then came up the next module which is called as Langserve. Now, Langserve, obviously, if we are able to do this, finally, we really need to deploy this application. Now, to deploy this application, we really need to convert this into the form of APIs, right? Now, this APIs can probably be converted by using another module which is called as Langserve. So Langserve actually helps you to create chain as REST APIs. So it is written over here. It actually helps you to create this chain as REST APIs. So now is the main thing, right? Now understand the entire mechanism. Why I'm saying this as an ecosystem, right? First, you had LangChain. Now with the help of LangChain, by using concepts like chain, agents, retrieval strategies, which we will discuss. Because in this course, I'm going to cover each and everything that is available in this ecosystem, right? And then finally we deploy. After creating this particular APIs, we deploy it in different clouds like AWS. We'll focus more on AWS. Then there's also another cloud which is called as Hugging Face space, right? Which will be available to everyone probably completely for free for some space, for some resources, right? So we'll also be seeing with respect to this particular deployment, right? Now, initially LangChain came, we are able to generate generative AI application. Now in this LangChain, since we have so many different models, we have models from OpenAI, we have models from Google Gemini Pro, we have models from Hugging Face. That is the reason it came up with this another model which is called as LangChain Community, which has access to all these kind of models. Yes, for the paid one, you really need to have a key. For open source, you can directly use Hugging Face, or any other things like Meta Llama 3 and all, right? Then over here, prompt engineering is also probably done. Example selectors is a concept which we'll be learning about. Then you have something like output parser, like how should the response come after we probably input, if we give an input to our LLM models, if we really want to customize the output, how do we do that? We'll be discussing about that. Then we'll be discussing about retrieval, document loader, like there are different data ingestion techniques. We can load data from amazing different data sources, which we'll be discussing about this, right? And it'll be a detailed videos when we'll be discussing, right? Then we have vector store, then we have text splitter. Now, what exactly is this vector store? See, at the end of the day, when you're working with LLM models, that basically means you're working with text, right? And when we're creating this kind of application called as RAG or document Q&A or chatbot Q&A, there may be a scenario where I will be having a huge amount of data, and for that particular data, I really need to convert into vectors, right? For converting into vectors, we will be specifically using different embedding techniques, right? And after we convert that into vectors, right? Because the reason we convert into vectors because with the help of LLM models, whenever I try to query it, right, it tries to apply cosine similarity and it will be able to retrieve the results. So after I probably convert into vectors, how to store it in a vector database, we'll also be discussing about that. We'll be discussing about various vector databases that are available within the Langsmith, the LangChain itself. We'll be discussing about that. So as an ecosystem, we'll just not be building generative AI application, but instead we'll be thinking about the entire life cycle of a Gen AI project. So here, our entire focus will be on life cycle of Gen AI project. We will be focused on this entire life cycle, which will be including Langsmith, Langserve, and along with that, some of the default templates are also available. We'll be discussing about that. So I hope I was able to answer these two important things, why LangChain and some of the things with respect to LangChain ecosystem. Now you'll be seeing that in the upcoming tutorials that we're going to do in this course. We'll be discussing about all these models. We'll be breaking it down. We'll be developing into projects. We'll be doing many things as such, right? So I hope you like this particular video. This was it from my side. I'll see you in the next video. Thank you. Hello guys, so we are going to continue the LangChain series, and in this video we will go ahead and set up our entire environment for LangChain so that we will be able to start the coding and we'll be seeing multiple applications, how to build generative AI applications. Now what I've actually planned is that I will probably create just one folder. Okay, so let's go ahead and see this. This will be one folder. My entire projects will be probably created over here. And let's say the end-to-end projects that I specifically create, I will probably create a different project folder for them. Okay, so go to any folder in any of your drive, and from this let's go ahead and right click over here and you'll get an option of open with code, right? So here once you do or once you click this with open with code, you'll be able to see that I'll be having the VS Code. This is one way how you can actually do it. The other way is that I'll just go ahead and copy this path, open my command prompt. Okay, if I've installed Anaconda and VS Code, so I'll just go to this particular command, this particular path. So I'll just go ahead and write cd this, and I'll go to my E drive. So here you can see that I'm actually I'm in that same path which I am planning to create my code project itself. So here I will just go ahead and write code dot, and automatically my VS Code will open. So these are two different ways how you can probably start your VS Code. Okay, so I've done this, and now my entire coding will specifically be happening over here. Let me do one thing. Let me just make this as a full screen. Now let us go ahead and first of all create one virtual environment. Since in LangChain, all the things that we are going to probably discuss, it will be related to LangChain. So it is always necessary that you create your own virtual environment. And with respect to that specific virtual environment, we'll try to do all the installations, and we'll try to probably see what all packages will be required and many more things. Now, since I don't know like how many of you are familiar with working with VS Code or not, but VS Code I feel is an amazing IDE wherein you'll be able to create projects, you'll be able to work with Jupyter Notebook and many more things. So here, what I'm actually going to do first of all, here you can see that first of all you need to go ahead and open your terminal, right? So in this terminal, we will go ahead and create our virtual environment. Now, one way is that I can directly go over here, click on the terminal, and click on new terminal. So this is one way. But my entire session, I will try to use some shortcuts in VS Code. I just will press Control back symbol. Okay, so Control plus back symbol, and automatically I'll be able to see that okay, this is my terminal over here. Okay, so you can also go ahead and probably just open this terminal by using shortcuts so that you'll be much more efficient while working on the project itself. Now here you have multiple options like PowerShell, Git Bash, command prompt, JavaScript debug terminal. So whatever thing you really want to go ahead with, you can go ahead. Again, in Mac, you'll be having another terminal itself, so you can probably check with respect to the kind of system that you have. But here I'm just going to go ahead and open command terminal. Okay, so this will basically be my command terminal. Now I am going to, as I said, I'm going to probably go ahead and create my own virtual environment. So first of all, what I'm actually going to do, I'll just go ahead and conda create -p VNV will be my virtual environment. I will just go ahead and use my Python version 3.10. 3.10 I'm using because the most of the stable libraries that are there, I think it is compatible to Python 3.10, and I think it is also 3.11. In 3.12, there's still a lot of developments that are specifically happening, new things are coming. So once that actually becomes stable, you can also work with that. So I'm just going to go ahead with Python equal to 3.10, and here along with this, I will also say by default y, so that what are the default installation that is going to probably take place with respect to this particular virtual environment that is going to happen. So this virtual environment, in this, I will probably go ahead and do all the installation that I really want to work with the LangChain. Okay, so here you can see this entire folder and packages will get installed. And this is my VNV environment, and you can see slowly everything is basically getting installed. So till this is getting installed, I will just go ahead and create my requirements.txt. Requirements.txt. Okay. Now inside this requirement.txt, now you can see that my environment has got created. So here I'm just going to use one library that is called as LangChain. Yeah, I'm also going to install different libraries in LangChain also. You'll be seeing like LangChain underscore community and all. We'll understand why it is basically used, and then we'll go ahead and do the installation. So right now I just require LangChain to show you that how you can probably go ahead with the installation in this requirement.txt. Now once my virtual environment is created, so here you can see this is my VNV folder. I will go ahead and activate this particular environment. So let's go ahead and activate this. So here I'm going to write conda activate VNV, and here is my virtual environment. Okay. Now already my packages have been I've written that in the LangChain itself. So let me quickly go ahead and clear my screen, and let me just go ahead and right click install -r requirement.txt. So here you'll be able to see okay, install I've written ls. So let me just go ahead and do the requirement.txt installation. So automatically you'll be able to see LangChain, LangChain core, all this installation will automatically happen. Okay. So once this installation basically happens, we are good to start our LangChain projects, and even we'll be starting multiple modules in LangChain where we'll be discussing step by step and how you can specifically use it. Along with LangChain, I would also like to probably install one more package which I've already discussed in my Python module. It is nothing but IPyKernel. Now IPyKernel is something which we are going to use it only to make sure that we'll be able to create a selected kernel for our Jupyter Notebook file. Initially, all the topics that we are going to learn will be mostly through Jupyter Notebook, but later on, once we get our fundamental or basics clear, we'll also be developing end-to-end projects. So yes, this was all the steps that we really need to do in order to create a virtual environment. Now I'll just go ahead and probably create my first module, whatever things I really want to develop over here with respect to LangChain. And inside this, let's say I want to go ahead and probably work with IPynb files. So I'll just go ahead and create one file and I'll start my work, which I'm going to probably show you in the next video. Right? So yes, this was it from my side. In this particular video, I've shown you how you can actually go ahead and create a virtual environment along with that requirement.txt. I just use one packages, and as we go ahead, we will be using multiple packages, and after that we'll also go ahead with the installation. I've also created the entire the virtual environment by just using conda create -p VNV Python with 3.10, and I've just used -y so that whatever is the default installation that will happen. So yes, this was it from my side. I hope you like this particular video. I will see you in the next video. Thank you. Hello guys, so welcome to the LangChain series, and in this video we are going to get started with LangChain and OpenAI. Here, this video is super important because some of the important modules that are available in LangChain will be setting it up, like Langsmith and Langsurf. Along with that, you'll be seeing in series of videos, we will be building a sample application, a simple sample application with the help of LangChain. There we are going to use OpenAI models. Along with that, if you do not have OpenAI API key, then you can also go ahead and use open source models that also I'll show you with the help of Ollama. Again, the main aim over here is to make sure that what all tools we are going to use in this entire course, I'm going to probably do that entire setup right now so that you will be able to follow all the lectures as we go ahead. So let me just go ahead and share my screen. So here in this video, what all things we are going to do. First of all, we're going to get started with LangChain, and let me just go ahead and write and OpenAI. Okay. In this quick start, we'll show how to get we'll see how to get set up with LangChain, Langsmith, and Langsurf. So we'll be discussing about all these three modules, important modules that are present in LangChain. Then use the most basic and common component of LangChain, like prompt templates, model, and output parser. Then we are going to build a simple application, with LangChain, and then we are going to trace our entire application with the help of Langsmith. Right? If you really want to do debugging, monitoring, everything, we will be specifically using Langsmith. And then finally, if I want to probably make this entire application in the form of APIs so that it is production ready, I will be using Langsurf. So all these things, not only in this single video, but in the series of video I'll be doing. Once we do it with OpenAI, I know like everybody knows that OpenAI provides you API key, and obviously you need to put at least $5 credits to check out all these things. The reason why I'm considering OpenAI because it is important. In most of the companies, people are using it in the form of APIs and all. So first of all, initially I'll go ahead with OpenAI API, and then we will also go ahead with open source models through Ollama. Okay. So initially, the first step is getting set up with LangChain, Langsmith, and Langsurf. So quickly, let me do one thing. Let me go back to my browser. So here is my entire LangChain page. So over here, you'll be able to see in LangChain, we have a library or module which is called as Langsmith. Along with this, we also have something called as Langserve. Okay, so LangChain is an open source framework where you'll be finding a lot of modules, a lot of libraries, which will actually help you to develop the Gen AI application. So first of all, I'll just go ahead and click on sign up. Okay, and once I sign up, you'll be able to see that you'll be able to log in into the Langsmith basically, like say this Langsmith, why it is used. So we can just go ahead and understand. It will be like if you want to make your LLM app from prototype to production, we will specifically use this entire Langsmith module itself. So by default, whenever I do the sign up, you have to go ahead and insert your user ID or whatever like name, all the details, and probably go ahead and sign up with your email ID. In the Langsmith also, if I go ahead and sign up, it will probably give me the same page that I actually got. Okay, now here you can actually see I've created so many different projects, tutorial 1, test LLM. So over here we'll be able to do the entire monitoring, everything as such. Along with this, if you go over here and say that I can also upload my own data sets, there's something called as annotation queue, prompts. If you want to probably do the deployment, I can go ahead and click this, and LangGraph API deployments is also there. And right now, hosted Langserve is coming soon. If you're interested, you can sign up for the early access. Let's see till the recording of this particular entire course gets over. If I get this particular access, I'll also make a tutorial for the same. Okay, so this is the first step. Please go ahead and create an account in LangChain, and automatically you'll be able to create an account with respect to Langsmith. Okay, so this is the first step. Everybody needs to have this. Okay, and I will show you that how I will be using this. I'll be monitoring my entire Gen AI application and everything as such. Now the second thing that you really need to add is an OpenAI API key. So just go into Google, search for OpenAI API key, and over here you'll be able to see platform.openai.com. Just click on this. Okay, it will tell me to log in, so I'll just go ahead and log in. I'll continue with Google. I hope everybody may have an account in OpenAI, right? I hope everybody's used ChatGPT at least, right? So here is your entire API. You can probably see this OpenAI platform. Okay, and here you'll be able to see there's something called as API keys. You can go ahead and create your API key over here. Okay, but for this, it will not be completely for free because you at least have to put $500, not $500, that is $5 to probably check it out. So here you can see some of the usage that I've actually done in June, right? And right now the date is 18 June. I've not used it, but from today I'll be probably using it. You can also see that I've used for GPT-4o, GPT-4. So I'll be using these models when I'll be developing an end-to-end application. Okay, if you want to probably go ahead and upload put some amount again, you have to go to the payments, and here you can see cost, activity, everything is basically there. If I go ahead and click on increase limit, you'll be able to see that I will also be able to set my limit based on the requirement that I have. So if you go to click on billings, so here you can upload your payment methods. Right now my credit balance is 2.85, but if I require more, I will be inserting more $5 to $10 and probably showing you how you can actually use this OpenAI API key. Okay. But at the end of the day, you really need to use this because many of the companies are using it, right? So there are options of putting up payment methods and all, right? So based on that, you can actually do it. But at the end of the day, I will be using one API key, which I will try to create it over here. I'll also show you how to create it and where I'll be creating the entire environment. Okay. Now let me just go back to my project. So I have actually created each and everything over here. The first thing that I'm actually going to do is that over here you'll be able to see that I've created a lot of folders, which you'll be able to understand. In requirement.txt, I have put up LangChain. So LangChain is one of the libraries that I'm actually going to use. And since we're going to work with Jupyter Notebook, so what I've actually done is that I've used IPyKernel. Okay. IPyKernel just enables to attach a kernel to the Jupyter Notebook itself. So this is the first thing that I really need to install. Along with this, there are some more installation that I will be doing, which I will be showing you, right? The first thing is that you'll be able to see that I'll go ahead and create my .env file. Now this .env file is super important because with the help of this .env file, what I'm actually going to do, I'm going to go ahead and create my OpenAI API key over here, okay? And I will be assigning the values over here, right? So this will be one key that I'll be using. The next key will be my LangChain API key, right? So if I go ahead and do this and probably go ahead and put my LangChain API key. Now why do we require LangChain API key? It is very simple. If you probably go to the browser, right? So let me just show you over here. So if I go to my Langsmith, right? Over here, you'll be able to see if I go ahead and click on settings, right? I'll be requiring one API key because at the end of the day, entire monitoring will be specifically happening over here, right? So if I go ahead and see in this LangChain series, you'll be able to see right now there's no request. But if I go ahead and see in some tutorial 1, right? Okay, let me just go ahead and see from the last 7 days, last 30 days. Okay, so nothing is here. So let me do one thing. Let me just go ahead and test some more. Right now, everything looks blank. Okay, but it's okay. We will see this all time. If I go ahead and see over here, I created some request from OpenAI, and here you'll be able to see I'll be able to monitor each and every request and all. I'll be talking more about it, but just I'm giving you an idea why we specifically require a LangChain API key because in this portal, I am going to record all my monitoring things, debugging things with respect to the Gen AI app that I'm actually going to create. So in order to create the API key, just go to the settings over here, click on API key, and select create this API key. Right now, I've already created it. So if you go ahead and create it, you can give any kind of description over here. Okay, let's say that I'm giving here this will be my test key that I'm actually going to create. Personal access token. I'll go ahead and create this API key. So I'll copy this. Okay, I've saved it to a safe place. Now what I'm actually going to do over here is that I'm going to paste the API key, right? And this API key I'm going to specifically use it over here. Again, I'll not say that please use my API key. Don't do that. It will be of no use. You can create your API key because it is completely for free. Okay. Then coming to the next part, right? So since we are in the .env file, so first of all, I kept my OpenAI underscore API key as a key. Then my LangChain API key. Then I will also go ahead and create my LangChain project. Okay. So I will just go ahead and write LangChain project. Okay. So this will basically be my LangChain project. And let's say this is my Gen AI app with OpenAI. So this will be my project name that I'm actually going to create it. Okay, so I will be requiring this 3 information to start with. Okay, now you may be thinking, Krish, why I have not yet put up this OpenAI API key. I would suggest please go ahead and put your own API key. Okay, do not be dependent on mine because I'll keep this hidden. Otherwise, a lot of charges will happen on my end. Okay, so this will be the 3 API keys that I'll be requiring: LangChain underscore API key, LangChain project, and OpenAI underscore API key. Perfect. Once this is done, now I will go to my requirement.txt. Okay, now here I'll not go ahead and install IPyKernel because IPyKernel I'll do it only for the Jupyter Notebook, so I don't have to put that entire thing in the requirement.txt. I will go ahead and write python.env. Now why this library is actually required? It is very much simple. Whatever things I've written in my .env file to import all this key value pairs in my Jupyter Notebook or in my .py file, I'll have to use this python.env. Okay. Now my requirement.txt is updated, so let me just go ahead and open my terminal. So this is my terminal over here. Now quickly, I'm in my venv environment. So quickly, let me just go ahead and install all this requirement.txt. Okay. So LangChain and python.env. So here you can see it is successfully installed. Perfect. So this is good. We are ready with it, and you can see that I've also created my API key itself. Now what I'm actually going to do is that in the next video we're going to get started, and now the first step is done. LangChain, Langsmith, and Langserve. Langserve also I'll be talking more about it, like what kind of code we'll be writing. For this, you don't require any code to sign up and stuff. Only LangChain and Langsmith you basically require. Okay. Now in the next step, we will use the most basic and common components of LangChain, like prompt templates, models, and output parser. So I hope you were able to understand this video. This was it from my side. I will see you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to LangChain. In this video, we are going to discuss about some of the very important components of LangChain that we use while generating a Gen AI application. Already in our previous video, we have seen the entire ecosystem of LangChain, and we had also done the setup of Langsmith. Before I go ahead and do the coding, and start using this library, we will just try to understand what are the most common components that we will be specifically using. And in this video, I'll be taking an example of a RAG application that is nothing but retrieval augmented generation. Now, what does this RAG actually means? Is that, and we are just going to create a lot of projects as we go ahead. But let me just give you a brief idea about RAG. What exactly is a RAG application? Let's say. And by just seeing this particular diagram, you'll be able to understand. Okay. Now, RAG augmented generation basically means, let's say you have a specific data source. Okay. Now, this data source may be some kind of PDF file, right? Let's say you have thousands and thousands of PDF files. Now, if you want to make this PDF file as a document Q&A application, that basically is whenever I ask a question, automatically my Gen AI application. Okay. Let's say if I'm probably creating a Gen AI app over here. Okay. So this is my Gen AI app. What I will do is that if a user asks any query, it should be able to probably send this query to this entire data source, and from this PDF, we should be able to get the response. Okay. So this in short is the entire process of RAG. But again, I've just given you a 10,000 height overview, right? 10,000 feet height overview. So that is the reason I just told that, hey, we have some kind of data set where we have thousands and thousands of PDF. And now what I'm doing is that I'm creating a generative AI application. This generative AI application, what task it performs is that whenever input is given from a user or regarding any question from this particular PDF, I should be able to get it by having a conversation with this entire data source, right? That is nothing but tons of PDF that you have. Okay. This is just a basic example, but we'll discuss more about it. Now, if I just consider this application, okay, and most of the common components that we use in LangChain to develop this kind of application and similar kind of application itself. So we'll try to understand step by step how we will probably be developing, and then along with that, what all components are used in each and every step, we'll try to understand it. Okay. So initially, what we do is that whenever I have this kind of use case, first of all, we need to load the data set, right? Now, loading the data set will be from various data sources. Okay. Now, this data source can be anything. So that is the reason we have used this diagram. It can be a PDF. It can be a Excel file, it can be a JSON file, it can be an image, it can be videos, it can be URLs, right? So initially, whenever we develop this kind of application, the first step that we specifically use is data ingestion. So this is the most important component in LangChain, okay? And in the upcoming video, in the next video, I will try to show you with the help of LangChain how you will be able to perform data ingestion with respect to various data sources, okay? So that is the first component that we are going to discuss. Then what we do is that after basically using this entire data, like let's say we have ingested this data, we have loaded this particular data, then the next step will be that we will divide this data, we'll split this data into smaller chunks, okay? So here what we are doing, we will take this entire data and we will split into text chunks. Okay, it can be text chunks, it can be document chunks. The reason is very much simple. Why we are basically doing this? Because see, in the later stages, we will be specifically using LLM models, or it can be multi-model, right? And one of the very important property of this particular LLM model is that it has some limitation with respect to context. So for different LLM models that we'll be seeing like OpenAI or Google Gemini Pro or any different kind of models that are even available in Hugging Face, open source models like Llama 3, they have some limitation with respect to the context size. Okay. So based on this particular context size, what we will be doing is that there is a restriction. The size, like if my LLM model, I can only give this much maximum context size of data, so that it will be able to understand from where it needs to take the query or response, and it needs to give it as an output, right? So that is the reason what we do is that we divide this particular data, right? And this data can be having 1,000 PDFs. If we read all the data from 1,000 PDFs, it can become a huge data itself. So we'll take that data and we'll split that into text chunks. Okay, so that is the second step that you'll be seeing. And splitting these chunks is done by various other techniques. So here I will just consider this as a data transformation technique. So this is nothing but this is my data transformation. Here my main aim is to transform the data or divide this data into chunks. Okay, so this is the second important component that we will be doing. And again, based on our upcoming videos, we'll discuss each and every component. Okay. Now coming to the third and the important step, which is called as embed. Okay, embed is nothing but it is just embedding. Okay, so here we are basically going to do text embedding. Now what does text embedding basically mean? We will take this entire text and we will convert into vectors. Okay, now why do we require vectors? Because see, whenever we query this kind of data source, unless until we don't convert this text into vectors, over there algorithms such as similarity search, because see, one of the most important algorithm that gets applied when we are working with this kind of text data is nothing but similarity search. Okay, similarity search. And it will basically be using a cosine search over here to try to understand based on the vectors which are the similar context, which are the similar sentence that I'm actually searching for, and based on that it will retrieve those particular context. Okay, so that is the reason we basically use embedding techniques. Now in this embedding techniques, you have different kinds of embedding. OpenAI has OpenAI embeddings. You also have open source embeddings for different models. Even in Hugging Face, you'll be seeing a lot of open source models. All of them specifically has its own embedding techniques. Okay, even Google Gemini Pro has its own embedding techniques. So we will again be seeing that whenever we are developing that particular application. So this was the third step. Now coming to the fourth step. So here you can see I'll take this text, I'll convert this into vectors. The vectors will look something like this. Okay. Now this vectors, once we convert it, we really need to store it somewhere, right? Because we can't just keep it in our local file, right? So for this, we will be using a store, and this store is nothing but this is basically called as vector store database. Okay, vector store DB. We will be seeing different vector store DB. First example is nothing but we will go ahead and see Fires. Then there is something called as Chroma DB. In our course, we'll also be seeing Astra DB. Okay, so different vector databases will be see how we can basically save this entire data into this kind of vector database that we are going to see. Okay, and that is what this is exactly a vector database. And what you can also do is that from this vector database, you can also directly query anything that you want. But the result or the response that you are basically going to get will be the context information. Okay, it will be the context information, and it usually uses the similarity search. Okay, so this is my fourth step that usually happens. Now once I save this entirely into the vector DB, vector store DB. Okay, now we go to the second most important step. Okay, and this is my second. You can just consider that this is my second module. This is my first module. In the first module, you have this particular 4 steps. Okay. And in the second module, you have some more steps. Okay. Now, while we are working with vector store DB, okay, in the second module, you will be seeing that a user will be able to ask any questions. Okay. And what we do, we also design our separate prompt. So here is your user question. Along with this, we combine with this particular prompt. This prompt usually says that, hey, you are an LLM model, you need to behave something like this. I'll say, hey, act as an AI researcher and try to answer all the questions that is given by the user. Okay. So if I give this kind of prompt, any LLM model that we are going to use, it will act like an AI researcher. Okay. So here prompt is just like the message that I am giving to my AI assistant. Okay, AI assistant, like what it needs to behave like. Okay, so once I give that particular prompt, then any question that is given over here, we will try to combine with this particular prompt. Okay, so as soon as we give this particular question, okay, this question initially will be searched from this vector store. okay, from this vector store. Then from that particular vector store, we will get some context information. So for doing that purpose, to basically query from the vector store, we really need to understand two important things. One is there's something called as document stuff load chain. Okay, this is one thing which we will be learning about. Okay, this is also one very important component. And the second thing is something called as the retrieval chain. Or I'll not just say two. I can just consider it as one because document stuff load chain will be a part of that. Okay, so here we need to understand about something called as the retrieval chain. So this retrieval chain, how it is basically created. And what is this retrieval chain? This retrieval chain is nothing but it is an interface which is responsible in querying the vector store DB. Vector store DB. Okay. And based on this particular query, I will be able to get the response. And once I get the response through this retrieval chain, I will basically be having my context info. Context info basically means based on the query, where is the similar data in that particular PDF, that entire context will be picked up, right? And along with this context info, we will be combining this prompt template and finally giving to the LLM model to get my output response. So this, in short, is the entire cycle over here. Okay. Now, what will happen in the next video? First of all, we'll see what are the different data ingestion techniques in LangChain. You'll be amazed to see like what all different data ingestion techniques are there. Right. The second thing that I'm actually going to show you, if I take up any data, how will I be able to divide that into chunks? This is also amazing. Like multiple properties are specifically there. Then the third thing that I'm actually going to show you, which all embedding techniques we can specifically use. Right. There are embedding techniques like Faiz, ChromaDB, AstraDB. We'll be seeing multiple embedding techniques. Okay. Sorry, not Faiz, ChromaDB, or AstraDB. This is vector store DB. But we will try to see with respect to OpenAI, I have a different embedding technique. With respect to open source models, I have a different embedding technique. So we will try to see that embedding techniques, whose responsibility will be for converting your text data into vectors. And finally, you'll also be seeing that we'll also discuss about vector store DB, right? And then we'll combine all these things and we will be creating some amazing projects. We'll also be learning about retrieval chain. So step by step, we will break down each of these things because these are most of the common components that are used in every project of GenAI, right? So I hope you like this particular video. These are some of the very important components of LangChain which you should never miss it out and definitely you should know about these things. So yes, this was it from my side. I will see you all in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to LangChain. In our previous video, I had actually shown you the example like what we will be specifically doing step by step, from data ingestion to data transformation, then converting the text into vectors, finally storing it in a vector store DB, and then probably creating a retrieval chain along with prompt template. We send that entire data to the LLM model, and finally we get the response. Now over here, what we will be doing is that we'll be exploring each and every step and how we can actually implement with the help of LangChain. The first step that we are going to discuss about is data ingestion, right? And when I say data ingestion, it's more about loading a data set from a specific source, right? We also say it as document loaders in LangChain. So we'll be discussing about this. We'll be doing some practical implementation. I'll be taking different types of files, and I'll show you that how we can read that particular data from that and convert into a document. Okay, so all those things will be probably discussed. So first step, we'll go with this. Then we will, as we go ahead, we'll be seeing other modules also. So let me quickly show you over here. I've actually created a data ingestion.ipynb file, and I have selected my virtual environment. One very important thing that you should remember: whenever I really need to work with this ipynb file, I need to have a IPy kernel. Okay, so that is the reason I've already done the installation in the requirement.txt. So this is perfect till here. Now let me do one thing. Let me also go ahead and show you the documentation. Okay, now it's really important that you understand or you have the habit of reading the LangChain documentation because this documentation is just like you have each and everything available over here. And the only problem I see while following the documentation is that it is completely scattered. So that is the reason when I'm actually creating this course, I will create in such a way that it will be having the videos in an ordered way so that you understand step by step how things are basically getting implemented in generative AI application, specifically for the generative AI application. So here, as I said, we're going to discuss about data ingestion. In that data ingestion, we're going to discuss about document loaders. Now, what exactly is document loader? It's just like what are the different ways to load different data sources. And here, if I just see on the left hand side, there are multiple different ways. You can load a table, you can load amplified data set, you can load RSIF, you can probably go ahead and see about, let's say, your browser base is there, Cassandra is there. You'll be able to load from this particular data. So you want to load it from CSV, you have this particular option. If you want to go ahead and load it from web based, so many different options are there. If you want Hugging Face data set, you can go ahead and load it. If you want to load images, you can go ahead and load it. So that is why I said that LangChain is an amazing framework. And it's like whatever document loaders you really want to load the data from, you can just go ahead and refer this. Okay. In this video, I will be showing you some of the good examples, most common examples that we use with respect to data ingestion using document loaders. Anyhow, tomorrow, if you have any other requirements, you can definitely see this particular documentation. So here I have already given the link for the documentation. You can start the coding from here. Okay. Now let's go ahead and let's start this, and I'll be showing you multiple ways of doing the data ingestion technique itself. Basically, we'll be seeing multiple ways how you can load the data set. Okay. So the first technique that I'm actually going to use is something called as text loader. Okay. Now text loader actually helps you to load any types of TXT files. So I have created this folder called as data ingestion. Inside this, I've created this particular speech.txt folder file. Okay. And in this, I've just put some information of a speech over here from Wikipedia, and I've just copied and pasted it. Okay. Now what I'm actually going to do inside this, and again I also have a PDF file, I also have an XML file. We'll also try to read that as we go ahead. So this text.loader, what it does is that it actually helps you to load any speech.txt file, like any TXT file in short, right? So here I've created this speech.txt file, so it will actually allow you to load this. Now how do you do that? So for that, what I will do, I will go ahead and write from LangChain _community. Okay. Now this LangChain _community, we need to make sure that we go ahead and install in the requirement.txt. Okay. So I will quickly go ahead and press Shift Tab, and let me just quickly upload or run this requirement.txt file. Okay, so I have to be in my virtual environment. Please remember that, and then I will go ahead and write pip install -r requirement.txt. So once I do this, I've already done the installation, so it shows me requirement already satisfied. Okay, so here LangChain _community we are specifically going to use. Now I'll go ahead and import from LangChain _community. We have something called as document loaders. Okay, now inside this you have something called as text loader. Now in the web page, in the website, we saw different types of loaders, right? Document loaders. Everything is available inside this LangChain _community.document loaders. Okay, please remember that. Now, after I import this text loader, right? What I really need to do, I need to initialize the text loader, and here I will give my file path. File path is nothing but inside this, since I'm working inside this folder, I have something called as speech.txt. So here, what we can basically do is that we can go ahead and write speech.txt. Okay, speech.txt. Now, here what I'm going to do, I'll go ahead and initialize this as a variable called as loader. Okay. Now, when we are reading it, okay, let's go ahead and execute this. And if I go ahead and execute it, shows that hey, loader is nothing but it is a document loader of a text at this specific memory location. This is fine. Okay. Now when we are loading this, right, entire content inside the speech.txt will be converted into a document only when we go ahead and write loader.load function. So loaded.load function will basically help you to create this text documents. Okay, we'll see to it. Okay, and then finally I will go ahead and print the text documents. So here you can see this actually is my document, and it has this page content variable, and all the text inside that txt file is inside this page underscore content. Okay, and here you can see that metadata source is nothing but speech.txt. So in short, what it has done is that it has loaded this entire speech.txt in one document that is available over here. Okay, so this is one very easy way of loading a txt file. Okay, now let's go ahead and do one more thing. I will just try to show you with respect to PyPDF, like how do you read a PDF file. So reading a PDF file. Okay, so here what I'll be writing, I'll again go ahead and write from Langchain underscore community dot document loaders. Okay, again, and this time I'm going to import PyPDF loader. So PyPDF loader basically loads the PDF, any PDF that you're giving inside this. So I'll go ahead and initialize PyPDF loader, and here I'm just going to go ahead and write attention.pdf. So this is my PDF name that I have, and this PDF I've actually taken a research paper of transformer attention is all you need. I hope you may have heard about it, and again it was available in Arshiv's website. Okay, now here what I'm actually going to do is that I'll go ahead and create a variable called as loader, and again to get the documents I'll just go ahead and write loader.load. Once I do that, so finally you'll be able to see this will be my docs. So it'll go ahead and read from this particular PDF. Now it says, hey, I'm getting an error. It's saying that, hey, please go ahead and install PyPDF. Now let me quickly go to the requirement.txt. Again, the error that we're seeing, we really need to fix the error. So here I'll go ahead and install this PyPDF. So quickly, let's go ahead and write pip install requirement.txt. Now the installation will start, and here you can see the PyPDF is installed. So I'll close this quickly, and now let's go ahead and execute it once again. So now I think it should be loading it, and here you can see with respect to all the PDF, it has been able to read each and everything, right? So here was my first page, I guess, then this was my second page, third page, fourth page, like this. I'm able to see all these things, and the return type is basically docs, document. So if I go ahead and see type of docs, here you'll be able to see that, hey, it is a list of documents. So let's say if I go ahead and write type of docs of 0, here you can say that it is a document type. Okay, and inside the document type, you have this attribute called as page content, and at the end, you'll be able to see some kind of metadata. Okay, it's a very big PDF, so let's not explore that. So that at the end, if you probably scroll till the end, okay, if I just go ahead and scroll it till the end, right, you'll be able to see the metadata source attention.pdf, and this is page 1. So every page is basically converted into a document over here. Okay, perfect. So this is another way of reading a PDF file. Okay, so I hope you got an idea with respect to this till here. Let's go ahead and do one more amazing. We will just try to use another document loader technique, and this time we are just going to use something called as web-based loader. So here we're going to discuss about web-based loader. Okay, again, since we're just discussing how we can load the data sets from different data sources. Okay, now I will go ahead and write from Langchain underscore community dot document loaders, and here we are going to import web-based loader. Now web-based loader is like, let's say that you probably want to give any website. Okay, it should be able to read the content from that particular website. Okay, that is what we specifically do in this. So let's take one example, and this example URL I will show you by opening the browser itself. Okay, so let's quickly show this over here. So let's say I'll go ahead and copy and paste it, and let's consider this particular website. This is a website which is saying that, hey, LLM powered autonomous agent, I have so and so information, everything is over here. Okay, now this is my entire website, and I want to load this entire content. Okay, so let me quickly go over here, and let's go ahead and initialize this web-based loader. Now inside this web-based loader, the first parameter is something called as web underscore path. Okay, now inside this we will be giving one path. Let's say my URL is something like this, and I'll paste it over here. Okay, so this is my URL. Okay, and over here you'll be also able to see that when I'm using this particular URL. Okay, and let's try to execute this directly. Okay, here what I'm doing, I'll just give this web path, and let me go ahead and create a variable. So let's see whether it'll execute fast or not. So here it says, hey, user agent environment not set, considering to identify your request. Okay, no worries. So what I will do over here, I will go ahead and, okay, just a second, I'll just go ahead and put a comma and provide more parameters. Okay, now this time the parameters that I'm actually going to provide is with respect to the element. So let's execute this first of all. Okay, so here you can see that I've executed it over here. Okay, and the reason why I've given comma, because you can put any number of URLs over here. Since I've used web paths, if you just use web path, you can just give one URL. Okay, so here I've just given web paths, and I've given this particular URL. Okay, now let's go ahead and take this loader. Okay, loader. Okay, and I'll do dot load. Once I do loader.load, you'll be able to see, hey, I have actually got the page content of the entire page, right? So this is my entire page content. So if I just go ahead and see my browser, okay, so here I've got this entire page content inside this, okay, along with new line, everything as such, okay, and this is so amazing, right? You just by writing this 2 line, you're able to get it. One important thing that you need to remember is that here you also require Beautiful Soup. Okay, Beautiful Soup is one kind of library that you definitely require whenever you are doing the scrapping task in any of the project. Okay, so in order to execute or install Beautiful Soup, you can just go ahead and write this over here, BS4. Okay, and I'll just go ahead and press this. Now let's quickly go ahead and do the requirement.txt. My BS4 will basically get installed. That is nothing but Beautiful Soup. Now what I will do, I will go ahead and close that particular terminal. Now what I am actually going to do over here is that let's make this and provide more parameters based on our needs. Okay, now in order to provide more parameters over here, I can play with this web page based on what content I want. Right now everything has been extracted, like post, archive, search, tags, everything. Let's say I will go ahead and inspect this. Okay, now when you go ahead and inspect this, let's say that I want some of the classes. Let's consider I want post title because I'm interested in this. Okay, I want post content. Post content basically means I want this entire content from that. And finally, after this, I also want the post header. Okay, so let's say with respect to these 3 classes, I want the information from this particular page. Okay, so how do I give that? That is what I'm actually going to show you now. Okay, just by using the same functionality. So here, what I'll be doing, I'll be using this web path. Along with the path, I will give more parameters. The next parameter that we are going to use is something called as bs underscore kwargs. Okay, here I will be giving in the form of dictionary. The first thing will be that I will try to give the parse underscore only. Will be nothing but I'll just go ahead and import BS4. So let's go ahead and import BS4. Okay, Beautiful Soup 4. I'll say, hey, parse only is equal to BS4 dot soup strainer. Okay, and just by giving this parameter, I will be able to give my class. So here I'll write class underscore equal to. Let me just go ahead and give which all classes I want. I want post dot title. Okay, dash title. Then I also want post dash content, and I also want post dash header. Okay, I want this three information, and based on this particular three information, I need to retrieve the content from this particular URL. So I will just go ahead and execute it, and this will now be my loader.load. And here you can see /n has all removed because I just want that relevant text, and this is how I'm also able to clean some of the information while I am loading all the information over here, right? And I hope you are able to understand with respect to this particular parameter. And here you will be seeing that power of beautiful soup is amazing because you're able to retrieve all the details itself, right? So this was with respect to web-based loader. Okay, now there are also different data ingestion technique which I will be showing you over here. Let's go ahead and I'll show you two more important things. Okay, one is with respect to the most famous, because see this RSIF. Okay, now RSIF is something if you don't know about RSIF, if I go ahead and search attention is all you need research paper. Okay, the default website that it'll go will be in this particular website that is called RSIF, right? And here you can go ahead and see the PDF. What if I have the entire data source as RSIF, right? I'll be able to directly communicate with this. So how do I do that? Okay, so first of all, what I really need to do is that I will go ahead and install this, that is pip install RSIF. Okay, so for that I will go back to my code, go ahead and update my requirement.txt with RSIF. Okay, I will go ahead and open my terminal and quickly write pip install -r requirement.txt. Now here you can see quickly it will get installed and my RSIF package has also got installed. Now in order to check it out whether RSIF is working fine or not, I'll go back to my data ingestion, and this time I'll just go ahead and write RSIF. Okay, and let's go ahead and copy this. Let's say I want to copy this. First of all, I will go ahead and import my library document_loaders. Okay, and then we will go ahead and load this particular paper. The paper is nothing but the number is 1605, and here you'll be able to see that. I will just go ahead and give this. So here what I'm doing, I'm initializing RSIF loader. The query parameter will be the paper number. Let's see if I go ahead and search this. Okay, if I go ahead and search this over here, okay, and press enter. So here you can see, hey, this is the research paper that we are talking about, right? Similarly, if you go ahead and see attention is all you need, right? So attention is all you need will also have some kind of numbers. So if I go ahead and see, hey, attention is all you need, okay, and here is the number for this, right? Attention is all you need. What is the number that we saw? It was nothing but this one, right? So let's go ahead and search this, okay? So here I'm going to just go ahead and copy and paste that particular number over here. Now I'm saying, hey, go ahead and take this particular query and load maximum 2 documents, and I'm writing .load, and here is my length of documents. So here I'm obviously, so I'm getting an error. Let's see what is the error. It says, hey, py_mu PDF package not found. Please install it with this pip by using this command, which is called as pip install py_mu PDF, right? So here I'll just go ahead and copy this. I'll go ahead and update it over here, and this is how you basically do it. You can also do pip install, right, directly. I'll quickly go ahead and do this installation. Now this installation will take place, and once this installation is taking place, we will be able to go ahead and use it. So I will close this now, and now again I'll go ahead and execute it. That's it. I'm searching for this particular query. It should be able to give me this particular documents from that entire research paper. See, provided proper attribution Google here by grant, so and so all the information is probably here, right? The entire research paper is just given in the document, and this is so amazing. That is the reason I like LangChain, because it has almost document loader functionalities. You want RSIF, you want any kind of data source, Excel, CSV, TSV, whatever things you want. There's a document loader for that. Okay. Now there's also one more. If you want to go ahead and explore this, there's something called as Wikipedia. Okay, you can also go ahead and see Wikipedia. Okay, so let me show you here. So Wikipedia, for Wikipedia, you need to go ahead and install Wikipedia over here, right? So I will go ahead and install Wikipedia. Quickly open this, install it, right? So I'm giving you a complete generic way how you can access it along with this, right? So I'll copy this quickly. Okay, I will close it over here. I will go ahead and say Wikipedia loader. Then it says, hey, based on any query that you search. So I will just go ahead and execute. Instead of writing hunter x hunter, I will say, hey, let's find out some information about generative AI. Okay, and I want this particular docs, and let's go ahead and print my docs. Okay, and here you have this. Automatically, it will be loading 2 documents, and here's the entire page content, right? Entire page content. If I just go ahead and display docs, you'll also be able to see all this information, right? So everything is over here. I think it should be giving you the page URL also. See, page URL is also given. This is the URL that is researched. And just by using this, wow, I think you should be able to feel very much happy, because now any kind of data you'll be able to get it, and this is completely free. Wherever there is an API required, you can use the API. Let's say I want to have a weather data, so I need an API for this. You can go to weather data loader and probably create your API. You can do that, right? So I hope you were able to understand the entire data ingestion technique with the help of document loaders. I've shown you multiple examples. Don't forget to check out the documentation. Again, I've given the link over here. Okay. At the end of the day, LangChain has actually included a lot of document loaders through which you can ingest data from different data sources, right? So go ahead and explore. I will see you all in the next video, where I will be talking about, once we take this entire document, the next thing is that how we'll be able to do the text splitting, right? That's what I'm actually going to discuss about in my next video. So yes, I will see you in the next video. Thank you. Hello guys, so we are going to continue our discussion with respect to LangChain. Already we have discussed about data ingestion techniques, where we discussed about various document loaders. Now in this video, we are going to go to the next step and discuss about data transformation. Now in this data transformation, we will try to see how we will be able to convert these documents into chunks of text. Again, in LangChain, we have a lot of different ways how we can probably go ahead and convert all these documents into this text chunks. And why do we do this? So that every LLM model has its own limitation of the context size. In order to take care of that, we have to probably divide this particular documents into smaller text chunks. Now let's go ahead and let me just go ahead and show it to you how we can actually do this. I'll keep my face hidden so that your focus will be completely on the screen. Okay. If you remember in our last class, I had shown you how to read a PDF file, text file, along with that a web-based loader, how to probably read it from a website, RSIF. Then you also have Wikipedia, so many different things we saw, right? Let's take one of the example. So let's read this particular PDF file in this particular file itself, right? I'll go ahead and select the kernel. So let's go ahead and select it. Now once I execute it, so these are my docs that you will be able to see from this particular attention.pdf. Now what we are going to do is that we are going to take this entire PDF, and then we are going to convert this into text. Okay. So here, first method that we are going to do is that you see how to recursively, okay, or let me just go ahead and make this as a markdown and write the title over here. How to recursively split text by characters. Okay. So we first method is this particular technique. So here, let me just go and do it. So here, what we are going to do is that we are going to recursively take up all these documents and split this text by characters itself. So first of all, before we go ahead, we require a library. Now, what is the library that will be required over here? I'll just go ahead and write it down. So this is nothing but LangChain-text-splitters. Okay. So this is the library that we will be requiring in order to use all the different types of text splitting techniques. So I will go ahead and quickly do pip install. So here you can see pip install -r requirement.txt. Now this way you can actually open your terminal. The other way is directly go to this particular option and click on terminal, right? So you'll be able to open this, right? I'm using a shortcut, which is nothing but this backspace along with control. So control and backspace. When you do that, you'll be able to open this particular terminal. Okay. So already my installation is done with respect to the LangChain text splitter. Now I will go ahead and write my code. Now first, what we'll do is that we will go ahead and import from LangChain underscore text underscore splitters. Okay, and we are going to first of all import, which is called as recursive character text splitter. Now this is responsible in recursively splitting the text by characters. So here we have already loaded the document. Okay, I have my entire document over here, right? So this is my docs folder. Okay, now what I'm actually going to do is that I'll just go ahead and write text underscore splitter. Okay, and here will be my variable, and we will go ahead and use this recursive character text splitter. Inside this, there are some parameters which you really need to know. The first parameter is something called as chunk size. So here you basically define the chunk. Let's say I go ahead and define my chunk is somewhere around 100, and I will just based on this chunk size, or let's make it to 500. And here you'll be able to see that I will keep my second parameter, which is called as chunk overlap. Okay, so this will basically be my chunk underscore overlap. You'll understand each and everything. First of all, let me just write the code so that you get to know what I'm doing. So here I'm saying, hey, try to split all these things by considering the chunk size of 500. That basically means when I'm dividing my documents into smaller chunks of text, each chunk of text should have a maximum chunk size of 500 characters, and there can be an overlap of 50 characters. Okay, and here I'll use this two specific parameters for now. Okay, after this we will use this text splitter, and we have a lot of option over here. So first option is nothing but create documents. You also have option like let's see, create documents is there. Okay, so let's go ahead and use this create documents. Okay, so here what I'm actually going to do, I'll just go ahead and write create documents, and along with this particular documents, I'm just going to give my docs file. Okay, so once I do the split, okay, I'm actually going to get some values over here, and this will basically be my final underscore documents. Okay, once I get this over here, you'll be able to see that. I'll go ahead and execute it. So here it says, hey, expecting string or byte like object. Now see, there is one problem that you will be seeing over here when we are dividing this entire text into documents. Okay, so here I've used split underscore create underscore documents, but you can actually see my return type of this particular docs, right? What is the return type of this particular docs? It is nothing but document. So if I go ahead and see the type of docs, so here you'll be able to see that, hey, you'll be able to see, hey, it is a list. Okay, if I go ahead and see docs of 0, here you'll be able to see it is a kind of document. Okay, but the function that we have used is saying create document. Okay, so create documents will be helpful when we use along with the text file or any other file. I'll also show you one of the example with respect to the text file. Okay, instead of using create underscore document, we will just go ahead and directly use split underscore document, because see, already we know here I'm going to pass all my documents over here, and based on this I'm going to split it. So now if I go ahead and execute it, now here is my entire final documents. Right now this final documents is again a list of documents. So let me do one thing. Okay, let me just go ahead and print. Okay, final document of 0, and then I will go ahead and print final document of 1. Okay, so here you will be able to see this is my page content. Now focus on this words, University of Toronto, with all this information. Okay, and if I go last, okay, so here also you can see University of Toronto, right? Now why we are actually getting this? Because there is an overlap, right? So this is my first document, the first document with 500 characters, and as I said, there will be an overlap of how many characters? There will be an overlap of 50. So that is the reason you'll be able to see that some of the last characters in this will be again getting repeated in the forward, right? So University of Toronto is there, then here you're actually getting this information. You can compare it. Okay, so that entire information is basically getting displayed over here, right? So this is one way how you can probably split the documents using this recursive character text splitter. This is nothing but here you're trying to recursively split all the text by characters. Okay, now this is one way. Let me do one thing. Let me if you remember, I had actually created this speech text. Okay, so I'll say Reveal in File Explorer. I will copy this data. I'll put it in my next folder in Data Transformer, and let's go ahead and read this also. So in order to read it, you know how do we read it, right? Here you can probably convert this entire things into probably a documents or how you specifically want. So let's go ahead and read in this way. So here I'm going to use this. Here let's go ahead and write loader.load, and finally this basically becomes my documents. Okay, so this will be my documents, and here we'll go to write loader.load. Okay, now I'll go ahead and write print, or let's go ahead and display this particular docs. Now whenever I do this, by default I'll be getting the return type as document. Okay, let's say I will try to read this document, that is speech.txt, in another way. Okay, so here I'm going to write with open, right? Open function, I hope everybody knows in Python. And here what I'm going to do, I'm going to basically write my speech.text. Okay, and then we are just going to create a file variable f with some context over here. And let's say I will go ahead and create a variable which is called as speech. Okay, and finally we will go ahead and read this entire speech. Okay, so once we read this, let's you can also basically see like what kind of document this is exactly. Okay, and let's say for here I'll go ahead and initialize this particular speech variable to something like blank. Okay, blank right now. Okay, now let's see this particular speech. You'll be able to see that I'm able to read the document directly. So this is not giving me a document type. This is directly giving me the text that is present inside this txt file by just reading this. Now I'm just going to use this text splitter with recursive character text splitter. Okay, now here I'm going to give a smaller chunk size because I know that the elements are very less. So let's go ahead and give the chunk size of 100, and then I'll give the chunk overlap of 20. Okay, so these are the two information that I will give. Then I will take this text. You know, my return type is specifically text from this particular speech variable, right? Let me remove this right now. Here, what I'm actually going to do, I'm going to basically go ahead and write text splitter dot. Now, if I want to probably see after this particular step, you know that I have to convert all this text into vectors, and then afterwards store all these vectors into a vector database. It is a good practice because over here, whenever we work with LangChain, it makes sure that hey, it tries to convert everything into a document type. Because if we try to convert a text into a document type, we will have more features which we can specifically implement. Now, in order to convert this text splitter, whatever text split we are basically doing, and if I use this particular function, which is called as create documents. Okay. Now in this create documents, if I give my speech, okay, in the form of list, okay, this will basically give you your entire text. So I will just go ahead and print my text. Okay. So here you can see it has got converted into this particular document, right? And finally, you are able to see this. Okay. So text splitter dot create documents. Okay. Right now, the 100 chunk size was there. I think it is less than 100. So I'll just go ahead and make it 50. Let's go ahead and make it 10. Okay. So now if I go ahead and execute it, let's see this. Okay. So I'll just go ahead and print text of 0. Okay. So this is my first one that I'm actually getting. The world must be made safe for democracy. Okay. So let's increase this size. So here you can see the world must be safe for democracy. Its peace must be planted upon the tested foundation of. Okay. Now if I go ahead and print my second document, text of 1, you'll be able to see. See this, the world must be safe for the democracy. So here, let me just increase the chunk size, then it'll be much more better. So here you can see, world must be safe for democracy. It must be planted upon the tested foundation of. See, it is getting repeated. This 20 chunk size is basically getting repeated. And this is my second chunk that you'll be able to see, right? So for all these things, we actually use something called as recursive character text splitter. I've also shown you if you have a text, if you just have a text, how you can actually convert this into a document type. And if I just go ahead and see this type, it is nothing but it is document type. So if I go ahead and just go ahead and write type of this, it is nothing but it is a document type. Okay. So this was some of the basic examples of using recursive character text splitter. Now in my next video, I will be showing you more other splitting technique. You can also do it by characters. You can do it by HTML headers and all. So that is what I'm actually going to discuss in the next video. Thank you. Hello guys, so we are going to continue discussion with respect to text splitting technique. In our previous video, we saw about recursive character text splitter. We saw all the code over here. I forgot to talk about the specific points, which I've again mentioned it over here. This text splitter, that is recursive character text splitter, is the recommended one for the generic text. Okay, it is parameterized by a list of characters. It tries to split on them in order until the chunks are small enough. Okay, the default list, that basically means they use this specific list, like slash n or a new line, blank space, right? They use these characters to probably do the splitting. Okay, this has the effect of trying to keep all the paragraphs and then sentences and then words together as long as possible. Okay, there are also two important things: how the text is split by the list of characters, which is used over here, and then how the chunk size is measured by number of characters. Okay. Similarly, in this video, we're going to discuss about character text splitter. Okay, so this is also another way, this split based on a given character sequence. Okay, right now the default character is /n/n. Over there in the list of character, you had /n/n/n blank. Okay, here you have /n/n. Similarly, here also you have 2 points: how the text is split by single character separator, how the single character separator we will be providing. Okay, how the chunk size is measured by the number of characters. So let me go ahead and show you this example also. So here you can see that I have this particular text loader. Okay, I'm reading this speech.txt. Okay, and again it is in the same folder location that I've actually created over here in the data transformer. Okay, so once I go ahead and execute this, so here you'll be able to see this is my entire document page. Okay, just by using loader.load, you'll be able to get the documents, which we have seen in our previous video. Now, in order to import it, I will be using from langchain underscore text splitter import character text splitter. Before we used to import recursive character text splitter. Okay, then we'll go ahead and initialize this character text splitter. The first parameter that we need to give is a separator. So here I'm giving new line as a character, as a separator. You can also give blank if you want. Okay, then you have chunk size. I've given chunk size of 100, chunk overlap of 20. Okay, then we are just splitting this entire document with the help of these documents. So here you'll be able to see these are my documents. The world must be safe for this, and all this particular documents will be over here. Okay, now let's focus on this. It says that he created a chunk of 470, which is longer than the specified 100. Okay, why it may have done this? The reason is very simple, because it was not able to find out the separator. Okay, so that is the reason. What it has done is that wherever it was able to find out the separator, based on that, it has basically created the chunk size. Okay, now this is very simple. Okay, now coming to the next one, again we'll try to open this speech.txt. We are again using this character text splitter. By default, if you are not giving separator, then it will be /n/n. Here we are seeing chunk size is equal to 100, chunk overlap is equal to 20, and then we'll use this creator underscore splitter dot create documents of speech. And then we'll use the text of 0, text of 1. So this code I have already written it over here. That is the reason I'm just showing you so that you can actually go ahead and check it out. So once I execute it, this is my page content, and here you will be able to see that all the information with respect to this page content is possible. Now again, question comes, which one should we use? Should we use recursive character text splitter or character text splitter? Guys, this is the most generic one. Okay, so whenever you have an opportunity, you have a choice from this particular two you want to select, go ahead with recursive character text splitter. So I hope you like this particular video. I will see you all in the next video, and this time we are going to talk about HTML text splitter. Okay, so yes, I will see you all in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to text splitters. Now we are going to see how we can split by HTML header. Okay, so there is an amazing library again which is called as HTML header text splitter. It is a structured aware chunker that splits text at HTML elements level and adds metadata for each header relevant to any given chunk. It can return chunk elements by element or combine elements with the same metadata with the objective of A, keeping related text groups more or less semantically, B, preserving context-rich information encoded in the document structure. Okay, so yes, I know you'll not be able to get much from this specific information, but don't worry, I will just go ahead and show you this particular code. Okay, so first of all, I will go to from langchain underscore text splitter. Okay, we are going to import HTML header text splitter. Okay, now after this, what we are going to do is that we'll take one HTML string. Okay, so let's go ahead and copy this HTML string. So here I'll be putting this information. So here you can see doc type HTML, right? Body, foo, submit robot foo, bar main section. Some tags we have given like header tag, t tag, div tag, right? So different tags are there. Break commands are specifically used, right? Over here, br. And the paragraph is there again. We're closing the body, we're closing all the divs and HTML. Okay, so let's consider that this is my entire HTML string. Okay, now what I'm actually going to do over here is that I will just go ahead and create on which all headers I need to split, right? So I'll say, hey, headers underscore to underscore split underscore on. Okay, and this will basically be my header splitting. Here I'm going to write h1 header. Okay, so let's say this will basically be my header 1. Okay, header 1. I'm just renaming it over here, something like this. So this will be my h1 tag, whatever h1 tag is there. Then let's go ahead and write. Okay, I also want to probably play with my h2 tag, so I'll just go ahead and write over here. So this will be my header 2. Okay, I'm giving some custom name over here, header 2. And finally, I'll also go ahead and use h3. Let's say h3 tag, and this is nothing but my header 3. Okay, so these are my headers tag that I'm using to split. Okay, now in order to use this tag and probably do the splitting, what I will do, I will go ahead and write HTML underscore splitter is equal to HTML text splitter. And here I'm going to basically use this header to splitter on. Okay, so this is the parameter also. So you can just go ahead and assign this parameter over here. Also, header splitter on is equal to this. Okay, otherwise I know I am going to use that, so I'm just going to use this. Okay, now this is fine. Now what we're going to do, we're going to basically write HTML underscore splitter dot split underscore text. So we're going to probably use split underscore text, or there is also options. Yeah, split text is what we're going to use over here. And here I'm going to give my HTML string. Finally, I'll save all these things into my variable, which is called as HTML underscore header underscore splits. Okay, so now I can go ahead and write HTML underscore header underscore splits, and let's go ahead and display this. So once I probably see this, now here you can see I've used these 3 tags, h1, h2, and h3. So let's see where foo was there, h1 tags, right? So based on this h1 tag, I was able to get another page document, right? Some intro about foo, where it is basically present in the t tag, right? Some intro about foo, so this has also become another tag over here, right? Header 1 of metadata, you can see over here, foo, bar main section. Then you can see some about the first subject, something was written, right? So here again with the h3 tag, another division is specifically made, right? So here you can see all the tags have been basically created with the kind of headers that we have actually used, and metadata information has also been shared over here based on the tags that we have actually splitted this entire content. And finally, you can see that when we are splitting this into text, I'm able to get in the form of documents. Okay, so this can be handy. Again, it is up to you how you specifically want to use it and where you really want to use it. Okay. Not only this, let's say that I have some kind of URL. Okay, so let's pick up some URL over here. So I will just open my browser. Let's see. So this is my tag. Let's see. Okay, let me just go ahead and open my browser over here. Okay, and with respect to this particular browser, so this will basically be my browser. Here I'm going to take one URL. Let's say this is my URL over here. I'll just copy and paste it over here. So once I am uploading this particular URL, this URL provides some information over here, right? So here you can see some information is there. And if you go ahead and inspect all these elements, there will be some kind of header tag. There should be something, right? A h1 tag, h2 tag, and h3 tag. So what I will do, I will create this particular URL, go back to my code, okay? And let's take this URL. And I'm saying, hey, header to split on, and then I will try to just split that same condition, whatever I've actually written over here, right? So I'll go ahead and say, hey, split this particular URL, and finally I'll be also able to see the splits. So if I go ahead and write HTML header splits, so here you'll be able to see it will take some time because it will be a bigger website, and here are all my documents that has got separated, right? So this can be really, really handy wherever you specifically want to use it, okay? Whenever you have something like HTML and all, right? So I hope you like this particular video. Yes, this was it. Again, there are many, many techniques with respect to character text splitting, which you should keep on exploring. Also, make sure that you always check the documentation of the LangChain to see what all new techniques are specifically coming. So I hope you like this particular video. Again, guys, we are still in this particular phase. That is second one. Now we are going to go into the third one, right? That is nothing but the embedding techniques. So yes, I will see you all in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to text splitter, and in this video we are going to discuss about how to split JSON data. Let's say that if we are getting a chunk of JSON data from an API, right? After that, if we read that entire JSON data, how do we split that into chunks so that we'll be able to pass it to our LLM model? So here, the JSON splitter, this JSON splitter that we are going to use, split JSON data while allowing control over chunk sizes. It traverses JSON data depth first and builds smaller JSON chunks. It attempts to keep nested JSON objects whole, but will split them if needed to keep chunks between a minimum chunk size and the maximum chunk size. If the value is not a nested JSON, but rather a very large string, the string will not be split. If you need a hard cap on the chunk size, consider composing this with a recursive text character splitter. So what you can basically do, you can also use along with recursive text splitter. There is an optional pre-processing step to split list by first converting them into JSON dictionary and then splitting them first. Okay, how the text is splitted based on JSON value, how the chunk size is measured by the number of characters. So same thing is basically happening over here. Now let me just go ahead and show you how we can probably go ahead and implement this. For this, I'm going to take this specific example as my API. Okay, so this is a very huge API, right? So big API with all the information that I'm actually giving. I'm saying not huge API, but if I'm hitting this API, I'm able to get so much of information right over here, right? So what I'll do is that here, obviously, we cannot read this entire chunk and just use it, right? Instead, what I'll do, I'll try to convert this entire API response in chunks, and then we'll see that how things will work. Okay, so let's quickly go ahead and do this. So first of all, what I will do, I will be using import JSON. Along with this, first of all, let me go ahead and select the kernel, and here I'm going to go ahead and import my request library. Okay, let's go ahead and call my JSON data. Now inside the JSON data, we'll be using this request library, and I'll be saying, hey, request.get. Okay, request.get. So once I write request.get, all I have to do is that I have to give my URL over here, right? So this is a get request since I'm reading this entire API, right? So I'll go ahead and hit this particular API over here, and here what I'm actually going to do, I'll also convert this into .json. So once I get this will basically be my JSON data, right? So if you want to probably go ahead and see your JSON data, it'll be a huge file. So this is the entire information with respect to the JSON over here, right? And right now here, most of the information is not visible because if you click on scrollable element, then you'll be able to see it. Now what we'll do, we will use this from LangChain text splitter. We will import something called as recursive character or recursive JSON splitter, right? Because here we know that there are also nested elements inside this particular JSON. Okay, like JSON has a value, inside that value there is another JSON. Okay, so what we'll do over here, we'll quickly go ahead and write our JSON splitter. So I will just go ahead and create my JSON underscore splitter, and here we will be initializing this recursive character JSON splitter. Here we can give a maximum chunk size. Let's say the maximum chunk size that I want to give is 300. Okay, and after this I will go ahead and write JSON underscore chunks is equal to JSON splitter dot split underscore JSON. Okay, and here we are going to give our entire JSON underscore data. Okay. And this is what is my JSON underscore data, which I have actually got it over here. Okay. Once I get this, then you'll be able to see that I will be able to get this JSON chunks. So now if I go ahead and execute the JSON chunks, you'll be able to see, hey, we're getting something, but right now again you'll not be able to see it. So what we'll do, we'll just go ahead and print the top 3 chunks. So I'll write from chunk for chunk in JSON underscore chunk. Let's take the top 3 element, okay, the top 3 document, and then we'll go ahead and print the chunk. So here I'll just go ahead and print it. So this is my first chunk, OpenAI in the key value pairs. Then the second one with respect to path, then third one with respect to path, right? And this is how easily you are able to probably get this entire information. You may be also having a scenario right now. If you see this chunk, it is normally in the key value pair, but let's say I want to get this into documents. So the splitter can also output documents. Okay, so here I'm going to create my documents, and let's go ahead and use the splitter again. Sorry, JSON splitter dot. Here instead of writing this, I'll use create documents. Again, in the create documents, we will give a parameter which will be my text, and here I'm just going to give my JSON underscore data. Okay. Now once I get my docs, again I can go ahead and display for doc in docs of, let's say, the top 3 docs. I'll just go ahead and print the doc. So here you can see this is my documents, right? The same information that I'm able to get it. Okay. Now let's say that I want to also directly get the string content. Okay, I don't want in this particular format like page underscore content or something like that, right? So for that also what you can do, you can directly get this particular text just by writing splitter or JSON splitter dot split underscore text, right? So there's also split underscore text, split underscore JSON, and here I'm just going to give my JSON data. Okay, and if I go ahead and write print, let's say text of 0, and let's go ahead and print the text of 1, you'll be able to display both of them, right? So both this information is basically getting displayed. So I hope you got this idea about how you can split with JSON with the help of recursive JSON split data. Let me just see the library in recursive JSON splitter. Okay, and again, these are just the splitting techniques. Now in the upcoming videos, we are going to see about different embedding techniques. Hello guys, so we are going to continue our discussion with respect to LangChain. Till now, we have discussed about step 1, that is loading from various data sources with the help of document loader. This was loading different kind of data itself. Then we went to the second step, wherein we converted all these documents that we loaded into text chunks or document chunks. And we saw again various different methods over here. Now coming to the third step here, what we are going to do is that we are going to probably take this text chunks or document chunks and convert this into vectors. Now converting a text chunk or a document chunk into vectors, there are various ways. Okay. In our session, what we are going to focus on, we are going to focus on 3 important techniques. One is with the help of OpenAI library. Second, we will be seeing something called as Ollama. Okay, we'll discuss about what exactly is Ollama. And the third technique that we are going to use is with the help of Hugging Face. Okay. Now out of this, it's not like only these 3 embedding techniques are there. There are a lot of different techniques that are available. But if you know all these 3, that will be more than sufficient, because in terms of accuracy with respect to the embedding techniques, I think these 3 will be more than sufficient. Yes, there are different LLM models. Like say you have Google Gemini. For Google Gemini, you have different embedding techniques. If you're using other models like Cloudy, right, Cloudy 3 from Anthropic, there they have a different embedding techniques. But what I feel for our course, these 3 embedding techniques will be more than sufficient. If I probably consider with respect to OpenAI, this is paid. Okay, with Olama, you can run this embedding techniques from local. So this will be using open source. Okay, and Hugging Face also, we will try to use an open source embedding technique. Okay, so we are going to come up with 3 videos. First of all, we'll discuss about OpenAI, how you can probably go ahead and use an OpenAI API, and how you can use OpenAI embedding techniques to convert text into vectors. Then we'll go with Olama, and then finally Hugging Face. So this is the plan of upcoming videos. In this video, let's focus on OpenAI. Now quickly, I'm going to go to my browser over here. Okay, if you go ahead and search for OpenAI, okay, API key. Okay, now I hope everybody knows about OpenAI, right? It has brought up this entire ChatGPT, right? And I hope everybody's maybe using ChatGPT. Now inside that, you will be having a lot of LLM models. Right now, the recent model is GPT-4o, right? And again with OpenAI, there's OpenAI embedding techniques also available, right? So for this, I will be requiring my OpenAI API key, since I said that this is paid. So if you go ahead and go to this particular URL, that is platform.openai.com/playground. Please go ahead and create your account if you have not created it. And here you just need to invest $5. Okay. The reason is that go ahead and check it out, because the reason why I'm showing you OpenAI embedding, because the accuracy is amazing in this. The accuracy with respect to implementing with the help of APIs, any chatbot solution, it's amazing, right? Many companies are using it, so that's the reason. You need to probably invest $5 to check out how the API key actually works. So in the OpenAI, you will be able to see, if I go to my settings option over here, there'll be something called as billing, right? So right now you can see I have $2.82, and let's say if I want more, I will probably keep on uploading because I've added some payment methods. Okay. Now what I will do, I'll go to my dashboard and I'll go to my API key. So here you can see I've created 2 API keys. You can go ahead and create your own API key. Okay, give any name over here and just click on create secret key. So once it is created, it will give you the entire API key. Just go ahead and copy and paste it. Okay, I'm going to keep this as hidden because if I share here, again you'll be using it, and again I may finish up all my balance, right? So your API key will start with SK dash, okay, and the remaining key will be available over there. So once you create it, please make sure that you copy it, and then we will go ahead and create an environment variable for this. Now I will go to my code. Okay, now in my environment variable, see over here, if you see in this folder, I have this .env file. Now this environment variable is like I will be storing my API key over there. I'll not show you the environment variable because I've already stored my API key over there. So for that, you just need to write OpenAI underscore API underscore key and just go ahead and use equal to, and your key should be pasted in this format, right? So whatever key will be present, you just go ahead and copy and paste it over there, right? Now this will be the environment key that will be available in your environment variable. So if I go ahead and open this, probably you'll be seeing this key value pair over there. Okay, you just need to write OpenAI API key and this particular information. So please do that particular step. So I'm not going to show you because it is crucial not to show your OpenAI API key. Now, if I really want to call that API key of the OpenAIs, I have to load that environment variables in my coding environment. Okay, how do I do that? So for this, you will be requiring one library. So first library is python-.env. Okay, we will be using this specific library. Why do we use it? Because with the help of this particular library, you'll be able to see that I will be importing something like this from .env import load _.env. And when I initialize this, it will basically call all your environment variables in your coding environment. Okay, so first of all, we will go ahead and install this. Okay, python-.env. Okay, now since we are also working with LangChain with OpenAI, right? So there is also one more library that we will be requiring. That is nothing but LangChain-OpenAI. Okay, so these 2 libraries I will be requiring. First is to load the environment variable, and second is nothing but LangChain OpenAI. So I'll go ahead and open my terminal over here. I'll clear on my screen. So let me clear on my screen, and here I'll say hey pip install -r requirement.txt, and please make sure that it is there in the environment variable. Okay, so I'll go ahead and execute it. Okay, so finally here you can see that the requirement is already satisfied, and here I've already done the installation of this. So this both the libraries has been installed. Now let's go back to our embedding technique and let's see how can we specifically work with LangChain -OpenAI. Okay, and we'll go step by step in order to understand this entire thing. Okay, so first of all, I'm importing OS, and then I'm importing this. This is for my environment variables, to load all my environment variables. Load all the environment variables. Okay, perfect. Now you'll be able to see that I'm getting true. So obviously it is saying that hey, it is loaded. Now I'll go ahead and write os.environ. Okay, and you know that I've created my OpenAI API key. So I'll write OpenAI _ API key, and I'll set this environment variable by calling my environment variable that I've saved in my env file, right? So this will be get environment variable with OpenAI _ API _ key. Okay, so this is what I'm actually able to get. So once I execute this, that basically means my environment variable has been loaded. Okay, now in order to use the embedding technique, now what exactly is embedding techniques? Here we are converting our text into vectors. Okay, that is what we are specifically doing over here. Okay, we are converting the text into vectors. So for using the OpenAI embedding, I will go to LangChain. From LangChain _OpenAI, I'm going to import OpenAI embeddings. Okay, so this OpenAI embeddings. Now this is what I'm actually going to use. Okay, now in OpenAI embeddings, you have different models. In order to check it out, what I will do, I will just go back to my documentation, and here you'll be able to see all the models, what all models are specifically there and all. So here you can see documentation. Okay, so in the documentation, here lot of different functionalities available, right? And we will be also using OpenAI later on to create many Gen AI projects. So here you can see you have models, right? With respect to model overview, you have all the specific models like GPT-4o, GPT-4 Turbo, GPT-4o, GPT-3.5. If you want to work with images, that is DALL-E. Then you have audio for Whisper and all. But right now I'm focusing more on embeddings. So I'll click on this. So see, a set of models that converts text into a numerical form, or I can also say it as vectors. Okay, and that is what I have written over here. If I want to convert a text into vectors. Okay, so I'll go ahead and click on this. Right, later on we'll be seeing all the specific models once we develop an application. So here you can see in embeddings you have this many number of models. One is text embedding large, right? Text embedding 3 small, text embedding ADA002. So here you can see this is the most capable embedding model for both English and non-English tasks. The output dimension is 3072. Increased performance over second generation embedding model. Most capable second generation embedding model. So what we will do is that we'll try to just use this and we'll call this particular model for our embedding purpose. Okay. So quickly let's go over here, and here I have initialized OpenAI embedding. Now I'll call OpenAI embeddings, and let's go ahead and call my model. The model is nothing but it will be text embedding 3-large. Okay, so this is my embedding model that I'm actually going to use it. Okay, so I will just go ahead and execute this. So if you go ahead and execute this embedding, it will show hey, it is nothing but it is an OpenAI embeddings. Okay, and here you can see all the other information at this particular memory location and some of the default parameters that has been assigned over here. Now let's test this OpenAI embedding. So let's say that I'm going to consider text, and this text will be like this is a tutorial on embeddings on OpenAI embedding, right? OpenAI embedding. Okay, now Remember, this OpenAI embedding is not completely for free because there will be some charges that will be applied for this particular embedding. Okay, but since and it will be a minimal charge anyhow for to test our application and all. Okay, so here what I'm actually going to do, I'll take this particular text and I'm going to say, hey, embeddings dot, and I'm going to probably convert this text into vectors. So here I'm actually going to go ahead and write text. Okay, so this basically becomes my text. Okay, my vectors. So in order to see my vectors, I will just go ahead and see my query underscore result. Okay, and I'll go ahead and execute it. So let's go ahead and see this query underscore result over here. So it is going to take this particular text and it has converted this. Okay, converted this into a vector. Now let's see the dimension for this. Okay, so if I go ahead and write query underscore result of 0. So this is my first vector that is visible. Let me do one thing. Let me just go ahead and write length of query of results. So here you can see 3072 dimension is there, and that is what we got from the documentation, right? So what it does is that it takes this entire sentence and it converts into a vector of 3072 dimension with all these values. So you'll be able to see all these values over here. Okay, and that is what is all about. How it probably converts a text into vectors, right? See, you can definitely do multiple in different ways also. Okay, and what I can also do is that I can go ahead and set my own dimensions. If you want, let's say that I don't want to go with 3072, which is the default, I can just copy the same thing. Okay, let's say I will go ahead and call these embeddings again. Okay, I'll paste it over here. Now inside this embeddings, what I will write, I will go ahead and say, hey, this is my dimension. Okay, this is my dimension, and this time I will say, hey, just convert this into 1024 dimension, right? And this dimension I will just go ahead and say embedding underscore 1024. Okay, so once I execute it, you'll be able to see this over here, and embeddings underscore 1024. So this is my embedding. Okay, now I'll do or execute the same code over here. So let me just go ahead and paste it over here, right? So this is the sentence that I'm actually going to do. I'll write 1024, and here let me just go ahead and write query result. So here I'll just go ahead and write length of query result because it needs to show me in 1024 dimension. So here you can see I'm able to get into 1024 dimension, right? And if you want to see the result, so this will be your vectors for that same text. Okay, so this was a simple way of converting an embeddings of any text into vectors. Now let me do one thing. Let me just go to my one of the example over here, recursive character text vector. Okay, so let's say I will be taking one example, okay, and I'll try to convert that entire thing into, so let's take the speech.text, okay. I will copy this, I'll put it in my embedding, okay, and here I'm going to just copy this entire thing, paste it, okay. So I'll just show you for an entire document how you can actually do. So once this basically comes, this will basically be my document, okay. Then what do we do after we get the document? Here I can say loader.load. Then with respect to this loader.load, I will just go ahead and convert that into recursive. I'll split that based on my recursive character splitter. Okay, so I'm just going to copy and paste it over here. Okay, I'm going to take this particular documents, and this basically becomes my 500 documents. So here is my all the text that I have. Now once I use this code over here, what I'm actually doing, I'm taking this entire documents and I've done the recursive character text splitter and converted this into chunks of documents. This is perfect. Okay. Now what I really need to do is that I need to take all these documents and convert this into vectors and finally store it in a vector DB, right? Vector store DB. Now this is really important. Please focus on this. So what I'm actually doing is that I will combine both of these steps. First, I will take this entire chunk of documents, convert it into vectors, and then store it into the vector DB. That's what I'm planning to do. Okay. Now, how do I actually do it? I'll just give you one example. Okay. And one of the vector database that I'm actually going to use. So here, what I'm actually going to do, I'm going to combine vector embedding. Since we have a list of documents. Okay. Since I have a list of documents, I will combine vector embedding and vector store. Okay. So let's say for this particular example, I'm going to use a vector store DB, which is called as Chroma. Okay. We'll discuss about vector store DB more in depth in the upcoming videos. First of all, I just want to give you a simple basic example. Let's consider that I'm going to use a vector store DB, which is called as vector stores, which is called as Chroma. Okay, so this will be my vector store DB. Okay, again, it is an open source. You can use this. Okay, now my main aim is that with the help of vector embedding, first of all, I need to convert all these documents text into vectors. Okay, that is the first step, and then finally store it in the Chroma DB. So here I will go ahead and write DB is equal to, let's crawl this particular Chroma. Okay, dot. I'll just go ahead and call from documents since we are working with documents. Okay. Inside this vector store DB, the first parameter that goes is nothing your final documents, okay? And the second parameter is nothing but your embedding technique that you're going to use. Let's say I'm going to go ahead and use this embedding technique of 1024. Okay, where did it go? Here. Let's say I'm going to use this embedding technique. So I'm just going to copy it. I'm just going to paste it over here. So this basically becomes my vector store DB. Okay, so if I go ahead and see this DB now, it will get executed, and I'm getting an error. Could not import Chroma DB Python package because I need to go ahead and install Chroma DB because this is a vector store DB. So I'll go ahead and open my terminal, and first of all, I'll just go ahead and update my requirement.txt, and let's go ahead and quickly install this. Chroma DB is another vector store, and it is in the form of library. We will first of all go ahead and install this, okay, and then only we'll be able to use this. But here, what we are doing is that we're combining vector store DB along with vector embedding techniques, and that is the code we have written it over here, right? So it'll take some time to do the installation. So here again, let me repeat it. First of all, we are importing Chroma. We have already created our embedding underscore 1024. This is nothing but this is OpenAI embeddings, and in Chroma DB, what I'm actually going to do, I'm going to use this function under dot from underscore documents. I'll give all my final documents. And on all these final documents, I need to apply this particular embedding technique, and finally we get this particular vector store DB. Okay. Again, based on your internet connection, it will take some time, and again, this will be open source vector store DB, which you can also use it. Yes, for deployment, I will also be showing you. I'll be using some of the vector database where I will be deploying it in the cloud, and from that also you will be able to call it. Okay. But just get an idea here. Instead of just using just a vector embedding, converting that documents into text, it is also good that you get to know about how to store it in the vector database. As we go ahead, right now I'm just going to discuss about one vector database called Chroma, but as we go ahead, we'll be discussing more about different vector databases. So yes, this installation has taken place. Now I think it should get executed. So now if I'm executing it, you'll be able to see that I'll get a DB, and it says that hey, it is a vector store, and this is my Chroma at this particular memory location. Now, how do I query from this particular vector database? Okay, so first of all, I'll just go ahead and open this particular speech text. Okay, let's say I will be copying this entire content and I'll be searching. Okay, over here. So here I will go ahead and write. This will basically be my query. Okay, I've just used some text over there, and I'll say, hey, use this DB and do some similarity search. Okay, similarity search. And here I'm going to basically use this particular query. Okay, and here I'm going to save this entire in one variable which is called as retrieved results is equal to this one. Okay, and then I will go ahead and print it. Retrieve. So we'll just go ahead and write retrieved underscore result. Okay. And I'll just go ahead and execute it. So here you can see I'm able to get the response. I'm doing a similarity search, right, on a specific query. I want to retrieve some information from this particular vector store DB. I've taken a text from that, and I'm searching by using the similarity search method. And finally, you'll be able to see I'm able to get that entire information, right? It will be all easier to conduct. And finally, you'll be seeing that entire text, the context has got explored and it is basically searched this and it is basically displaying over here, right? And that is the power of vector store DB, right? Now, I hope you are able to understand how step by step we have taken a text, we have converted that into vectors, and finally, with a document over here like this .txt file, we use all the methods. First of all, we did the data ingestion. Second, we did the text splitter. Then third, we applied vector embedding along with vector store DB. And fourth, we have also retrieved the results, right? So here you'll be able to see what did we do over here. We retrieved the results from querying vector store DB, and here what technique we have applied? It is nothing but we have applied similarity search. Okay, so I hope you are able to understand all these things. Now in my next video, I'm going to show you with some open source libraries like Ollama, how you can actually do it, and then we'll also be discussing about Hugging Face. Okay, so yeah, this was it. I hope you are quite excited to understand this entire session. I will see you all in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to the embedding techniques. In our previous video, we have already seen how we can use OpenAI embeddings and convert your text or document into vectors. Let's say you do not want to use OpenAI API, then you can also go ahead with open source models. And one of the way of using this open source models and use the embedding technique is through this platform which is called as Ollama. Now in this video, I'll show you how you can probably go ahead and do the setup of this Ollama and how you can run the code. Okay, so what exactly is Ollama? Ollama is a kind of platform where you'll be able to use open source LLM models like Llama 3, Phi 3, Mistral, and Gamma. These are various open source models that are available right now, and you can probably run all these models in your local machine itself, in your local workstation, right? So here you can see get up and start running with large language models. I'll be showing you this particular Ollama platform. You can download it in your local machine, and then you can download any of the specific models, and then you can use this LLM models. Okay. Now, when we discuss about embedding techniques with respect to this Llama 3, Phi 3, Mistral, Gamma, there are also different embedding techniques with respect to that, right? If I go ahead and use Ollama embedding, then let's say that I've installed Llama 2 or Llama 3, then I'll be able to use the embedding techniques that are available over here. So let me just go ahead step by step. First of all, we'll see how to download this particular Ollama platform. I will go ahead and click on this Ollama. First of all, you need to go to this particular website called as ollama.com. And if I go to this GitHub of this, it is a complete open source. Here you'll be able to see that it supports all these open source models. Okay. So here you can see all these open source models like Llama 3, 8 billion parameters, Llama 3, 70 billion parameters, Phi 3 mini 3.8 billion parameters. Then you have Gamma, Google Gamma, 2 billion, 7 billion parameters. Then you have Mistral, Moonrim, Neural Chat, Starling, Code Llama. So we will be using all these specific models as we go ahead. We'll be creating end-to-end projects by using all these models. Okay. So first of all, I will go ahead and click on download. As soon as I go ahead and click on download, you have this particular platform in all the operating systems like Mac OS. Then you have Linux. Then you have Windows. Right. So right now, since I have a Windows machine, I will go ahead and download this particular Windows exe file. Okay. For this Windows, we will have a exe file that will get downloaded. But one condition is that you really need to have Windows 10 or later. Then only this will work. Okay. So this is one of the criteria. So in order to download it, just go ahead and click on this. So as soon as you click on this, you'll be able to see that I will be getting an exe file that gets installed. Okay. Once this exe file gets installed, the installation is pretty much simple and easy. So here, what I will do is that I just go ahead and double click that particular exe file once this gets downloaded, and just keep on clicking next. Okay. Once you finish the installation, here in the bottom section, you'll be seeing one icon. So this kind of icon, you'll be able to see it. I'm not able to zoom in much more over here, but just here you can see this particular icon will get enabled. Now this icon is nothing but it is the icon of Ollama. Okay. So first of all, you just download the exe file, double click on that, and keep on just pressing next, and do the installation. As soon as you do the installation, an icon will be running in the backend. Okay. Now let's go back and after the installation, I've already done the installation, so I will show you how you can go ahead and download this kind of models. Okay. So after you do the installation, just go ahead and open your command prompt. Now in this command prompt, let's say I want to go ahead and use Llama 3 or Llama 2 or Gamma model. Okay. So I will just go ahead and use this or run this command. Right. So let's say if I go ahead and write Ollama run Gamma 2 billion parameters, I will go over here, paste it. So Ollama run Gamma 2 billion parameters. As soon as I run this command, if this particular model is not downloaded in my local, right? So first of all, what it will do, it will pull this entire Gamma 2B model and then it will download it in my local machine. First of all, let's say if it is already downloaded, then this chatbot will automatically get started. So let me go ahead and press enter. So here you'll be able to see that I have already downloaded this model. Okay. So here you'll be seeing, hey, nothing has got downloaded because already in my local machine it has got downloaded. If you're doing it for the first time, initially this particular model needs to get downloaded. So as soon as you write this command, Ollama run Gamma 2B, so it will keep on downloading and it will take some amount of time because this particular file is 1.4 GB. Okay. So once you have this, you can go ahead and chat it. Hey, hi, who are you? Okay, I'm a large language model trained by Google. I'm capable of engaging in a whole wide range of conversation on various topics. Okay, so here you have all the information. You can ask any question as such. Similarly, you can go ahead and play with any model that you want, any model that you want to work with, like Llama 3, Llama 3 70 billion, Phi 3 from Microsoft, right? Any of the models that you really want to play. Now, once you do this installation and everything is working fine from the command prompt, now it's time that we go ahead and start our coding. Okay. So first of all, let me just go ahead and open my Ollama embedding. So here, what I will do is that I will just hide my face. Okay. So here you can see Ollama supports embedding models, making it possible to build a retrieval augmented generation. So this is basically a RAG application based on the architecture that I've actually discussed. Okay. Now, first of all, one of the libraries that you require is LangChain_community. Okay. So I'll just go ahead and write LangChain-community. Let me use this particular thing, and along with this, what I'm also going to do is that I'll talk about one more library that will be required. But before this, let's go ahead and install this. Okay. So here I'm just going to go ahead and write pip install -r requirement.txt, and here you'll be able to see that if it is already installed, I've already done the installation, so you can see that it has got successfully installed. Okay. Now, in order to use the Ollama embedding, what I'm actually going to do is that I'll go ahead and write from LangChain. Before that, let me just go ahead and select my kernel. Okay. Don't forget to do that. From LangChain_community, I'm just going to import. Sorry, it should be LangChain_community.embeddings. Okay. Embeddings. I'll be importing Ollama embeddings. Okay. So this is the embedding technique that we are going to use. So once this gets executed, you can see that it got successfully executed. Now I'll go ahead and create my embeddings. Okay. Like how we did it with OpenAI. And here I'm going to give my Ollama embedding. Okay. I'm initializing my Ollama embedding. Remember, once we execute this, by default, this Ollama embeddings, for which LLM model it will be probably taking up, it will be taking up for the Llama 2 model. So here I will just go ahead and write a comment. By default, it uses Llama 2. Now, if you really want to use the Llama 2, so what I will do, I'll just go ahead and open my command prompt. Let me just execute this. Okay, Control Z. You just do Control Z and exit. So if I want to use this by default, if I'm giving Llama 2, okay, over here, this is taking Llama 2. So we need to first of all install Llama 2. Okay, without installing Llama 2, it will not work. Okay, so that basically means here in Ollama embedding, I will just go ahead and write my model is equal to, and here I will give my model name. Right? Let's say, as I said, by default it uses Llama 2. Since you know that I've already downloaded which model, I've downloaded this Gamma 2B. Right? So I will just go ahead and copy this particular model and I will paste it over here. Okay, so once I go ahead and execute it, here you can see that it has got executed successfully. Now this embedding technique is basically, see the base URL is running over here, the model is 2B, and we are using the embedding technique of this specific model. Okay, now I will just go ahead and use some text. Okay, let's say one of my text will be something like this. R1 is equal to, I will write, hey, Ollama, or let me just go ahead and write embeddings dot, I will go ahead and write embed underscore documents. So this is one of the functionality that I'm actually going to use. Embed underscore documents, if you want to see the definition, it says that, hey, list of text words to embed. Inside this, I have to give the list of text that I really need to do the embedding. So here, I will just go ahead and create my list. Okay, now with respect to this list, let's say that I have two sentences, which I will be copying it over here. I'll say, hey, alpha is the first character of the Greek alphabet, and I'll say, hey, beta is the second letter of the Greek alphabet. Okay, now what I will do is that I will just go ahead and execute this. Okay, so I'm just trying to embed the specific documents, and here I'm just going to see R1, and this is what I'm actually able to get it, right? If I say, hey, R1 of 0, so here this is my first one. So first over here you can see, and if you go ahead and see the length of this, that many number of dimensions you'll be able to see. So in short, over here, this gamma model actually creates a dimension of 2048 with respect to the vectors. Okay. Now let me go ahead and try one more functionality. So here I'm going to use the same embedding, and I'm going to embed a query. See, initially I used embed documents, right? Inside this I can give a list of text that I have. Here I will be just giving one text, right? What is one sentence? So what is the second letter of Greek alphabet? And here also you could see that second I asked beta is the second letter of Greek alphabet. And when I probably go ahead and see R1 of 1, I'm actually able to get this particular vectors, right? Now this question is also something similar only, okay? Then I think both these vectors should match a bit, right? Because here I'm just asking what is the second letter of Greek alphabet. There I've given the answer. So here if you go ahead and see, just go ahead and compare these two vectors. So this is 2.18, here also you can see 2.35. So it's almost matching a bit, right? That basically means you're talking more about these two sentences are almost similar because that is just an answer saying that hey, beta is the second letter of the Greek alphabet. Here I've just asked the question as what is the second letter of the Greek alphabet, right? So I hope you are able to understand about this Ollama embeddings. Similarly, you can go ahead and try different embedding models also, right? So Ollama has different embedding models, okay? So for that, in order to show you what all embedding models it has, I'm just going to open a new browser over here and I'm going to probably hit this particular URL. So here it shows Ollama blog embedding models, right? So what are embedding models? Embedding models are models that are trained specifically to generate vector embeddings. Here you can see all the information. Now, with respect to embedding models, you also have different embedding models, right? Like say you have this MXBAI embed large, right? You want to go ahead and see this particular model, you can go ahead and see it over here, right? Like how many parameters are there. If you want to pull this, okay, let's go ahead and pull it. Let's see. Okay, so I'll paste it over here. I'll press enter. Now see, if I'm downloading it for the first time, it may take some amount of time because this is 669 MB. So this is getting downloaded. Once it gets downloaded, I can use this model. Okay. So we will wait for some time since this is basically getting downloaded. Till then, we'll go ahead and explore other models also. So inside this, you also have Nomic embed text. You also have all mini LM. So these are some very free models that are available, right? And we can actually use this kind of models and perform our embeddings, whatever things we really want to do. Okay. So for this also, I'll try to show you how to actually do it. And over here also you can see in Ollama also you have this Chroma DB. If you want to save it in the form of collections, you can actually do that and again retrieve it and generate it. It's up to you. So we'll discuss more about this as we go ahead. But in this video, as I said, we are just focusing on the embedding techniques. Now let me just go back to my command prompt. Right now, 228 to 237 MB has been loaded. Now I will just go ahead and write my code till then. Okay. So now let's say that I want to use some other embedding models. Okay. If you want to probably go ahead and explore the other embedding models, I'll keep the link over here so that you can refer it. Okay. So this is the link that is there for the other embedding models. Now, once this basically gets downloaded, the embedding model, I will just go ahead and call this. Okay. So here you can see I'm created embedding, which is Ollama embedding, and I've used the model MXBAI embed large. Then I've said that this is the text, and we try to just find out what will be the my vector, right? So this will basically be my query underscore result. Now let's quickly see how much time is basically involved. Another 200 MB, and then once this download actually happens, it is hardly taking 38 seconds. So this is what, right? If the model is not downloaded in your local, then you have to first of all go ahead and download it. And here also you can see that another 120 MB is there. Similarly, that is with respect to all the LLM models. If you do not have Llama 3, then again you have to go ahead and write Ollama pull Llama 3. Otherwise, your code will not get executed. Okay. But this in short, what is happening is that this model is basically getting downloaded in the local itself. So another 3 to 4 seconds, and then we are good to go to run this. Okay. So now here you can see it is downloaded. 11 KB. This is also downloaded. So it's just like downloading a Docker, right? Docker also gets downloaded in a similar way, right? So finally, it's got downloaded. Let's go ahead and execute it. Now I will be using this Ollama embedding with respect to MXBAI embed large, and here is your entire length. Now let's go ahead and see length of query result. So it has nothing but 1024 dimensions, right? So I hope you're able to understand about the embedding technique using Ollama. You can again try different open source embedding techniques. It is up to you. But again, our main aim was to understand how we can use Ollama and perform embedding. But trust me, if you do not have APIs, OpenAI API, you can definitely use this. And going ahead, I'll also be creating an end-to-end project with the help of Ollama. So yes, this was it. I will see you on the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to embedding techniques, and in this video we're going to see about embedding techniques using Hugging Face. Now Hugging Face also has a lot of open source models specifically used for embedding, and also different types of LLM models through which you can actually use them and create your generative AI application. So let's go ahead, and first of all what you really need to do is that just go to the huggingface.co website. Okay, so in this particular website you'll be able to see that there will be models, there will be so many things that are available over here with respect to all the tasks. So first of all, just go ahead and create your account, because later on we are going to create a lot of end-to-end projects again using Hugging Face. And the best thing about Hugging Face and LangChain is that they have created a library which is integration of both Hugging Face and LangChain itself. So you can call any LLM models that you like over here. Okay, so first of all, in order to work this, you really need to have to create your own API key, right? So once you go to the settings over here, right? Once you click on the settings here, you'll be able to see something called as access token. So just go ahead and create your access token. Okay, so here you can see I've created so many different access tokens. You can just go ahead and click on new token, give the token name, right? What type you want. You can basically select read, because you're just going to read the token to access any LLM models. Okay, so here I can probably go ahead and write LangChain. Okay, and here I will just go ahead and select read, and I'll generate a token. Now this is a token that I'm actually going to use in order to work with Hugging Face, right? All the embedding techniques that are available in Hugging Face. So now I'm just going to go back to my code. First thing first, what I really need to do if you remember, right? So here we use this .env. So same thing, I will be copying and pasting it over here because we need to call that same token, right? So what I will be doing is that I will be creating a token, a specific token in my environment variable, and the format will be something like this. Okay, so I will show you the format. So here you can see this is the format that it will be in your environment variable. So just go ahead and probably open your environment variable .env, and there you can just copy and paste this particular token in a new line, right? Like how we did it for OpenAI. Again, I'm not going to show you the .env file. The reason is very much simple because this particular token I need to keep it hidden, right? So I'll just remove this. Now what I'm actually going to do, I'm just going to write os.environ, okay? And let me just go ahead and call my Hugging Face token, hf underscore token, okay? So I'll be setting this up token over here, and I'll go ahead and write os.getEnv with respect to the same token, right? If I execute it, you'll be able to see that this will get executed successfully. That basically means in my environment variable, whatever token I've actually created, I've assigned it to this particular Hugging Face underscore token, okay? So this is the first step that we need to do, okay? Now the second step is that I will go to my requirement.txt, and here I'm going to install one library, okay? The library is nothing but it is basically called as sentence underscore transformers, okay? I have to use this particular library because in this library the embedding technique is basically available. So now I will just go ahead and open my terminal and just go ahead and write pip install -r requirement.txt. Okay, so here you will be able to see this, and all my requirement.txt will get downloaded. Now for sentence transformer, the default that library that we require is nothing but Torch. So here you can see within 30 seconds it will be getting downloaded. It is somewhere around 159.8 MB. Once this is getting downloaded, we can use this sentence transformer embedding technique for embeddings, right? So till then the installation is basically taking place. I will just go ahead and also we need to also install one more library. Since I said that recently LangChain and Hugging Face, they have combined their hands together and they've created another library which is called as LangChain underscore Hugging Face. Okay, so we need to also install this library because inside this library only we'll be finding various techniques of calling LLM models and all, which I will be discussing. But in this video, I'll be focusing more on the embedding technique. Okay, so here you can see I have my LangChain underscore Hugging Face. Now what I'm actually going to do is that as soon as this particular installation takes place, I will also go ahead and install this. Now till the installation is taking place, let's go back over here. So I'm just going to go ahead and write my code. I'll say, hey, from LangChain underscore Hugging Face. Okay, I'm going to import Hugging Face embeddings. Okay, so we are going to use this Hugging Face embeddings over here. Okay, now this Hugging Face embeddings, this same Hugging Face embeddings, I can copy and paste it. And the first embedding technique that we are specifically going to use is something called a sentence transformer. So let me just go ahead and make a field over here. I'll create a markdown, and I will also provide some information. Okay, over here, I'll just go ahead and copy and paste it so that you'll also get some kind of description information. Okay, so here you can see sentence transformer on Hugging Face. Hugging Face sentence transformer is a Python framework for state-of-art sentence, text, and image embeddings. One of the embedding model is used in the Hugging Face embedding class. We have also added analyze called a sentence transformer embedding for users who are familiar with directly using that package. Okay, so this basically uses something called a sentence bird. Okay, with the help of that, you'll be able to call any embedding techniques. So here I will just go ahead and use this Hugging Face embeddings. Now here also you can see the installation has taken place. Now let me quickly again do the pip install requirement.txt because I also need to install this LangChain underscore Hugging Face. Okay, again installation is something that you will always be requiring. So I'll just go ahead and execute this. Now inside this, I'll give my model name. Okay, so here I'm going to say, hey, this will basically be my model name, and let's go ahead and give my model name over here. The model name will be something called as if you go ahead and search in Hugging Face, this is the model that we are going to use. All mini LM L6 version 2. Okay, this will basically be used for embeddings. So now I'll go ahead and create my embeddings equal to this one. So it's no syntax. Okay, I have to write from. Okay, from. So if I go ahead and execute it, I think this should be working fine, and I should not get any error. You can also go ahead and install TQ2M so that you'll be able to see that how much time it is probably taking the model to get downloaded. Okay, so there's some warnings. You can ignore this particular warning. Okay, but it is going to take some seconds to probably load the model in our system. Okay, and then once we do this, I will just go ahead and create my text document. So this will be my text. Let's say I'll go ahead and write this is a test document, and we will try to convert this into vectors. Okay, remember the reason why this is working because we have already called this particular hf underscore token over here, right? So here is this is the test document over here. I will just go ahead and write my query underscore result is equal to embeddings dot. And here we can go ahead and write our embed underscore query. Okay. And once I go ahead and execute this, give my text over here, then I will be able to see my query underscore results. So if I go ahead and execute this, you'll be able to see this. And if you want to go ahead and see the dimension of this particular vectors, this particular sentence, how much vectors it has got, what is the dimension of that? So I can go ahead and write length of query underscore results. Okay, so it's a result. Okay. Now here you can see it is basically converted into a 384 dimension. Similarly, you can also do it for embed documents wherein you can give multiple lists of statements. And here is one example where I'm writing embedding.embed documents with respect to this particular value, and this is not a test document. Okay. So here if I go ahead and see my document results of 0, so the first embedding is this one, and the second embedding also you'll be able to see it. So this in short actually shows us like how to probably perform with the help of Hugging Face sentence transformers. Similarly, you can also do it with Hugging Face itself. Okay. And one is through sentence transformers, which we have already seen it. Okay. The other thing is that we can also check something called Hugging Face inference API embedding, but that we'll see it in the later stage. This is just to give you an idea like what all techniques we can specifically use over here. So I hope you were able to understand about the embedding techniques. Now, see, step by step, we are able to cover each and everything, right? From data ingestion to text splitter to probably converting vectors, text into vectors. Then you also saw one example of vector store DB, right? Now there are two important things again after this. One is vector store DB, different vector store DB we'll try to see, and then after that we will also go ahead and explore retrievers and chains, which are super important. And then we can finally go ahead and implement a lot of end-to-end projects. So yes, this was it from my side. I'll see you in the next video. Hello guys, so we are going to continue discussion with respect to LangChain, and in this video and in the upcoming series of video, we are going to discuss about vector store DB. Again, I've listed down some of the vector stores that I will be showing you with respect to practicals. One is Fias, another one is ChromaDB, and after doing both of them, I will be also showing you more couple of examples. There is also a vector store DB which is called as AstraDB. This I will show you with the help of some end-to-end projects because we will be using this AstraDB from cloud. Specifically, it uses Cassandra DB itself, right? So later on, I'll be showing you the specific example. But right now, we'll focus on this two vector store, and you'll be seeing each and everything, like how you can actually work with this, what is this entire vector store, and many more things. Okay, so let's quickly go ahead and open my file. So here I will just go ahead and open my file. So here is my files.pynd file. Okay. Now you need to understand first of all what exactly is this particular vector store. Okay. So FIS is nothing but it is Facebook AI similarity search. It is a library for efficient similarity search and clustering of dense vectors. It contains algorithms that search in set of vectors of any size up to ones that possibly do not fit in the RAM. It also contains supporting code for evaluation and parameter tuning. Okay. So let's see some of the example, and I'll just show you one very good example with considering a TXT file. We'll try to read that particular data from that. We'll convert whatever things we have learned till now, right, from data ingestion till embeddings, and then finally storing it into a vector store DB. Everything we'll be doing. Okay. So for initially we will go ahead and first of all let me go ahead and select the kernel. So I will go ahead and select the kernel over here. So here you can see first of all I will go ahead and import from langchain underscore community. First of all we are going to go ahead with document loaders. Okay. Here we are going to import text loader. Then we are going to go ahead with langchain underscore community dot vector store, since I'm going to use this particular vector store, which is nothing but FIS. Okay. I'm going to go with this. Okay. Please remember one thing, that you need to have installed the FIS vector store. So here what I'll do, I'll go over here, I'll go ahead and write FIS, and let me use the CPU version because right now I'm doing it in my local machine. Later on when we take this into cloud, you can actually also use GPU. Okay. So quickly let's go ahead and install this. So I will go ahead and pip install -r requirement.txt. Here you can see requirements will already be satisfied because I've already done the installation. Okay. Now the next step will be that after importing FIS, I will not use OpenAI embedding, but I'll use an open source embedding, which is Ollama embedding. So here I'm going to go ahead and write for langchain underscore community dot embeddings. Okay. I'm going to import Ollama embeddings. Perfect. Then again from langchain underscore text. So let's go ahead and use a text splitter. So I'm going to use langchain underscore text splitter. Let's me go ahead and use some character text splitter, which we have already seen. Okay. Now I'll take my loader. I will use this text loader, and then I will go ahead and upload one txt file, which is called a speech.txt. And if you go ahead and see over here, and here I have the speech.txt file. Okay, since I'm working in this vector store folder. Okay, I put it already. Then from this particular txt file, I'm just going to load all the documents. So I'll be using loader.load. This we have already discussed in the data ingestion by using document loaders. Then after this will be my next important step, is that text splitter, and here I'm going to use my character text splitter. Okay, let's consider the chunk size. The chunk underscore size will be 200, and my chunk overlap. Let's say that I don't want any chunk overlap, so I'll just go ahead and make it as 0. Okay, otherwise I'll just make it as 30. Okay, this is a smaller number. Now we will go ahead and use this particular text splitter, and we'll split all the documents. So here I'm just going to go ahead and write split underscore. So text splitter underscore split underscore documents. Okay, and here I'm just going to use my documents. So let's execute this. So here you can see created a chunk of 470. Everything is shown over here, but let me make this as 1000. So sorry, let's make this as 1000. Okay. So now let's go ahead and see my docs. This is my docs, and this is the splitting that has already occurred. Okay. Perfect. Till here, all the splitting has been done. Now the next thing that we do is create our embeddings. So for this, I'm going to use my Ollama embedding. By default, I've also shown you that Ollama embedding uses which kind of embeddings itself. So DB will be nothing but FIS dot from underscore documents. So I'm going to use this FIS vector store, and I'll probably convert all these documents with the help of this particular embedding. So in order to do that, the first parameter after FIS.from underscore documents, I will give all my documents, and then I will just go ahead and use my embeddings. Okay. So once I do that, this basically becomes my vector store DB, right? So this, if I go ahead and execute it, it will take up all these particular characters, then it will perform all these Ollama embeddings. It is going to take some amount of time because this Ollama embedding is running in my local machine. Okay. Since it is running in my local machine, so it is going to take some amount of time for your system also. If you are doing it in a local with the help of Ollama, it is going to take some time. Okay. Because we are going to use this FIS CPU to convert all the documents into vectors, right? So here you have this langchain community.this at the specific memory location. This is perfect till here. Now what I'm actually going to do, I will take this particular vector database and start querying it. Okay, so in order to do the query, I'll go ahead and create a query. Let's say my query from that particular speech text is that. I will just go ahead and show you this. Okay, so this is one of the questions that I have in my speech text. Speech.text. What does the speaker believe is the main reason United States should enter the war? Okay, so that is based on the speech text over here, and I will be considering this example. Or what you can do is you can just go ahead and open the speech.txt. Okay, and you can search for any of the questions that you really want. Okay, it is up to you. Whatever things you specifically want. Okay, so let's take one more question. Okay. So I have actually searched for one of the questions, so I will just go ahead and paste it over here. Okay, how does the speaker basically talk about this? Describe the desired outcome of the war. Okay, and here now we will take up this entire query, and here we're just going to go ahead and write docs is equal to db.similarity search. We'll use this, and here I'm just going to give my query. Okay, so finally you'll be able to see if I go ahead and print my docs. As soon as I do the similarity search with respect to the query, this is the entire response that I get with respect to the context. Whatever things are basically matching, we get every of these things, right? What I will do, I will just go ahead and display the first one, which is nothing but this one, right? Page content. So if I go ahead and execute it, here you'll be able to see, hey, it is a distressing and oppressive duty, and gentlemen of the Congress which have performed. So information is basically there. Okay. Now this is one way how you can do the query. But as I said, after this, I'm also going to show you with respect to retriever. So let's go ahead and see example with respect to retriever. And I'll just give you an example. What does the retriever actually do? Right. So I'm just going to put a comment over here. So here you can see we can also convert the vector store into a retriever class. This allows us to easily use it in other langchain methods, which largely works with retriever. In order to just give you a brief idea, we will be discussing about this retriever in a separate module. But just to give you an idea, this retrievers are like an interface, which actually, whenever we put any kind of query, it is just like connected to the vector store DB. It can connect to the vector store DB only when we convert this vector store DB into a retriever class. So it acts like an interface, which will be able to retrieve the details from the vector store and provide you the response. Okay. So here, what I will do in order to convert my vector database as a retriever, I will just go ahead and use db.as retriever, and I'm just going to use this particular variable. So here I'll go ahead and write retriever. Okay. Then let's go ahead and use this retriever dot invoke. Okay. And I will just go ahead and give my query. So once I do that, you'll also be able to see that I will also be able to get the same answer like how I used to get it over here. But the reason of using this is that later on when we work with different LLM models, right? At that point of time, I cannot directly use vector store DB, but initially I need to convert this DB into a vector store DB, okay, and then finally use it. Okay, sorry, I need to convert this particular vector store DB into a retriever, and then I will be able to use it in LLM models, right? So that is the importance of using retrievers. So that is the reason I've written over here. This allows you to easily work with other LangChain methods, which largely works with retriever, right? So this basically becomes my docs. So here you have docs of 0 dot page underscore content. Okay, so I have this entire information over here, right? Now in FAISS, right, you also have one beautiful mechanism which is basically called as similarity search with score. There's some 5 specific methods. One of them is similarity search with score, which allows you to return not only documents but also the distance score of the query to them. Right, the return distance score is L2 distance, which is also called as Manhattan distance. Therefore, lower score is better. Okay, so this is important to understand. We can also use similarity search score, search with score. Okay, so here I will just go ahead and write docs underscore and underscore score. And here I'm just going to go ahead and write db dot similarity search with score. And here I will just give him my query, whatever query I'm actually writing, and let's go ahead and print this particular db score. Okay, docs and score. So once I execute it, here you will be able to see that hey, it is a distressing, and with respect to every information that I get, right, there'll be a score that will be attached, and this is nothing but your L2 score, which is also called as Manhattan score, Manhattan distance. Okay, so based on that particular information, whichever is the nearest, that way you will be getting as the first context from that particular text file. Right. So here one more additional thing that you're actually getting is with respect to the score. Okay. Now you may be also thinking, Krish, can we not directly pass vectors instead of sentences? Yes, we can actually also do that, or instead of any documents. So for that, I have to probably go ahead and make my vector. So I will go ahead and write embedding underscore vector, and then here you'll be able to see embedding dot embed underscore query, and here I can give my query. So once I give this, so this basically becomes my embedding vector, okay, based on Ollama embedding that I've actually used. Once I have this particular vector, then what I can do, I can just go ahead and write db dot similarity search by vector, okay, and here I can actually go ahead and give my embedding vectors, right? And once I do this, here also I will be able to get the docs and score, okay, the score. So finally, if you go ahead and see this docs and score, sorry, docs underscore score, you'll be able to get the same information how we should get it, right? So here the query that has been done is with respect to your embedding vectors, okay. Now, finally, you should also know this, how I can probably save this vector store DB in my local, right? So here, I will just go ahead and create some cells, okay? Let me copy this. I'll write some comments over here. Here, we are going to basically do the saving and loading. So here, let me just go ahead and write db dot save underscore local. So there will be a function which is called as save underscore local. And here, I can actually use one index name, okay? It'll be FAISS index. So once I execute this, you'll be able to see that here, the file will get saved. It will be saved in the form of pickle. And here, you also have something called as index.file, some of the configuration information, right? So this is your FAISS underscore index folder. Now, what you can do is you can load this particular folder also very much easily. Now, in order to load this folder, you will go ahead and write new underscore db, let's say. Here, I'm just going to use this FAISS, and there'll be a function like load local. I'll give my index name, that is FAISS index, and here along with that, you know what all embeddings also we need to use, right? So embeddings, I've already defined Ollama embedding, you can directly initialize over here. And once I execute this, you'll be able to see, hey, we are getting an error. The deserialization relies loading a pickle file. Pickle files can be modified to deliver a malicious payload. So during this point of time, it is just saying, hey, something is fishy is happening. Because the reason is very simple, I'm trying to load a pickle file over there. Whenever we get this kind of issue, before we used to not get it, but right now in the recent version of FAISS, we are able to get this. So what you do is that you just go ahead and use one parameter which is called as allow dangerous serialization, okay? Because you're just saying that, hey, I trust this particular file, right? So allow dangerous deserialization is equal to true, and just use this, okay? Now if I go ahead and use this docs is equal to, and I will just go ahead and use my new underscore df file and write new underscore db, right? You just go ahead and use the similarity search. I think it should be able to work. Okay. Again, you can also do similarity search by vector or whatever things you want. So once you set this allow dangerous deserialization, you will be able to see the answer. Okay. So this was more about FAISS. I think we have discussed each and everything. Working with FAISS, how you can actually go ahead and see with respect to vectors, how you can do the similarity search by vectors. Each and everything is discussed. I hope you were able to understand the specific video. Yeah, this was it. I will see you in the next video. Thank you. Hello guys, so we are going to continue discussion with respect to vector stores. In this video, we are going to discuss about Chroma DB. So what exactly is Chroma DB? It is an AI native open source vector database focused on developer productivity and happiness. Chroma is licensed under Apache 2.0. So let's go ahead and see. Again, I will be showing you with the help of code itself. So first of all, you need to go ahead and install Chroma. So in order to install Chroma, you just need to make sure that you update your requirement.txt. So for this, what I'm actually going to do is that I'm going to quickly go ahead and write Chroma over here. Okay, Chroma DB. And then I'll just go ahead and open my requirement.txt. Pip install -r requirement.txt. Let's see. You'll be able to see that I think I may have already done this installation, so it has been installed. Okay. So this is the first thing. Please make sure, like one by one, you should be able to install all these packages till now. Okay. The first step, again, we will be building a sample vector DB. Okay. And then first of all, I will go ahead and write from langchain underscore Chroma. Okay. Import Chroma. Okay. Now, if you go ahead and see the previous version of Chroma DB, right? That time we used to directly install Chroma DB and we used to use it, right? But now in the langchain, you have this new library that has come, langchain underscore Chroma. So you need to also install this, right? No need to install Chroma DB separately now. Now you have this entirely where you can actually use langchain underscore Chroma DB. Okay. So what I will do, I will again go ahead and I will say, hey, just clear the screen. Okay. And then let's go ahead and install this requirement.txt. So here you can see now, you need to install this langchain underscore Chroma. This will be my library that I'll be using. And right now you can see the recent version 1.1. Please make sure that you keep this version also ready so that you'll be able to understand which version you have actually created. Okay. Now from langchain underscore import Chroma. So I'll just go ahead and import this. Let's see whether it is working fine. So yes, it has got successfully imported. Okay. Remaining everything will be almost same like how we used for FAISS. So here I'm going to import langchain underscore community.document loaders. I'm going to use text loader. Then use Ollama embedding. You can also use OpenAI embedding if you want. Then along with this, I'm also going to use langchain underscore text splitters with recursive character text splitter. Okay. Now, quickly, let's go ahead and read this particular speech.txt. And again, I'm going to go ahead and write my data.loader, right? Loader.loader. So here you can see text loader is there. Why it did not get executed? Let's see. I'll have to execute this. Then let's go ahead and execute this. I think I did not execute this part. Okay. So here you have this entire speech.txt, and here is my entire data. Now, what we'll do, we'll basically do the split. And for splitting, we have to use a recursive character text splitter. I've used chunk oversize as 500, chunk overlap as 0. Okay. It is up to you how much overlap you want to use it. Then we will go ahead and write text underscore splitter.split documents with respect to data is equal to splits. Okay. So here you can see this basically is my splits. Okay. Now, quickly, let's go ahead and create my vector store along with the embedding. So in order to do that, first of all, I will go to write embedding is equal to Ollama embeddings. Okay. And then I'm just going to write vector db is equal to chroma.db, from documents. Okay, so again, it'll be like the same thing like how we discussed for files. And inside this, I will go ahead and give my data that is splits. Okay, comma. Along with this, I'm going to just go ahead and apply my embeddings, which will be equal to this specific embedding that I have initialized. Remember, the first parameter is nothing but it is documents. Okay, so this basically becomes my vector store, vector db over here. Or you can also say vector store db. And once I execute it, this is basically going to apply to this entire documents. Okay, which we have actually done the split. It is going to take some amount of time since this is getting executed in the local. Okay, once I do this, let this get executed. Then I'm just going to query this particular db. Right. So for that, again, how do we query it? By using the same technique what we used in files. So let's say here I say what does the speaker believe is the main reason United States should enter the war. So vector db.similarity search of query. So this basically becomes my docs of 0. I will go ahead and print. Along with that, I'll also go ahead and print my page content. Okay, content. So if I go ahead and execute this, you'll be able to see that, hey, I'm getting the entire response. Okay. Now, like how we made sure that we can also save this in the local, we'll also be able to save chroma vector store db in the local itself, right? So now let's go ahead and save to the disk. Okay, saving to the disk. And here again, I'll be using the same command like this. Okay, this will be my vector store db. Okay, here what I can do is that along with this entire documents that I'm actually providing with the embeddings and all, what I will do, I'll go ahead and use one persist directory. So here I have to go ahead and write my persist directory, and I'll give my directory location. That is nothing but chroma underscore db. Okay, and finally I can use this. So if I go ahead and execute this, it's going to take some amount of time. And again, here you'll be able to see a folder is basically getting created. And this internally creates a SQLite DB. Okay, SQLite 3. So this DB is specifically used inside. That basically means every vector is stored inside this particular DB. Now, see, if you're able to see one DB, right, this can be hosted anywhere you like, right? So this is the main fund or importance behind saving it to the disk, okay, or saving it in a file that can be reused again and it can be called. Now, in order to call this, what you can do is I can just go ahead and write this particular code. See, chroma. I'm just saying, hey, give the persist directory that is /chroma db. Embedding technique is nothing but my embedding over here, right? Whatever embedding function is there. And I can again do the same similarity search. So let's say if I get my docs, so this will be my db2.similarity search. You can do the similarity search by vectors. You can do it by anything as such. And then we'll go ahead and print docs of 0. Okay, dot page underscore content. Once I execute this, here you'll be able to get the response. Okay. If you want to probably get the similarity score, you can also go ahead and write this particular code like this, like how we did it for files. There's a function which is called a similarity score, with score, and here you'll be able to see the docs. Okay. So here again, Manhattan distance, based on the Manhattan distance, you're able to get this information. Okay, perfect. Now finally, again, we should not skip this option also. That is nothing but retriever option. Okay. Now in the case of retriever option, I will take this vector store db dot as retriever. Okay, and then I'm just going to create this particular variable retriever is equal to, and let's go ahead and invoke this. Okay, retriever dot invoke. Okay, and here I'm just going to give my query and get me the first, whichever will be the first result. Right. So this will basically be my first result. I can go ahead and also display my page underscore content. Okay, page underscore content. Okay, perfect. This was more about it, where we were discussing about vector store DBs and all. And this is one example with respect to the Chroma DB. We will be using everything like this kind of vector store DB or databases in our end-to-end projects. Just to give you an example, two of the most common things that we use, which are completely open source, is Files and Chroma. As we go ahead again, when we develop end-to-end projects, we'll be seeing a new DB like Cassandra DB, Astra DB. We'll be talking about different DBs like Pinecore vector store DB. So that also we'll be talking about where we will be creating some kind of, that will be hosted in some kind of cloud. So that is the reason I'm saying that we'll discuss about that when we develop end-to-end projects, right? So yes, this was it. I'll see you on the next video. Thank you. Hello guys, so till now we have seen these two amazing vector databases called as Files and Chroma. Again, if you want to go ahead and check out more different vector databases, here you can see over here, you can just go into this particular link, and there are so many vector store databases that you can actually use, right? And it is up to you like what kind of vector database you really want to use, but again, there are many. It's just not limited to a couple of them. What I'm actually going to do is that I'll give this entire link over here so that you can go ahead and check out all the other vector databases. But one thing I'm going to make sure that when I will be creating an end-to-end project, then I'm going to use other vector databases. Not only I'll be restricted to Files or Chroma, but just to give you an idea how you can get started. That is the reason I created this two series of videos with respect to vector store DB. Now, as we go ahead, a lot of end-to-end projects. So there we are going to use Astra DB, we are going to use Pinecone, and then we'll also see how to deploy that in a cloud and probably use it directly from there. So all those things we will be seeing as we go ahead. So yes, please make sure that you keep on seeing the documentation. Again, which vector database to select is based on the requirement that you'll be facing in the companies where you really need to store how feasible it is for you and all, right? Yeah, this was it from my side. I hope you like this video. I'll see you in the next video. Thank you. Hello guys, so we are going to continue the LangChain series. In our previous video, we have already done the setup of LangChain and Langsmith. We have also seen how to probably extract the LangChain API key. Along with that, we also saw how to get the OpenAI API key, and we have set up that entire thing in our environment variable. Now let's go ahead and probably start this particular coding where we will be using some basics and common components of LangChain, like prompt templates and all. But before that, let me do one thing. Let me clearly show you that how you can go ahead and export all these environment variables that we have. Right? We really need to have that first. So first of all, what I'm actually going to do, I'm going to go ahead and write import OS. Right? OS is one of the library in Python, which will be which we will be specifically using to set up our environment variable. Then, if you remember, we had also imported from .env import load_.env. Okay, so this load_.env will be specifically used to import all the environment variables that are available in this .env file. And already you know that we have imported this python.env, and from here only this particular library is getting imported. Okay. Now the first thing what I'm actually going to do, I'm just going to write os.environment, and here I'm going to set up my OpenAI API key, OpenAI underscore API underscore key. Okay. And in order to call that particular environment variable, I'll just go ahead and write os.getEnv, and here we are again going to use the OpenAI underscore API underscore key. Okay. So from the environment variable, the key name that I've actually created is OpenAI underscore API key. That will get set up with this specific environment. This was the basic setup. Okay. Again, if you probably go ahead and see that we also had created something like LangChain API key, right? So that also will go ahead and do the setup. So here I'm going to write os.environment, okay, and here we are basically going to set up our LangChain underscore API underscore key, okay, and this will be nothing but os.getEnv, again with the same name, LangChain underscore API underscore key, because this is what we have actually created in our environment variable. Along with this, and this is specifically used for Langsmith tracking, okay. We'll discuss about it as we go ahead more, so this is nothing but Langsmith tracking, okay. Along with this, what I'm actually going to do, I'm also going to make sure that I'll go ahead and write os.environment, okay. And here we will be also setting up our LangChain tracing. Okay, so we have to make sure that we set up this particular value also, LangChain tracing underscore v2. That is the requirement for LangChain to true. Okay, so this will basically be set up to true. Okay, so till here everything looks perfect. And along with this, there is one more very much important thing that is with respect to the LangChain project. So here what I'm actually going to do again, we will go ahead and set up os.environment. Okay, this is just for Langsmith tracking that is required. And here I'll just go ahead and call my os.getEnv. Again, the name will be nothing but LangChain project. Okay, so these are my 3 important keys that I'll be able to set up over here. And by default, here you'll be able to see that what all things I'm actually doing, right? So this is my OpenAI API key. This is my os.environment with respect to LangChain API key. LangChain tracing needs to be enabled, so it is set to true. And then finally we have this LangChain underscore project. Okay, so all this setup is specifically done. We have also done the installation of LangChain. Now, since we are using LangChain with OpenAI, so there is one very important library that we have to probably go ahead and do the installation. That is nothing but LangChain dash OpenAI. Okay, so OpenAI. The reason we have to do this because all the inbuilt function that is required with the integration of OpenAI, we really need to use this particular library. So let me quickly go ahead and open my terminal. Okay, and here I will just go ahead and pip install -r requirement.txt. So the installation will happen, and now it will also start the installation for LangChain dash OpenAI, right? So it is going to take some time based on the requirement. So here you can see the installation has basically happened. Perfect. So this is good enough. We are good to go. Okay. So I'm just going to close this up. And now the next step is that how do I probably create or work with Chat Open API? Okay. Now since I want to use OpenAI API key along with that, so there is a library which is called Chat OpenAI. So I will go ahead and write from LangChain underscore OpenAI. I'm just going to import something called as OpenAI, right? So this will definitely be there, and this OpenAI will specifically be responsible in creating your object. But I'll not use OpenAI directly over here. Instead, let's go ahead and use Chat OpenAI because I really want to create a chatbot. Okay. Now I'll go ahead and create my LLM. Okay, and here I'll say, hey, use the Chat Open API, and here I'm going to set my API key to nothing but it will be the same value that we're going to set it up, right? See, API key is nothing but OpenAI underscore API key. But since I've already made sure that I have created my environment variable, I don't even have to specify the API key. Okay. So if I go ahead and execute this, and let's go ahead and print my LLM, right? So this will be my LLM model. Okay. So here you can see install kernel, change kernel. Okay, now let's do this one thing. So here you can actually see that I have not installed IPy kernel. So let me just go ahead and do that. Pip install IPy kernel. Okay, because I really require IPy kernel for this, and I'm not even executed this. So let me quickly install this. Okay, so here you can see pip install IPy kernel. Okay, run cells with this. Let me do one thing. I'll just go ahead and update over here IPy kernel. Okay, IPy kernel, because for the first time I think we have to do it from here, from the terminal. So I'll just go ahead and open a terminal, pip install -r requirement.txt, quickly do the installation of IPy kernel, and then I'll go ahead and select my kernel over here. So no need to go ahead and execute it again. Okay. Okay, right now it is getting installed. Let's wait for some time. Okay, and then you'll be able to see that this all errors will probably go. But you have to install pip install IPy kernel. Okay, so this error that you're seeing, I will keep it like that. I'll not cut it because the simple reason that I really need to show you that where all things will be specifically getting an error. Okay, so IPy kernel is basically getting installed, and then only you'll be able to attach this particular kernel. Okay, so let's wait for some time, and it is again depending on internet connection, it will take how much time to install a package. So now the installation is done. Now let's go ahead and execute this. So here you can see connecting to a kernel, and this has got executed. Okay, IPy kernel is definitely required. Now let me just go ahead and execute this LLM. Now here you'll be able to see that I have actually got this particular LLM model over here. This is my OpenAI secret key. Everything is basically there. Okay, perfect. This is good. Now again, with respect to whenever we specifically work with LLM models, one thing that you really need to worry about is like what all different kind of models are definitely there, right? In OpenAI right now, the most famous model that you will probably be seeing is GPT-4o, right? And how to call that particular model will be seeing how simply easily you can basically call it. So here what I will do inside this Chat OpenAI, and for our entire course we'll use the best model instead of using different variants model, that is GPT-4, right? So here you just need to write model equal to GPT-4, right? And now I'll go ahead and print my LLM. So we will be using this particular model because this is the most efficient model that is available in OpenAI API. Okay, so perfect. Till here you have actually done this everything as such. So this is how you can load your LLM model. Okay, now with respect to LLM, if I want to ask any question, so let's provide some input and get a response from LLM. Okay, and again, as I said, the reason I'm able to connect it because I have my OpenAI API key loaded in my environment variable. Okay, sorry, as an environment variable, I've loaded it over here. Now, in order to give any input to this LLM, I will just go ahead and call LLM invoke, and here we will go ahead and write. Let's say what is generative AI? So this is my question that I'm asking this LLM model. Okay, so once I probably go ahead and execute it, so here you'll be able to see that I will be able to get the response through the API key. Okay, again, this depends on how much time it is going to take. Okay, and the best thing why it is taking so much of time, right? That also you really need to understand. So here you can see I have actually got this AI message content is equal to generative AI, something like this, right? So let me do one thing. Let me store this in my result variable, and now I'll just go ahead and print my result. Okay, result. Okay, so let's go ahead and print this result. So it is going to take some time. The reason it is taking time, why 8 seconds has basically taken time, because of this, with the help of this LangChain API key, we are going to record all these things, all these events that are specifically happening in the Langsmith. Okay, so if I go ahead and print the result, so this is what I'm actually getting. To get the content, I can just go ahead and write result of content. Okay, so here is my output. Okay. AI message is not scriptable. Let's see what is the error. Result content is equal to generative AI. So here is my entire output that I'm able to get. Okay. Let's see. We will try to. I'll also say why we're getting this error, but just in some time because I really need to show you some very important thing. So let me do one thing. Let me just go back to my browser. Let me show you this. Okay, just a second. I will just go to my browser over here. Okay. Now inside this browser, let me just go to my Langsmith. Okay. Now if I go ahead and click on the project, so here you can see Gen AI app with OpenAI, right? And here if you go ahead and see there are two chat OpenAI requests, right? What question I asked, what is generative AI? So see how beautifully as soon as I probably hit the LLM model, everything is basically getting tracked in this particular Langsmith. Now I hope everybody is able to understand why Langsmith is super amazing, right? Because if you see the entire ecosystem, Langsmith is a unified DevOps platform for developing, collaborating, testing, deploying, and monitoring LLM application. That is the most amazing thing. And right now here you can see, right? And now let's go ahead and do one thing. Let's click on this request. So here you'll be able to see what is the human feedback that was given, then what is the output that we got, right? Everything is basically getting displayed. How much delay is basically happening, right? How much delay latency, right? Tokens, and it also probably suggests you how much cost it is basically taking based on the token size, right? So 364 token, 494 token, this much cost has basically incurred in my OpenAI, right? And this is how beautifully we are able to develop this entire thing, right? Now coming to the next step over here, you can see that I have actually displayed the results, and this is my entire results over here. Okay. Now let me work along with chat prompt template. Now see, there's something called as prompt template, and again, prompt template is like how you want your LLM model to behave, or what kind of response, or what kind of role you really want to give your LLM model. I can say, hey, act as an AI engineer and provide me suggestion how to develop an amazing Gen AI project, right? So that is the kind of rule I'm setting it to my LLM app itself, my LLM model. It's okay, you have to behave in this specific way and give me the answer, right? So similarly, LangChain also supports different types of chat prompt template also, right? So that is what I'm actually going to show you. So now we're going to discuss about chat prompt template. So I have just shown you one way of calling this particular model. We'll be discussing as we go ahead, right? Now what I'm actually going to do over here, I'll just go ahead and write from LangChain, okay? LangChain underscore core, okay? Dot prompts, okay? Dot prompts. I'm just going to import chat prompt template, okay? Now what is this chat prompt template? We'll discuss about, okay? Now chat prompt template, it is just like I can tell my LLM model, hey, you have to behave something like this, okay? So let's say I will just go ahead and create my custom prompt. So here I'll go ahead and write prompt is equal to chat prompt template. Now here with respect to this prompt template, I will be using one very important function which is called as from messages. And from this particular messages, we will define our entire, like what my LLM model needs to behave like, right? So here I can probably go ahead and create my list. Now inside this list, I will be giving in the form of tuples, my key value pairs. So first thing, when I go ahead and write, hey, system, I'm assigning some role to the system. System basically means my LLM model. I'll say, hey, you are an expert AI engineer, okay? Provide me answers based on the question. Okay, something like this. So this is a very simple role that I'm giving to my system, my LLM model, saying that, hey, you are an expert AI engineer. Okay, so please go ahead and provide me some answers based on the questions that I have, right? So this is one very important thing. Now this is for the system, but what with respect to users, right? So here I'll go ahead and write user, comma, and here I'll say, hey, user will provide you some inputs. Okay, this input is just like a placeholder. Okay, this input is just like a placeholder. Like user is asking you any question, then the system, the LLM model is that basically an AI engineer and should provide me the answer based on the question provided by the user or based on the questions. Okay, so this is what is a very simple mechanisms. Okay, and this is my entire prompt template that I've actually created. Okay, now if I go ahead and just execute this, okay, and show you, so this becomes my chat prompt template. My input variables is input, and here you can see system prompt template, input variables. Template is like you are an expert AI engineer, provide me the answer based on the questions, right? And it has also said that, hey, in the template also you have to consider input as your input variable itself, right? So all this information is there in my prompt template. This is very much good to start, right? Now what I can actually do, right, is that use this particular prompt template along with my LLM model, right? So what I will do, I will first of all go ahead and create a chain, and it is important because see, my LLM model should know like what it has to behave like, and that instruction is probably coming from here, from this particular chat prompt template. So we will go ahead and create a chain. So prompt slash LLM model, right? So when we do or like this pipe sign, right, it is basically saying that hey, we need to combine this prompt along with my LLM, and that actually becomes a chain. Now whenever I give an input, first of all it will go through the prompt, and then it will go to the LLM, and finally we'll get the response, right? Now in order to call this, right, chain, so I'll just go ahead and write chain.invoke. Now you know what is my input, right? So this is my key that I really need to pass because that is what I've actually set it over here in my prompt template, right? I'll go ahead and say, hey, can you tell me, let's say, can you tell me about Langsmith? Okay, what does Langsmith is useful for? Like, what is Langsmith useful for? So I'm just asking a simple question over here. Let's see what kind of answer we'll be able to get. And let me do one thing. Let me just go ahead and provide a variable which is called as response, and then I will just go ahead and print this response, display this response, or print this response, whatever thing I really want. So I'll just go ahead and print this response. So if I go ahead and execute it, so here you'll be able to see that again, the best thing will be that the entire thing will also be going towards you'll be able to see that everything is basically getting tracked in the Langsmith portal. Okay, so here you can see certainly Langsmith is a tool designed to enhance the development. All the answers you're specifically getting, logging, tracing, everything, all the answers you're actually getting over here based on the content that I'm actually getting a response as. Okay, now this is one basic example of probably creating chain. So chain basically means you can combine multiple things. Chain like prompt, you can combine LLM, you can create your own custom prompt, and based on that, and it just gives you an idea like how once the input is given by the user, how the flow is. You know, initially it will go to the prompt template, then it will go to the LLM, and then that is how you'll be able to see it. If I go ahead and see the type of response, you'll be able to see that it is a kind of AI message. That basically means this response is basically coming from the AI message itself, right? So I hope you're able to understand it very much clearly. Okay. Now let's do one more thing. See, right now by default I'm getting some kind of message. Okay, and I really want to make sure that I probably can use some kind of output parser also to display my response. So that is where one type of output parser, the default output parser that we'll be using is something called a string output parser. Okay. Now string output parser, if I really want to give you an example, you know, and you'll be seeing in further sessions, you know, we will also making sure that our output parser is just like getting the message from the LLM and how you really want to display it. Okay. By default, there's a string output parser class, but you can also create your own custom output parser. Okay. And so for that, we'll be seeing that how we can basically create this output parser. So first of all, what I will be doing, I will be going ahead and importing from LangChain. So underscore core, okay, dot output parsers, okay, and then we are going to import str output parser. Okay, now this output parser will be responsible in displaying my entire output. So here I'm just going to go ahead and write output parser is equal to str output parser, and here I'm initializing it. Now again, I have to go ahead and create my chain. This time, first thing that I really want to pass is my prompt. Then I'll pass it to my LLM. Then whatever response LLM is basically giving, it'll just go through this particular output parser, which is nothing but it is my output parser variable that I've actually defined. Okay, now see the magic. What will specifically happen once I create this chain? So here I will go ahead and print my response. Let's go ahead. Okay, so I'm writing same thing, chain.invoke input. Can you tell me about Langsmith? Print response. So let's go ahead and execute it. And this time you'll be able to see my output parser. I'm able to get directly. I don't have content. So that is the reason I was showing you, right? That time we are getting an error when I was able to access this particular variable content. By default, string output parser, whatever message you're specifically getting, that is only going to get displayed, right? So it is always handy to use the string output parser because based on your likes and dislikes, you can actually display the output result. In the upcoming videos, we'll also be customizing this entire thing. We'll be creating this particular class and we'll be doing more things. Okay. So in short, in this video, we have used the most common and most basic and common components of LangChain, prompt templates, models, and output parser. Now in my next video, we'll build a simple application with the LangChain in the same notebook so that we'll be able to track things, right? Now let me just go ahead and see like how much information has basically been tracked over here. So here you can see so many different information has basically been tracked, and all this information is probably available over here, right? So this was my chat prompt template. See chat prompt. Can you tell me about Langsmith? So this is my entire chat prompt template that you'll be seeing. I'm setting you are an expert AI engineer based on this, and then we hit the chat OpenAI request, and based on that I got the entire response, right? So step by step we'll be able to explore everything. See, let's consider in this case. Okay, so this is my runnable sequence. So first my chat prompt template was there, then I gave it to my chat OpenAI, then finally I got my string output parser, which is probably displaying the entire content. That same chain you're able to do it, and this in turn helps us to monitor each and everything. And here you can see the token based on the token cost. You're able to see each and every cost that is there, right? So yeah, I hope you were able to understand this particular video. I hope you like it. And in the next video, we will try to create a simple generative AI application again with the use of OpenAI, right? So yes, this was it from my side. I will see you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to LangChain. In this video, we are going to create a very simple application, LLM application or generative AI application using LangChain, and we'll also be understanding what all tools we will be specifically requiring. So what kind of task or what kind of application we are just going to generate over here is that, let's say I have a specific website, and that website has some content. Let's consider that it has some kind of text format, some information over there. Now what we are going to do is that we are going to extract that entire information. Again, for that we definitely require some data ingestion technique. We'll be seeing in LangChain there are multiple data ingestion techniques such as web-based loader. You have a PyPDF directly reader, and you can also read PDF directly. There are a lot of libraries that are available in LangChain, which we will be looking at it one by one. But in this video, what we'll do is that I will be considering a website, and from that particular website, we'll try to take up the content, or we'll try to scrap the entire content. After scrapping that specific content, what we are going to do is that we are going to divide that entire content, or entire text into chunks, and then we will try to convert that into vectors by using some vector embedding techniques. And after doing that, we will be using LLM along with prompt engineering to specifically get output from that particular page. So there are a lot many things that we are specifically going to discuss. So let me just go ahead and share my screen. So here you can see I have this Langsmith page. So what I'm actually going to do, I'll go down over here, and there's some documents. Okay, so these documents we will try to read one of these documents, and let's see whether we'll be able to scrap this entire thing. So let's say this is my tutorial over here. Let's pick up a page where I will be able to see some information. So here, let's consider this is my page. So I'm going to probably take this entire page. I'm going to read the content from this particular page, and with the help of LLM and prompt engineering, if I ask any question to my Gen AI app, it should be able to give the answers. Okay, so that is what I'm planning to do it. So let's go ahead, and here you can see in getting started, we have learned about all these things. Now I'll go ahead and create my next file, and we'll be doing the coding over here. So let's go ahead and select the kernel. As usual, as I said, that we are going to generate a simple Gen AI app using LangChain. Okay, and here again we are going to use OpenAI initially, and then we'll also go ahead with some open source libraries. Okay, that also will be seen. Okay, so let's go ahead and execute this. Here I'm going to just go ahead and create some cells. Now the first thing which we have already done getting started is, and this is the most important thing, specifically loading all the keys. Right, so I'll just go ahead and load all the specific keys. So here you can see from .env load underscore dot. Then I need my OpenAI API key along with the LangChain API key, LangChain project. So this will be specifically common. Now, as I've already told that what I'm actually going to do is that if I want to retrieve the information from that particular website, I have to first of all read the entire content from the website, right? That is what I really have to do. So what I'm actually going to do over here is that we will first of all go ahead and import one important library, which is called as Beautiful Soup. Okay, Beautiful Soup 4. Okay. Now, why this library will be used? Because this library will help us to scrap the entire website data. Okay, and as you all know, right now we are going to use this particular website data, so we'll be taking this URL in order to scrap this entire text and retrieve it at our side. We will be specifically using this Beautiful Soup 4 library. Okay. Now, after doing that, first of all, let's go ahead and install it. So I've already done. I've written it in the requirement.txt. I'll go ahead and open my terminal, and here I'm just going to write pip install -r requirement.txt. So once I do the installation, here you'll be able to see that my installation will take place in the same VNV environment. Okay. Now once this is done, I will close this. Let's quickly use one data ingestion technique. Now, first of all, we'll focus on data ingestion. Data ingestion basically means from the website, right? From the website, we need to scrap the data, right? Scrap or scrape the data, right? I'll not say scrap it, scrape the data. Okay. So that is what we really want to do. Okay. Now from LangChain usually provides an amazing module, which is specifically available in LangChain underscore community. So I will go ahead and import from LangChain underscore community. Okay. So here, what we are basically going to do is that, again, for this, we require LangChain underscore community library. So let me just go ahead and import it over here again. So here you have this LangChain underscore community. Let me open my terminal and let me quickly install this as well, because I will be requiring it. Okay. LangChain underscore community has a lot of document loaders, right? Document loader basically means you will be able to load the entire data from different sources. That is the reason I am installing this particular library, which is called as LangChain underscore community. We'll be discussing more about it as we go ahead. Okay, so now the installation has been taken place. What I'm actually going to do, I'm going to go back to my code. So here, now let's see if I go ahead and see this LangChain underscore community. Okay, and here we're going to basically use document underscore loaders. Okay, and here I'm going to import web-based loader. So web-based loader is nothing but you give the website link and automatically it will be able to load it. I'll get an error, I guess. So here you can see, okay, this is A. Okay, let's see whether I'll get an error. So user agent environment not set. Consider setting it to identify your request. Okay, so right now it is some kind of error. User agent environment variable not set. User agent. So I have selected the virtual environment over here. Let's see what is the issue over here. Okay, so this has got executed now. Now what I'm actually going to do over here is that I'll go ahead and use a loader, and I'll say, hey, use this web-based loader. Okay. Web-based loader, and inside this I will give my link, right? So link will be nothing but, let's go ahead and see the link which it is. So I will go to quickly, I'll be probably giving this entire website link because this is where I really need to scrap my entire data, right? So I will just go ahead and give my link over here. Okay, so this will be my https docs.smith.langchain.tutorials/manage spam. Okay, now after I load this particular data, you can probably go ahead and just print this loader. So here you'll be able to see, hey, it is a document loader, web-based loader, right? Now web-based loader is something, it is a kind of library, whatever link you specifically get or give, right, a website link, it will be able to scrape the entire content from that particular website. Now, the prerequisite is that you really need to have this Beautiful Soup library because internally web-based loader uses Beautiful Soup 4. Okay. Now, once I get this entire documents, right, what I really need to do is that I will load this document. So here, if I go ahead and write loader.load, right, so in short, I'm going to get all my documents. So if I go ahead and execute this, and let's go ahead and print my docs. So you'll be able to see all the documents inside this, all the page content. I'll be able to see page content, hosting tutorial, the entire scraped data from the website, which we have actually explored. We have actually got it over here. Okay, very much important. Now, very much important thing. One more step after this, what we do, and usually in every RAG application, we usually perform this thing, right? First of all, we read our entire data source from a specific data source. We'll read our entire data from a specific data source. Then we will load this and convert into our documents. Once we get that particular document, now this is a huge huge document, right? Now, in this particular case, if it is a huge document, okay, we need to perform, we need to probably divide this entire document into chunks. We cannot directly give this entire document to our LLM model. The reason is very simple. With respect to every LLM model, there is some context size. There is a limitation with respect to context size. And as we go ahead and see different LLM models that are going to come up, the context size will keep on increasing. But it is always a good idea that we divide this entire documents into chunks of text, right? Or whatever text is basically present inside this document, we'll try to divide that into chunks. Okay. So that is the next step that we really need to do. And after we divide all our data into chunks, see, I'm just going to write it down over here. Initially, we load our data, then we get all the docs, okay, by just executing loader.load. Then after that, we divide our text into chunks, okay, into chunks. Chunks basically means smaller size data, right? And it is very simple. Why do we do that? Because every LLM model has a restriction with respect to context size, right? Then after we divide our text into chunks, then the next step what we are specifically going to do is that convert this into vectors by using some kind of vector embedding, okay? Now what is vector embedding? Vector embedding basically means these are some techniques wherein we'll be able to convert all this text into vectors, okay? And again, we have to use some different vector embeddings. There are a lot of different vector embeddings. Some of the vector embeddings I'll be using is OpenAI, and we'll also see some open source vector embedding techniques. And after you probably get the vector embeddings, all the vectors, we will try to store it in a vector store DB. Okay, so these are my steps that we are going to follow in this entire tutorial. Okay, so I hope you got an idea with respect to this. Here we are going to load the data, divide our text into chunks, text vectors, vector embedding, and vector store DB. Okay, finally, let's go ahead and do this. So first of all, what I'm actually going to do is that I will go ahead and use from LangChain underscore, there's something called as text splitters, since we really need to split our entire documents into chunks of text, right? So I'm going to use this text splitter and I'm going to import something called as recursive character text splitter. Okay, now this recursive character text splitter is a function which will be helping us to entire split our documents, right? So let's go ahead and initialize this recursive character text splitter. Here there's some parameters. First is your, let's see, so okay, I'll go ahead and initialize this recursive character text splitter. So let me just go ahead and define this. This will basically be my text splitter over here, which is nothing but our recursive character text splitter, which we are specifically going to use. Okay, now why we are using this is that because with the help of recursive character text splitter, we will be simply, we will easily be able to convert our entire documents, into chunks of documents in short, right? So we will be able to do that, right? So chunks of text I can basically say. Now inside this, you also have an option to specify your chunk size. Let's say I go ahead and specify my chunk size is 1000, and I can also overlap like my text while we are doing this splitting, right? It can also overlap, and the number of characters that can overlap is 200. Okay, so this is what I'm going to specifically use with respect to recursive character text splitter. Okay, now coming to the next step, after we do the text splitting, right? What we really need to do is that we'll use this text splitter, and then I will split all my documents. So I'll go ahead and split all my documents, and obviously this docs that I'm actually going to give will be available inside this, right, as a parameter. So once I do this, I will be able to get all my chunk of documents, right, over here. Perfect. Till here you have actually done each and everything, right? So if I go ahead and execute it, and if I go ahead and show you, so here will be my documents, and this is how it has been divided, right, based on the chunk size and the overlap. Initially I just had one document, now I have multiple documents, and we really need to do this because every LLM has some limitation with respect to context size. Now once you have done this, the next step will be that converting all this text into vectors. Okay, the reason we convert that into vectors because whenever we work with Q&A chatbot or document Q&A chatbot, or let's consider RAG application, there a very simple algorithm is basically used, which is called as cosine similarity. And based on the cosine similarity, usually gets applied in the specific vectors itself, right? So that is the reason what we really need to do is that in order to convert this into vectors, first of all, I will go ahead and use some embedding techniques. Now in this case, since I'm using OpenAI, I will go ahead and write, hey, LangChain underscore OpenAI. I'm going to import something called as OpenAI embeddings. Okay, so this is the embedding technique, and this is a very efficient embedding technique wherein it will take the text and it will convert that into vectors. So here I will go ahead and initialize this. Embeddings is equal to OpenAI embeddings. Okay, so once we have done this, so in short, this is my embedding technique which will convert our text into vectors. So I have executed this. Okay, now the next thing that I'm actually going to do is that I will be also installing one library, because with the help of embeddings, we will be converting the text into vectors, right? But where we will be storing that particular vectors, we have to store these vectors in some kind of vector database, right? And in this example, I'm going to take a simple example of FAISS vector database. FAISS vector database is, it has been created by Facebook, and you can use it very much efficiently. And there also similarity search is applied in the backend. So first of all, I will go ahead and import my FAISS-CPU. Okay, so since it's okay, you can also have the GPU version, but right now I think CPU will be more than sufficient. So I'm going to go ahead and install this, and let me go ahead and open my terminal and quickly install all the requirement.txt. Okay, so now you'll be able to see that my FAISS CPU has been installed. Okay, now once I do this, the next step will be that I will just quickly go ahead and import from LangChain underscore community dot vector stores. There are different vector stores like FAISS, ChromaDB, and many more. We will be discussing about them later on when we do projects. We'll be getting to know different vector stores. There's also like one vector store database which is called as ObjectBox. We'll also be seeing some example from there. Now I'm going to import FAISS. Okay, after importing FAISS, you'll be able to see now with the help of this embedding that I have, right, OpenAI embedding, I'll be converting all my documents into document text into vectors, and then all those vectors will be stored in this particular vector database. That is nothing but FAISS. Now here you can actually see that I've converted all my things into documents. Now let me just go ahead and create my vector store DB. Okay, now this vector store DB here I'm going to specifically use FAISS, and then I will be using a function which is called as from underscore documents, and here I'm actually going to give my documents comma embeddings. Okay, so documents comma embedding basically means all the documents which I'm actually going to do, and all these documents which embedding I really want to apply, that is nothing but OpenAI embedding, so I've given it over here, right? And finally you'll be able to see that I will be having this vector store database. Okay, so once I go ahead and execute it, you'll be able to see that it'll get successfully executed, and now I will be having my entire vector store DB. Okay, so here is my entire vector store DB, right? And now from this particular vector store DB, I will be you'll also be able to save this in your local environment or in any hard disk, wherever you want, right? And now from this particular vector store DB, I'm going to query, and based on the query, I can ask anything, and it will be able to provide me the response. Okay, and over here I've discussed about this FAISS, I've discussed about vector store DB and many more things, right? So yes, right now in this video, I'll stop it till here of creating this vector store DB. Now in the upcoming videos, I will be talking about more amazing things wherein we'll be discussing how we can retrieve queries from this particular vector store DB and get all the content based on the similarity search, right? So yes, this was it from my side. I hope you like this particular video. I will see you all in the next video. Thank you. So guys, in our previous video, we have actually done this project till creating this vector store DB. Now let's go ahead and see that how with the help of similarity search, we will be able to query anything from that specific page inside this vector DB. Like let's say that I'm a user, I want any content from that particular website. So I obviously want to query the vector store DB, and it should be able to give me the response. So first of all, I'll go ahead and create a query. So in this query, what I will do, I'll just go over here. Let's say I will be selecting in this particular page something like this, okay? And let's see. we will use, okay, let's go ahead and do this, okay, and extend it something. Let's just go ahead and ask this particular question from here, okay, quickly. So let's see this. I will go ahead and select my query. Langsmith has 2 usage limits, total traces and extended, and then we will go ahead and search for the result. I'm just querying it from the vector store DB. It should be able to provide me the context and provide, based on that, it should be able to retrieve all the information from here itself, right? All this information should be, you should be able to get it, okay? So quickly, let's do that. And here now in the result section, what I'm actually going to use, I'm going to just call this particular vector store DB and probably perform our similarity search and similarity search based on this particular query. Once I get the result, I can go ahead and write result of 0, and inside that we will be having a key which is called as page content. So let me just quickly go ahead and execute it. So here you can see use usage limit to prevent Langsmith has 2 usage limit, total traces and extended retention. This corresponds to the 2 metrics. All those information is specifically able to retrieve it, right? And that is the same thing that we are able to get from this, right? See, this corresponds to 2 metrics we have been tracking on our usage graph. We can use this in tandem to have a granular control over spend, right? This is really amazing. Just from with the help of vector store DB, which is having all the content in the form of vectors itself. From that directly we are able to query things and any information that you really want to query. Over there, just copy and paste some of the text over here, and you'll be able to get that particular answer, right? Isn't it just amazing, right? Now this is how you query from a vector store DB. So I'll just go ahead and write query from a vector store DB, okay? And you can probably go ahead with other queries that you are actually looking for. Now let's talk about retrieval chain. Now see, this querying from a vector store DB will just try to give you based on the context all the information that is available near those vectors, right? It'll just come and it'll display it in front of you. But let's say I want to ask a question which is much more meaningful. I really need to also provide context with respect to that particular question, right? So that is the reason why we will be using retrieval chain. Okay, so here we are specifically going to use a retrieval chain. Now this retrieval chain is quite important, and in this video I'll be explaining you about that. Okay, so multiple things I'm going to talk about. One is retrieval chain, then we'll talk about documents chain. Okay, document chain, and then how we can basically combine all these things and get proper response by using the LLM also. Okay, so that is what I'm actually going to discuss now. Okay, so quickly I will just copy this over here. I'll paste it over here. Okay, and understand guys, this retrieval that you will be seeing, right? It is a very important step because wherever we will specifically be working, we have to use this retriever. We have to use this specific chain in most of the RAG application or document Q&A chains, right? So that also we will be seeing it. Okay, so what we will do is that first of all, let's do something. Okay, I will go ahead and import from LangChain dot chains. Okay, now inside this you have something called as chain underscore document. Okay, so I will go ahead and write chain underscore documents. I hope so this, oh, not chain underscore documents, I'll not use chain underscore documents here. Instead I will go ahead and write combine underscore documents. Okay, and from here we will go ahead and import create stuff document chain. I will talk about this, what exactly it is, create stuff document chain. But here you can see that create a chain for passing a list of documents to a model, right? So as I said, right, my LLM model should also have a context about any documents to answer it much more properly, right? So that is the reason we basically use this create stuff document chain. Now what I'm actually going to do, I'm going to go ahead and create my prompt. And now with respect to this particular prompt, first of all, I will go ahead and go ahead and import this chat prompt template. So let me just go ahead and see where that library was present. So I'll be using from LangChain underscore code.prompts. Okay, I'm going to just import this chat prompt template. Now with the help of this chat prompt template, I will go ahead and give my own custom prompt. So I'll say from template, and this is what is my prompt. Okay, now inside this prompt, I will go ahead and just define it. So it will be triple quotes. Okay, triple quotes, and this will be a multi-line prompt. Okay, let's say I will go ahead and say answer the. So I'm giving some instruction to my LLM model. Answer the following. Okay, following question based only on the provided context. Okay. So I'm just going to ask this particular context. I'm just asking, say, hey, answer the following question based on the provided context. Now, what is this context? This context is the information that I will be giving to my LLM model regarding the information about the documents or text. Okay, so I will just go ahead and create something like this. I will close the context tab over here, and internally I will create a key on this particular name, that is context. Now, see, let's say that I want to probably search anything. Okay, so let's say over here I'll take one example. Over here, if I give this particular text, okay, now what it needs to do is that I need to get it context information. Context information basically means instead of searching the entire page, I can probably go ahead and give this entire paragraph, and I may say, hey, go and search for this particular text in this particular paragraph. So this paragraph becomes my context. So through this, the search will also happen very much quickly. Now, how do I get this entire paragraph as a context? And that is where we will be using something called as create stuff document chain. Okay. Now, inside this create stuff document chain, you will be able to see how we will be able to provide this context. Okay. So this is what is my entire prompt template. Okay. Now let me just go ahead and create my document chain. Okay. Now this document chain will be responsible in providing my prompt template this specific context information. Okay. Regarding any input that I'm specifically asking. Now this document chain is basically created by create stuff document chain, and here I have to give 2 parameters. One is LLM, and second one is something but prompt. Okay. But still, I have not defined LLM over here. So let us go ahead and create my LLM model. Okay. And for creating an LLM model, I am going to just use the same with GPT-4o. So I'll copy this. Okay. I'll paste it over here. So from LangChain underscore OpenAI, import chat OpenAI. I'm going to use this chat OpenAI with model GPT-4o. Okay. Now this is done. You'll be able to see that I've given my LLM. Okay. Now let's go ahead and see my document underscore chain. So here you'll be able to see LLM is not defined because I've not executed it. No worries. Now it should be able to execute it. Okay. Perfect. Now see, understand what this document chain is. It is a runnable binding. Okay. And the mapper is something like this. This is my chat prompt template. The input variable is context. Message is nothing but human prompt template with prompt input variable is nothing but context information. And here you will also be able to see that chat OpenAI chat completion is basically happening in this memory location, and you will be able to see the secret key which is hidden along with this chat OpenAI string output parser is also there, right? So step by step, first chat prompt template, then chat OpenAI, then string output parser. All has been combined together in the form of chain, right? After going through all this chain, it should be able to give me some context information. Okay, some context information about the thing that I'm searching for, right? In short, this is also a chain, and in this chain, you have initially chat prompt template, then you have chat OpenAI, then you have string output parser. One by one, it will go and it will give you some kind of output based on the context, right? Now, right now, I've got this entire information. Now, what I'm actually going to do is that I can also go ahead and use this document chain. So let's go ahead and do this. So first of all, I'll go ahead and write document underscore chain, and there is an inbuilt function which is called as invoke. Okay. Now inside this invoke, I will first of all give my input. Okay. The input will be the same thing which I gave it earlier. Let's say over here. So this will basically be my input. Okay. This will be my input. Okay. Now let's see. Let's execute this and let's see what kind of response we will get. Okay. So here it says, hey, key error context, because I'm not given the context yet, right? So from where can I view the context, right? It is very much simple, guys. Here, what I will do, I will go ahead and create my next field, and here I'm just going to give my context. So this is my input, which the user is basically giving, and this is my context, which I really need to give, right? And just to let's say over here, if I go ahead and give the context, right? Over here, I need to give the entire documents, right? So here, I need to probably give this entire documents. Whatever documents is basically present in this vector store DB. Okay. Now let me just create this document manually for currently, right? So I will go ahead and write from LangChain underscore core.documents. I'm going to import the document. Okay, the document has been imported. So now in this particular context, I'm just going to give a document over here, and it will be in the form of list. Okay, let's say, and I will just go ahead and write page underscore content, and this is what is the format we basically get the document in, right? Is equal to, and let's say I will go ahead and write over here. Let's say this is my context. Langsmith has two limits: total traces and extended traces. Okay, and I will give some more information over here. Let's go back. Let's see over here. I'll say like this corresponds to something, some more text. Okay, so I'm just adding it manually over here. Okay, so this is my entire context. Okay, and finally I will close this particular bracket over here. Okay, so this basically becomes my entire document context. Now if I'm invoking this based on this particular input, it should be able to give me the entire output. You see this, okay? So if I go ahead and execute it, see Langsmith has two limits, this is extended, this corresponds to the two metrics tracked on the usage graph. So I've given the context, I'm saying from this you search this and try to then give me the result. Okay, and here you can see just by seeing this particular example, document chain works absolutely fabulous, right? Now, anyhow, I will put one comment over here. Okay, I will put one comment saying that, however, we want the documents to first come from the retriever. We just set up that way we can use the retriever to dynamically select the most relevant documents and pass those in for a given question. Now, let me make you understand about retrievers. Okay, what exactly is this retriever? Right now, guys, I'm just giving a brief idea of creating this GenAI application where we have learned about document chain, where we have learned about data ingestion technique. Now, this is the most important thing: retriever. What exactly is a retriever? Okay, what exactly is a retriever? You know, right now I have this vector store DB, right? This vector store DB has all the vectors information available in that, right? Now, retriever can be considered as an interface. Okay, it can be considered as an interface, and its responsibility is that if anybody asks any input, right, then what it will happen is that this interface will just be a way of probably getting the data from the vector store DB. Okay, vector store DB, where we don't even have to do the similarity search, right? So what we do is that after we create this particular vector store DB, we convert this vector store DB into a retriever. Retriever is just like an interface. With respect to any input, I will be able to pass that particular input through this retriever and get the response from the vector store. You can just consider like a pathway to probably get the information from the vector store DB. Okay, and that is where now I will show you how we can go ahead and create a retriever, right? So in order to create a retriever, it's very much simple. I will go ahead and write vector store DB dot as retriever. Okay, so as retriever function. You can see over here written vector store retriever initialized from vector store, right? So this basically becomes my entire retriever. So here you can see this is my vector store retriever, tag is fires, OpenAI embedding, all the information is basically visible over here, right? This I will save it in my retriever variable. Okay, now see the magic. Okay, now I will go ahead and say, hey, I will go ahead and import from LangChain. Okay, since I've already created the retriever, so I'll go ahead and write from LangChain.chains import create retriever chain. Okay, now see this magic. What will happen with the help of this create retriever chain? Now this create retriever chain basically takes the first parameter as retriever, okay, retriever, and the second parameter as document chain. Now see the magic over here. Why I'm giving this two parameters over here. First, we need to combine this retriever, which will be taking the information from the vector store DB, right? And that is the reason we converted it from here, right? By just using this as underscore retriever. And then we are using document chain. Document chain will be responsible in giving you the context information, right? And then when we're creating this chain, along with the document chain, we are also going to use the retriever. Over here, when we created this particular prompt, this context information will basically get filled in the chat template using this particular document chain that we have defined over here, which is nothing but create stuff document chain, right? So create stuff document chain only we created over here, right? So here you can see, right? Create stuff document chain. So we are going to combine this chain along with creator retrieval chain, right? Which is nothing but my retriever, and the context will be given by this particular document underscore chain, and we'll be able to get the information. Now here, I'm just going to go ahead and define my retrieval underscore chain. Okay, perfect. Now let's go ahead and execute it. Now once this is there, what is this retriever underscore chain, right? It's very much simple. See all these things step by step. Initially, it has this runnable binding parameters over here. You can see first of all I have the chat template, then chat OpenAI, then string output parser. Inside this, you have something called a stuff document chain, which will provide you the context, right? All this information is specifically there. You can see it. Now finally, we will get the response. Let's get the response from the LLM. Okay. Now for this, I will go ahead and use my retriever chain dot invoke function, and this time I will give my invoke with respect to the input. This input is passed by us, right? Whatever input we want. And let's say in this particular input, I give the same text, LangChain, so and so, and this extended. Okay, some information over here. So this basically becomes my input, right? That's it. I just need to give this particular input. It will invoke this entire answer. Now over here, what I'm actually going to do, I will go ahead and create my response. So as soon as I call the retrieval chain, it's going to go to the chat prompt template. And if you see over here, there'll be an input which is called as context. Okay, this context is going to get filled by what? Stuff document chain. Then we have this chat OpenAI, then string output parser. Finally, when I get my response, inside this response, there will be a parameter. Response. There'll be a parameter which is basically called as answer. Okay. In this key, I should be able to get my answer. So let's go ahead and execute this. So yes, you can see to set up usage in Langsmith, navigate usage billing, then you'll be able to find a table, all with the associated cost, and all the information is specifically there, right? And this is how you probably get the entire information, right? I've basically created a document Q&A. Okay, let's do one thing. Let's go ahead and just print this response also. Now see, in this response, here is my input, right? Here is my context. See, this is the context that what I was actually talking about, right? Document page content user element to this is this more than 10%. All this are my context, right? And answer, it is selected. This particular answer, usage billing and all, based on the context it has, right? So all the information is over here. And if you also want to probably go ahead and display your context, you can go ahead and write it down. Response of context, okay? And if you go ahead and see this, this basically shows you the entire context, right? All these documents basically from where it has got the context from, right? And this is only going to get fit where in your prompt template where we have created this context variable, right? So I hope you're able to understand this, but at the end of the day, I've completely created an end-to-end project from a simple, like I can say that, okay, this is a simple generative AI application. Initially, we went with data ingestion, then we loaded the entire documents, then we divided our entire data into chunks, documents into chunks. I'll not say text, but I'll say document into chunks, documents into chunks, documents, okay? Then all the text from the document is converted into vectors, then embeddings, right? So here you'll be able to see this is my documents. Then we use OpenAI embedding to convert all our text into vectors, store it in our vector store DB. Here we have used Fires, we can also use ChromaDB. Then query from a vector store DB, I used similarity search. This was one way. Then we used LLM model. We created create stuff document chain because when we were designing our chat prompt template, there was a context that needed to be used, and this create stuff document chain is going to provide this particular context. And finally, here you can see I created this. Then we combine our document chain by seeing one example over here. And finally, we are able to see this vector storedb as a retriever, and we are able to find out the retrieval chain, and we are able to invoke based on any question that we have. We'll be able to get the response. Not only that, you'll be able to explore the context, you'll be able to explore answers, whatever thing you specifically want. So this was most of the things that we have actually discussed over here, which is quite amazing. And over here, as an end-to-end project, we have actually developed it, right? Yes, in the next video, we are going to discuss still more things that are remaining over here, and then we are going to also see how, with the help of Ollama, we'll be able to do it, right? So Ollama is another application which actually helps us to access open source LLM models, right? So yes, this was it. I will see you on the next video. Hello guys, so we are going to continue our LangChain series. Already in our previous video, we have seen that how with the help of OpenAI API, we can probably create a generative AI app. One of the examples that I had actually taken, I took this entire website as my data source. I read all the content and converted this into documents. Later on, I divided that documents into a chunk of documents. And after that, we used some kind of embedding techniques, specifically OpenAI embedding technique to convert this text into vectors. And finally, we also used Files, which was a vector database. And then with the help of document chain and retriever, right, we were able to create an amazing LLM Gen AI application where we were also able to use LLM models along with our prompt engineering, that is prompt template, and we were able to get the response from this particular text. So all those things we specifically did. And now the scenario will be that many people will not be having OpenAI API, and obviously they may not be even having credit card, or they may not be uploading $5 credits, right? So for that, this video will be super important, because here I'm going to use Ollama, and along with this, I'll be using your open source LLM models, which you can run completely locally, right? So if you don't know about Ollama, you will be able to run large language models, specifically open source large language models, in your local machine, and then I will try to probably show you how you can create this generative AI application with the help of this. Okay, so quickly, let's do one thing. First of all, you need to go ahead and download this Ollama, right? So this Ollama, it is available for Mac OS, Linux, Windows, right? So all operating system is obviously available, but you need to have Windows 10 or later. So right now I have Windows 11. So if I go ahead and download this, I'll go ahead and click it. So here you'll be able to see that exe file will get downloaded. So this is the exe file. You just need to double click it and just keep on pressing next, and then your Ollama will start running. Okay, so just to give you an idea, once Ollama will be running in your background, right, in the background services, you'll be able to see this kind of icon, right? And this icon is nothing but this is the Ollama icon, which will be running in the background process. Okay, so once you probably do the installation, then I'll just go ahead and tell you like what all things you can specifically do with Ollama. Now Ollama, if you probably go ahead and visit this GitHub, right, it is completely open source, anybody can use it. Here it supports a lot of open source LLM models like Llama 3 8b, Llama 3 7b, 5.3, Gemma 2, Gemma Mistral. Then you also have Llama 2 Uncensored, Lava, Solar. So different open source models like Gemma, everything is there. Okay, now once you download this Ollama, how to probably download this entire model. So I will just go ahead and open my command prompt. You can open your terminal if you're in Mac, or Linux. Now inside this, I will just go ahead and write Ollama run any models that I really want to work with. Right? Let's say that I want to go ahead and work with Llama 3. So I'll just go ahead and say, hey, first of all, we need to download Llama 3. So here I'll just go ahead and click this. I'll remove this over here and paste it over here, right? So as soon as I go ahead and write Ollama run Llama 3. So initially, let's say if in my machine this Llama 3 is not downloaded, so it will go ahead and download this entire LLM model, and then you'll be able to even execute it in this command prompt by just giving some input and getting the response. So let me just go ahead and press enter. So here you'll be able to see that Llama 3 is already downloaded in my machine. So you'll not be able to get any configuration over here, because usually when we are running Llama 3, it is nothing but let's say if I'm going to use this 8 billion parameters, it is nothing but it is 4.7 GB file, right? So here you can see as soon as I write Ollama run Llama 3, since I've already downloaded it in my local machine. For you, if you're doing it for the first time, you'll be able to see that your Llama 3 will get downloaded over here. Okay, so in my case, since I don't want to make this particular video, so I did this particular download beforehand, right? Now here, let me just go ahead and write some message. Hi, you can see that how quick we are able to get the response. This response is specifically coming from Llama 3. So let me just go ahead and write what is generative AI. I will also be able to get the response quickly. And this model is basically there in my local machine, and it is basically interacting from there. And how fast it is, right? And obviously you need to have a good configuration of your system. If you do not have it, it may take some time to get the response. Okay, so obviously you can do this. Then I'll just go ahead and write exit. Okay, so here you'll be able to see that any type of conversation I will be able to use it over here. Okay, similarly any model that you really want to work with, right? Let's say if I go ahead and write Ollama run, there's also one more model which is called as Gemma, right? So let's go ahead and download this Gemma 7b. Okay, so here you can see I'm just writing Ollama run Gemma 2b, right? 2 billion parameters. So here you can see quickly we will go ahead and see this. So if I go ahead and write this Gemma run, so first of all let me do one thing quickly. Okay, so let me just execute it over here, or let me just go ahead and open my command prompt again. Okay, and you can run it from anywhere. So I'll just go ahead and copy this entire thing. Okay, paste it over here. Now see, I've also downloaded Gemma 2b. So directly I'm getting the prompt. Hi, who are you? Okay, let's me go ahead and write this particular message. Who are you? I'm a large language model trained by Google. I'm a conversational AI that can assist with a wide range of tasks, including language translation and information retrieval and creative writing. Right? How can I help you today? Please provide me Python code to play Snake game. Okay. I'll just go ahead and write this. So this is my entire Python code. You'll be able to see this. And if you don't know about Gemma, it is an open source model by Google, right? So we will be using this kind of models, and along with this, there are a lot of open source models like 5.3 Mini. You have Mistral, you have Neural Chat, you have Code Llama. Code Llama is specifically for getting response with respect to any kind of codes that you have, right? So all the specific models you'll be able to run it. Okay. So this was about the initial setup of Ollama, and again, it is very much simple. We just go over here, download the exe file, or based on your Mac OS or Linux, you get that particular file extension, and just go ahead and install it. And once you install it, it will be running. And then with the help of command prompt, first of all, to use any model, let's say I want to go ahead and use Llama 2, or I want to go ahead and use Llama 3, I have to first of all download it. That is compulsory over there. Let's say that in my next example, I will be showing you how I will be using Gemma 2b, 2 billion parameters model, specifically to create my generative AI application. And for that, you have to first of all download that in your local machine, right? So in my next video, I will be showing you how you can go ahead and create a generative AI application, complete end-to-end. That is what we are going to discuss about. So I hope you like this particular video. I will see you in the next video. Thank you. Hello, so we are going to continue the discussion with respect to our LangChain series, and in this video, we are going to create a generative AI application with the help of Ollama, where we'll be using open source models. So let me quickly go ahead and open my files. So here you can see these are my entire files over here. Okay, and I can do all these tasks which we did with OpenAI, but here I've created another folder. So let me just go ahead and create my app.py, and we'll try to create an end-to-end project. Okay, and this end-to-end project we will be using Streamlit, and we'll be using some requirement.txt and all. Okay, so first of all, as usual, what I'm actually going to do quickly, first of all, let me just go ahead and open this over here. Okay, I will be using all this information. Okay, over here also, because I really need to have, I don't need to have OpenAI key. Okay, I'll remove this, but for my LangSmith tracking, I need to have all these particular values like API key and all, right? Now, quickly, what I'm actually going to do is that from from, I'll go ahead and import some of the libraries. And for importing some of the libraries, I will go again over here. Okay, let's go ahead and from LangChain, okay, underscore community. Now, Ollama is basically present inside this library itself, LangChain underscore community, because Ollama is something is just like a third-party integration where you can use various models, right? So LangChain underscore community dot LLMs. Okay, if you use this, I will be able to import Ollama. Okay, and Ollama will be specifically used in order to create my LLM models. Okay, so here we have this Ollama. Okay, along with this, you'll be able to see that I'm going to use Streamlit. So let's go ahead and write import Streamlit as ST. And since we are working in the virtual environment right now, Streamlit is not available. So let me just quickly go ahead and install this also in the requirement.txt. So here in my requirement.txt, I have this. Let's go ahead and install this. So quickly, we'll go ahead and write pip install -r requirement.txt. Okay, so here you can see all the installation will start taking place, and my Streamlit library, which is the recent one, that will also get installed. Okay, so let this installation takes place. It will probably take some amount of time with respect to this. Now I'll go to my app.py, and since you know that I've imported Streamlit as ST, along with this, I will go ahead and from LangChain underscore core, I'm going to basically use LangChain underscore core dot prompts. Okay, I'm going to just import chat prompt template. Okay, chat prompt template. So chat prompt template is basically to design my own chat prompt, like what I really want this open source models to do. So that entire thing I'll be defining in this particular chat prompt template, like how we did it in the simple app, right? We also imported this. See over here somewhere we have used chat prompt, right? So if I go and show you down, this is what is my chat prompt template, right? So I'm also going to use it over here. Now once this is done, now let's quickly go ahead and write from LangChain. Okay, so I think the installation has been done, right? It's complete. Perfect. So we are good to go. Let me do one thing. Let me just hide my face so that you'll be able to clearly see the text. Okay. Then quickly I'll go ahead and write from LangChain underscore core dot output parser. I'll also be using this string output parser, str output parser. Okay. So all these things are there. Okay. Now quickly let me just close this file and again open it so that I'll be able to load all these libraries clearly. Right. I don't know why this libraries are not getting loaded because I will just be able to see some green color or something like that. Okay. But since we are using Streamlit, let me do one thing. Let me just quickly run this. So in order to run Streamlit, I will just go ahead and write Streamlit run.app.py. So quickly you'll be able to see, okay, app.py does not exist. It's okay because I need to go inside this particular folder, LangChain and then Ollama. Okay. So here I'll go ahead and write cd1 LangChain. So inside this particular folder I'll go. Please make sure that you see this how I'm running this particular file because this app.py is available inside this 1.2 Ollama folder, right? Inside one LangChain and 1.2 Ollama. So I will go again back to this 1.2 Ollama. Okay. And here I'm just going to write Streamlit run app.py. Okay. So we'll go ahead and execute it. See any error is probably coming up. So this is the Streamlit app. Right now, no error is there. It is a blank page. So I think whatever things we are doing, it is working absolutely fine. Okay. So this is the local host where it is specifically running. Okay. So let me just close this again. We'll go ahead and close this particular terminal and we'll continue our coding with respect to this. Okay. Now we have actually done this. We have also used this Langsman tracking. Now the thing is that we need to use this Ollama LLM model, which I've actually imported over here. Okay. So let's quickly do this. First of all, I will go ahead and design my prompt template. Okay. Now inside this prompt template, I'll go ahead and create my prompt. This will be my chat prompt template. Okay. Template dot from underscore message. Okay. And inside this, I'm going to basically define my prompts. So first of all, I'll go ahead and say this will be my system prompt. Right. System basically means what I really want the AI assistant to do. So I'll put a message over here. Hey, you are a helpful assistant. Okay. Please respond to the question asked. Okay, so this is a simple prompt that I'm writing over here. Okay, so this basically becomes for my system, and now with respect to the user, I will give an input to the user saying that hey, this will be my question. Okay, so this will be my question, and this question will be I'll be using an input variable which is like question over here. Okay, so this basically becomes my chat prompt template. Very much simple over here, right? And this is my Langsman tracking. Everything is fine, and I've also created my chat prompt template. Perfect. Now let's go ahead and design my Streamlit framework. Okay, so here I'll go ahead and write Streamlit framework. Okay, and inside the Streamlit framework, let me go ahead and write my st.title. Now with respect to the st.title, I'll say hey, this is my LangChain demo with. Let's say I want to go ahead and use Llama 2 or Google Gamma model, or let's go ahead and say, right, Google Gamma model, okay? Google Gamma, or let's go ahead and see Llama 2, okay? I've also installed Llama 2. Llama 2 is a model, LLM model from Facebook, okay? So Llama 2, okay? Now, again, you can go ahead and use Llama 3, whatever you want, you can go ahead and use it, okay? So I'll just go ahead and write my input underscore text, and here I'll be saying, hey, this is my text underscore input, okay? With respect to this, so here you can see everything is got loaded. It'll take some time, but right now you can see everything is in green color. Now inside this text.input, I'll say, hey, what question you have in mind, okay? Something you have in mind, okay? So this is my first question. It is a text input over here. So I will probably write any question over here and I will go ahead and ask my LLM models in short. Okay. Then quickly, what I'm actually going to do over here is that I will just go ahead and call my Llama 2 model. Now see, this is the most important thing. How do I specifically call it, right? You know that Ollama is basically present in LangChain communities.llm. So I can use this class of Ollama and I can create my Ollama. I can go ahead and create my Llama 2 model. Okay. So if I go ahead and write Llama 2, so that basically will go and search in the local whether Llama 2 model is present or not. If it is not present, then you have to probably go ahead and use a command prompt and go ahead and just write Ollama run Llama 2. Along with Llama 2, you can also go ahead and explore any other model that you want. Let's say in this particular case, I will be writing, so Llama 2 is here. I'll just use Gamma 2b. Okay. So if you want this, I'll also show you this. So here you can see this is my model. I'm going to use Gamma. Gamma is my Google open source model. Okay. Again, it is an LLM model altogether. Right. Now let's say that I've used this particular LLM model. So I'll just go ahead and update this Gamma model itself. Okay. And let's call this, and you can call any other model, right? Whatever model name is over there, you can just go ahead and write it over here. Okay. But please make sure that you do the installation or you download that particular model in your local just by writing Ollama run that specific model. Now I'll go ahead and probably create my output parser to just show that how my output should be displayed. And then finally I'll go ahead and create my chain. Now I've already in chain, what I'll do first, I'll go ahead and use my prompt. Then after using prompt, I'm just going to use my LLM. And after using my LLM, I'll be using output parser. Right. So all these things will be there. Now finally, in order to run it, I'll say, hey, if I put anything in my input text and if I press enter, right, what it should do, it should basically take this particular chain and invoke this chain by giving this input parameter of question, and whatever input is basically coming, it will basically come from this input text. Okay. Now with respect to this, I will be getting some kind of response, and this response I will just go ahead and write it in my in my system. Okay, so here you can see I'm writing it in my system. So here, this is what I've actually done it, right? And this is the beautiful thing. I've used the Ollama open source model over here, no OpenAPI and all. You'll also be able to see that we'll be keeping the track in the Langsmith, and this time you'll not be having any cost involved. So let me go ahead and execute this. So here, first of all, I will just go ahead and open my command prompt. Okay, let me quickly delete this. Okay, now I will go ahead and write streamlit run app.py. This is how you run a streamlit file. Please make sure that this will give me an error. The reason is very simple. I am not inside the right folder where app.py is present, right? App.py is basically present in 1.2 Ollama folder, which is inside one LangChain. Many people will find this as a confusion. They are not able to run it, and it shows file does not exist over here, right? So what we will do, we will go to this location, cd 1 LangChain, then cd 1. Let's say 2 Ollama, and here I'll clear the screen. Now before I run this, I will just make one changes over here. Inside this Ollama, I'm just going to give my model parameter. Okay, so this will be my model parameter. Otherwise, it'll give us an error. Okay, the reason is very simple because it will say that hey, you have given one additional parameter or something like that. Okay, so let's go ahead and now run it. For running it, I have to make sure that I have to just go ahead and write streamlit run app.py. Now let's go ahead and run this entire thing. Now here you can actually see this is what it is there, LangChain demo with Gamma model. Now what question I have in mind? So I'll just go ahead and ask, hey, what is generative AI? So quickly I'll go ahead and press enter. You'll be able to see that I will be able to quickly get the response. And again, everything is running over here. You can see we will be communicating with this Gamma model, and finally you can see that I'm able to see that entire response, right? So I hope you are able to understand that how we can probably use Ollama and create our entire end-to-end Gen AI application with any custom, with any open source models like Llama 3, Llama 2, Gamma, or any other models that is available or supportable by Ollama. So yes, this was it from my side. So let me quickly go ahead and close this particular connection so that I will be able to open some more things. Okay, and now in my next video, I'll be discussing about more amazing things with respect to developing generative AI application. But yes, this was it from my side. I will see you in the next video. Thank you. Hello guys, so in our previous video, we had seen that how we created this LangChain demo with Gamma model with the help of Ollama. And here you could see that I asked any question and it is able to give me the answer. Let's say if I go ahead and ask what is machine learning, I'll be able to see that. Once I press enter, I'll be able to get the response. And again, this is interacting with the Gamma model that is downloaded locally with the help of Ollama, right? One thing that I forgot to tell you about, like see in my code which I was actually running, right? Here we are making sure that the tracking also happens, right, in the Langsmith. So in this video, I'll be talking about like how this entire information is basically getting tracked in the Langsmith. And the best thing is that no cost is involved. In OpenAI, usually cost was involved, but in this, nothing is there. So let me just go ahead and open this. So this was my project. Okay, so Gen AI app with OpenAI. So here you can see what is machine learning, what is generative AI. This was the question that I asked. So let's open this first one. So see, how is the runnable sequence? So first of all, I got the chat prompt template. So let me just hide my face so that you'll be able to clearly see it. So my input question was, what is machine learning, right? And here you could basically see that I'm getting some kind of content to my AI assistant. It is saying, hey, you are a helpful assistant. Please respond to the question that is asked, right? And then once we go from here to Ollama, right? Now here with respect to Ollama, here we are going to use the Llama 3 model, right? You can also open the playground if you want. But here you can see my human question is that what is machine learning? Then this entire message is basically getting displayed by the Ollama itself, right? Ollama, which is using this Gamma model, right? And this is what is basically getting returned, okay? Now after using this prompt and completion from Ollama, I will go ahead into the string output parser, that is str output parser, and with respect to this, you are able to see this entire output that is basically getting displayed along with the styling, right? Which is amazing. So this entire chain here you can see that it is being tracked. How much latency is there? How much time is basically taking up? With respect to more information. Let's say if I want more information over here, if you go to the right side, right? How much token? See, cost is 0. There is no cost involved over here, right? So this is also amazing. See, no cost is involved, right? So over here, no cost is involved because I'm using a complete open source model, right? So I hope you are able to understand this with respect to the kind of thing that we have developed. If you still feel that OpenAI, you don't have credit card, you don't want to use any balance as such, you can go ahead and use open source models, right? And that is what I'm actually going to show you as we go ahead more amazing end-to-end projects that I'm trying to create, right? So yes, this was it from my side. I hope you like this particular video. I will see you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to LangChain, and already in our previous module we have discussed about some of the very important components of LangChain that we usually use. That are nothing but like document loaders. We also discussed about data transformation technique where we are dividing our documents into chunks of text or chunks of documents. After that we also saw how we can convert this text into vectors by using various vector embedding techniques, and after that we also saw how to store this vector embeddings into our vector store database. And finally we could find out the response of our output with the help of both a retriever, and along with that we also use some kind of LLM models. Okay, so now we are going to go ahead and build some amazing simple LLM applications. So in this video we're just going to build a simple LLM application. And in the upcoming videos, many things we're going to add on top of it. Okay, so what we're going to discuss in this video, we're building a simple LLM application with LCEL. Okay, so this is a very important word. If you don't know the full form of LCEL, it is nothing but using LangChain expression language, and this is basically used to chain components together. Okay, so what we're going to do in this tutorial here, I've given a brief information. In this quick start, we'll show you how to build a simple LLM application with LangChain. This application will translate text from English into other languages. This is a relatively simple LLM application. It is just a single LLM clause plus prompting. So I will also be talking about prompting over here. Still, this is a great way to get started with LangChain. A lot of features can be built, and that is what we're going to see in the upcoming series of video. Right. So after seeing this video, you'll be getting a high-level overview of using language models, using prompt templates and output parser, using LangChain expression language to chain components together, debugging and tracing your application using Langsmith, and finally deploying your application with Langsa. So everything we will go ahead and discuss about it. Here in this video, we're also going to discuss about something called as Langsa. Okay, so multiple set of videos are going to come with respect to this. So let's go ahead and discuss this entire thing. But at the end of the day, after completing at least this particular module, you will probably get the best hands-on experience of building the LLM application. I'm going to make that sure. Okay, so let's go ahead. So first of all, here we will go ahead and install. That is nothing but LangChain. Okay, so I will go ahead and write over here pip install LangChain. Okay, so we definitely require this, and already in our previous module we have done this installation, but just for the people who have directly jumped into the session, I'll just show you how to do the installation. So once we do the installation in this specific environment, it will get installed. You can see already the requirement is already satisfied at my end. Okay, the reason is because I've already done the installation. So please make sure that you go ahead and write after the installation this particular library name in the requirement.txt, right? How I've actually shown you in the previous module. Now After this, what we are going to do in this particular video, that is very much important. Here, see, in our previous module, we have shown how to use the OpenAI API key, right? And with the help of this, we try to interact with some LLM models over there. Now, the most important thing that you really need to understand from this is that whenever we try to create an OpenAI API key, you have to go to the account and create it. So one problem that I usually find that many people do not have credit card or debit card, and they don't even want to invest some money in just going ahead and seeing OpenAI API calls, right? And OpenAI API is basically paid if you specifically use both the embedding or any other models like GPT-4o or GPT-4 Turbo or GPT 3.5. So there will be some charges involved. So in this video, I'll just not show you OpenAI. I will also go ahead and show you how you can use open source models, okay? Open source models such as Llama 3, okay? Llama 3 from Meta. I will also show you how to use this Gemma 2 model, which is a recent model that has become, it's an open source model that has been brought by Google before it was Gemma 1. Along with that, if you want, you can also go ahead and use Mistral, okay? So all this kind of various model we are going to see how we can actually use it. And to use this open source model, I'm going to use a platform which is called as Grok, okay? So the first thing what I'm actually going to do is that I will go ahead and show you how you can go ahead and create your Grok API key. OpenAI API key is already there in the env file, which we basically created in our previous module. So let me do one thing quickly. Let me just go over here. I will open my Google over here, okay? I'll just go ahead and write Grok LPU, okay? Now, what exactly is this Grok LPU? We'll discuss about it. So first of all, instead of just searching, I will just go ahead and do grok.com. Okay. So once I write grok.com, this is what platform you'll be getting. I have right now signed in. If you're not signed in, so please make sure that you go ahead and create your account over here, sign up, because Grok actually helps you to access all these open source models like Gemma 2.9 BIT, other than that Gemma 7 BIT, Llama 370 billion parameters, Llama 3 8 billion parameters, Mistral 8 into 7B. All these models are completely open source, and these are like powerful models. These are from tech giants. Now, to access these models, you definitely require API key because Grok has deployed this particular model in its own cloud, and over there they have used this amazing inferencing, which is called as LPU AI inferencing engine. Right now, what exactly is this LPU AI inferencing engine? Let's talk about it. So first of all, we will go ahead and click on why Grok. Okay, you need to understand why Grok. So Grok is a fast AI inference. Okay, what is exactly Grok? It is an AI infrastructure company that delivers fast AI inferencing. Let me tell you one thing, guys. Right now, in this generative AI era, every bigger companies are in that competition to probably create the best LLM models. Okay, every company, like let's say Llama 3, open source, they're coming up with this Llama from Meta. Specifically, Llama 3 model has come from Google. Gemma 2 model has come. You know, if I probably talk about OpenAI, again there is a GPT-4o model, right? It is a multi-model which works with both text and images. So all these specific models are there, right? And all these tech giants are in fierce competition. Who actually brings the best accuracy out there? But I still believe that the company, instead, the company who will win is that who will be able to help us in the inferencing, right? Because all these models are huge models, and we really need to deploy this particular model somewhere. Let's say that if we are using our own inferencing, or if we are using our own premise, right, to deploy that particular model and use it for inferencing, then there will be a lot of charges for that, right? It's not that simple. There will definitely be a lot of charges. And Grok, what it has actually done, it has brought this amazing LPU inferencing engine, right? So what is an LPU inferencing engine? LPU stands for Language Processing Unit. It is a hardware and software platform that delivers exceptional compute speed, quality, and energy efficiency. And because of this, this is really, really fast. You'll be able to get the response in no time. You'll be seeing it. Once I will probably go ahead and execute things right in front of you, you'll be able to understand how powerful it is. Now, why it is so powerful and why it is faster than GPUs, that also you really need to understand. The LPU is designed to overcome the two LLM bottlenecks. One is compute density and memory bandwidth. An LPU has greater compute capacity than a GPU and CPU in regards to LLM. This reduces the amount of time per word calculated, allowing sequence of text to be generated much faster. Okay, so this is what it is basically doing, is that it's the two bottlenecks is basically there in the GPU, which is called as compute density and memory bandwidth, and it is fixing that. You can go ahead and read about more about this particular research paper, and probably understand about the architecture and all. But again, thanks to Grok, this AI infrastructure is giving us some APIs to probably call all these kind of LLM models and use it for our application purpose. Okay. Now let's go ahead and let's do this. So first of all, I will go to my grok.com. Okay. Now let's go ahead and log out. I will first of all show you how the homepage looks like. So this is what you will be able to see. So first of all, go ahead and sign in. For signing it, I will just go ahead and use my Google account. Okay. So I'll just go ahead and click on Google. Right. Now, as I said, here are so many different LLM models. Now, if you want to use this LLM models with the help of in the Grok AI platform, specifically from here, we have to go ahead and create our we have to create our API key. Now, in order to create an API key, I will go ahead and click on Grok Cloud. Let's open this in a new link. Over here, you'll be able to see playground documentation, right? How to use this Grok API key. Everything is over here, right? How to use it along with the library. Everything is basically available, right? We will talk more about this, but let's go ahead and create our API key. So here you can go and see that I've created so many API keys. You can use any of the API key that you want. In order to create it, just click on Create API key. Give the name of the API key, like something like Grok Test, and just click on Submit. Once you click on Submit, you'll be able to get this secret key, something like this, right? It is not visible right now, but once you create it, you'll be able to create that secret key. Once you get the secret key, please copy it, and then you go to your environment variable, and here you can see I've also created this Grok underscore API key with this particular secret key because I've already created it. Okay. Now, with the help of this Grok API key, I will try to call the open source models. Okay. So let's go ahead and let me show you how you can basically go ahead and do it. So first of all, I will go ahead and write import OS. Okay, import OS. Along with the OS, I'm also going to say from .env, I'm going to import load underscore .env. Okay. Now let me just go ahead and initialize load underscore .env. Okay. So now this load underscore .env, right? It actually loads all the environment variable. I have both my environment variables of OpenAI key and Grok API key. In order to load the OpenAI key, what I can do, I can just go ahead and write import OpenAI, and here I'll just go and say OpenAI .api key is nothing but here I will say os.getenv. os.getenv, and here I'm just going to give my key name, which is nothing but OpenAI underscore API underscore key. Okay. This is done, right? That is how I actually call. Now I can go ahead and just use any OpenAI models, and I can basically go ahead and do my further task, whatever task I really want to do, right? Similarly, in order to create the Grok API key, what I will basically do is that I'll say, hey, this is my Grok API key. I will go ahead and create this, and I'll say, hey, this is my os.environment, and let me just go ahead and call, os.getenv, I'll say, and here I'm just going to go ahead and call my Grok underscore API underscore key. Okay. Now this basically is my Grok underscore API key. Okay. Now understand one more thing. I have got my key. This is my key that I'm actually going to use to interact with the models, right? Now the next library that I'm actually going to use is something called as pip install LangChain Grok. Now understand why I'm installing this library, because this library will be responsible in taking that particular API along with interact with any LLM models that are deployed in the Grok platform. Okay. So first of all, we'll go ahead and install this. So here I think I've already done this installation because I don't want to take much time. So here you can see it is already satisfied. Okay. Now do one thing. As soon as I do this installation, you also need to go ahead and update in the requirement.txt. So I've already done that. I've updated in the requirement.txt. And please do not miss that, because later on, whenever you want to do the installation, you can directly go ahead and write pip install requirement.txt in the same environment that is called as VMV. Okay. Perfect. Till here, everything is done. Now let's see how to call our model. Okay. So I will go ahead and write from LangChain. LangChain underscore Grok, and we will be using this. We'll not be using OpenAI. Yeah, in some of the use cases, we'll be using OpenAI API keys because it actually performs well over there. But in most of the use cases, I'll go ahead and use this open source API keys itself, right? So here I'm going to import something called as ChatGrok, right? So whenever I go ahead and import OpenAI, so for that I use from LangChain underscore OpenAI, I'll import chat OpenAI, right? But in the case of Grok, I will be importing ChatGrok. Now see, this is what LangChain is basically doing. LangChain wants to probably create integration with every LLM platform out there, right? LLM models out there. They'll say, hey, you all bigger companies, you keep on competing, you bring up new models, but we will create a wrapper which will help us to integrate with any kind of model that comes in the picture right now, right? So that is what it is basically doing. Now let me show you how we can go ahead and call a specific model from Grok AI platform, specifically the open source model. So first of all, I'll go ahead and initialize ChatGrok, and I will say first parameter that I need to give is my model name, okay? And the second parameter, I will go ahead and write my Grok API key, which will be equal to my Grok API key, right? So this is what I'm actually initializing. Now we need to understand what model name we will give, okay? So to give the model name, so I will just go ahead and use this one. This is the most newest model, Gemma 2 9B IT, okay? So if you want to know about this particular model, it is nothing but it is a 9 billion parameter version of Google Gemma models, a family of lightweight state-of-art language models from Google with open weights and pre-trained variants. Okay, so we are going to use this specific model out there. So quickly, let's go ahead and open this over here. Now I will just go ahead and write, let me just see the model name, Gemma 2 9B IT, okay? Gemma 2 9B IT, Gemma 2 9B IT, okay? So this is specifically my model over here. And with respect to this particular model, if I go ahead and execute it, so here you'll be able to see that I'm able to call this model, and the model name is nothing but Gemma 2 9B IT. So let's see, Gemma 2 9B IT. Okay, so this particular model is basically over here. Now, with the help of this specific model, we are going to develop our entire application. I've already shown you how to call chat OpenAI model name. Already we have set up this particular environment variable. I can just go ahead and write chat OpenAI and give the model name over there. That's it. Automatically the model will be initiated. Perfect. I hope you got an idea till here. Now, in the next video, we will continue this implementation. But in this video, I've shown you how to even set your Grok API key to access the open source model that has been hosted or deployed in the Grok AI platform. And remember, you will be able to use this particular API key for some number of requests completely for free. And I think I've never faced a problem with respect to the number of requests till now I'm using it. You can also go ahead and use it, okay? So yes, this was it. In the next video, we are just going to continue the implementation of Simple LLM by LCL. And then after loading this particular model, we are going to see what all things we will do, okay? So yes, this was it from my side. I'll see you in the next video. Thank you. So guys, now let's continue and let's start building our LLM application, okay? So see, if I want to probably interact, see, whenever a user gives any kind of query, building an LLM application basically means, let's say if I'm giving any query to my model should be able to give some response, okay? But you should understand some very key libraries that are specifically used in LangChain, which we also say it as runnables, okay? So we'll be discussing more about it as we go ahead. But just to give you an idea, like which are the common libraries that we specifically use? Like let's say if the LLM model is getting some kind of message. If I want to tell the LLM model to behave in a certain way, how do I probably mention that? All those things also we'll go ahead and discuss. So first of all, what I will do is that quickly I will go ahead and install one more library, which is called as LangChain underscore core, okay? Now this particular library is important because I will be discussing about some of the libraries that I'm actually going to use from this particular library itself, right? Some of the important components. So once I install this, you can also see that the requirement is already satisfied. I will go ahead and update in the requirement.txt. Now I will go ahead and write from LangChain, okay, underscore core, okay, dot messages. I'm going to import. One is called as human message, and the other one is something called as system message, okay? Now, why this human message and system message is required? See, whenever we chat or whenever we provide any messages to our LLM model, we should specify our LLM model which message is basically provided by the human being and which message is a kind of instruction to the LLM model. So the system message that you have, this is just like an instruction like how the LLM model should basically work like, okay? So here what I will do, I will go ahead and create a list of messages, okay? And this list of messages I'm going to pass to my LLM model, okay? Now inside this list of messages, I have to first of all say, okay, how the LLM model should behave like. So here I'm just going to use my system message. I'm going to say that, hey, let's create this particular content. The content will be, I will say, hey, translate the following from English to French, okay? French. So this is what I'm actually telling my LLM model to basically do. The second message will be that whatever human is basically asking, what sentence it really needs to convert, we can go ahead and write human message is equal to, and here let's say I'll go ahead and write content as hello, how are you? Okay, so this is the content that I really want to send to the system, that is my LLM, and get the response, okay? So we have created this list of messages in the form of system message and human message. Again, repeating, what the system message basically does is that it instructs the LLM model like how it really needs to behave or work like in this particular case, it needs to work like a translator, which will be converting from English to French. Then I'm also giving the human message, like what sentence I really need to convert. Now, if I get this list of messages, now I can use my model, I can invoke this specific messages. So let me just go ahead and invoke this. And once I execute this, here you'll be able to see some output. And this output starts with something called as AI message. And the output over here is bonjour. Whenever I get an output which says of AI message, this basically means it is a response from my LLM model. Okay. So here it shows, hey, content is bonjour, and that is what we basically say, hello, how are you? In French, if you try to convert this, we basically say bonjour, comment all is woes. Okay. I don't know this one, but at least I know bonjour. And I think it is correct itself. It cannot be wrong because we are working with powerful LLM models. Then along with that, you'll also be able to see some response metadata, like how much tokens it has basically created, how many prompt tokens are there, total tokens, completion time, prompt time, right? Total time, along with that, which model name we have basically used. And these are my metadata information that you'll be able to see. At the last, you'll also be able to see that how many were input tokens. So input tokens were 26, output tokens I got as 11. So total tokens is 27. By seeing all this particular information, get to know that how much cost is basically involved with respect to each request. Now, when I'm getting the output as AI message, okay, that basically means we're getting the response from the LLM model. Okay. Now, there may be scenarios that I'm just interested with this particular content. Now, for that, what do I do? Along with this invoke function, whatever response I specifically get, whatever results I actually get, let me just go ahead and save this in one kind of result or response. So here I will say, hey, this will basically be my result. Okay. Now, what I will do, there is something called as string output parser. Because see, here we know that this result is nothing but it is a AI message. Okay. But I want to only retrieve this particular output, right? So for that, in LangChain, if I go ahead and say in LangChain underscore core, okay, underscore core, we have something called as output parser. This output parser will be responsible to basically display the message that is coming outside as a response from the LLM model. Okay, so here we will go ahead and import string output parser, and I will just go ahead and create my parser. So let's go ahead and initialize this string output parser. What the string output parser is going to do is that it is just going to display my content message out, right? So this is the default. You can also go ahead and create your own custom string output parser if you want. So from this particular result, so this is the result that I have. If I say parser dot invoke, okay, and I invoke this or I give this particular result value from this. So what it's going to do is that this string output parser is going to take content from that particular message, from the AI message, and it is just going to display it. So here you can see bonjour comment all is was. Okay, so here you'll be able to see the entire output. Okay, now there is, I already told you something called as LCEL, okay, in the initial stages, right? I told you about language expression language, right? Sorry, language expression language to chain components together. Now you know that I have two components over here. One is my model, okay, model.invoke, which is specifically doing, and the second is my string output parser. So here, using LCEL, we can chain the components, okay? So we can chain the components. Chaining basically means one after the other. So for this, I'll create my variable. I'll say, hey, model slash parser, okay? So here what I'm saying, so I'm creating a chain of events, right? First of all, I'm adding model, then I'm adding parser. Now whenever I invoke, I say, hey, dot invoke, and I give my messages parameter over here. In this messages, we have the list of message of human message and the system message. Once I do this invoke, what it is going to do is that, first of all, it is going to go to this particular model. It is going to send both those messages to the model. The model is going to give you the output as AI message over here, like how it is given. Then this particular output is going to go to the parser, and finally I'll be able to get this particular output. Okay, and that is what you'll be able to see over here. See, finally we get this bonjour comment all over us, right? So this is one way of creating agents with LLM. Or sorry, not agents. Sorry, creating our or using our LCL to chain the components. Okay, now. We have discussed about output parser over here. We have discussed about the prompt, the LCL chaining the components, right? Now, instead of giving like this, right now we are passing every time list of messages, right? Instead of this, we can use one more efficient technique, and that is nothing but it's called as prompt templates. Okay. Now, with respect to the prompt templates, what I will do is that again, let's go ahead and do this. So I'll say instead of just giving the list of message, I will try to take a combination of user input and some application logic, where I'm also able to give the instruction. I'm able to take the user input over there, okay? And this application logic, which I'm actually talking about, is usually takes the raw user input and transforms into a list of message ready to be passed to the language model. So how actually it is done, I have already told many things over here. So let me just go ahead and write langchain_core.prompts, and I will go ahead and import chat prompt template. Okay, so here I'm going to use this chat prompt template. Again, it is available in langchain_core. Okay, so first of all, I will define my generic underscore template. Okay, I will say, hey, translate the following into this particular language, and this language I'll give it as a parameter. Okay, this particular language. Okay, and I will give this entire into like this language will be passed as a parameter. Okay, now once I take this particular generic template, I will create my prompt. Okay, and this prompt will be assigned to this particular prompt template, that is chat prompt template. And here I'm just going to say dot from underscore messages. Okay. And here we are just going to give this prompts, right? Like how we give the list of messages, right? The first prompt will be in the form of tuple. Here I'm going to add system, comma. Let's say I'm going to say system, comma, system template or system, comma. Like what is the instruction that you really want to give to the system? So it will be like a generic template over here, okay? And the next one will be basically with respect to the users, right? So here, instead of just giving the message, I'm giving it this way. So I'll say, hey, user, and this will basically be my text, okay? What text I'm actually giving. So this text, we have to give it in the runtime, okay? Same thing, see, before we use messages, how we are giving this in this particular way, here we are going to give it in the form of chat prompt template, where I also have two information, system and user, okay? Now this basically becomes my prompt, okay? Now, let me quickly go ahead and write something like this prompt, or let me just go ahead and execute this first of all. Now, if I go ahead and write prompt dot invoke, okay? If I invoke this, okay? Over here, let's say two parameters I want to give, right? So I'll give it in the form of key values. One is language, will be my input, and then it will be text, okay? So first of all, we will go ahead and set language. Let's say language, I'm going to set it as French, okay? So it will be French. And the second parameter that I'm actually going to set is called as text, okay? So text will be, let's say hello. I'll just say hello, okay? And once I execute this, here you'll be able to see that this is what is my entire chat prompt value. And see how beautiful it is converting this into a list of messages, right? So this list of messages that we were getting, right? The same list of messages you will be able to see over here, right? So what this is basically doing, the chat prompt template is doing, is converting that into a list of messages. So here I have system message, translate the following to French, and then I have my human message, content as hello, okay? And this is the power of this prompt, right? This prompt, whenever we use this chat prompt template, okay? Now this is fine. If I just want to get the information like what all messages it is able to convert to, so let me just keep this in a variable. I'll say result is equal to prompt, and let me just go ahead and write result dot to underscore message. Okay, so to underscore message, once I do it, here you'll be able to see these are my messages that is visible, and that is the same list of messages that we used to pass earlier. Now, again, I will go ahead and try to create a chain, right? So now in this chain, first of all, I will go ahead and add my entire prompt. So let me just go ahead and add my prompt. So this will basically be my prompt. Now after this prompt, what will happen is that I will go ahead and give it to my model. So this will basically be my model, and finally you'll be able to see that I'll finally get my output, and this output should also be passed to the parser. Okay, so this time using LCL, I've combined three things: prompt, model, and parser. Now once I execute it, so I will go ahead and write chain.invoke. And here, what are the key parameters that I really want to pass? One is language. So let me just go ahead and write language is equal to French. Okay. And then text is equal to hello. Okay. So once I execute this, you'll be able to see that I'm able to get the output as bonjour. Okay. So this is how two things we have learned. One is how to create chain and how to create chain with prompt templates. So here I'll give this particular comments over here. Chaining together cooperates with LCL. Here we have combined prompt, model, and parser. So I hope you're able to understand this. Now in the next video, what we will do is that we'll try to create let's say like I want to create an end-to-end project, and I have to make sure that I want to create all these things, all this chain in the form of APIs, right? How do I basically use it? And for that, we'll be using a new component which is called as LangServe. So in the next video, we'll be discussing more about the LangServe itself. So here, this was it from my side. I hope you like this particular video. I will see you on the next video. Thank you. So guys, we are going to continue the discussion of building a simple LLM application using LCEL. Now in this video, we are going to talk about LangServe, right? And whatever things we have learned in the past couple of videos, we are going to probably deploy that entire LangChain application as REST APIs. So here when I say deploy LangChain, runnables and chain as REST API, that basically means how with the help of LangServe, we will be able to create REST APIs. See, deployment parts and all, where to deploy, how to deploy, we'll be talking about that in upcoming videos. But here, before doing that specific deployment, how you can convert this entire LangChain, complete chains and runnables as REST API is super important, okay? So for this, when we are using LangServe, this is basically integrated with Fast API. So let's go ahead and do the specific coding, but this is another amazing module that has been brought by LangChain, and it really makes your application, like it will be very much easy to probably go ahead and create an entire chain. Okay, so I will be discussing about that. So first of all, what I will do, I will just go ahead and install one more library. So let's say that I'm in my VNV environment, so I'll say pip install, and here I will say Fast API. Okay, let me just go ahead and install this. So I definitely require Fast API over here. So here you can see the requirement is already installed because I've done that particular installation, so that I don't want to waste any time. So once you do the Fast API installation, make sure that you update in the requirement.txt. Also, along with this, we'll also go ahead and install something called as UVCon. Okay, so this is also one thing that is basically required. So I will go over here, and here you can see requirement already satisfied with respect to UVCon also. Okay, so this is perfect. Now let's go ahead and start implementing it. As you all remember, what all things we have already added. So quickly, first of all, I will go ahead and import from. Now I'm using this .py file. See, this is a different file altogether in the same folder, right? Before we were executing step by step over here in this particular file, simple LLM SEL, right? Now in the same folder location, that is basics of LangChain. Here I've created another file which is called as serve.py. Okay, and here is what we're going to implement everything, whatever we have implemented over here, right? And finally, we'll be able to see that how the chain API looks like. So I'll write from Fast API import Fast API. Okay, and then here I will go ahead and write from LangChain underscore core dot prompts import chat prompt template. Okay, and similarly from LangChain underscore core dot output parser, we had also used something called as string output parser, right? Chat prompt template we had used. We had also used this string output parser, and along with this, we had also used from LangChain underscore grok. We have imported chat grok, right? Along with this, we'll go ahead and say import OS, and then I'll also go ahead and write from .env import load underscore .env. We will go ahead and initialize load underscore .env, so to load all the environment variables. And you know that how to get our grok API key. So for that, I will go ahead and write grok underscore API underscore key. This is the variable name that I'm actually going to create. And I'll write os dot get env. And here will basically be my grok underscore API underscore key. Okay. Now quickly, I will go ahead and initialize my grok LLM model. So quickly, let's go over here. And you know that how did we go ahead and initialize our grok LLM model. So this was it. So I will just go ahead and copy this entire thing, model, chat grok, model this one, and I'll write it over here. Right now, my model is specifically ready. And this is what we have learned already in our previous video. Let me go ahead and import one more library, which is called as langsurf. Okay. Now before going ahead, you need to also install langsurf, right? And without installing langsurf, it will be of no use. So since this is a new module, we will again go ahead and write pip install. And here I'm going to write langsurf, okay, langsurf. And with respect to the langsurf, I will also give all, if you want, all the components that is specifically required. Otherwise, I'll just go ahead and install langsurf, okay. So this is for the first time I'm installing because I did not install it. I wanted to show you. So here you can see I'm having this particular langsurf 2.2 version, right? So once I install it, right, you can just go ahead and write pip install. But please make sure that you update in the requirement.txt, okay. So after installing it over here, I've installed the langsurf or any libraries that you install. Please make sure that you update in the langsurf, okay. Sorry, requirement.txt. Now after importing langsurf, I will quickly go ahead and import from langsurf. I will be importing add routes. Okay, you need to have a basic idea with respect to Fast API. Okay, now this add underscore routes will actually help you to create your APIs, right? So now let us go ahead and as usual, what I will do, I will go ahead and create my entire prompt template. So here the same code, whatever we had in our IP file, I've copied and pasted it over here, right? This is my system template, translate the following into this particular language, then chat prompt template, user with text. Okay, then I've already created my model. I will go ahead and also create my string output parser. So I will write parser is equal to string output parser. Okay. Now after creating the string output parser, let's create chain. So for creating chain, what I need to do, I need to combine these three things, right? One is the prompt template, another one is the model, and the other one is something called as parser. Okay. So we'll go ahead and combine this, and finally we have this app definition that we have. Okay. Now for this app definition, what I will do is that now we are going to use this add routes. So if I really want to add any kind of route over here, I will go ahead and use this add route. And inside this add route, which is coming from langsurf, I have to give my app, the first app which I've actually created, and still I'm not defined the app also. So let me just go ahead and define the app. So I will go ahead and create my app over here, app definition, and I'll say, hey, this will be my Fast API app. It is almost like Flask, but there is some more additional functionality that you get in Fast API. But if you have seen this Flask tutorials, I think you should be able to understand it. So I will give my title saying that this is my LangChain server. Okay. And the second parameter that I'm actually going to give is nothing but version is equal to 1.0. And finally, I will also go ahead and give my description. Description will be nothing but I'll go ahead and write a simple API server using LangChain runnable interfaces. Okay. So this I've actually given it. So this will basically be my first parameter in this route, which app I'm actually going to give. That second thing, I want to give my chain, the chain which has the combination of prompt template, LLM model, and string output parser. And the third one, I have to actually specify my path. So here I'm going to specify /chain as my path. Okay. You'll be understanding what exactly this route will basically do. So here, this is basically adding chain routes. Okay. Perfect. Now it's time that we can go ahead and execute this. So I'll write from underscore name underscore is double equal to underscore main underscore. This is how we start the entry of the program. I'll go ahead and import UVCon. Okay. UVCon, and then I'll say UVCon dot run. This is how we run the Fast API. We'll tell the app name. I will give the host. Host will be my local host. Okay, local host. And finally, I'll also give my port if I want. So port will be 8000. Okay. So these are all the information. Now see what we have exactly done. We are loading our chat grok model. Here we have created a prompt template. Then we have created a chain and output parser. We have created a Fast API app. We have added the route, right? /chain. And finally, we are executing this. So now let's quickly go ahead and execute it. Okay. Don't forget to save the file over here. Now, if you remember, this particular file is present in the location 1.1 basics of LangChain. So let me just go ahead and write cd 1.1 basics of LangChain. And here I'm just going to write python serve.py. This is how you go ahead and execute your Fast API app. Once I execute it, I think it should get executed, but here I'm getting an error saying that, hey, pip install SSE starlet. Okay, I need this particular dependency. So quickly I will go ahead and write it over here. Okay, so quickly I will go ahead and execute this. Let me do one thing. Instead of writing it over here, I'll open a new command prompt. Okay, and let me write it over here. Pip install SSE starlet. This is one of the dependencies that we have. So once I have written or created the routes, now what we are going to specifically do over here is that I will give the entry point and I'll start the execution, right? So first of all, what I will do, I will write if underscore name underscore is double equal to underscore main underscore. So this is the entry point. I will go ahead and import UVCon. Okay, and along with this particular UVCon, I will go ahead and write UVCon dot run and app comma host is equal to, I'll give my host as 127.0.1. This will be my local host, and here I will give my port as 8000. Okay, you can also replace this particular values to localhost. Okay, now let's go ahead and execute it. And remember, I'm inside this particular folder 1.1 basics of LangChain. Here I will just go ahead and write python serve.py. Okay, and once we execute this, here you'll be able to see that it is running over here. Let's click on this particular link. Okay, so here is the page that is visible. Right now in the home page, nothing is basically visible. So what I will do, I'll just go ahead and write /docs. Once I write /docs, so this is what Fast API using Pydantic rules. Okay, so that actually gives you all the APIs that is over there. Okay, so here it gives you this entire thing. You just need to write this particular URL /docs. You'll be able to see that I have this chain invoke. Okay, here I can pass any values. Then let's discuss about this single by single. Right, so this basically has created this entire chain configuration with all the information that I have over here. Right, so if I just write /chain, right, from that line, so you'll be able to see that here you have this input schema. Right, it says that you have to provide the input as string. Here is the output you will be getting in the form of JSON. Okay, then you have this invoke function. Invoke basically means you will provide some value. Okay, and based on that value, what all values will be providing, like language and text. Okay, and this is what is the kind of response that you're going to get, and this all are there. Right, so all this information, like let's say I'm going to go ahead and try out this invoke. Okay, so here let's say language is equal to string and text is equal to string. This is the request body. Okay, let me just go ahead and pass these values over here. Okay, so I'll say hey, language is French and text is basically hi. And if I go ahead and execute it, you'll be able to see that it has got executed. I'm getting the output as salute. Okay. So guys, now let's explore more example from this particular documentation. So I have just created one chain, that is /chain/invoke. You can create any number of chains over there. Let's say I will go ahead and write, hello, my name is Krish. Okay. And this is what is the post request that needs to go. And if I just go ahead and click on execute it, here you'll be able to see bonjour, d'appeler Krish, right? This is the output that I'm actually getting. So this is how you can actually go ahead and create chain. And along with this documentation, you'll also be seeing that there are some other information like /chain/input schema. See, if I just go ahead and execute this, since this is a GET request, so I'll say /chain/input schema, I guess, input underscore schema. So if I execute it, see what is the information that I'm able to get, right? This is the prompt control, this is the language, the text should be a string type and all the information. Along with this, I can also go ahead and see some more information. So this is with respect to the input schema, how the output schema should look like. I can go ahead and hit this URL, right? And that is what is beautiful about Fast API, So I can go ahead and write like this. I will copy the same thing. I will go ahead and write it over here. And let me just go ahead and see my output schema. Okay. So this is the entire documentation, right? The Swagger documentation we see in Fast API. So here it says that hey, your string, your output is a string output parser and the type is string. That entire information we see. So this is one post request. You also have something like batch. Okay, you can give let's try this out. Okay, so let's try it out over here. Let's say here I'm going to give language as Hindi. I will convert text into Hindi, English into Hindi. So I'll say hello, how are you? Okay, so I'll go ahead and execute it. Let's see what kind of output I will get. So here you can see output like namaste, aap kaise hain, right? How are you in Hindi? All the information over here with some more metadata information you're getting. So that there is one more by default one more post request when you created /chain, right? So many things have got created like /chain/invoke, /chain/batch, and you can also use Postman and you can probably use all these things, right? So this is what you specifically get from this. I hope you're able to understand this part of the video. Let me just go ahead and show you with help of Postman also, right? So if you don't know about Postman, Postman actually helps you to interact with any kind of APIs, right? So let's open this and I will create one get post request. Let's say so the post request that I really want to get is /chain/batch. Okay, so here I will say okay, I'll dismiss this. I'll make it as a post request. It is 127 point this. The 8000 port address is there, and here let me just go ahead and write it over here. What it is /chain/batch. Okay, /chain/batch. Now I know in my body I have to make this as my raw, select my JSON, okay, and here is what I'm actually going to give my entire body, right? Now how my body should look like, same this way, where is it? Okay, this is the get request, okay, so I just not write it out, right? So I will keep this entire as my body in the form of JSON. I'll paste it over here. Let's execute this. So let me just keep this in string because I need to send it in the form of body, and once I click on send, here you can see invalid JSON body. Okay, let me just remove this. I think this is invalid. Now see, once I send it, here is what is my output along with my metadata. So this way also you can go ahead and test each and every request. And from the Postman also you can do this. You can just go ahead and download Postman, go ahead and set the post request, what is the URL and what should be your body, right? And you'll be able to get it. So I hope you like this particular video, So in this video, what are things we basically did? We developed a simple LLM application. First of all, I'll try to close this up. Okay, I don't require it more. First of all, we saw how to develop an LLM application with the help of LCL. Then we also saw how we used LangServe and probably created this entire application in the form of chains and APIs, right? That is the most amazing thing because after this, you can take this entire application and can deploy it wherever you want. Okay, and in upcoming videos, you'll also be seeing, in upcoming modules, you'll also be seeing that I'll be showing you various deployment mechanisms and techniques, right? So yes, this was it from my side. I hope you like this particular video. I will see you on the next video. Thank you. Take care. Hello guys, so we are going to continue the discussion with respect to LangChain, and now I'm going to show you how we can go ahead and build a chatbot. Already in our previous video, we have seen that how to build a simple LLM application with LCEL, and we have discussed about LangChain expression language, where when we were able to, combine the chains together, all the chain components, and we were able to do the prediction, right? So let's go ahead and let's start working with chatbots. Now in this video, we'll go over an example of how to design and implement an LLM-powered chatbot. This chatbot will be able to have a conversation and remember previous interaction. Note that this chatbot that we build will only use the language model to have a conversation. Okay, there are several other related concepts that you may be looking for, like conversational RAG, like how to enable a chatbot experience over an external source of data. We will probably discuss this in upcoming videos. Then we'll also be discussing about agents. We'll be developing multiple projects. Okay, but in this video, we will try to focus on LLM-powered chatbots. Okay, so first of all, as usual, again over here, I am going to use the open source models from Grok API instead of using OpenAI. Okay, so first of all, what I will say, I will go ahead and say import OS. Along with this, I will go ahead and write from .env import load_env, and then we have this load_env. Here we are just loading all the environment variables, Okay, and then after this, what do we exactly do? We basically get our Grok_API_key, and you know that we have in our environment variable, which we had updated last time. So this is my Grok API key. So I'll just go ahead and call it, right? And in order to call it, I will just go ahead and write os.getEnv, and here I'm just going to call this, right? Perfect. So if I go ahead and print my Grok API key, this is the output. Please do not use this anyhow. After I upload all these videos in the course, these all keys will be deleted. Okay. So now I have my Grok API key. Now the next thing is that we will go ahead and see how to call our LLM model. So that already we have seen over here. So here we will be importing chat Grok, right? So here you can see LangChain_Grok import chat Grok, and here we're going to use chat Grok with model Gamma 2 9BIT. This is the most newest model that we're going to use over here. Let me just go ahead and execute this, right? And here I've actually given the Grok API key. Okay, so this is how you specifically load a model. Okay, now after loading a model, what I'm actually going to do is that we're going to first of all start with basic things. Okay, so let me just go ahead and write from LangChain underscore core. I am going to go ahead and import this messages, and from this messages I'll import the first type of message is called as human message. Okay, whenever I have a human message, that basically whenever I'm using this particular class, it indicates that a user is giving a message itself, right? So let me just go ahead and write model.invoke over here, and with respect to this, let me go ahead and create my human message class, and let me initialize it. And here we are going to talk about content is equal to, and here I'm going to say, hey, hi, my name is Krish, and I am a chief AI engineer. Okay, so I'm just giving this kind of message over here, and let me go ahead and invoke this. So here you'll be able to see as soon as I give the message over here, this we are invoking with respect to this particular model. That basically means this information is going to my model, that is Gamma 2 over here, and I'm getting the response. Hello Krish, it's nice to meet you. As a chief AI engineer, what kind of projects are you working on these days? I'm always eager to learn about the exciting work being done in the field of AI, and these are my all the metadata information, like how much is input tokens, what is output tokens, and what is the total number of tokens. So here just a simple conversation by using a human message class. I've actually done it, right? Still, I've not initialized anything from the system message itself. I've not told like what kind of behavior the LLM model should probably go ahead with, right? Now let me do one thing. And you know this, right? Whenever we get this AI message, that basically means we're getting the response from our LLM model. Now let me go ahead and write from LangChain. Oops. Over here, I'll go ahead and write from LangChain. Okay, I think I was searching it over here. From LangChain underscore core dot messages. I'm also going to import AI message. Okay. Now again, here I'll go ahead and write model.invoke, and let me put some combination of AI and human message. Now understand one thing is that we can give a list of messages, like how we basically develop a simple LLM application, right? So let's say first message is my human message, and here I will go ahead and write content with respect to this entire information. Hi, my name is so and so, and I'm a chief engineer. I'll put it over here itself. Okay. And I will close this quickly, and then I will go ahead and take my next message. The next message will be basically AI message, and here in the AI message, I'm just going to go ahead and write this particular content. And let me just go ahead and copy this entire thing, whatever content is over here, right? In the field of AI, right? I'm just going to go ahead and write this particular content over here, right? So this is the AI message that I've actually got a response. So now here I'm actually going to create a sequence of messages from this particular text. I'm just hard coding. Okay, I got this particular message from this particular LLM model, and now I will go ahead and just say again a human message, and now I will go ahead and ask, hey, what's my name, and what do I do? Okay, so this is the question that I'm going to ask over here. Now this is amazing. Okay, let's see the output. What I'm actually going to do, because I'm first of all feeding this particular information with respect to the human message. Hey, my name is Krish, and I'm a chief AI engineer. And from this AI message, I got this entire value, so I'm probably putting it up, and I'm asking it whether it is able to remember my whether it is able to remember the information that I've actually given. Since I'm passing it in the form of list of messages here, right? I think it should be able to remember it. Okay, so now once I go ahead and execute it, so here you can say, you said your name is Krish and you're a chief AI engineer, right? Is there anything else you would like me to remember about you? Okay, so all this information is basically coming. That basically means one important thing is that whatever conversation I'm giving inside this list of messages with the human message, AI message, human message, it is also able to remember the previous context. Okay, now that is where we are going to discuss about message history. Okay, and this message history will probably help you to understand all the context, help the LLM to remember all the context that we are probably discussing about. This is just an idea that whether the the LLM model is able to remember things or not. But at the end of the day, whenever we develop real world application, there will be different sessions that will be happening, right? Let's say I'm using ChatGPT, someone is using ChatGPT, some other people are using some other LLM models, and they are chatting, right? How that particular models are able to remember their context, that is with respect to session. So in order to understand that how these sessions are managed, we will be discussing about a very important property which is called as message history. Okay, now let's discuss about this message history, and this is a very important component altogether in the LangChain itself, right? Which will actually help you to work with the LLM model. Okay, now what we really need to use or understand how message history works. So here I'm going to put a message saying that we can use message history class to wrap our model and make it stateful. We have to make it stateful so that it remembers all the context with respect to any kind of person who are actually interacting with that LLM model. This will keep track of our inputs and outputs of the model and store them in some data store. Further interaction will then load this message and pass them into the chain as part of the input. Okay, so let's see how this can be actually done. So first of all, for this we require another library which is called as LangChain underscore community. So please make sure that you install this. And once you install this, I've already done this particular installation so that it does not take much time. You have to go ahead and update in the requirement.txt. Okay, so first of all, go ahead and update this in the requirement.txt and make sure that whatever installation that you've done, you are doing it in your virtual environment. Okay. Perfect. So from here, what I will do is that LangChain community is basically used because any integration related to message history will be available in this LangChain underscore community. Okay. So let me go ahead and import some very important libraries. Let's say from LangChain underscore community, I will be using something called as chat message histories. Okay. Inside this chat message history, we will be importing chat message history. Okay. I will talk about this. What exactly is the chat message history? Just for now, let me just import some more libraries. So I will go ahead and write LangChain underscore core dot chat history. Okay. I'm going to import base chat history. Okay, base chat message history, and then finally I will go ahead and import from LangChain underscore core dot runnables. Okay, since this is for the chain, and for the chain also we basically go ahead and import this particular history, and I will go ahead and import runnable with message history. Now this is something really important. Okay, here you'll be able to see that we can import the relevant class over here, set up our chain, which wraps the model and add in the message history. That is what we really need to do, right? Every message that we are probably putting up, it needs to be added in the message history itself. How it is done, I'll just talk about it sometime. Okay, but the thing that you really need to understand is that whenever different users are chatting with the LLM model, how we are going to make sure that one session is completely different from the other session. So for that reason, what we will do is that we will create one amazing function. Okay, and this particular function will be definition get underscore session underscore history. Now what this function is going to do, let me talk about it. Okay, here this function will be creating a session ID. Okay, this session ID, and this session ID will be a string. Okay, right? I've written a session ID, and this will be a string, and this will get inherited to your base. The return type. Sorry, not inherited. The return type of this particular function will be base chat message history. So whatever chat history is basically getting created, right? That is imported from this particular library. So what I'm actually going to do is that this get session history, right, with respect to a session ID will be created, right? And this session ID will be used to distinguish one chat session with the other. Okay. So here the return type is base chat history. I will say, hey, if session ID not in store. So let me just go ahead and create one variable called a store, which will be a dictionary over here. So here I will just go ahead and write store. Okay. Let me talk more about it, and the explanation will be very good, and I will show you the practical example. I will go ahead and write store of session underscore ID is equal to chat message history. Okay. So now see this, everything, please try to understand it, right? First of all, for this particular message history, so you can see that we have a class which is called as chat message history. Okay. Now this chat message history, whenever we are creating a session ID, right? We are storing the session ID in this particular dictionary, right? With respect to this particular value, whatever session ID I'm actually creating, I'm initializing a chat message history, right? So that basically means this is an object of a chat message history, and whatever chat is specifically happening, automatically it should be going inside the session ID. Okay. Next thing is that after this, I will just go ahead and return store of session underscore ID. Now see, I know there is some confusion with respect to the definition, but let's understand this definition. So what is the definition over here? This is a function which is called as get session history. Whenever I give a session ID, it should be able to check whether the session ID is present in this particular dictionary or not. If it is present, we are going to get the entire chat message history from that, and we will return it. Okay, and that is how we are going to distinguish it. Two things: this get session history will give you a response type of base chat history. It is an abstract class for storing the chat message history. If I talk about chat message history, it is an in-memory implementation of chat message history. Stores messages in a memory list. So it is very much simple. Whenever I give a session ID, it should first of all go ahead and check in this particular dictionary whether it is available or not. If it is available, it will go ahead and pick up the entire chat message that we have discussed with respect to whatever questions we have asked with respect to the LLM model for that session ID, and it is just going to return it. Now see how it is going to work. Okay, so I'll execute this. I will talk about this runnable with message history. Soon it will be used as we go ahead. Okay. Now the best thing over here will be that we will be seeing how we will be using this. Okay. So first of all, we will go ahead and create our config. Okay. So I'll write, hey, this is my config over here, and this config will be nothing but it will call as configurable. Okay. I will just give this key value pairs configurable, and here I'm just going to give my session ID. So let's say my session ID is something like this. Right now I'm hard coding it. Let's say my session ID is something like chat1. Okay. I'm just going to write it as chat1. Now let's go ahead and execute this. Okay. Let's go ahead and execute. So this basically becomes my config. Okay. My session ID is chat1. Now let me use this particular session ID and let me chat with the LLM model. So here you'll be able to see that I will write response is equal to with so before this, let me do one more thing. Okay. See, I've used the get session history, right? Now, in order to execute this, I really need to use this runnable, right? Unless and until we don't have this runnable, it is not going to probably execute this entire chain. So here you say runnable that manage chat message history for other runnables. Okay. The chat message history is a sequence of messages that represent a conversation. So here what I'm actually going to do, I'll go ahead and write with underscore message underscore history. And here I'll go ahead and write runnable with message history. And here the first parameter we'll get is model, whatever model we are going to use. And the second is get session history. Okay. So these two parameters will be specifically required for this, right? And this with message history, we will try to invoke this. As soon as we invoke this is going to take this particular model. This is going to take the entire chat history, what we are getting based on the session ID. Again, how to pass the session ID, I'll let you know. Okay. And then it will be able to give you the entire information. So here, let me just go ahead and write double S because I don't want to write triple S. Okay. So here, so many S's are here. Okay, perfect. Right. So again, let me repeat it. What we have exactly done. First of all, we have created a dictionary over here. Then we have created a function which will be able to retrieve whatever chat history is there for a specific session ID. Then we are converting or we are using this runnable with message history so that we can interact with our LLM model based on the chat history. So for this, we give two parameters, that is model and get session history. Now we have created a configuration called as session ID is chat1. And now what we will do is that we will call this with message history. And here I'm just going to go ahead and invoke. Over here, first of all, I will give a human message. Let's say this is my human message over here. Now see the magic. Okay, this will be amazing. I will go ahead and write this is my content is equal to, and let me say hi, or I'll give the same message over here. Right. So hi, my name is Krish and I am an AI engineer. Okay. Now see, I am trying to interact with based on the session ID. Okay. Now see, this all information is over here. But along with this, we can go ahead and give our configuration. The configuration will be given inside this invoke, and here I will go ahead and write that this is my config, which will be equal to config. Now, when we are giving the config, that basically means for this session ID, we are interacting. Okay. So based on this session ID, it will be able to remember all this context. So if I go ahead and execute this, okay. So with message history is not defined because I did not execute this. So let me execute it now. Let's go ahead and do this. So here you can see AI message. Hi Krish, it's great to meet you. Being a chief AI engineer is an exciting role. All this information is basically coming. Okay. Now, if you want to get this particular content, I will also save this in my response variable. Okay. And let me just go ahead and write response.content. Yeah, I can also go ahead and write like this. So this is what is the message that I will be getting. Now, let me do one thing. Okay. Let me take another response, or let me go ahead and again use this with message history. And this time I'm sending a message of human message like what's my name, and I like config is equal to config. Now in this case, if I see the output here, it will say that hey, your name is Krish. Okay. Why it is able to remember it? Because we are giving the same config. So let's say that now if I change the config, will it be able to remember this particular context? Okay. Now here I'm just going to change the config. When I say change the config, I'm changing the session ID, right? So I'm changing the session ID. Okay. Now if I give the session ID some different session ID. So for giving the session ID, I will again use this config over here. The first session ID was chat1. Now this will be my config1. Okay. Let me just go ahead and give it. So this will basically be my config1. Okay. Now with respect to this particular config, I will again go ahead and use my response, and I'll say hey, with this particular message history, right over here, I will go ahead and write dot invoke. And here I will go ahead and give my message. The first message is nothing but my human message. The human message will be nothing but content is equal to, I'll say what's my name. Okay. Now see, before also I asked what's my name, but I give the previous session ID with respect to this particular configuration. But here I'm going to give my new configuration. So I'll go ahead and write config is equal to, I'll go ahead and write config1. Okay. Now, do you think it will be able to remember or not? Just try to take a guess and make sure that you write down in the comment section, the Q&A section that we have. Okay. So here you'll be able to see that if I go ahead and execute this response.text, sorry, it should be response.content. The reason it is able to remember because I've given the same session ID. Now let me change this particular session ID. I'll say chat2. Okay. Now if I go ahead and execute it, hey, as an AI, I have no memory of past conversation and don't know your name. Now what exactly I've actually done over here? I've just changed the session ID. Now whatever conversation I have right now, it will entirely be saved in the session ID chat2. Okay. So that in the later stages, whenever we use this with message history, it will just give the session ID of chat2 and it will retrieve the information. Now let me do one thing. Let me quickly go ahead and copy this entire thing. Okay. Let me go ahead and write and say, I'll say, hey, my name is John. Okay. Hey, my name is John. Okay. And now I will go ahead and execute with this config. Okay. So if I go ahead and say, hey, John, it's nice to meet you. Now if I go ahead and execute the same code with this particular config, okay, now you'll be able to see that it will understand your name is John. I remember. Is there anything else I can help you with? Okay, so with the help of this session ID, you'll be able to see that how easily we are able to switch with respect to the context of conversation that we are having. Okay, so I hope you got an idea. I hope you got an idea with respect to this particular message history, why we are specifically using it. But just an easy way to understand, if just highlight it over that particular class. Let's say over here, base chat message history is there. This is nothing but this is an abstract base class for storing chat message history, and chat message history is basically present over here. This is an in-memory implementation of chat message history. As soon as I give my session ID, whenever I call this, so what is with underscore message underscore history. It is a runnable. It is a chain between model and get session history. Whenever I'm going to interact with the model, it is first of all going to probably go ahead and give your get session history. That basically means based on the session ID, it is going to pick up your entire chat session, okay, and based on that, it is going to remember the context. So this was just an idea with respect to implementing or how you can basically work with chat history whenever you're developing a chatbot. Now we will try to implement all this chat history in our prompt template, and that is what we are going to see in the next video. So I hope you are able to understand this. This was it from my side. I'll see you in the next video where I will be discussing about prompt template. So thank you. I'll see you in the next video. Hello guys, so we are going to continue the discussion with respect to creating this chatbot. So already we have seen about the message history and how we can remember the context. Now let's go ahead and use this prompt templates. Okay, now prompt templates helps to turn raw user information into a format that LLM can work with in case the raw user input is just a message which we are passing to the LLM. Let's now make that a bit more complicated. First, let's add in the system message and add some custom instruction. Till now we were just passing the list of messages, right? Now let's go ahead and work with this particular prompt template. Now for working with prompt template, I will go ahead and write from LangChain underscore core dot prompts. Okay, I'm going to import my chat prompt template. Okay, chat prompt prompts. It should be prompts. Okay. So chat prompt template. Okay. Along with this, I will also use a message placeholder. Before we used to give the messages right directly. If you see over here, like human message and all, we are just giving it right in the form of list of messages. But here we will just go ahead and use this. Now quickly, let's go ahead and create my prompt. Here I'm just going to write chat prompt template is equal to, and with respect to this, here I'm going to give a list of information. The first information that we are interested in providing system information. So I will go ahead and write system. I'll say, hey, you are a helpful assistant. Okay, and I will just go ahead and say, hey, answer all the questions to the best of your ability, right? Something like this. So once I do this, I will go ahead and create my next field. Now in this case, the next field that I have to probably go ahead and create it is nothing but message folder. Okay, so message placeholder. So message placeholder here, I will just go ahead and create a variable name called as messages, and this messages will specifically be used. I'll talk about this why we are creating this particular variable name just in some time. Okay. Now once I go ahead and execute this, let me go ahead and first of all create my prompt chain. So I'll write prompt of model, and this should be my chain, right? So in it takes exactly how many parameters? One position element, two are given. Let's see why two are actually given over here. This is my prompt template, and here I've used the message player. This should be the system over here, system comma this, right, with respect to the key value pairs like this. And one more thing that we can just do is remove this. Just a second. Okay. Now I think it should be right. Okay. Let's execute this and let's remove this. Okay. So it says init takes exactly one positional argument. Why? Let's see. Chat prompt template. Okay. That was not the issue. Okay. The issue was something else. I will try to fix this issue. We have to use a function called as from underscore messages. Okay. I'm not going to edit this part because you have to definitely see all the errors and then try to fix it. Okay. So here you have this, and this is my chain. Now let me quickly go ahead and provide this entire or invoke this chain. Now understand one thing, guys. Whatever human message we specifically give, it needs to be given in a key value pair where the key name should be messages, and that is the reason we are giving a message placeholder over here. Right. Before we were not using any message placeholder, so over there we were giving in the form of list of messages like human message, AI message, system message like this. Right. But here I've told that hey, we are going to use a message placeholder called as variable name as messages, and inside this, whatever information you definitely require from the human side, it will be given in that. So how do I call it? So here I have created my chain. So let me quickly go ahead and write chain dot invoke. Okay. And inside this, I'm going to pass my messages. Okay, messages. This will be my key, right? This will basically be my key. And here I can give, hey, whether I want to give a human message over here. And let's say I'll go ahead and write content. Hi, my name is Krish. Okay, so this is my message that I'm specifically giving over here, right? So once I execute it, automatically we'll be able to see that. Now the message placeholder is messages. So inside this, it will try to understand, okay, here is what I will get my entire messages, or the list of messages that I'm actually going to get. And this will basically go ahead and interact with the chain. So whatever information I'm giving it over here, it will be going and it will get displayed over here, right? So this entirely basically talks about how you can actually include this along with the prompt template itself. And here I can get the answer that hi Krish, it is nice to meet you, and all the information specifically over here. But how to invoke with respect to the chat message history, right? With the chat message history. Now let me just go ahead and create a variable over here. So I will say, hey, with message history, let me create a new one. And here I will say, hey, runnable with message history. Now two important information needs to be given. One is chain and one is the get session history. If you remember the get session history that I've actually created, right? So once you give this two information, now see how I will be able to invoke this. Okay. So this is why with message history. Here I'm just giving the chain. Chain is nothing but this entire prompt and model. And this is my get session history over here. Now I will go ahead and create my config. So let me go ahead and create my config. And this is my chat 3. Okay. I'm just going to write a session ID over here, chat 3. And I'm going to probably go ahead and create my response. And again, we will go ahead and use this with message history dot invoke. Now when I am specifically invoking, when I'm actually taking this entire chain and all, I can give the same information like how I gave it over here, right? Something like this. So I will say, hey, this is my human message. I will go ahead and paste it over here. Okay. Along with this, the next thing that I'm going to give is my config. Okay. So once I get the response, I should be able to display the response. Hello, Krish, it's nice to meet you, right? Now this is fine. See, this message history is almost same like how we used to use it before, right? But let me add some more complexity. Instead of just one input variable, now let me go ahead and add multiple input variable. Okay. So I will be taking one type of prompt over here. So this is my prompt. See over here. I'm using chat prompt template dot underscore from messages. So I'm going to add some more complexity. Okay. Add more complexity. Okay. So here you can see I'm having chat prompt template dot from underscore message. Here's my system. You are a helpful assistant. Answer all the questions to your ability in this language, whatever language I have, right? So this basically becomes my new input that I'm actually going to give. Okay. So I'm saying, hey system, you are such a helpful assistant, and you have to probably answer all the questions based on your ability in this particular language. The language will be passed as a key. Okay. Then this is my message folder. Message space folder where I'm giving the variable as message, and this is my chain. Okay. So this is fine. Now over here you'll be able to see that whenever I need to invoke this chain. So if I go ahead and write a response is equal to chain dot invoke. Here there are multiple parameters that I will need to give. One is messages, and this will be nothing but human message. And here I'm just going to write my content where I'll say, hey, hi, my name is Krish. Okay. And along with this, the second parameter that I need to give, see, very important thing in this messages, this will be a key value pair, right? So one parameter I'm actually giving it over here. The second parameter, I will again go ahead and add a key, which is called as language. Okay. And let's say language over here, I'm just going to write it as Hindi. Okay. So this is the second parameter I need to give. So first I'm passing it as a human message content. This is basically there in the key called as message, and the second key that I'm actually passing is for this particular input, that is this particular language. Okay. Now once I could probably get the response, I can go ahead and display the response.content. Okay. So once I go ahead and see, Namaste Krishna, मुझे आपसे मिलकर अच्छा लगा. So here you can see that I'm able to probably give this again in this message key and in this language key I'm actually giving. Okay. Now there are two keys that are going over here. So with respect to the chat message history, how it is going to change. Okay. So now I'll just go ahead and create a markdown and add some information. Let's now wrap this more complicated chain in a message history class. This time, because there are multiple keys in the input, we need to specify the correct key used to save the chat history. Okay. So let's do this. Okay. This time what I will do while I'm creating my with message history. Okay. I will use this runnable message history. Now inside this runnable message history, first parameter is nothing but my chain, whatever chain I'm specifically giving. The second parameter is nothing but my get session history function. Based on the session ID, it is going to pick up all the information. Now is the most important one, which is called my input key message, input message key. And here I'm going to give my input as messages. Okay. So these are my parameters that I really need to give. Now see the magic. Okay. Based on this particular input message keys, now it knows where since there are multiple keys, it knows which one to basically specify to. We need to specify. See over here, as soon as we give this particular key, it will be able to understand when we are giving messages and when we are giving the language input over here. Okay. So let's go ahead and execute it. Now this time I will go ahead and create my next config over here. So let's take a simple config. So this time I'll go ahead and write chat4 message. Okay. And here will be my chat4. Okay. And along with this, we will go ahead and write response is equal to with message history dot invoke. Now see how I'm going to pass the parameter. The parameter will be with respect to the messages, which will be my key. Here I'm going to pass my here I'm going to basically pass my human message. And inside this human message, again, this will be in the form of list. Okay, human message. And inside this human message, I'll say, hey, content will be nothing but hi, I am Krish. Okay. Now this is fine. Till here we have given this particular information. Remember, this will get closed over here. Okay, it should get closed over here. So this will basically be my list of messages. Now in the next parameter, what I give my language key. So this will be nothing but language is equal to Hindi. Okay, so this is all my information. Now let's go ahead and probably give my configuration, and this is how we basically give the entire response. So finally, I can go ahead and print the response.content. So once I execute it, Namaste Krish, तुम्हें कैसे हो? क्या मैं तुमकी कोई मदद कर सकता हूँ? Okay, it's somewhat right. Again, there are some grammatical issues, but again, it's an open source model, so we should be happy that we are able to use it completely for free. Okay, so here are all my information. Then again, if I really want to go ahead and ask, hey, what's my name? And I can go ahead and ask over here, and here also I will go ahead and press Hindi. So here you'll be able to see my response.content. It shows आपका नाम Krish है, right? So it is able to understand all these specific things. Okay, so this is how you can actually work with chat history, where you really need to worry about the message history class, how you can go ahead and create it, what all input message keys need to be used, what is this particular function based on a session ID, how do you pick up information. So I hope you are able to understand this particular video. Now in my next video, I will be showing you how you can manage this entire conversation history, because managing this conversation history is very much important. Yes, you can whenever you're communicating with the LLM model, here what we are specifically doing is that we're giving the entire history itself. But sometimes this history can become very, very long, and it remains completely unmanaged. So how we can probably, and see, there's a limitation with respect to the context window of every LLM. So managing the conversation history is very, very much important. So in my next video, what we are going to do is that we are going to see how we can manage the conversation history. Okay, that is what we're going to discuss in the next video. So yes, this was it from my side. I will see you all in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to creating the chatbot, and already in our previous video we have discussed about prompt template with the conversation history. Now we're going to focus on understanding how do we manage the conversation history. See, one important concept to understand when building chatbot is how to manage conversation history. If left unmanaged, the list of messages will grow unbounded and potentially overflow the context window of the LLM. Therefore, it is important to add a step that limits the size of the messages that you're passing it. Okay, so let me just go ahead and show you how it can basically be done. So here I will probably go ahead and write or import one important library. Let me say from LangChain underscore core. I'm going to write dot messages, and here we are going to import system message. So system message, along with that, we are going to also use one more method which is called as trim messages. Now what exactly is this trim message? Okay, so here I'll just go ahead and write over here. Okay, so trim message, trim underscore messages. This will help. This is a helper which will reduce how many messages we are sending it to the model. Okay, so let me write some brief information over here. So this helper to reduce how many messages we are sending to the model. The trimmer allows us to specify how many tokens we want to keep along with the other parameters. Like if you want to always keep on the system, keep the system message, and whether to allow partial message on it. Okay, so this is what specifically we do with the help of trim underscore message. And this trim underscore messages we have probably imported over here. Okay, now quickly I will go ahead and initialize this trimmer, and I'll go ahead and write trim underscore message. Inside this, there are some tokens some parameters that will be playing with. So the first token over here is nothing but match token. Let's say I want to keep the match tokens to 70. I want to limit it to 70. Okay, then I'll ask for a strategy. We will go ahead and say, hey, what strategy do you need to follow for trimming it, right? And there are multiple strategies. One of the strategy over here that we are going to use last. If I say last, it is just going to focus on the last conversation that it had. From there, it is going to count the entire tokens. Okay, then the token, there is also one more parameter which is called as token counter. See, match token is match token count of trim message. Token counter basically is functional LLM for counting tokens, right? So here, if I go ahead and write token counter, I'm going to use my model which will be used for counting the tokens, right? Then I will say include system. So there are more parameters over here. If you see over here, there is also maybe one more parameter. Not able to see it over here. And this is one example it is given, right? I will discuss about it. Okay, I'll give you one very good example over here. So here, what we'll do here also, we will go ahead and set our include system is equal to true. I'm saying, hey, include the system message. Because system message is important. We cannot because that is where we say what exactly the LLM model should do. Okay, then I'll say allow partial is equal to false. So I don't want partial information. I just want to trim. That's it. And here I will go ahead and say start on from where it needs to start. It should not start from the human conversation. Okay, perfect. So this is the trimmer that I'm actually going to use. Okay, now let me do one thing. Let me keep a set of messages. Okay, so here are my set of messages. So here you can see system messages content, your good assistant. Then human message says, hey, I am Bob. Then AI message says hi. Human message says, I like vanilla ice cream. AI message says nice. This is the response from the LLM model. Then human message is like, what is 2 plus 2? AI message says 4. Human message says thanks. So there's a set of conversation that has happened between human and AI. Okay, so now if I just use this set of conversation or messages, and if I use streamer.invoke and I pass it over here, now you see the magic what it will happen. If I execute it, okay, trimmer underscore message allow partials. Okay, allow partials should not be there one. So here you'll be able to see instead of allow partials, it should be partial. Okay, now if I go ahead and execute it, Here you'll be able to see that it will apply all the trimming on this with the help of that same model. Now you can see system message has been considered, and here you can see human message. Hi, I'm Bob. So hi, I'm Bob. Over here you can see hi, I like vanilla ice cream. So everything is basically taken. The reason is I've taken all the 65 tokens. Okay, let me this if I probably go ahead and count it, the total number of tokens maybe 65, 70 over there. So for this I will just go ahead and use 45 tokens. Now let's see whether it will change. So here you can see your good assistant, and it has started now from I like vanilla ice cream. See. I like vanilla ice cream, right? So this information you can see from here. The top two has been trimmed off, right? Not top two. The top two human and AI message conversation has been trimmed off. Okay, and remaining all you can see that you are able to see it. And this is how you specifically manage the entire information. We don't need to every time pass the entire context. The reason is very simple because there is a limitation with respect to every context window in our LLM models. Okay, now. Let's do one thing. We can also go ahead and use chains, right? And see, right now we are just passing all the list of messages, and at all the time we need to probably go ahead and pass this trimmer, right? So in a chain, how do we pass it? Okay. So here I will go ahead and like if I'm creating a chain, how do I pass this particular trimmer function that we are going to see? So here I will go ahead and write from operator import item getter, okay? And I'll tell you what exactly we do with this item getter. First of all, I will go ahead and create my I'll import my runnable library. So here I will go ahead and say from langchain underscore core dot runnables, okay? And from this runnables, I'm going to import the runnable pass through, okay? So it'll be runnable pass through, okay? Now once I have this runnable pass through, I think it should be imported langchain, okay? Now, see this. Whenever I create my chain, okay, I know that first when I'm creating this chain. So now, if I really want to apply the trimmer function, first of all, the trimmer function in my list of messages, I can actually use this runnable pass through, and I'll say, and this I will be providing in my chain itself. I'll say dot assign, and inside this, I will go ahead and write my messages is equal to item getter, okay. And here the item getter that we are going to basically say is messages. By using this item getter of messages, we will be able to retrieve the entire messages that is available in the prompt template, and along with this, we will go ahead and apply trimmer, okay. After applying this, one step by step, I've applied over here, right? The next important thing will be that along with this, I will go ahead and concatenate the chain with prompt, okay? Then I will go ahead and concatenate, and this is basically using LCEL, right? I'll go ahead with model, okay? So this basically becomes my chain. Now, if I go ahead and say chain dot response, and here, chain dot invoke we have to do. Invoke, okay? And here we will be passing the parameters. The first parameter that we're going to pass is nothing but messages, and this will basically go with all my messages that I have, okay? So the messages over here you can see, right? This is the messages that I've actually created, okay? And along with this messages, I'll pass it over here. I'll say, hey, let's go ahead and add my human conversation with this. So it'll be my human message. I'll say, hey, content, what is my or what ice cream do I like? Okay, I'll just go ahead and ask, what ice cream do I like? So this will basically be my content. I should not give this in this one. So this will basically be my content, okay? Content over here. And this will be my first information. And again, we need to give this entirely, this human message, I need to give it in the form of list. So let me just go ahead and close this. Now the second parameter here, what I will be doing is that I'll just go ahead and write language is equal to English, because in the prompt template, we have used two parameters, right? So finally, I will store this in my response. And here you'll be able to see that I will go ahead and display response.text. Oh, sorry, response.content. So once I execute it, I'm getting an error saying that messages over here, okay, this should be in the form of key value pairs. Okay, so guys, now let's go ahead and execute this. So once I go ahead and execute, you can see as an AI, I don't have access to a personal preference. The reason is very simple. Why we are not able to find out what ice cream do I like, right? The reason is very simple, because the trimmer, which is specifically applying this 45 tokens, right, max tokens, when it is applying the trimming on this particular messages, that context is not there, right? So that is the reason you can see over here that I'm not getting that particular information. So it is saying I don't like your favorite ice cream over here. And I think this one, I like vanilla ice cream, has also gone. Okay, since we have changed the context maximum number of tokens to 45. Okay, but let's see for this whether this will be able to remember this. What is 2 plus 2? So here, what I'm actually going to quickly do is that I will go ahead and invoke one more chain, and this time I'll just go ahead and ask what map problem did I ask for. So if I go ahead and execute it, here you can see you asked for what is 2 plus 2. Okay, so this way you're able to get all the information and you're able to see it. Okay, again we can go ahead and again still work with. Now let's wrap this in the message history. Okay, we will wrap it message history. Now in order to wrap it again, what I really need to do is that I will go ahead and create my config with message history. So I will go ahead and write with message history, runnable message history chain, get session history, and here you'll be able to see all this information. Okay, now I will just go ahead and set up my config. So my config will be nothing but it will be config build. This is one of the key that is used, and I will go ahead and write my session underscore ID, which will be nothing but chat 5. Okay, so let's say this will be my chat 5. So here I'll just go ahead and execute it. Okay, now based on this particular context, let me go ahead and have some of the conversation. Okay, and here I will go ahead and execute. What's my name? Obviously, I'm not going to get anything, right? So human message is this, and I'm calling this particular configuration. And if I even go ahead and ask the math problem, right? What math problem did I ask? Again, it will be showing me that as a large language model, I have no memory of the past conversation. So this was it. I hope you were able to understand this entire thing. And this is important whenever you really want to work with the chat conversation history, right? So what are things we did in all these 3-4 videos, right? We played with messages, we played with trimmer, we played with managing the conversation history, with prompt template, how you can actually work with the entire conversation history. We have also discussed that, and all these things has been discussed. And these are some of the very important components that will be required whenever you're building your chatbot. So yes, this was it from my side. I hope you like this particular video. I'll see you on the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to LangChain. Already we had in our previous module we had discussed about building chatbots with chat message history also. Now in this video we are going to discuss about vector stores and retrievers. And in this video tutorial we will familiarize you with the LangChain vector store and retriever abstraction. These abstractions are designed to support retrieval of data from vector databases and other sources for integration with LLM workflows. They are important for applications that fetch data to be reasoned over as part of model inference. Already, if you remember, previously also we have discussed about vector stores and retriever, but here I really want to add more features and even play with the chat message history. Okay, so first of all, what we are basically going to do over here is that we will quickly go ahead and install this important libraries like pip install LangChain. Along with the LangChain, we will also go ahead and install pip install LangChain Chroma. I hope we have done all this installation beforehand in our same virtual environment, and then along with this, you have also done the installation of pip install LangChain /grok. Okay, so all this installation you have specifically done, I guess so, because you should also have written this in your requirement.txt. Okay, so here you can see requirement is already satisfied, so I will just go ahead and make this right. Okay, but just understand that I've done this all installation with respect to the libraries that I require. Okay, so please make sure that you update all these things in requirement.txt. Now the next thing that we are basically going to do is that I will take one example that is even given in the documentation page of LangChain. So how to probably go ahead and create a document. Okay, so you need to understand what exactly this document is. So here I'm going to write some information about the document so that you will be able to get this and even be able to refer this. So I'll quickly add some comments over here. Let's say this is my page content. Okay, I will go ahead and add over here page content. This will basically be my metadata. Okay, and then we will read it and I will try to see it. Okay, so here you can see LangChain implements a document abstraction which is intended to represent a unit of text and associated metadata. It has two attributes: page content, a string representing the content, and it has metadata where a dictionary is containing arbitrary metadata. The metadata attribute can capture information about the source of the document, its relationship to other document, and other information. Okay, note that an individual document object often represents a chunk of a large document. Okay, so let's say here in order to work with this specific document, I will go ahead and import from LangChain_core.documents. I will be importing this document class. Now, in order to define my documents, I will be using a list of documents which I'm actually creating this, right? As said, documents has two important properties, right? Two important attributes. One is the page content and the other one is the metadata. So metadata over here will be a dictionary containing arbitrary metadata. The metadata attributes can capture information about the source of the documents, right? So here you can see that the source is nothing but this specific doc. Okay, we have just written it over here in this way. So this will basically become my one document, second document, third document, fourth document, right? And remember, this document can be a part of a large document. It can represent a chunk of a large document. Let's say if I have one PDF where I have 8 pages, this can probably be my first page, this can be my second page, this can be my third page. So that kind of information we'll have, right? So this is what a document is. So let me just go ahead and execute this. Now, if I go ahead and print this particular document, I will be able to see this document over here, right? And again, the type will be specifically document itself. Okay. Now let's go ahead and work with vector store. Now already I've told you what is the main importance of vector store is that we will be able to convert this text into embeddings, right? Into word vectors, into vectors we basically say, and then we can store all those vectors inside our vector store DB, right? So in this case, I will take an example of Chroma. So I will go ahead and write LangChain_Chroma. I'm going to import my Chroma DB. Okay. Now what I'm actually going to do over here is that quickly we'll do one thing over here. I will use completely open source libraries. Okay, open source LLM model, open source embedding techniques and all. Now you know in our env file we have also used this hf_token, right? This token is specifically coming from Hugging Face. Now with the help of this particular token, I can call open source libraries that are available with respect to embedding or even LLM models, right? So in this case, first of all, what I will do is that I will just make a new cell over here. I will go ahead and write import OS, and along with this, I will say from .env import load_.env, right? I will go ahead and initialize this load_.env because I really want the environment variable. Now I will go ahead and first of all take my Grok_API key because I will be able to refer my, I'll be able to usually use the open source models that are present in the Grok AI infrastructure. Okay, so here I will go ahead and write os.getEnv, and here I'm just going to give my Grok API key. Please make sure that you have created that in your environment variable. Okay, the next thing that I'm going to set is os.environment. I'm just going to call this particular hf_token. So let me just go ahead and call this hf_token. I hope the spelling is right, but should be capital. So here you have my hf_token, and I'm going to initialize this value to os.getEnv. And inside this, I'm just going to use the same hf_token, right? So this is quite simple, quite easy till now. Okay, we have set up all the environment variable. Now let me just go ahead and call my LLM model. So here, for using the LLM model, I also have to import from LangChain_Grok, import Grok itself for chat Grok, right? So this will be the chat Grok, and with the help of this API key, we will try to access all the models. So this time, for this particular problem statement, I'm going to take my different model name over here. So over here, first of all, I will go ahead and apply my Grok API key, which will be equal to my Grok API key itself. Okay, this will be my first parameter, and the second parameter will basically be my model. Now this time, if you go ahead and see the documentation page of Grok, this time I'm going to take another model. Previously we used Gamma 2, but now I'm going to use Llama 3 and 8B and 8192. Okay, so from where I'm actually getting this, let me just open the browser and show it to you. So this is my browser. I will go to grok.com, and here I've already logged in. So you can see I'm using this Meta Llama 3 8 billion 8192. So this is my model. It is 8 billion parameter version of Meta Llama model, delivers compelling performance at best in class speed and price. Okay, so we will be specifically using this. Okay, so let's quickly go ahead and use this over here. I've actually used this, and now I'll go ahead and execute my LLM model. Okay, now this is fine. Now as you all know, why do we use Chroma? Chroma is a kind of vector store, and in order to use Chroma, first of all, we need to convert our text into vectors. Now how do we convert a text into vectors? Obviously there are embedding techniques. We have seen about different embedding techniques like OpenAI embedding, Ollama embedding, right? In this video, I will be showing you one embedding technique which we have used with respect to Hugging Face because it is open source. Okay, so with respect to Hugging Face, what we are actually going to do is that first of all, I have set up this hf_token with respect to the environment. Now I will quickly go ahead and install one library which is called as pip install LangChain Hugging Face, but I hope we have done this before also. So let me just go ahead and write Hugging Face, and we are just going to install this particular library. So here you can see that this library is basically getting installed, and it shows requirement already satisfied. We have already done this installation, so I'm just doing it in front of you. If I'm not done it, please make sure that after you do the installation, write this in your requirement.txt to keep a track of it. Okay. Now what I'm actually going to do, I'll go ahead and write from LangChain underscore Hugging Face. Okay, I'm going to import Hugging Face embeddings. Okay, so this Hugging Face embedding, so it actually helps us to download the embedding techniques, embedding model with respect to the different kind of models that are available over there. So I'm just going to go ahead and create my embeddings. So I'll go ahead and write embeddings is equal to Hugging Face embedding, and here I'm going to give my model name, the model name that I'm actually going to specify. Okay, now let's go ahead and open my Hugging Face. Okay, so here I will go ahead and open my huggingface.co. Okay, now please make sure that you create an account in this. See, for embedding, we have a lot of different models. Okay, so if I go ahead and search for embeddings, or let's say that I'll go ahead and click on models over here. So once I click on models, you'll be able to see computer vision, natural language processing, audio, tableau, different models are basically there. For our work use case, I have searched for one model which is called as All Mini LM. Okay, so this will basically help us in doing the. So here you can see All Mini over here, right? It is L6V2, right? The same model we can basically use, and from different companies also it is provided. They have made some kind of changes and all. But if you understand, this is a kind of a sentence transformer. But I'm going to just use the sentence transformer over here. Now, what this model is all about? This is a sentence transformer model. It maps sentence and paragraph to a 384 dimension dense vector space and can be used for tasks like clustering or semantic search. Okay, so whatever words it basically takes, it basically converts into a 384 dimension dense vector space. Okay, so we will try to use this over here. Okay, and based on this, we will try to use this specific model. Now, in order to call this model, what we need to do is that in the model name, I will just go and write and paste this All Mini LM6V2. Okay, so once I go ahead and execute this, this will basically be my embeddings that I'm actually going to use. Okay, this will take some time because it is just going to download it from the Hugging Face, and it is downloading it in your local machine. Okay, so that it can be used at any point of time. And again, so now you can see that it has got downloaded. Okay, now it's time we will go ahead and use this embedding techniques. Okay, along with our where we'll be converting our text into vectors. So we will be using this Chroma vector store. Now let me just go ahead and create my vector store. In this vector store, I'll just go ahead and write Chroma dot from documents, okay, and inside this from documents we will be giving our documents, okay, and we are going to give our embedding technique. So embedding is equal to nothing but embeddings, and this embeddings is nothing but the same embeddings that we have basically used called as Hugging Face embeddings. Now, what exactly is happening over here when I write chroma.from documents with respect to documents and embedding is equal to embedding? First of all these documents is going to get converted into vectors, okay, into vectors by using this embedding technique, and then it is going to get stored in this ChromaDB. So that is what is basically happening inside this particular line of code, okay. So this was most of the thing that we really want, okay, and now let's go ahead and execute it. And if I go just go ahead and see the vector store, so this it will show it to me that it is a chroma vector store, okay, and already in my previous video I've shown you how to store this vector store in your local if you really want, okay. So but this is just like a ChromaDB which is storing the specific information in the form of vectors, okay. Now this is fine. Now with the help of this vectors, what exactly we can do with the help of this vector store? I can apply something called a similarity search. I can go ahead and apply this, and let's say if I'm going and searching with respect to cat, I will be getting all the sentences which has cat information over here which is similar to this particular cat word, okay. So any word that you write you will be able to do this. Now along with this in the vector store we can also go ahead and hit with sync query, okay. So async query also functionality is supported by this particular vector store. So let me just go ahead and write. In order to implement this async, I will just go ahead and hit I'll use this await keyword, and then I will be using the same thing that is called as vector store similarity search by cat. Now here you'll be able to see that await object list cannot be used in await expression, okay. Let's see. Okay, instead of using this similarity search, there is another function which is called as asimilarity search, okay. So now if I go ahead and hit this, here you'll be able to get this particular information, but this entire query will be hitting with respect to using, it will not be it need not wait till the response is probably coming back. It will just use this async method, okay, over here. Now this resource, see this information that we are specifically getting here, we are only getting the page content. Sometime I would also like to get the scores, like how much match is basically happening. So what we can do is that I will just go ahead and use this, and instead of using just similarity search, I will say, hey, use similarity search with score. And again, they are with vectors also, you can convert into vectors and you can also do it. So here you will be able to see that I'll be getting, okay, this is this much score and this is over here 1.57, 1.59, whichever is the nearest. I think it uses distance metric to calculate the sentence and the words, okay, whichever is the nearest. So 0.93 is the nearest, then 1.57. After that, you are able to get this, then 1.59, 1.66. Okay. So in short, this is about vector stores where you are able to do it. Now let's do one thing, and let's talk about one very important thing which is called as retrievers. Okay. Now let's worry about this retriever topic, and I'm just going to put a description over here, okay, so that you have this for the reference. Let's read this, okay, and then we'll try to understand it. LangChain vector store object do not subclass runnable, and so cannot immediately be integrated into the LangChain expression language chains like LECL, right? LangChain retrievers are runnable, so they implement a standard set of methods, synchronous and asynchronous invoke and batch operation, and are designed to be incorporated with LCEL chains. So vector store, you can see that it cannot be integrated with your entire chain. That is what this sentence basically say. The reason is very simple, because it is not a subclass of runnable. Whereas in the case of retrievers, they are runnables, okay, and this can specifically be integrated, right, or incorporated with the LCEL chain. Now what exactly is this LangChain retriever? It is you can just say it is a standard set of methods which will be able to perform synchronous and asynchronous invoke and batch operations. Okay, so if vector store is not a subclass of runnable, we cannot integrate with LangChain. We cannot integrate with chains by using LCL. So what do we do is that we have a way how we can basically convert this vector store into a retriever, which is a runnable, so that it can be integrated to the LCL chain. Right? How to do it? I will be talking about that. Okay. So first of all, what I will do over here is that, and then you can see we can create a simple version of this ourselves without subclassing retriever. If we choose what we wish to use to retrieve documents, we can create a runnable easily. Okay, let me just show you. I know I've spoken about many things over here. So first of all, I'm going and I'll import this from typing import list. Okay, this list we will be specifically using. This is see the list functionality is almost different, but this is a kind of a different list when compared to the data structure list that we are using. Okay, so now I'm going to import from langchain.core_core dot document import document. Okay, so we are going to just import this document langchain. Okay, then I'm going to go ahead and write from langchain_core dot runnables. We are just going to import runnable lambda. Okay, runnable lambda. Now what exactly is this runnable lambda? Everything we will be talking about it. Okay, now see this. Here we will try to create retriever by two ways. One by using this runnable lambda. Okay, so here I will go ahead and write retriever is equal to runnable lambda. Okay, and here what we can do, we can basically go ahead and write vector store dot similarity search. Okay, and here we can just say dot bind and give the top result, whichever result you are able to get. Okay, select the top result, k is equal to 1. Now I will just go ahead and call this retriever. I will explain you right what exactly is happening. Dot batch. Okay, I'll be using a batch function in the retriever. Okay, and this is, I feel this way you should not do it, because the next method that way I will be talking about how you can retrieve the data from the vector store. That will be the best way. Let's say inside this batch I give two words. One is cat and one is shark or dog. Let's say I'll go ahead and pick dog. Okay. Now what this is going to basically do, please see to this. Okay, so here I am creating, this is just like a runnable lambda function. Okay, and this function is going to get applied to all the parameters that we are giving inside this particular batch. Okay, let's say if we give cat over here, right? So first of all, it is going to do the vector similarity search on cat, and whichever will be the topmost result, I will get that particular value and it will get displayed. Then since this is a runnable lambda, that basically means a lambda function to execute this runnables, then I will be passing this dog parameter will get passed. Again, the similarity search will be done, and based on the similarity search, whichever will be the top result, I'll be getting that. Okay. That is what is basically going to happen over here. Now if I go ahead and execute it, here you can see cats are independent and they often this, and this is my related to dog. So two content are we have been able to retrieve from the vector store. So vector store is a DB, right? And we are able to convert this into retrievers just by using this runnable lambda. Okay, and what is the meaning of this runnable lambda? Based on the method that I'm calling, whether it is invoke or batch. In batch I can probably call multiple parameters, multiple inputs. It will get executed with respect to the similarity search that we are doing. Okay. Now the second technique that we are going to use over here is something called as vector store implement as retriever method. This will generate a retriever, specifically a vector store retriever. This retriever includes specific search type and search KWARGS arguments, attributes that identify what method of the underlying vector to call, okay, and how to parameterize them. Now this is probably the best way how you can go ahead and query from a vector store, right? We really need to convert this into a retriever. So I will go ahead and write vector store dot as retriever. Okay. Now this retriever acts as an interface, right, to pass or to take any information from the vector store and give it as a response. Okay. So here I will go ahead and give my parameter. The first parameter will be my search type. So here you have the functionality of search type, and the search type over here I can go ahead and write similarity. Okay. Then the search argument, search underscore KWARGS. Okay. Now this argument specifically I will be mentioning with k:1. So this I'm saying, hey, give the top first result. See, here we have written dot bind with k is equal to 1. Again, we are using similarity search. Here we are giving two parameters over here. One is search type and one is search underscore KWARGS. Okay. And finally, here you'll be able to see that once I create this retriever. Okay, let's go ahead and create this retriever, retriever is equal to this. Okay, I'm just going to go ahead and write retriever dot batch, and now I will give the same two words that I've actually given. One is cat and one is dog. So this is the next way, and here is all the information that I'm able to get. Okay. So this is how you can go ahead and probably use any of this with respect to implementing things. Okay, and this is how you can actually go ahead and work with it, right? So here we have basically what we have actually done is that we have taken a document content. This may be coming from a PDF, it may be coming from any website and all. We have converted this into a vector store, and finally with the help of retriever we are able to get the response. Okay, so this was mostly about all the things that we have actually discussed till here right now. I hope you were able to understand this. Okay, now one final thing that I really want to show you is that how we can integrate this retriever along with the chain. Okay? So guys, let's go ahead, and here I will be putting up some information. Let's say this is my chat prompt template and this is my runnable pass through. This is the basic prompt that I'm actually trying to create. Answer this question using the provided context only, right? And this particular context needs to be filled by the vector store, right? And this is the question that what user is going to give. Okay, so here what I will do, I will go ahead and create my prompt quickly. So this will basically be my prompt, and we have discussed all these things earlier also, right? So chat prompt template dot from message and human message. I'm giving the message, whatever message we are giving it over here. Okay, and this message I'm just specifically saying that hey, what is the information that I really want to give? Okay, so after this, you'll be able to see that I will go ahead and create this prompt, and after that, I will go ahead and create my entire RAG chain. Now, in order to create this RAG chain, how do I pass this retriever, right? How do I pass this retriever along with my chain? Because now retriever is a type of runnable over there. It is a subclass of it is, you can just see over here, right? It is a subclass of so here where it went. Okay, so retrievers are runnables, right? So now it has become a subclass of runnable, right? So how do we integrate it over here? So first of all, I will just go ahead and replace whatever context I've written over here. So instead of this context, I should be getting this entire context from retriever. Okay, this retriever will be responsible. The second parameter that I really want is my question, right? And this particular question will again be in the form of key value pairs, right? And this value, what we are basically going to pass, we will go ahead and write runnable pass through. Runnable pass through basically means so we are going to get this particular information in the invoke method. Okay, then you have prompt. After this, I will go ahead and pass through prompt, then my LLM model. Okay, so this basically becomes my the entire chain itself. Now, in order to execute it, I will go ahead and write rag underscore chain dot invoke. Okay, and let me just say, hey, tell me about dogs. Okay, and once I get this response, I will go ahead and print it. So print response dot content. Okay. So here, once I execute this, according to the provided context, the dog are great companions known for their loyalty and friendliness. So from all the documents, we are basically getting this. Now, what we have actually implemented, this is just a basic RAG, right? This is RAG, retrieval augmented generation, right? So here, what we have done, we have used chat prompt template, we have used runnable pass through, we have created our prompt. Here, we have given two inputs, one is question and one is context. This context needs to be replaced by our retriever. So this retriever, if I'm writing over here, this is basically the information from our vector store. All the documents will get added over here, right? And finally, you'll be able to see that I'm able to also integrate this in the RAG underscore chain. Your question will be runnable pass through. That means whatever input I'm actually giving over here, that is going to get placed over here. And then we are going to use prompt and LLM to create the LangChain. Finally, we get the response. So I hope you're able to understand and get some idea with respect to vector store retriever. And this is the entire thing that we really need to learn. And this is something basics because later on, once we start building projects, you will be able to learn more amazing things. So yes, this was it from my side. I hope you like this particular video. I'll see you on the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to LangChain, and now in this particular video we are going to talk about conversational Q&A chatbot. So we will be building some amazing conversation Q&A chatbot. You'll be understanding how you can go ahead and build this. Now see this, in many Q&A application, we want to allow the user to have a back and forth conversation, meaning the application needs some sort of memory of past question and answers, and some logic for incorporating those into its current thinking. In this guide, we focus on adding logic for incorporating historical messages. Further details on the chat history management is covered in the previous videos, right? We have already discussed about some of the chat history management terms, and now we will be covering two approaches. One is in chains, in which we will always execute a retrieval step, and the second one is agents, in which we give an LLM description over whether or how to execute a retrieval step for multiple steps. So already we have discussed so much things about chat history, right? But the main idea of using this chat history specifically for a Q&A chatbot. So in this video, I will go ahead and explain you that. Okay. Now, first of all, over here also, I'll be making sure that I use open source models. So for this, I will be again importing import OS, and then from here, I will go ahead and write import or from .env import load underscore .env, right? So we're also going to go ahead and import this. Let's see whether it is executing fine. So we'll go ahead and initialize this load underscore .env because we'll be having all our environment variables. Now, with respect to the environment variables, the first key that I will be requiring, and here I will go ahead and write from LangChain underscore grok import chat grok. Okay. And I think we have repeated this code multiple times, right? So I'm just showing you again and again so that you don't forget this. Okay. Now, when I'm importing this chat grok, along with this, you'll be able to see that I will also go ahead and take my API key from my environment variable. So for this, I will go ahead and write os.get env, and inside this, we will go ahead and write grok underscore API underscore key. Okay. So once we get this, the next step will be that we will go ahead and call our LLM model specifically over here. So for this, we will go ahead and use Llama 3 in this particular use case. Okay. So this is where we specifically get our LLM model. So this is the fundamental thing that we should definitely do in each and every basically whenever you're developing most of the application. This is common. If you are really interested to just work with open source model, grok AI infrastructure is the thing that you should really go ahead with. Okay. Now let's work on some of the important things. First of all, what I will do is that I will go ahead and pip install BS4. Okay, so this is the library which is called Beautiful Full Soup 4. This is used to extract a HTML page. Okay, extract the content of the HTML page. So here you can see that the requirement is already satisfied. I have selected this VNV environment, and make sure that whenever you do this installation, you update that in the requirement.txt in the specific projects. Okay. Now the first thing what I'm actually going to do over here is that I will quickly go ahead and upload or import some of the libraries. Okay, so I'm going to import something called as Chroma. So here in this code, I'm going to go ahead and import Chroma from LangChain underscore Chroma. Along with this, I'm going to use the document loaders and we'll be importing from web-based loader because I want to read the content of a web page. And we'll try to create a conversational Q&A chatbot. That basically means I'll be having a website which will be my external data source, and from that I will try to chat through my chatbot. Okay, and whatever conversation we basically add, we will also add our message history, right? Then along with this, we're going to use the chat prompt template, and you know where it is available inside prompts. Now, instead of using OpenAI embeddings, I will remove this. Okay, because I will not be using OpenAI embeddings because it will charge you some amount of money. So instead, what I will do, I will go ahead and use this particular code wherein I'll go ahead and import my HF underscore token. If you remember, how did I import HF underscore token? Along with this, in my environment variable, this is also present. Okay, so from LangChain underscore Hugging Face, import Hugging Face embeddings. And this HF underscore token, from where do you get? You get it from your Hugging Face account, right? So this is the embedding that I'm actually going to use, right? Hugging Face embedding. So let's go ahead and execute this. Perfect. Till here, I think everything looks fine. And then after this, we're going to also import recursive character text later so that we will be able to split our document in chunks. Okay. So once we upload or once we load all these things, now we are also going to use two important functions also, right? And these functions we'll discuss about it. So one is from langchain.chains, right? So inside this, whenever we try to create a chain, by using this library or by using this function, we will be able to create chains. Okay, so create retrieval chain. Let's say if you know about retriever is nothing but it is an interface to a vector store database, right? And if I want to create a chain with this particular retriever, I have to use this particular function which is called as create retrieval chain. Okay, we'll discuss more about this as we go ahead. The next thing that we are going to use is something called as combine documents, create stuff document chain. Okay, so as you go ahead in the future, right, in upcoming sessions and modules, I will be talking about text summarization. Now, when we discuss about text summarization, there we'll be discussing about three types of text summarization. One is stuff document chain, one is map reduce, and one is refine. In stuff document chain, what it does is that it combines all the documents and then it sends it to the prompt template, and that is why we will be using this specific function. Okay, so I will show you everything with an example. Okay, now let us go ahead and execute this. Okay, so here we have got executed it. Now I'm going to use a web-based loader, and let's say I'm going to use this particular website. Okay, so let me just go ahead and quickly import BS4 also. So I will go ahead and write import BS4 because I'm going to use BS beautiful soup 4. Now here inside this web loader, I'm giving my web path. This is the URL that I'm trying to read the content from. Okay, and then here you'll be able to see I'm using a class which is called as post content from that page and post title. So if I go ahead and hit this page, let me just show you by opening this page over here. Okay, let me open my browser and let me just hit this page. Okay, so here you can see that this is the entire page content, and I will be using this particular page content as my external data source. Okay, now from this, what all fields I'm really interested in. So I am interested in getting the post content field, post title field, and post header field. So if I go back, if I just go ahead and do the inspect, so here you'll be able to see I'm getting the post title field, post content field, and post header. Post header will also be somewhere here only. Yeah, here. So all this information we'll try to extract from this. Now, let me close this console. Let me go back to my code. Okay. Now, once I probably use this loader, that is a web-based loader. This is for the data ingestion from a website. I will go ahead and write loader.load, and I will load all the documents. Okay. So here I will be able to get my documents. Okay. So if I go ahead and execute this and see my documents, you'll be able to see that one single document I'm able to get over here, and all the information is basically shown over here inside this particular page content. Perfect. Now, usually what we do is that once we get all this content, it is a good practice that we try to divide this entire document into chunks of document. The reason is very simple, because every LLM models specifically have some kind of context size, right? So it is better that we try to break all these particular documents into chunks. So for this, we will be creating a text splitter variable, and here we will be using some recursive character text splitter. And let me go ahead and write our chunk size is equal to 1000, and here we're going to basically use chunk underscore overlap with 200. Okay. So once we actually do this, then we are basically going to create our text splitter over here. The next step, what we are going to do is that I'm just going to write splits is equal to text underscore splitter dot split underscore documents, and whatever docs I have, I will be giving over here. So it will basically do the splitting. And after doing the splitting, I will go ahead and store this entirely in our vector store database, right? So for that, I will write from chroma.from documents, and I will give this documents is equal to whatever splits I'm actually getting over here. Okay. And here I'm going to apply my embedding, which will be equal to this particular embeddings that I have actually used. That is nothing but Hugging Face embedding, right? So here you can see that I've initialized this Hugging Face embedding. Perfect. So till here, everything looks good. This will finally give me my vector store. Okay, vector store. And this we have already repeated in our previous video, right? And if I really want to convert this into a retriever, all I have to write is that I have to write something like vector store dot as retriever, right? And here is your entire retriever, right? Now, so this is the retriever over here. Okay, perfect. Let's see. So here is your entire retriever that we are able to get it. Okay, now this is fine. Now it's time that once we get this entire retriever, and this is for the vector store. The retriever basically means it is an interface with respect to vector store, so that whenever I ask any query, I should be able to get it from the vector store itself. Now this is important, and this you have actually seen it. Okay, now it's time we will go ahead and define our prompt template. Okay. See, the same thing what we are doing, because after this, I'm going to execute more things over here. Okay, so let me do one thing. Let me go ahead and define my system prompt. So this is my system prompt. I'm saying, hey, you are an assistant for question answer task. Use the following piece of retrieve context to answer the question. If you don't know the answer, say that you don't know. Use 3 sentence maximum. Keep the answer concise. Okay, and here new line, and here we will be passing the context. Now what this context will be getting replaced with, I will talk about it. Okay, then I'm going to take the system prompt. I'm going to use it as a chat prompt template. I'll again from underscore message I'll use. I'll give a system prompt over here, and along with that human, whatever input I'm giving with respect to the human, I will pass it over here. So here we can actually go ahead and pass this particular input, and this is my system prompt, which is basically saying how the system should behave or how the LLM model should act like. Okay, now this is absolutely fine. Now my time, now is the time that we need to attach this retriever along with the system prompt and along with the prompt, right? So here we really need to create this particular chain, because this retriever is pointing to the vector store database. This is my system prompt based on which I should be able to get my information, this is specifically my prompt. So I need to probably go ahead and create a chain. Now the one thing is that how do I get this context information? Now to get this context information, I will first of all go ahead and create my question answer chain. Okay, and here we will go ahead and write create stuff document chain, and here we are going to pass LLM comma prompt. Now the reason I'm passing my LLM model and prompt, okay, what this exactly is going to do, okay, and that is the reason we have imported this create stuff document chain. I've already told that this create stuff document chain is going to make sure that it will combine all the document and it will pass in the form of the specific context in that specific chain. When we create the chain with respect to system prompt, with respect to this particular prompt LLM model, right, you'll be seeing that when we use create stuff document chain, here I'm passing two parameters LLM and prompt. Now this prompt, right, is requiring some context information, right, and this context information needs to be provided with respect to all the list of documents, like what list of documents you have over here, right, all the list of documents, right, we did this particular split and all, right, so that it will combine and it will send it to this particular prompt itself in the form of context, right. Now if we are doing this, the next step will be that we need to go ahead and create our entire RAG chain. For creating the RAG chain, we will be using a create retrieval chain. Now, inside this create retrieval chain, I'm going to make sure that I pass my retriever. Along with this, I also pass my question answer chain, right? So this create stuff document chain will also get passed over here. Now, I have retriever, I have LLM model, I have prompt. So these all are connected in a case of a retrieval chain itself, where I'll be able to get the response. Okay. Now, once I execute this, next time that we will go ahead and execute it. So in order to execute it, I'll just write RAG underscore chain dot invoke, and here we're going to give my input. So I know my key is basically input over here. I'll write, hey, what is let me see what was the page over here that we used. What is, I'll ask any question. What is task? What is self-reflection? Okay, I'll ask this question. Okay, from here. So here, if I go ahead and ask what is this, I should be able to get my response, and my response is nothing but it will be over here. And with respect to this, I will go ahead and write a response of, and I'll display the response. So here you can see what is self-reflection, and I am getting this entire context. See, this context is basically having these particular documents. How it is combining all the documents and giving it to the prompt? It is because of this create stuff document chain. And the stuff document chain is basically used in text summarization, where it combines all the documents and sends it to the prompt, right? Further from the prompt, it goes to the LLM model, right? So here you can see this is my entire context, and from that I'm able to get the answer. So if I just want the answer over here, I will go ahead and write response of answer. Perfect. And here you can see self-reflection is a mechanism that allows autonomous agents to improve iteratively by refining action and more information. Okay. Now, here you can see we have used built-in chain constructors, which is called as create stuff document chain and create retrieval chain, right? But at the end of the day, the basic ingredients that you'll be able to find is something like retriever, prompt, LLMs, right? Just a way to how to replace data with respect to this particular context and how to replace, how to probably get the answer with the help of this particular retriever, right? But now it's time that we start working towards adding chat history. Okay. So here we're going to basically go ahead and add our chat history. Now, how to add this chat history, right? Let's say I've asked a question over here, right? What is self-reflection? Now I will again go to this and ask another question over here. Let's say I'll just continue and ask. This is my invoke, and here I'm just going to take the input. Now, instead of writing what is self-reflection, I'll say how do we achieve it? Okay, so this is what I'm going to ask. Now here you can see achieving task decomposition, it is basically same. Okay, I was trying to ask with respect to what is self-reflection, but here it is probably giving me some other thing like how do we achieve it? Achieving task decomposition is basically it is a tree of thoughts involves so and so. But I wanted the information with respect to self-reflection. Now the problem with this rank chain is that it's not able to understand the context, right? It is because it obviously do not have any kind of chat history. So what I will do now is that I will go ahead and show you how we can go ahead and add chat history along with the prompt template and how we can do the same task and see how things work with chat history over here. Okay, so let's go ahead and first of all, what I'm actually going to do is that for adding chat history, I will be importing from LangChain. Okay, and this chat history specifically for conversational Q&A chatbot. We'll go ahead and write LangChain.chains import create history aware retriever. Now, the kind of retriever that I'm going to create, or the chain of retriever that I'm actually going to create. See, here also we created a chain of retriever only, right? So this is nothing but a create retriever chain, right? So this is nothing but a retriever chain. But when we use this create history aware retriever chain, that basically means the retriever will also know about the history of information or history of conversation that has been basically made with the LLM model. Okay, so we are going to probably create our chain with respect to with the help of this particular function. Okay, the next thing is that I will go ahead and use from LangChain underscore core dot prompts. Okay, prompts. I'm going to go ahead and import messages placeholder. Okay, and why I have to use this because I will be able to create a chat history. I'll just say that okay, this can be a key value pairs where I will be storing all the information, right? And that is where I will be using this message placeholder. Just wait for a second. I will just make sure that in the coding you'll be understanding where we use this message placeholder, right? If we define a message placeholder with any variable, in that particular variable only all the chat history will be saved. Okay, this is what I really want to talk about. Okay, now I will go ahead and create a prompt. Okay, so this is basically called as contextualized queue system prompt. Okay, so I'll say given a chat history and the latest user question, which might reference the question in the chat history, formulate the standalone question which can be understood without the chat history. Do not answer the question, just reformulate it if needed, otherwise return it as it is. Okay, so this is the kind of prompt that I've actually created over here. I'm saying, hey, please, you have the chat history, you have the later user question, which might reference the context in the chat history. Formulate a standalone question which can be understood without the chat history. Do not answer the question, just reformulate it if needed, otherwise return it as. Okay, so simple prompt that we're going to use over here. Now for this, we will be using, I will be creating a prompt template. Now see, I've given the system message with respect to this, and this is where I'm going to use message placeholder. Now in this message placeholder, I'm creating a variable like chat underscore history where all my history of conversation will be stored. Okay, and here is my human input. Okay, so guys, now here you can see that I've created my chat prompt template. Now instead of using a retriever, I will go ahead and create this history aware retriever. Right now, I will be getting a new type of retriever instead of the previous retriever. And here I will write history aware retriever is nothing but create history aware retriever. And here I'm going to provide the parameters LLM retriever. So let me just go ahead and write this retriever. Along with this, I will also go ahead and provide my contextual Q prompt. Okay, Q prompt. In short, what we are doing over here is that we are upgrading this retriever to history aware retriever, which will also be able to retrieve the results or retrieve the get the results from the vector store DB, considering the chat history. Okay, that is what we are basically going to do. And now if I just go ahead and display this, you'll be able to see this entire thing over here. Right now, this is perfectly fine. Till here, everything looks good. Okay, and we are going on very on like on point. Okay, now it's time to go ahead and create the chain. Okay, now to create a chain, what I will actually do is that again we will go ahead and write the same question answer chain. Here we are going to use the create stuff document chain. Okay, and here we are basically going to use my LLM, comma QA, QA, or what is the prompt that I had actually used over here? This is nothing but it is a contextualized Q prompt. And instead of this, I can go ahead and create the new prompt over here. Okay, and I will name it as QA prompt. Okay, the same prompt only, nothing different. I'll use this QA prompt. Okay, it is same thing, right? So here I'm going to use this particular prompt, and along with this prompt, what I will do in the next step, I will go ahead and create my rack chain. But this time, my rack chain will be having this create retrieval chain. I will go ahead and create this retrieval chain. Inside this, instead of just giving the retriever, I will be giving my history aware retriever, comma the question answer chain. See, the question answer chain. If you remember, previously when we created this create retrieval chain, what all inputs we specifically gave? See over here, we gave the retriever, we gave question answer chain. But this time, we are giving history aware retriever and question answer chain. Now it's time that we can go ahead and use this LangChain. Okay. Now let's go ahead and add it and see what exactly LangChain will basically do and what are things we can specifically do it. Okay. So first of all, what I will do, I will go ahead and import from LangChain underscore core dot messages import AI message, comma human message. These are the list of messages that we usually append. Here I'm just going to go ahead and create my chat history. And remember, the variable name should be same, like how we have defined over there, right? In the message placeholder. Then my first question will be something like question is equal to, I will go ahead and write what is, okay? What was the question that I had asked earlier? What is self-reflection, okay? So from that particular page, I'm just going to ask this particular question, what is self-reflection, okay? So this basically becomes my question, okay? Now, if I want to execute it, so there, let's say this will be my response one. And inside this response one, I will go ahead and use the same chain. I will write dot invoke, okay? And let me just go ahead and give my input. The first input will be nothing but it will be question. Okay, and the second input will be nothing but chat history. Okay, so here we're going to basically go ahead and use chat underscore history, okay, which will be assigned to my chat history, right? Whatever chat history we are creating over here. And this is the message placeholder that we are giving, right? And here only we are going to save all our chat history. Now, along with this, what I will do, since this is a list, right? I'm going to go ahead and append this with every conversation that I have. So here I'm going to write extend, and let's say here I create a list. Here I'm just going to add my human message. So the content will be assigned to this particular question, whatever question I'm actually giving. And along with this, I will go ahead and write AI message, because we need to append it, right? And content is equal to nothing but response, whatever response one we are getting. And inside that there will be a variable which is called as answer. Because see, whenever we get the output from the retriever, you'll be seeing that there is an answer key. Okay, so we need to append this in the chat history over here. Okay, so once it gets appended or extended basically means it will just get added at the last. Okay, now Similarly, once I execute this, I will go ahead and write my question 2. The question 2 will be that how or what are the common ways of achieving it. Okay, I'll just go ahead and write it. Or let's say I'll just go ahead and ask a question. Tell me more about it. Tell me more about it. Okay, something like this. So this will be my second question that I'm going to go ahead and write. Now I will go ahead and write action chain.invoke, and here the same thing I'm going to pass, right, with respect to this history. I'll get my response 2. So this will basically be my response 2, and now I'll go ahead and print my response 2 of my answer. Okay. Now I think it should be able to understand the context and it should be able to give the answer. Let's see. So self-reflection is a mechanism that allows autonomous agents to improve iteratively by refining past action, decision, and correcting previous mistakes. See, initially I asked what is self-reflection, then I told tell me more about this, and this is what we are basically printing. Okay. If I go ahead and see with respect to the chat history, you'll also be able to see the first one is this particular message that we got, right? Errors are evitable. Okay. And second time when I asked tell me more about it, it was able to understand the context and it was able to give us the answer. So I hope you're able to understand this amazing thing. Okay. Now there are some more things that you can actually do with whenever you're working with LCL, right? That is adding chat history with respect to session IDs and all that we have already discussed. So let me quickly copy and paste some of the code over here so that you'll be able to understand. So if I go ahead and write this, if you remember, this base chat history runnable with message history and chat history, right? We used it. So here you can create this particular session, and based on the session ID, you will be able to retrieve all the chat history. The output key will be the answer, the input key is nothing but input, right? So here, if I go ahead and execute this, here is nothing but it is your entire conversational chain in short, right? Now I can go ahead and invoke anything based on my session ID. So here, I'll go ahead and write conversation rag chain.invoke. What is task decomposition is another one question. I can write my config. This config is going to make sure that it will store all the information with respect to the session ID, and then we can also get the answer, right? So here you can see task decomposition is the same thing, and here you can probably see the same answer. Okay? Now similarly, if I go ahead and use the same session, like I'll go ahead and ask what are the common ways of doing it. So I'm actually talking about task decomposition. The reason is why I've actually used the same session ID. You can go ahead and see the answer. Now to be able to understand that yes, we are fine talking about this task decomposition. So you can say that in the context, most common ways of doing task decomposition includes NN1, something new line characters using a large language model. Everything is basically displayed. Let me see one more thing. Did I print? Okay, yes, I printed the right response. So yes, this was all about the conversational Q&A chatbot with memory, right, with chat history, and I hope you're able to understand this particular question. This is how we basically create a history-aware retriever, and you can actually use all these things, right? So yeah, this was it from my side. I hope you like this particular video, and yeah, I will see you all in the next video. Have a great day. Thank you and all. Take care. Bye bye. Hello guys. So finally, I'm excited to implement the first end-to-end Gen AI application. That is nothing but a Q&A chatbot. I'll just give you a brief architecture, what all things we are specifically going to do in this particular project, and then from the next video, we will start implementing it. So over here, some of the tools or some of the APIs that, or some of the LLM models that we are going to use is OpenAI LLM models. Okay, so we are going to use OpenAI LLM models. To name some of them are nothing but GPT-4o. So this is a multi-model. Okay, GPT-4o. Then we will also be using GPT-4 Turbo. Right. We will create this entirely in a Streamlit web app so that you'll have multiple options to select the model and probably continue it. Okay, so this is one of the LLM models. The second one that we are going to probably use is Ollama. Now, with the help of Ollama, what we are going to do is that whatever open source models are available in Ollama, right, like Llama 3, Gemma 2. So here we are just going to write Gemma 2. Along with that, if you are also familiar with Mistral, so all these open source models also will try to use and create this Q&A chatbot. Okay. So in our project, first of all, what we are going to do is that we're going to create the Streamlit web app. So this will be my Streamlit web app. This Streamlit web app will be interacting. I'll give an option wherein it will be interacting with the OpenAI APIs. Okay, OpenAI API. And with the help of this OpenAI API, we will try to interact with various LLM models like GPT-4o, GPT-4 Turbo, or it can also be GPT, let's say 4 over here, right? Once we interact with this, then you'll be able to see that we will finally get our response. Now, we're not going to stop over here, right? Once this is entirely interacting with these LLM models, we'll take one step ahead and we will further put all these logs in our Langsmith platform. Okay, so Langsmith will also be there. So here you'll be able to see that we will be having Langsmith. Now, Langsmith, why it is used? It is specifically used for monitoring. Then it is used for debugging, right? To also see how much cost is basically getting involved. So all this kind of information will be available in the Langsmith once you're able to track it. So here we are just going to give our user query. Then all this process is going to happen. Okay. I know this looks like a very simple project, but understand one thing is that as we go ahead, we'll be building more complex project on top of it, right? Like RAG applications. Then we'll be seeing RAG with SQL. All this kind of applications we'll be trying to swing. So there are many projects that are probably going to come up, but right now we will start with this basic project itself. Okay. The best idea about this particular project will be that first of all, we will go ahead in creating our entire project. Then second one is we'll be setting up our environment variables. Okay, environment variables. So when I say project, I will also go ahead and set up our own environment. Then environment variable, then we'll see that what all libraries we specifically want, like requirements.txt will be implemented. Then we will go ahead and create our Streamlit web app. Inside the Streamlit web app, I'll show you how to probably call the OpenAI API key, the LangChain. So these are like things that are happening in the industry, and this is what I will try to cover in this particular project, right? And finally, after doing all these things, we will also make sure that we will do the deployment. Right? So all these steps will be specifically covered in this project. So just to give you an idea what exactly the project is all about. So here you can see this is what we are going to develop. So on the left hand side, you can see you can put your OpenAI API key. You can select different models like GPT-4o Turbo, GPT-4o, GPT-4o. So if I select this, I can also set up the temperature value and the maximum tokens that I need to get. And let's say I'll just go ahead and ask a question saying as hi. I'll be able to get some message. How can I assist you? Please explain what is generative AI. So I should be able to get the answer over here. Once I press enter, you'll be able to see that I will be able to get some kind of response. Okay. And based on the response, I will be able to see the entire data over here. So this is what it will get executed. And just to give you an idea over here, also you can see the Langsmith tracing is also happening. We will go ahead and deep dive on all these tracings and all also. Okay, so this will be taught in this particular project. So let's go ahead and implement this end to end. Thank you. So guys, now let's start our project implementation. So here you can see I've created one folder called as LangChain projects, and my plan is to probably create all the projects inside this. So the first one is a Q&A chatbot. Okay, we're going to specifically use this. Let me double click inside this, and I need to probably start my project solution from here, right? So what I will do, I will open my VS Code from here. I'll copy this path. I will open my command prompt. Okay. Now I will go to my specific path. That is nothing but E drive. Okay, and I'll say, hey, CD, go to E drive. Then you have this Udemy final. Okay, so let me just go ahead and write that down. Udemy final. Okay, CD, Udemy final. Okay, I'm going to this path. I'll show step by step. See everything. I'm not going to hurry in this. So please make sure that you follow along with me. Okay, I'm going to my LangChain projects and then finally going to my CD Q&A chatbot. Okay, once I go over here, now what I'm actually going to do is that I need to open my VS Code from here, right? See, this is the path, right? Udemy final LangChain projects, one Q&A chatbot. So I've just step by step went into that particular folder and I'm going to start my project from here. Now, in order to start the VS Code, I'll write code dot and automatically my VS Code will get started, right? So this is the first step over here, what we have basically done. Now I will go ahead and implement my project over here. Initially, to start with, what we need to do is that open my terminal, right? So there are multiple ways how you can open a terminal. First of all, here you can see there is a button called as terminal, which you can specifically open it. Otherwise, I usually use a shortcut wherein I press control or just Google, right? What is the shortcut to open the terminal, right? I'll give you this as an assignment. Okay, it'll be up to you. Come on, now you're implementing generative AI solutions, so I think you should be able to understand how things work over here, right? Now here is my terminal. Okay, now the first step, what I'm actually going to do, I'll open command prompt over here. You can also go ahead and do it in PowerShell. So here I'll write conda create minus t vnv. This will be my environment. I will go ahead and use Python double equal to 3.10. Okay, you can use 3.11 also, but I will go ahead and use 3.10. It is up to you, whichever Python version you want to run with or you want to work with, right? But I'm going to work all my projects with 3.10. And the reason is very simple, because I'm going to do some more complex projects in the future in the series itself, and there you'll be able to see that there will be some dependency with this particular Python version. Okay, so let me just go ahead and do this, and here the entire environment will get created quickly. Once the environment is basically getting created, I will probably start my entire things. Okay, and then you will also be able to see that once this project is basically getting created, right, we will be seeing that, okay, how we can also make sure that we have to update our requirement.txt. So here is my VNV folder that is getting created. It may take some time, and I will go ahead and write .env, and then I'll just go ahead and say requirement.txt. So two more files I'm going to create it. Okay, please note one thing, that I'm not going to repeat the step of creating the environments again for the other projects, but I hope you should be able to understand till here. Now in requirement.txt, I'm just going to go ahead and update some of the libraries that I'm actually going to use. Okay, since we are going to work with OpenAI, so obviously we need to have LangChain OpenAI. So I'll go ahead and copy this. Okay, along with that, I will also be requiring different libraries, like I can actually have one pandas, numpy and all. I'll also may require that. Based on this, what all basic libraries are there, I'll go ahead and write LangChain. Then I will go ahead and use python.env so that I can play with the environment variable. Then along with this, I will just go ahead and write LangChain underscore community. Okay, I'm also going to use this. Other than that, whatever new libraries that I will be requiring, I will try to install it. Okay, so quickly I will just go ahead over here and go ahead and write pip install -r requirement.txt. Okay, so once I do this, here all the requirement.txt will get installed, which is good enough. And here you'll be able to see that whatever things you really want, you can go ahead and probably install as per your requirements, right? So here you can see Chroma DB requires UECon. This error is basically coming. Did I not activate the environment? Okay, so this is one of the mistakes that I've actually done. See, this is the problem. And many people will also face this. So I'm not going to edit this part because we are facing some problem. The reason is very simple. I did not activate my VNV environment. So let me just go ahead and activate conda activate VNV environment. Once we activate this here, now we can go ahead and write out pip install -r requirement.txt. Now I don't think so it should give us any errors, and automatically the installation of this library should happen. Okay, and this is what we are going to do. The first step, so LangChain community, everything is getting installed. Whatever things are basically required. Okay, I just missed one more thing. I don't know whether with respect to LangChain underscore community, whether LangChain underscore core will also get installed. Okay, so that also we'll try to see. We'll try to, because this library is also required, LangChain underscore core, because they are some of the important libraries that we are going to use from this. Okay, so let's see how much time it will probably take. And in the environment variable, now there's some important information that I really need to put up. Okay, so environment variable, I will go ahead and use my LangChain API key. Okay, so I hope everybody knows how to create LangChain API key, which has been explained already in the previous module. So I will just go ahead and write my LangChain API key over here. Why I'm not using OpenAI API key? Because I'm trying to create a project wherein from the front end I'll directly try to give the OpenAI API key. Okay, so right now I just require LangChain API key. So this is now getting loaded and this is executed. Let me do one more thing. Let me again go ahead and install this requirement.txt because I had included one library, but I think because of the LangChain underscore community, automatically it made sure that this LangChain underscore core will also get installed. So this is the first basic steps that we really need to do for each and every project. Okay, one more thing I can probably go ahead and do is also make sure that add Streamlit over here, because I will be working with Streamlit. Okay, so Streamlit quickly, pip install -r requirement.txt, and then my Streamlit will also get installed. It will also take some amount of time because this is the framework that we are basically going to use. Okay, now in this video, what all things we basically did, we set up our environment variable, we created a new environment, we activated the new environment, and we installed all the libraries that is required in the requirement.txt. Now in the next video, once this installation takes place, we will go ahead and develop our first application. And here I'm just going to go ahead and write app.py. Okay, so perfect. Till here, I think everything looks good, and we are good to go with respect to this. So let's see you all in the next video, where I'll discuss more things as we go ahead. So yes, this was it from my side. Thank you. I'll see you in the next video. So guys, the requirement.txt has now been installed. Now in this video, we are going to develop our Streamlit web app, and then we will develop our entire application. So let me quickly close all these things and let me start. Okay, so here, first of all, what I'm actually going to do is that I'm going to import some of the libraries, like import Streamlit, okay, as st over here, and here you can also see my conda environment is there. Perfect. Import Streamlit as st. Along with that, we'll also go ahead and import OpenAI, and then from LangChain underscore OpenAI. See, since we are working with OpenAI in the first project, in the upcoming project we'll discuss it all on, right? So right now, if you really want to work with OpenAI along with LangChain integration, and I feel everybody should start working in LangChain, don't work independently with different libraries. Because LangChain is a framework which is created in such a way that it can interact with OpenAI APIs, it can interact with open source LLM models, it can interact with Hugging Face, right? All these things will specifically be included. So here I'm going to quickly go ahead and import chat OpenAI, okay? And then along with this, I will also go ahead and write LangChain underscore core dot output parser import str output parser. Okay. Then from langchain underscore core dot prompts, I'm going to import chat prompt template. Okay, so all these libraries will be the basic requirement that we really need to have. Then I will go ahead and import OS, and then from .env, I'm going to import load underscore .env. This is just to load all the environment variable. We'll go ahead and initialize this load underscore .env. Okay, just to check everything is working fine. What I will do, I'll just go ahead inside this particular project folder. I'll go ahead and write streamlit run app.py, and here I'll go ahead and execute it. Okay, so this works absolutely fine. Here you can actually see this, right? So everything is working fine. Nothing is getting displayed. I know that, but until here everything looks good. Okay, so I will just press Ctrl C. Perfect. Now, the next step, what we are really going to do is that we are going to implement our Langsmith tracking. Langsmith tracking. Okay. Now inside this Langsmith tracking, I will quickly go ahead and write os.environ, and I will just go ahead and call the environment variable that is nothing but langchain API key. So quickly, let's go ahead and write this langchain API key, and let me go ahead and write os.getEnv. Along with this, I will go ahead and call my langchain API key, okay, which is present in the environment variable. So for the Langsmith tracking, I need to set this one value. The other value that we really need to set is something called as langchain tracing. Okay, so this needs to be set to true. And finally, my project name, which is my langchain project name. So I'll try to go ahead and create this key, which says langchain underscore project is equal to simple Q&A chatbot with OpenAI. Okay, or I'll just go ahead and write Q&A chatbot with OpenAI. Perfect. So till here, everything looks good. We're good to go with respect to the implementation. Now, before we start, we have to go ahead and use Streamlit. Okay, sorry, since we're using Streamlit, first of all, we'll go ahead and define our prompt template. So let me quickly define our prompt template. Now, for defining the prompt template, we're just going to use prompt is equal to chat prompt template. And here I will just go ahead and write dot from underscore messages. Okay. And with respect to this, I will just go ahead and create two brackets. One is with the system, like what information I need to give to the system, some prompt message I need to give to the system, how the system should behave. System basically means all the LLM models that we're interacting with. And the second brackets that we are specifically going to use is something called as user. Now inside this user, I will go ahead and write my question. And here you will basically be having a question. So I'm saying, hey, see, just by seeing this, it is a simple Q&A chatbot. I have to probably give the question, and the system should be giving me the answer, right? So I'll say, hey, you are a helpful assistant. Okay, please respond to the user queries. That's it, right? We're good to go. Yes. Now, once we are able to do this, what exactly happens over here is that it's very simple. The system gets a message that, hey, you are a helpful assistant. Please respond. Let me make this spelling right. Response to the user queries. And the queries are basically coming from this particular placeholder, right? And this will be the format. So this is how you go ahead and write a prompt. I will write more complicated prompt as we go ahead when we work with RAG application. Now let me just go ahead and create a function which is called a generate response. Now inside this generate response, this function is basically whatever user query comes, right? We need to interact with the OpenAI model, LLM models, and it should give me the response from here, right? This is what this particular function basically does. So over here, you'll be able to see that. I will give my first parameter, which is called as over here. So let's say this is my first parameter that I really want to give over here. Is nothing but my question. What is the query that is actually coming? The second parameter that I'll give is my API key, because I need to pass my API key during the runtime so that it will get validated. Okay, I don't want to put my API key in my environment variable, and directly my application will be able to probably interact. Then we'll give my engines. Engine basically means let's go ahead and give my LLM model, which LLM model I really want to interact with. Then you have something called as temperature. Okay, and finally you have something called as max tokens, right? How many maximum number of tokens are there? What exactly is this temperature value? See, every LLM model we do set this temperature value between 0 to 1. 0 basically means the model is not going to be much more creative with respect to the answers. Let's say if I'm asking a question, if I ask that same question multiple times, it's just going to give me the same type of output. If I go ahead and keep the temperature value near to 1, it's just going to be much more creative, and it will give you some different types of values every time. Okay, so this is what the temperature value is for, right? Now in the second, as soon as I go inside this, I will first of all go ahead and use this OpenAI, and I'll set my API key. This API key will be nothing but whatever API key I'm passing over here that it will get to set to. Then we are going to use our LLM model. Now for this LLM model, we have already imported chat OpenAI, so we are just going to use this chat OpenAI, and here you'll be able to see that I will go ahead and use my model is equal to LLM, whatever models I'm actually going to give. Now what all models are there, we'll discuss more about it. We'll see the documentation page of the OpenAI itself, right? Then I'm just going to create my chain. The chain will be nothing but prompt or now, see, chain is something how the interaction is basically going to happen, right? Now, for this interaction, I definitely require, first of all, I need to have a prompt template. That prompt template will be combined with my LLM model. And one more thing that I did not mention over here is about our output, like how our output should look like. So I'll just go ahead and create my output parser, which is specifically coming from the, from the LLM. And here I will go ahead and initialize this. Then finally, I can go ahead and see my output parser. And this is what I am actually able to get. Then let me just go ahead and find the answer. So answer will be nothing but chain.invoke. We'll just go ahead and invoke it. And while we are invoking, we have to make sure that the key name should be same, right? So this will be nothing but question. But what will be over here with respect to the question that I'm asking, right? So this question is probably coming from this particular key. It is just going to get assigned as we do chain.invoke. Now chain.invoke is doing nothing. It is just first of all getting this prompt template, combining it with the LLM, and finally whatever response it is getting, it'll just go ahead and give this output parser. So finally I'll go ahead and return this answer over here. Perfect. So this is my function, which is interacting with my OpenAI LLM models. Okay. Now quickly I will go ahead and play with the Streamlit app. Okay. Now, in my next video, what I will show you is that I'll show you how you can probably go ahead and create your entire Streamlit app and how you can call this particular function. So yes, this was it from my side. I'll see you all in the next video. Thank you. Hello guys, so we are going to continue discussion with respect to this end-to-end project. So you could see that we had created this particular function called generate response in our previous video. Now what we are basically going to do is that we're going to create an entire web app using Streamlit, right? So first of all, I'll just go ahead and give you the title of the app. So the title of the app will be something like this, and you know how to use Streamlit for this, ht.title, and then Q&A chatbot with OpenAI. Now, as I said, I need to pass my OpenAI key during the runtime, right? So for that, what I will do, I will keep a sidebar, okay? In Streamlit, you have a sidebar where you can probably enter your OpenAI API key. So here I've written ht.sidebar.title, which will be settings, and here you can see API underscore key, which will be nothing but ht.sidebar underscore text underscore input. And I'm saying, hey, give your OpenAI API key, and the title will be password. That basically means no one will be able to see the password, right? And then I'll just press enter so that it will keep that particular value inside this particular variable. Okay. Now I will also going to create a drop down to select various OpenAI models. Okay. I'm actually going to create this. So for this, what I'll say, I'll write LLM is equal to nothing but st dot. Again, this will also be in the sidebar, the left-hand side. Okay, so I'll be using sidebar. And here inside the sidebar, I will go ahead and say, hey, let's go ahead and see the select box. I'll use a select box over here. And then I will go ahead and write select an OpenAI model. Okay, so we'll go ahead and do this. And inside this OpenAI model, we will give some of the models, like which model we need to select. So in order to get what values needs to be there in the model, I will just go ahead and open this. So here you can see I have just searched for OpenAI models itself, right? So if you go in the model page, you have so many different models. You have like GPT-4o, GPT-4 Turbo, GPT-5 3.5, right? So many different models are there. And as we go ahead, we'll also be seeing about DALL-E and all. So there is also like embeddings, which we have already seen. So what I will suggest is that right now these three are the best models, I guess, in GPT-4 and GPT, right? So GPT-4o, GPT-4 Turbo, GPT 3.5. So we'll be discussing about this. Okay. So right now, let me just go ahead and write this particular model. So it will be GPT-4o. Okay. This will be my first model. Then I'll go ahead and write GPT-4 Turbo, right? And then finally, I have this GPT-4. Okay, so this 3 is in the drop down that I'm actually getting, right? I'm getting in the drop down. I can select anything. So there are also two parameters that I'm passing in my generated response. One is temperature and one is match lookup. So we can also set up this particular values. And this time I'm just going to use a slider. Okay, in the sidebar I'm going to use a slider. Okay, and I'll say hey, the temperature value should be ranging between 0 to 1. So here you can see I created a variable called as temperature. I'm writing st.sidebar.slider. I've used temperature. The minimum value is 0.0, the maximum value is 1.0, and this particular value is nothing but 0.7. Right? 0.7 is nothing but a default value where the slider will be pointing to. Okay, then you have this match token. Similarly, I'm keeping the match token between 50 to 300, and the default will be 140. Okay, now quickly what I will do, I will just go ahead and define the main interface for user input. Okay, and here is what I'll write. So I'll say st dot right. Okay, go ahead and ask any question. Okay, so I'll say hey, let's define our user input. So user input is nothing but st dot text underscore input. Okay, and here we're just going to use this. I'll say you, whatever question you have, you can ask. Okay, so now whenever I give user input, so if I go ahead and write user input, so here we will go ahead and create a response is equal to generate response. Now inside this generate response, I'm going to call this particular function, and you know what all things I have. I have this question. Question is nothing but whatever user input is probably coming up. I'll have to give this. I have my API key, so I'll go ahead and call my API key because from this, the text input, whatever API key I'm actually giving, it will be written over here. So I have this particular variable. Along with that, I have my LLM model also. So which LLM model I'm actually selecting, I will go ahead and give my LLM model. And then other than this, you also have temperature and match token. So temperature and match token is already set over here. So let me just go ahead and write temperature, comma max underscore token. Okay. So here all the values are over here. So I will quickly go ahead and write st dot write response. Okay, so once I'm doing this, so that basically means the response will be written over here in the page itself, and you'll be able to see it. Okay, if user does not enter any input, so I'll say else elif or else there is no input, I can go ahead and write st dot write. Okay, please provide the user, please provide the query. Okay, something like this. So till here, I think everything has been implemented. It looks good itself. Okay, and we are good to go. I think let me just quickly revise. So first of all, we did the Langsman tracking over here. Then we developed our chat prompt template. Then we created a function which will be able to generate the response. And these are all my fields, user input values. Everything is over here. And then I'm probably calling this and writing the response. It's a quick, simple application. So finally, guys, let's go ahead and run this entire application. So quickly, we will do this. Just a second. I'll clear the screen. And here I'm going to just write Streamlit run main.py. So once I do this, this is my entire app that is running right now. Okay, perfect. Enter your OpenAI API key. I'll just go ahead and press enter. Perfect. Let's set some values over here. Let's say I'll go ahead and ask what is machine learning. Press enter. And here is what I will be able to get my response. Okay, so it'll take some time again based on the API itself. And here is my entire response. I'll also be able to see whether it is getting tracked in the Langsmith quickly. So I'll go ahead and add this, click on sign up, automatically it'll come up. So here is my project. So here you can see, yes, this is the recent one. And we have made this recent things, right? So here you can see chat prompt template, chat OpenAI, string output parser, what is machine learning, right? So this is a runnable sequence. You can see what is machine learning, and I've got this output, right? If you see the first thing in the chain is chat prompt template, and then this is my output message, then it is interact with the chat OpenAI. Here you can see the entire response, and finally you'll be able to see the string output parser. Yeah. So yes, everything looks fine, and everything is working over here. I hope you like this particular video. Now in the next video, we'll try to modify this entire application with respect to the Ollama models. Okay, so that's what I'm actually going to show you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to our LangChain series. Now in this video, we are going to create an end-to-end Q&A chatbot using open source models, and specifically we will be using Ollama. Now already in our previous video, I've seen this end-to-end chatbot with the help of OpenAI, and here the best thing was that we made it so loosely coupled that we could use any kind of models that we want and all, right? So similarly, what we are basically going to do is that we are going to go ahead and do it with the Ollama itself. Now in the case of Ollama, you definitely require different set of libraries. Again, I'll be talking about that, and instead of using chat OpenAI, now you will be having another library which is called as Ollama itself, right? So let us go ahead and let us start this. So first of all, I will go ahead and create my app.py. Now quickly I will go ahead and import from langchain underscore core dot prompts. I'm going to import chat prompt template. Okay, so let me quickly go ahead and write chat prompt template. Now after this, I'm going to go ahead and write from langchain underscore core dot outputs. Okay, output parser. We are just going to go ahead and import our string output parser. Right, this is also required over here. And then since we really want to go ahead and use Ollama, I'm just going to use this langchain underscore community dot llms import Ollama. Okay. Along with this, as you all know, since I will be specifically using, so it should be Ollama over here. As you all know, I'll be using Streamlit. So let me just go ahead and write import Streamlit as ST. And here, along with this, we'll also go ahead and import OS. Okay. Now quickly, what we are basically going to do is that again, I will just go ahead and open main.py. The initial setup that we really want, right? There's all specific information so that we'll be able to trace it in our Langsmith. Here I'll just say with OpenAI, instead of writing OpenAI, I will go ahead and write with Ollama. Okay. So these are the initial things that we will be specifically requiring. Okay. Now quickly, we are going to go ahead and create our prompt template. Now in order to create our prompt template, I have already imported chat prompt template. So let's go ahead and define our prompt template to create the similar way like how we have created this specific chatbot, right? So here I'm just going to go ahead and write prompt is equal to chat prompt template dot from underscore messages. And here we're going to use again two things, as I said. One is with respect to system and one is with respect to user. Okay, I'm writing, hey, you are a helpful assistant. Please respond to the user queries. Then you have this question, whatever question we are specifically given. Okay. Now, other than this, you'll be able to see that we have also defined the generate response, right? So let me copy this and let me paste it over here, and I'll show you what all changes will specifically happen. Instead of writing OpenAI, what exactly things we will be basically requiring. I don't require any API key because this is completely open source. Instead of writing chat OpenAI here, now I'm going to define my Ollama model, right? And with respect to this Ollama model, you will be able to just see like which all models I have, right? So in order to check it out, I'll just go ahead and import command prompt. Okay. Now with respect to this command prompt, I'll just say, hey, go ahead and write Ollama run, let's say Gamma 2. So this is one of the models that I have. I think it is also getting installed. Okay. So this is getting installed. It's okay. Till then, I'll just open my command prompt again. Okay. And I will see Ollama, let's say Gamma model. So Gamma model is also not there. Let's see what all models I specifically have, and then we'll try to run it. So for that, I will go to ollama.com. Okay. What all models Ollama actually provide, we also need to have a look onto that. And we will be seeing that what all models is basically provided by Ollama itself. So here, I'll just go ahead and click on models. Quickly go ahead and see the library. So many different libraries are there, like Gamma 2 and all. Gamma 2 is a recent open source library that has been brought by Google itself, right? So you can also go ahead and use that, right? Along with that, you have this Llama 3, you have this Qwen 2, DeepSeek Code 5.3, so many different models are there. Okay, if I probably go ahead and check with respect to the prompt 2, right? So this is over here. I'll just go ahead and hide this. Okay, what I'm actually going to do is that I'll just go ahead and write Ollama 5.3. I think this should be there. Oh, sorry, Ollama run 5.3. Okay, it should be, the command should be run 5.3. Again, this is also getting installed. Okay. So here, whichever libraries you really want to go ahead and probably use it with respect to Ollama, first of all, you need to download all these libraries, right? And that is the reason here you'll be able to see that as soon as I go ahead and write 5.3, it is getting downloaded. If I go ahead and write Gamma 2, it is getting downloaded. Okay, so this is the first important thing that you really need to see with respect to the libraries. Okay, so let me just reload it quickly. So here you have this. Let's say I want to go ahead and run anything like Ollama Gamma 2 is here, then Ollama run Lava is here, Ollama run Solar is there. Let me just go ahead and take some Mistral also. I don't know whether it is installed in my local or not, but I'll just go ahead and check it out. So yes, Mistral has been installed. So let me quickly, we'll go ahead and try to access this model and we'll try to see whether it is working fine or not. So if I go ahead and write hi, here you can see I'm getting all the messages over here. Perfect. This is great. So let's go ahead and use one of the models which is called as Ollama over here. And along with that, you also have Gamma 2 model. This is the recent model that has been there. The previous version of the model will get automatically removed. Like you also don't have Llama 2. Like right now, Llama 3 is also there, right? These all are open source models, which is super amazing. And you can also use this. Okay. Now, you know that I have this Mistral. So let me quickly, and I've been installing any libraries that you want to probably go ahead and install. Just go ahead and any LLM model you want to install in your local machine. You just need to go ahead and write the specific command. Okay. And always make sure that you keep on looking on this because this will keep on getting updated. Okay. So here, here I'm writing model is equal to whatever model name I'm specifically giving with respect to this engine. It can be Llama 2, Llama 3. It is up to you. Okay. Then we are creating this entire chain prompt output parser. We are invoking it based on the input text. Here we are going to get this. So this is only the change that we have actually done over here. And remember one more thing that guys that you really need to remember is that whenever we are using Ollama, we are specifically only using open source models. Okay. Now once this is done, it's time that we can go ahead and use the same functionalities, right? Whatever functionalities we specifically require over here. But as you all know, in Llama 3, in all the open source models, we don't have to even play with all the parameters out there, right? So what I can actually do is that I will just go ahead and copy this entire thing. Okay. I don't require the settings also, right? Anything as such. I'll copy this over here. I'll paste it over here. Okay. I'll say, hey, if user input is given, okay, just see, okay, what all things I will be doing. Here I just need to pass my user input and I need to pass my engine, right? Engine which model we are selecting. And over here also we'll remove this API key because I don't require any API key, right? So temperature is there, mesh token is there, everything is going on. With respect to the OpenAI model, let's say that right now I have Mistral, so I'll go ahead and write Mistral over here. Other models are basically getting downloaded, so I'll remove all these things. Later on, you can put any number of models that you want. Okay, this is the basic change. That is what is specifically done, right? Let's see whether this open source model supports this temperature or match tokens also or not. Okay, I'll be giving it over here, but I don't know whether it will be there or not. Okay, so this else if condition can be removed because I don't require it. That's it. See how simple it was, just replicating with respect to OpenAI with Ollama itself, right? So let's quickly go ahead and run this. So here I will just go ahead and write Streamlit run app.py. Okay. So here you can see. Let me just go ahead and change this particular message. Okay, I had to run app.py. Let's see. So I'll say cd dot dot. I have to go to my third folder, Ollama chatbot. Now I'll go ahead and write Streamlit run app.py. So this is got executed now. Perfect. Mistral is there. Let me just go ahead and select hi. I think there's an inputs also to be taking temperature and all. How can you assist today? See, so fast it is. And then I'll say hello. Please talk about generative AI. Right. Once I execute it, you'll be able to see that it will also give you the response. And similarly, if you go towards the Langsmith, okay, so let me just see, here is my output. And now if I go to my Langsmith, okay, so if I go to just my Langsmith, let's say over here, I'm going to do the sign up, or you can, once you do the sign in, I think every time will show you the sign up, but at the end of the day, you'll be also able to go inside this, okay. Now here you'll be able to see that this entire platform will get loaded, okay. So whatever conversation this time you're having it with respect to your open source LLM models, which is available in your local machine, right? So if I just go ahead and click on projects, so here you can see simple Q&A chatbot with Ollama, 2.64 seconds, hi, you'll be basically getting this input, what was the token size, first token, this much time it took, how many number of tokens, cost is 0, you can go ahead and just keep on exploring this, right? But altogether, we specifically design a chat prompt template, then we use LLM model, and finally we try to display the string output parser over here, right? So everything is probably visible with respect to this, right? So yeah, I guess you are able to understand this, see, the entire output is also basically getting displayed, which is good enough, right? Now, let's see like how much time it is probably taking this chat prompt template. Now see, once Gamma 2 and all will get added, what I will do is that I will also give an option over here so that you include Gamma 2 or 5.3, any number of models over here. You can select that models and you can start writing your code or start using these LLM models for any kind of response. Okay. So I hope you're able to understand this, how to create an end-to-end Q&A project with the help of Ollama. So yes, this was it from my side. I will see you on the next video. Thank you. Hello guys, now we are going to continue our new end-to-end project, Gen AI project, and here we are going to specifically use Grok AI inferencing engine. Okay, now what exactly is Grok? So it is an amazing platform which actually provides you open source models, or LLM models like Gamma, Llama 3, Mistral, and you can use all these specific models to probably create an end-to-end generative AI application. Now, first of all, you need to understand why Grok. So if I go ahead and click on this particular link and go over here, you need to understand that Grok is a fast AI inferencing engine. It uses something called as language processing unit, right? See guys, in this entire world, right, specifically in the development of generative AI field, you'll be seeing many companies who are coming up with amazing LLM models, let it be paid or open source. But that company is going to win, which will be able to provide an amazing inferencing in a small, let's say in some seconds in some milliseconds I should be able to get the response. And right now the research that is specifically happening with respect to the LPU inferencing engine actually makes it possible. Okay, so an LPU inferencing engine with LPU standing for language processing unit is a hardware and software platform that delivers exceptional compute speed, quality, and energy and efficiency. Let me just zoom in so that you'll be able to see it much more in a better way. This new type of end-to-end processing unit system provides the fastest inference for computational intensive application, such as AI applications like large language model. Okay, and over here it is also given why it is so much faster than GPUs, right? So LPU is designed to overcome the two bottlenecks. One is compute density and memory bandwidth. So you can read more about Grok over here. Okay, and I feel that yes, this is the company that can actually provide an amazing inferencing because I've been using this. Okay, so in this video I will talk about how you can go ahead and create your API in Grok Cloud and how you can use all these LLM models and start creating a project. So first of all, I will just go to the Grok Cloud. And the first thing that I'm actually going to do is that go ahead and create your API key. So here you also have a playground where you can probably play with all this Llama 3 models and all. So if I go ahead and just say hi, I should be able to get the response very much quickly. And we'll also be measuring the time, like how quick it is. So first thing first, we will go ahead and create our API key. Just click on the API key over here. I've created multiple times, but let's say any of the API key that I want to use, I can go ahead and use it, right? So in order to create it, just click on create API key. I will say this is for my project over here. I'll just go ahead and click on project and click on submit. So please make sure that you copy this API key. It starts with GSK underscore. So I'll copy this, go to my project over here, okay? And here you can see I've created my fourth folder, which is my fourth project right now, RAG document Q&A. I'll go to my .env file and make sure that I have this key pasted somewhere. Okay. Now, if I'm using this particular key, what should be my environment variable? That also we need to know, right? So I'll just go ahead and write Grok underscore API underscore key, right? So this is my environment variable over here. And now it's time that we will go ahead and start writing our code. Okay. Now, understand one thing is that we will be using this specific key to access all the LLM models that is available over there as an open source. Okay. So let's go ahead and let's start our coding. Okay. Now, before I go ahead, we need to also make sure that we need to install some of the libraries that is required in requirement.txt. And if I really want to work with both LangChain and Grok, so like how we have this LangChain underscore Hugging Face, LangChain dash OpenAI. Similarly, I'll also be using one more library which is called as LangChain Grok. Okay. So once I do this, I will go ahead and save this. And now I'll go back to my app.py. First of all, let's go ahead and install this entirely. So I'll go ahead and write cd dot. I'll go back to my parent folder and go ahead and write pip install -r requirement.txt. Okay. So now the installation will entirely happen over here. So here you can see this particular library of Grok will also get installed, right? So we're perfect to go ahead and we are getting started with Grok. Okay. Now, quickly, let's go ahead and import all the important libraries and then we are good to go. Okay. Now, these are some of the libraries that I'm actually going to use. So first of all, I'm going to use Streamlit. Okay. Then I'm going to use chat Grok. So this is what I'm actually want. So I'll go ahead and say from LangChain, so Grok import chat Grok. And then I'll be using OpenAI embedding. See, it is not compulsory that you need to use OpenAI embedding because I know that this will be paid with respect to an APIs. So what you can actually do, like how we did it in Ollama, right? You can actually use this Ollama embedding. So if you remember with respect to Ollama, when we were discussing over here, somewhat the other way, or if you go back to your code over here in the, let me just have a look over here in the embedding techniques, I can just go ahead and use this Ollama embedding, right? You can also go ahead and use this. I'll copy this entirely and, try to save some bucks of yours and try to paste it over here. So I will go ahead and use this Ollama embedding, okay, for my application. Now, the next thing is that from LangChain.TextSplitter, I'm importing text recursive character text splitter. Then from LangChain.change.combine documents, we are going to import create stuff document chain. Now, this is where it is very much important, and this is specifically used in RAG application. We'll be discussing more about it, why we'll be using it. Along with this, I will go ahead and write from LangChain underscore core.prompts. I'm going to import chat prompt template because we need to define our chat prompt template. And then finally, we'll also be using from LangChain.chains. We'll be using this create retrieval chain. Now, this too. Libraries that we have imported. This is really important for any RAG document Q&A applications or any Q&A application in short. Like let's say if there's an external data source and we really need to want to interact with it, right? So we will definitely be using this. Along with this, we're also going to use FAISS vector store, and then we'll also be using this document loader, which is called as PyPDF directory loader. So yes, this was the basic import that we have done. Now we're going to probably create an end-to-end application, and we'll continue in the next video so that we'll go ahead and do the further discussion, like what all things, how to import these libraries and all, and how to load the environment variable of Grok API. So yes, this was it. I'll see you in the next video. Thank you. So guys, now let's continue the discussion with respect to this particular project. Now what we are going to implement over here. So here you'll be able to see that I have a research paper folder, okay? And inside this folder, I have this two amazing research paper, that is attention is all you need, and overview of large language models. So I've kept both this PDF inside this folder, and we will consider this as an external data source, and we will try to ask any question, and probably we should be able to get the response from this particular research paper through this document Q&A, okay? So how we will be executing this again over here, we're going to be specifically use this chat Grok, okay? And along with this, you'll also be seeing that we will go ahead and implement open source LLM model instead of just using OpenAI, okay? So that you will also, everybody will be able to execute this, okay? So quickly, let's go ahead and do this now. First thing first, I will go ahead and write from.env import load underscore .env, okay? And then we will now just go ahead and execute this load underscore .env. Now this is specifically used to load all the environment variables, right? Now I'm going to load the Grok API. And this will be very much important. And for some number of hits, Grok completely provides you free API itself. So anybody can probably go ahead and create your account. Okay. You have to go ahead and create your account, and based on that, you can actually go ahead and create your keys. Now here I will go ahead and write os.environ, os.environ, and here I'm going to use my Grok API key. So I'll go ahead and copy this. I'll go ahead and paste it over here. Okay. Along with this, what I will specifically do is that I will just go ahead and write is equal to os.getEnv. Okay. Once I do this, I will quickly go ahead and write my Grok API key itself. Okay. So once I get this Grok API key, then I will be able to interact with any model that I want. Okay. Now, Once we are setting this up, I can also make sure that I can get the direct key from here. Okay. So let's go to the next step. And here, let me just go ahead and write. This is my grok API underscore key, which is nothing but if I just go ahead and write os.getEnv, it is just going to get it from the environment variable. Okay. So this way also you can actually get your API key. Now is the most important step is creating your LLM model. For this, we will be using this chat grok. And here we have to first of all provide our grok API key, which will be equal to nothing but it will be equal to this grok API key. Right. So this is the first parameter that is required over here. And the second parameter is nothing but my model name. So in order to provide the model name, I will go back to my website of grok. And here you'll be able to see if I go to the first homepage. Here are different models that you can specifically use. Right. So you can provide this Llama 3 8 billion 8192. You can provide Llama 3 7 billion 8192, Gemma 7b IT. So let's go ahead and select this. I will go ahead and write like this on itself. Gemma -7b -IT. Okay. So I will just go ahead and write in the same way. So here you have this Gemma 7b IT. Okay. So we are basically going to use this LLM model like this. You can also go ahead and specify your Llama 3 model if you want. So let's say I'm going to use Llama 3 model. I can go ahead and specify like this. So let's continue with Llama 3 so that it's okay. You can use any of the open source models. It is up to you. Now I'll go ahead and define my chat prompt template. Okay. Now inside this chat prompt template, I'm just going to use dot from underscore template. Now is the most important thing. Like see, the previous way is how we used to create chat prompt template. Now this will be a little bit different because here we need to provide some context information also. So here I'm just going to say, hey, I'll go ahead and write it over here. I'll say, hey, answer the questions based on the provided context only. Okay. And then I'll say next sentence, please provide the most accurate response based on the question, right? And here I will just go ahead and define my context. This will basically be my context. Here I will give a placeholder. Now why I'm just using this keyword, we will try to understand, okay? Because this is important. The libraries that we have used, this create stuff document chain and create retrieval chain. This has a separate meaning for this kind of context message that is seen in the prompt template. Okay, we'll discuss more about it. And then here I will just go ahead and write my question. This question will basically have my input. Okay. Now here is my prompt. So here in this prompt, it is just like a document Q&A. In case of document Q&A, I need to provide a context over here. What this context will be replaced with, I will just discuss about it once we proceed. Okay. So this is my prompt, a simple prompt that I've actually written. Now the first thing, as you know, I have to create my vectors, right? Create my vectors, and this time I'll be creating my vectors. I'll say vector embeddings. Okay. Now, inside this function, my main aim will be that I should be able to read all the documents from here. After reading documents, I should be able to read the content inside this. I mean, read this research paper, read the content inside this. And after reading it, make sure apply the cursive character text splitter. Along with that, split all these particular documents. And just by using fires, we can proceed further. And we can go ahead and probably store them in some kind of vector database. Okay. So here, what I will do, I will quickly go ahead and use define this function, which is called as create vector embedding. But here, since my vector store will be used in some other code also, what I will do is that I will try to use session state over here. Session states actually helps you to remember your vector store DB. Specifically, this is for vector store DB. That is the reason I'm trying to create some session state. The session state variables will be able to access in other functions also whenever it is required. Okay. This is just to make sure that your entire application has some kind of memory with respect to this particular chatbot. Okay. So here I will say if my vectors not in st.session state. I'm just going to try to create a vectors variable, which will be my session state variable. So I'll write st.session underscore state. Okay. Then I will just go ahead and write it over here. And I'll just go ahead and say st.session underscore state. First of all, I will go ahead and create my embeddings. Now, in this case, my embeddings that I'm actually going to use is nothing but Ollama embeddings. Okay. Now, whatever embedding I'm basically using, I will also keep this in the session state variable, right? Specifically in this particular session state. Then we will quickly go ahead and write st.session state, another session state we will go ahead and create. And inside this, I will go ahead and write a loader, right? This loader will be my data ingestion step, right? Now, in this case, I'm going to use this pipe PDF directory loader, okay? Pipe PDF directory loader. And inside this, I'm going to give my folder name. What is the folder name that you have? It is nothing but research underscore paper, right? So this is the folder name that we will be giving over here, okay? So let's go ahead and give this. So here you can see, this is my research papers I should write, okay? Now, this is nothing but, this is my data ingestion step, perfect? We are loading some information. This can also come from Streamlit directly. It's up to you, right? How you basically want to go ahead and upload this. Now, after this, I will just go ahead and say st.session underscore state dot documents. And from this loader, I'm going to load all the documents. So for that, again, I have to call this st.session state dot loader dot load. I will load all the documents over here. And this will basically be my complete document loading. I'll just write this comment so that you'll be able to understand it, okay? Then what we are going to do is that I'll go ahead and write st.session underscore state dot text splitter. I have to use some kind of text splitter over here. And this text splitter will be nothing but it will be assigned to a recursive character text splitter, which we have already discussed. Inside this, there'll be a chunk size of 1000, let's say. And then I'm going to use a chunk overlap of 200, okay? I'm just going to use this chunk with respect to this, okay? Perfect. So this is my recursive character text splitter, which I'm actually doing it. And then finally, it is st.session underscore state dot final underscore documents. This will be my final documents because I have to apply this text splitting technique. Again, I will go ahead and save everything in the session. That is what I'm actually doing, so that my entire application has some kind of memory whenever it has to refer to. Okay. Now I will be using this session state dot text splitter, and I will use this text splitter dot split documents, which is called as split documents. This way, we are actually splitting all our documents, right? So for this, I will again, where my documents is basically present, it is present over here. Okay. Just to make sure that this will not take much time, I will just take this documents and I'll say, hey, starting 50 documents, just go ahead and do it, right? You can also do the remaining one so that it will not take much time for doing this entire process. Okay. That is the reason I'm just giving top 50. Now I'll go ahead and write st.session underscore state dot vectors. And here we are going to basically use fires. See, this last step is all about converting your final documents. First of all, converting that into vectors. And after you convert everything into vectors, all the text or documents into vectors, then you try to store it in some kind of vector database. Okay. And this vectors that you are seeing, st.session.vectors, sessions underscore state dot vectors, this is your vector database. So I will go ahead and write fires dot from underscore documents. And here you have st.session state dot final underscore documents. This final underscore documents. And here I'm also going to, the second parameter we need to give is our embedding technique, right? So if I go ahead and write st.session underscore state dot embedding, whatever embedding techniques I have actually used, right? that's it. So finally, after executing all these things, you'll be seeing that you're converting this into vectors. You don't even have to return these vectors because already we are saving this in the session state. Perfect. Now, quickly, let's go ahead and do this. I'll go ahead and create my prompt, and here I'll write st.text underscore input. Okay, and here we are going to basically use enter your query. Okay, from the documents or from the research paper, I'll say. Okay, and then finally, I will go ahead and do this. I'll go ahead and just write if st.button. Okay, and I'll say, hey, document embedding. I'll just create a button, okay, over there. And this button will be responsible in running this particular function and creating our vector store. Okay, so as soon as we run this is basically going to read all the research papers. It is going to probably convert that into documents, and then it is finally going to convert into vectors. Okay, so here what I will do is that I'll just go ahead and call this, and I'll say, hey, go ahead and call this create vector embedding. And after doing that, if once it is successful, I'll go ahead and say st.write your vector database is ready. Okay, so that you will be able to query from it. Okay. Now it's time to check the power of Grok API. Okay, so once your vector database is ready, the next step will be that we will go ahead and check our, specifically we'll check that how powerful is the Grok API. So that is the reason I'm importing time. So here I will just go ahead and rename this to user underscore prompt. Okay, so finally, if I give this user underscore prompt, if user is giving any prompt, okay, now is the most important step. What should basically happen? You know that my vectors, this st.session_state.vectors has my vector DB, vector store DB, right? Now, as soon as my user prompt, basically user is writing some input and pressing some enter, right? It should first of all create this stuff document chain. And now let's discuss about this stuff document chain, what it is. Here we are going to give two important parameters. One is LLM model, and the second one is nothing but our prompt. Okay, so this should be the prompt. Now let me just go ahead and define this variable document underscore chain. Now see what this exactly does. Create stuff underscore document chain. It creates a chain for passing a list of documents to the model. Okay, what it is basically doing, it creates a chain for passing a list of documents to the model. And here the two important parameters are LLM and prompt. As soon as I give this, here you'll be able to see that in the prompt you have this variable called as context, right? Inside this context, all that list of documents will specifically go, and whatever specific input you're giving, it'll go over here, right? How it will go, I'll just combine it further with one more important retrieval chain which we'll discuss about, okay? But in short, this is providing a list of documents, and specifically in this particular context, like it'll get appended over here, and this entire chat prompt template will be created from here itself, okay? Now further, we will not keep quiet with this document chain. Here what I will do is that I will go ahead and write st.session_state, okay? Dot vectors, okay? You know this, it is a vectors is basically there. I will go ahead and write this as retriever. Now you know that we need to convert, if I want to retrieve any information from my vector DB, I need to first of all convert that into a retriever, right? So if I go ahead and write as retriever, let me just check the spelling, I hope it is fine. Okay, so just a second, as underscore retriever. Okay, so I'm just going to convert this into retriever and finally save this particular value in the form of a retrieval variable. And what this retriever acts as? It acts as an interface to query your vector database in short, right? So this is my vectors over here. I've used this st.embedding techniques that I've used over here. This is perfect. Now, once I get this as a retriever, what we do is that obviously this retriever is like querying a specific vector DB. This document chain has a context of list of entire documents. So once we combine both of them, in short, we are going to create a retrieval chain. That is create retrieval chain. And here two parameters are basically given. One is retriever and the second one is document chain. Okay. Once we do this, we will be able to invoke this entire thing, right? So here I'll go ahead and write retrieval underscore chain, right? So this actually is my chain, which has document chain, which has retriever combined together. Okay. Now let's go ahead and see the power of this Grok API. You'll just understand. So first of all, I will just go ahead and write a start timer over here. I'll say time dot process underscore time. And once we process this, you'll be able to see my response over here. And I'll go ahead and write my retrieval chain, okay, dot invoke, okay. And you know what kind of input I'm actually giving? It is nothing but input over here, right? This is the same input that we're giving over here, right? The same variable, the same input we are giving over here. And here we're going to just replace this with user prompt. Now we will be able to get the answer after this, but before that we will go ahead and calculate our response time, okay. So let's go ahead and print. I'll say, hey, I'll use f string. I'll say response time is nothing but it is equal to I will go ahead and write over here time dot process underscore time minus start time. Okay? Once I do this, I will be able to get my the time how much time it has basically taken for this retrieval chain to get executed. And then finally we go ahead and write our response. So I'll go ahead and write st.write. Let's say response of answer. Okay, done. Finally, we'll go ahead and write with see. You also need to know that what kind of response, what kind of other context we usually get, right? So for that also you can actually go ahead and display it. So I'll go ahead and write Streamlit with a Streamlit expander, and here I'm just going to write with st.expander document similarity search. Okay, so I'll go ahead and write for I comma doc in enumerate. Okay, and we basically take, see, along with this response of answer, there'll be another one variable which is called as response of context. That will actually give you all the relevant context information from that particular document. Okay, I'll go ahead and write this also. So I'll go ahead and write st.write doc dot page underscore content. Okay, now quickly let me just go ahead and make sure that I write all the other information. I'm just displaying what all other context is basically coming over here. I'll just give this. So one final change that I really wanted to do, okay, so after writing this code, see, we are using Ollama embeddings. It is of no worries, you can definitely use it. But sometimes, since this Ollama is running in our local machine, it may definitely take a lot of time to probably, convert that into, embeddings, specifically convert all the text into vectors. So that is the reason what I will do is that over here, instead of using Ollama embedding, I will just go ahead and use OpenAI embedding, because OpenAI embedding will be in the form of APIs. The reason why I'm doing this is that because, say, if I don't do this, automatically it is going to take a lot of time just to probably convert all our text into vectors. Along with this, we will go ahead and load our OpenAI API key. Okay, so please make sure that you do this. You can go ahead and try with Ollama embedding also, but as soon as you will probably run it, you will be seeing that it will take a lot of time, and I've already done that, so that is the reason I'm saying you. But I think with the help of OpenAI embedding, it should happen very much quickly, right? So let's go ahead and execute now. So I will just go ahead and clear my screen and say, hey, Streamlit run app.py. Okay, so now my entire website is over here. I will click on document embedding. Let's wait for some time. Now, as soon as I click on document embedding, see what is happening inside the hood, right? You should really understand this. So here, this function has got created. Now, this session state variable will get created. We are going to create embeddings, then it will become loaded, it will read all the research papers inside this. Then you have these documents, then you have this text splitter. Similarly, finally, you'll be able to create your vector database, right? And all these things are there. Perfect. It looks good enough. Let's see whether it has got executed or not. So yes, here you can see the vector database is ready. But if you try to just use Ollama embedding is going to take forever because that entire embedding is going to just happen in the local machine. So let me just go ahead and ask what is transformers. I'll ask a question. What is the transformers? And I'll go ahead and press enter. So here you can see based on the provided context transform is a model architecture that relies entirely on attention mechanism to draw global dependency between input and output, right? And here is your document similarity search, right? So from all this context, it was able to retrieve from the research paper, which is amazing, right? This looks quite good, right? Let's say what I'll go ahead and write, what is a large language model, okay? I'll go ahead and press enter. Based on the context, so much information is there, and here you can also see your entire context information is also visible, right? Very much nice. So you're able to see this entire information. See, if you want to get more larger context information, more larger information with respect to this research paper, what you can do is that you can go to the code and you can change these things, the chunk size. You can keep the chunk size to 10,000 and you can probably keep the overlap to 500 and keep on doing this, right? But here, in short, we have actually got this. Again, I'll tell you why I've used OpenAI document embedding. The open source LLM model is specifically used, but other than that, I think everything looks fine. Okay. Let me just go ahead and write. What is attention is all you need. Okay. If I want to ask this question, I'll just go ahead and press enter, and this is your entire information, right? And all the related context information is over here. See? Everything is visible. This is good enough over here. I think you are able to understand this specific project. This was it from my side. I'll see you all in the next video. Thank you. Hello guys, in this video and in the upcoming series of video, we are going to develop this amazing end-to-end Gen AI project that is nothing but conversational Q&A chatbot, where we are specifically going to chat with a PDF. Here we are also going to use our conversation history, right? So there will be a lot many things that we really need to discuss over here. It is a complete end-to-end project, and already in our previous module we have discussed about conversational Q&A chatbot. Okay, so first of all, what I will do is that in this video I will show you the demo. So let me just go ahead and click and press my Grok API key. Once I enter my Grok API key, there will be a default session that will be created. Okay, and this is just for me as a user, right? If I probably go ahead and implement this in any web application, I will make sure to track the session ID, and based on people using it, that session ID will be different. Okay, now let me just go ahead and drag and drop one of the files. So here I have my attention.pdf. Now once I do this entire PDF text will get converted into vectors and it will get stored in the vector store database. Okay. Now here I will just go ahead and ask one question. Okay, tell me about transformers, something like that. Okay, I'll just search transformer. Let's see whether I'll be able to get the response or not. So here you can see that I'm getting the response. The transformer generalizes well to English. Consistency parsing achieves F1 score of 91.3, which is trained on a set, and this is semi-supervised. Right. So this is some of the information that I'm able to get from the PDF. Then I will say attention is all you need. If I go ahead and search for this, okay. Let's see what kind of information I'll be able to get from here. Right. So here it says the attention mechanism is used in transformer architecture to weigh the importance of different input elements when computing the output. Okay. Then I'll just go and ask which topic were we discussing about. Okay, I'll just go ahead and search like this. Okay, so here when we search this, which topic were we discussing about? Here you'll be able to see we were discussing about a transformer model and its architecture. Okay, so this is the information, and this is able to get it from the previous context. Okay, tell me about a detailed summary of attention is all you need. Okay, I'll ask this particular question. Let's see whether I'll be able to get the answer or not. So once I press enter, and here I'm able to get something. Okay, it says tell me. Okay, I don't know. Okay, fine. I think in the research paper I just have put 2 pages, so that is the reason it is not able to find out. Okay, tell me more about transformer and its architecture. Okay, I'll just go ahead and ask this question. Let's see whether it should be able to retrieve the information and give me some kind of response. So here is my detailed. The transformer is a type of neural network architecture designed by so and so, right? Self-attention mechanism and all that. So I'll go ahead and ask what is self-attention mechanism now. So now let me see what is self-attention mechanism. Okay, I'll go ahead and search for it. So here I should be able to get some kind of response, and it's very fast. Okay, it says I don't know. Let me just go ahead and enter once again. I should be very much precise while I'm writing the output. So here you can see the self-attention mechanism, because there I did not write this particular word properly. Okay, a self-attention mechanism is a key component of transformer architecture and is used to store and so all the information. And here you can see the entire chat history is also basically getting considered, right? Now if I go ahead and ask like what is the previous message I asked, previous topic that I asked, I should be able to get the answer. So this is my history, and this all history you'll also be able to see it. Okay, you asked about transformer, then followed up with a question about the self-attention mechanism and transformer architecture. This is amazing, right? Provide me a detailed summary of the conversation we had. I'm just going to ask this. Okay, isn't it amazing use case? Think about it. Okay. So here I'm just saying provide me a detailed summary of the conversation we had it, and here you can initially ask about transformer model architecture. See, based on the chat history, everything is available over here. I provided a brief summary of the transformer model and its architecture, highlighting its use of self-attention mechanism and parallelization to process the input sequence. You asked me to provide more information about this, all these things has been visible, right? And this is my chat history, and this is based on my session ID, the default session ID, what all conversation we had. So yes, this was it. Now in the next video, we'll go ahead and implement this entire end-to-end solution, and I hope please make sure that you follow this, because already I've discussed about conversation Q&A chatbot in the previous video. So yes, this was it from my side. I'll see you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to our end-to-end project, Gen AI project, which is nothing but RAG Q&A conversation with PDF, including chat history. Okay, now we will be implementing this completely step by step. First of all, let's go ahead and start importing all of the libraries. Already we have discussed about this chat history, how to include that inside the chain in our previous module, and that module was nothing but it was something related to conversational Q&A chatbot. So a detailed video in the previous module has been already uploaded. Now this will be completely an end-to-end project. So first of all, we'll go ahead and import Streamlit as HT. Now this Streamlit that we are specifically going to use. Other than that, I will be also importing some of the important libraries. So first of all, let me just go ahead and import 2 important libraries. One is called as create history aware retriever and create retriever chain. Okay, so first of all, this will basically be used to create a retriever chain, and if I want to add history along with the history prompt, I'll be using this create history aware retriever, right? This is just like a retriever. This function will be just used to create a retriever with chat history functionalities. Along with that, I will be using this create stuff document chain so that we can combine the entire document and send it to the context. Then we are importing our vector store DB, that is Chroma. You can also go with Files. It is up to you. Then let's go ahead and import our chat history, chat message history. So that will be available inside your langchain_community.chat_message_history. Already, all these libraries has already been installed in this requirement.txt. So please make sure that you have this requirement.txt, and this is how the entire folder structure needs to be created. Like, right, I have all the projects over here. This is my requirement.txt with respect to all the files, right? So please make sure that so you don't have to even worry about any installation at large. Okay. Then you have this entire base chat message history over here. So I will also go ahead and import this. Okay. Then coming to the langchain underscore core dot prompts, that is chat prompt template and message placeholder. That also we will be using it. Okay. This message placeholder is to define the session key and what kind of session key I'm actually storing all the conversation in. Okay. And this is my base chat message history, which we have already discussed. Then we will also be importing a couple of libraries, which is called as ChatGrok. So let's go ahead and import this something called as ChatGrok over here. So ChatGrok will be specifically used with respect to the OpenAI API key that I'm actually going to use. Sorry, not OpenAI, Grok API key that I'm actually going to use. And here I'm actually using the model that is nothing but Google Gamma 2. Okay. Along with this, I will also go ahead and import Hugging Face embeddings. So here is my Hugging Face embeddings, so that I'll be able to import all my embeddings itself. In order to import it quickly, I will go ahead and import two libraries. I'll use import OS. Okay. And I will say from .env import load underscore .env. Okay. And I will go ahead and initialize this load underscore .env. And let me quickly go ahead and initialize this HF underscore token, which is present in my environment variable, right? HF underscore token. And this I've already shown you how to probably load it. Then I will go ahead and create my embeddings over here. So this is my embeddings that I'm actually going to use. Hugging Face embedding, and the model name is this one, right? All mini LM L6v2. Okay. So this is my model that we are specifically going to use. Perfect. Till here, everything looks good enough. And now let us go ahead and see some more libraries that we'll be requiring. Okay. So I will be importing some two important libraries that I'm actually going to use over here. One is recursive character text splitter and PyPDF loader, right? This is basically to load the PDF itself. Okay. So I think almost all the libraries has been taken place and has been imported. One final library that I want to import is with respect to the runnable history. Okay? So here we are going to use this runnable with message history. The reason why we are using this is that we will be able to create a conversational Q&A chatbot with the help of the chat history that we have, right? So here what we'll be doing is that we will be using this to create our retriever. When we are creating our retriever, we'll be making sure that when we create that specific agent to run the retriever, we'll also be using this library to probably include the chat history. I'll be talking about more of this when we go ahead. Okay. Now quickly, let's go ahead and do this. And here I've already imported all the libraries. So first of all, we'll go ahead and set up our Streamlit app. Okay. I will write st.title, and here I'm going to basically say conversational rag with PDF uploads and chat history. Okay. And chat history. So everything is basically going to get included over here. Then I will go ahead and write st.write. And here, let's go ahead and include this. I will say upload PDFs. Okay. And chat with the content. Okay. Chat with the content. Perfect. Now let me go ahead and input the Grok API key. Okay. And here I'm just going to go ahead and create my API key, which I will be writing st.text underscore input. And enter your Grok API key. And here specifically, I am going to do one thing. I will just go ahead and write my type as password. Okay, type as password. This will basically be my API key over here. Let's see, this looks fine or not. Okay, I forgot to give comma. Okay, so this is for my API key. And as usual, I will go ahead and check if Grok API key is provided. Okay, so I'll write, hey, if API underscore key is equal to double colon. I will just go ahead and if the API key is basically given, I will just go ahead and initialize my LLM model, right? So here I will go ahead and say chat Grok. The Grok API key that I really want to give over here will be initialized to my API key. Okay. The second parameter that I want to give is model underscore name. Now, with respect to this particular model, I will be using our Gamma 2 model for the same purpose. So let's go ahead and go to my Grok Cloud. Okay. Grok Cloud. Or I'll just go ahead and click on this. Okay. I can use any of this model. It is up to you. So I will use Gamma 2 90 IT. Okay. So Gamma 2 90 IT. Okay. I'll use this specific model. Perfect. This will basically be my model name. So till here, everything looks absolutely fine and absolutely good itself. I think we should proceed in developing this particular entire application. So here, as soon as I make sure that I initialize my LLM model, I also need to probably create my session ID. So I'll go ahead and write session ID is equal to st.text underscore input. And here, I'm going to basically give my session ID. Okay. And here, I'm going to basically go ahead and write my value is equal to some session. Okay. You can put anything as you want, but I will just keep it to default. Okay. Default underscore session. Okay. So this will basically be my session ID. Okay. Now, this is for my chat interface, right? So this is my chat interface, what we are specifically using. Okay. And the next, what we are basically going to do is that I'm also going to statefully manage the chat history. I have to manage it with the help of session states. Okay. Now here I will say if I'll create a variable called as store. Okay. Store not in session state, not in session. You'll be understanding where we will specifically be using the store. If you remember in the get session history in conversational Q&A when we discussed about, right? So if I go ahead and write not in st.session underscore state, I'm just going to go ahead and write st.session underscore state dot store. We'll go ahead and initialize to this empty dictionary. And inside this only we'll be having all the key value pairs, right? Like of the messages of the AI message content, human message content, all those things. Now I'll go ahead and create my uploaded files. So this will be upload button, right? I'll say hey st.file uploader. Okay. And I'll say hey choose a PDF file. Okay. A PDF file. Okay. And here I'll say hey type is equal to PDF. Okay. And I will also say accept multiple files. I'll keep it to false because I just want to try with a single PDF. But if you want to try with multiple PDF, just go ahead and give this as true. Okay. Perfect. So everything looks good till here. So I'll go ahead and process my uploaded files. Okay. So here what I will do is that I will go ahead and write if uploaded underscore files, if the file is basically uploaded, I will go ahead and create a document. Okay. This will basically be my document because in PDF I may have multiple files, right? I may have multiple pages. So here I'm basically going to write documents and I'll say hey for uploaded files. So uploaded underscore files file in uploaded files. So let's say even though I make this as true, let's make this as true. I have an option to probably select multiple files also. Okay. It is up to you whether you want to go with single or multiple. But I will write a generic code where I say that hey, for each and every file that is basically uploaded, we'll take that file. And first of all, we'll store that file in our local folder because see, when we upload it, right, there is no specific URL. Everything will be in the form of memory. So it is necessary that we create some temporary PDF file in our local, right? So here I will go ahead and say temp instead of writing temp PDF, okay, I'll go and write temp PDF, and this is the F string that I'll be using, and I'll create this with the name of temp.pdf. Okay. Now what I'll do, we will open this PDF. I'll say with open temp PDF, comma, I'll say in write byte mode. Okay. I'll open this PDF and I'll write as file. So once I open this, I will go ahead and write file.write, and here I'm just going to go ahead and create my uploaded file dot get value. Okay, so finally, if you go ahead and see file underscore name is equal to uploaded file dot name. Okay, whatever name will be there, I will also give that particular file name if I want. Okay, all the information from that. So in short, what I'm doing is that I'm opening that file that I've uploaded. I'm reading all the values and I'm also reading the name. Okay, now finally, in order to open this file and get that content, what I will do, I'll create a loader and I'll write, hey, let's go ahead and use this PyPDF loader, which will be useful in loading your files. So here I'm going to write temp dir. Okay, sorry, temp PDF. It should not be dir. It should be PDF. Whatever PDF file is there, we are going to load. And then I have docs where I'll specifically write loader.load. Okay. So all these things are specifically there. Now what I will do, I'll go ahead and write documents.extend. Okay, and here I'm going to go ahead and create my docs. Okay, so I'm saying, hey, let's go ahead and append all the docs over here, right? Now, what we are basically going to do is that we are going to split and create embeddings for the documents. So here I'll just go ahead and copy and paste it. So instead of using OpenAI embeddings, I'm going to use embeddings, whatever embeddings we have discussed over here. So let me just go ahead. But I think this is common code, right? Split and create embeddings for documents. First of all, we'll use recursive character text splitter. I'm using a chunk size of 5,000, chunk overlap of, let's make it to 500 at least. Okay. Then we have this text splitter, split documents of documents. Then I have the splits. Then I'm using chroma to probably split all the documents and store it in my embedding vectors, right? And finally, we are converting this into a retriever. Okay. Now, what I'm actually going to do after this is that I am going to go ahead and I will just go ahead and create my new prompt. Okay. Now this new prompt will have context. So I'll say contextualize underscore q system prompt. This is basically my system prompt that I really want to create. Okay, and here I will be writing this one. I'll say, hey, given a chat history and the latest user question. Okay, along with this I will just put some information over here. I can also write all this like this, right? So here you can see I'm saying, hey, given a chat history and the latest user question, which might reference context in the chat history, formulate a standalone question which can be understood without the chat history. Do not answer the question. Just reformulate it if needed, and otherwise return as is. So this is the kind of a system prompt that we are specifically giving to our LLM model. And for this, we will be creating a prompt template. So for this, I will just go ahead and like this. So I'll say contextualize q prompt, where I'm using chat prompt template from underscore message, where I'll give my system, which will be assigning to this particular system prompt. So this is a set of instruction that I'm giving to my LLM model. Then I'm going to create a placeholder which has this chat underscore history. So in my session, I will go ahead and create this chat underscore history. Just in some time, I will go ahead and create it. Don't worry. Then I have this human, which respect to any input that I specifically give. Okay. Now after this, what I will do, since I have created this placeholder for the chat history, I can go ahead and create my history underscore aware underscore retriever. Right. So that is where I am going to create my retriever. Right. So and this retriever will be nothing but it will be a retriever with memory. Okay. So here I'm going to use this. I'll go ahead and call this create history retriever aware retriever. Here I'm going to give three information: LLM, retriever, along with this whatever prompt that I have actually designed over here. This prompt and this chat history will be referring to that. So this basically means this retriever has a powerful feature of this particular chat history where it will be able to store all the information. Okay. So yes, this was about this chat aware history retriever. Okay. Now finally, what I will do, I will go ahead and create my answer question prompt. Okay. Answer question prompt, and let me just go ahead and write this particular prompt because this prompt will be based on context. Okay. So here I've created a system prompt. Okay, quickly, and the system prompt says that hey, you are assistant for the question answer task. Use the following pieces of retrieve context to answer the question. If you don't know the answer, say that you don't know. Use 3 sentences maximum and keep that answer concise. New line, and here we are passing this particular context, and this context will be replaced by stuff document chain. Right. So this is my system prompt. Now I will go ahead and create this particular prompt for this kind of question. I will say QA prompt, and from message I'll be using this. Again, I'm using this placeholder, this, and message that I'm actually giving is input. Okay. So almost this is specifically done. Okay, and it is up to you, like how you really want to create this and all. Okay, but at the end of the day, what I will be doing is that I will make sure that I will integrate this particular prompt with this history aware retriever. Okay, so now in the next step, what I will say, hey, let's go ahead and create our question answer chain. Okay, and I'll say create a stuff document chain. So here I'm going to use this. Here I'm going to give 2 parameters. One is LLM and one is QA prompt, right? Because this create stuff document chain will be replacing the entire documents over here in the context. So the 2 information is basically given LLM and QA prompt. Okay, and then finally I'll go ahead and create my RAG chain, which will be nothing but create a retrieval chain. Okay, and inside this retrieval chain I will be using a history aware retriever, and then you'll also be using this question answer chain. So in short, I've combined this history aware retriever with the recent QA prompt that I've actually used. Okay, so this basically gets my RAG underscore chain. So guys, now let's go ahead and we have already created this RAG chain, but as you all far remember, in the conversation Q&A history or chatbot module, we had also discussed something about creating a get session history function. So here we're just going to go ahead and write get session history, and we will create a specific function, and the function main aim will be that whenever we give any session ID, okay, it should return back our base chat history message history, right? So here what we'll do, we'll write if st dot session, or sorry, I'll just go ahead and write if session underscore ID not in st.session underscore ID state dot store, because inside this only we'll go ahead and check it. And this is where we are going to probably put all our session ID automatically get stored inside this, right? So I'll say st.session state dot store, and here I'm going to give my session ID, which will be equal to our chat message history. And this chat message history, what it will do, all the conversation that is basically happening with this particular session ID, it will get stored over here, and from here it will go to this particular the session ID itself will get saved over there. Then finally we go ahead and return this st.session state dot store. And here I'm going to basically use my session underscore ID. Perfect. So this is the same store that we created on top, right? So the same, right? Which is a key value pairs. So yes, once this is done, this is the function that we have actually created. Now I'm going to go ahead and create my conversational RAG chain. So I'm going to write conversational RAG underscore chain, which will be equal to runnable message history. And here I will be giving my information like RAG chain. Then I have my function which is called as get session history. The third thing that I'm actually going to give is my input key message or input message key. As you know, what is the input that I'm giving? So I'm giving basically input, right? And along with this, you should also know which is my history message key. History message key is nothing but chat history. So automatically this basically comes to know that where it needs to save it, all the chat session. And finally, your output message key, which will be assigned to your answer, right? The output message key means whichever response you'll be getting, that will be stored in the specific output. Okay. So till here, everything looks good. Now let's start and write our code. As soon as we get our input, that is the next thing that we really need to write. But I think till here, everything looks good. So this is an uploaded file. With respect to the uploaded file, we are able to see each and everything. This is good enough, and we have our system prompt, everything as such. Okay, I think one condition I may have missed somewhere. Okay, let me just go ahead and verify this. Here I've given my API key. Here I've checked the condition. Here's my uploaded file. With respect to uploaded file, I have my text splitter. Then okay, yeah. So this context splitter needs to be created all inside this if condition itself. Okay, so this is one of the changes that I will do. I'll go ahead and press Shift Tab. Okay, so please make sure that you do these changes. It needs to be inside this, right? If condition, because once I need to have the documents over here, right? Then only I should be able to go ahead and create all this chain. If I do not have the documents, then it will be of no use. Okay, so please make sure that you make the changes. Okay, just go over here and press select from here. This entire from the text splitter code. It should be inside this if block. Okay, perfect. Till here everything looks good enough. And now the next thing that I'm actually going to do is that after creating this conversational Q&A chatbot is that let's go ahead and create my user input. So I'll say, hey, this is my user input, whatever question I'm looking for, and I'm saying, hey, if user underscore input, I'll say create my session history, and my session history will be nothing but get session history. And here I'm going to give my session ID, right? Whatever session ID I have, the default session, that is what I'm actually going to give over here. And now I can probably go ahead and call my conversational RAG chain, this one, right? So I'll go inside this, I'll write dot invoke. Here input will be one key, and this configuration will be for my session ID. So that automatically, once I use this config, right, inside my conversation Q&A chain, it knows, right, where I need to save all my session information, like all the chat, right, inside this chat history variable. This will be my input, this will be my chat history where all the information will be saved based on the session ID, right? Since that is the reason we are using this, say get session history. Now, along with this, I will quickly go ahead and display this, all the three information, like what is the store, right? Then if you see over here, session history, it should be session history, okay? I will be displaying this store, I'll be displaying the answer, and I'll be displaying my message, okay? And here, instead of getting the response, I will use st.success over here, so that it shows in green color, okay? So yes, this was it, all the information that I've actually coded in front of you. And if the API key is not given, right, so let me just go back over here. Okay, and let me write else. If when the API key is not given, I'll give a warning saying that, hey, please enter the Grok API key. Okay, I will go ahead and execute this. Now let me just go ahead and open this quickly. Let me go back to the specific folder. So here I will write cd dot, and the folder over here that I'm actually using, if you see, right, which is the folder? The folder is nothing but 4.1 RAG Q&A, right? So I will go ahead and write 4.1 cd 4.1 RAG Q&A conversation. I will clear the screen and next go ahead and run this. Streamlit run app.py. Before that, I will open my env file and copy this key so that it will be useful. Let's go ahead and press this enter. And here you have this entire website. Okay, so it is loading. Let's see. I think one or two errors usually comes when we are basically writing the code from here itself, right? So let's go back over here and see whether we are getting any warning. Resume download is procured. Okay, so it is for the first time. It's just going to take some time. Okay, password is not a valid input text. Okay, let's see where is password. I'll go ahead and search for. So it should be double S. Okay, perfect. Let's now see, always rerun. Now I think it should see for the first time it will take time because it needs to download the Hugging Face embedding technique. Okay, so please make sure that you be patient for that. Okay, now I have my environment key. Then I'll go ahead and paste it over here. Press enter. Okay, I think it should work. It has got entered. Now here also it is going to probably take some amount of time. No, I don't think it will take time because only for the first time when the Hugging Face embedding is basically required at that time it will take. So now here you can see it is running. The embedding technique of Hugging Face is basically getting applied, you know, and here you have it, right? So here now let me just go ahead and ask about what is transformers. Okay, if you use OpenAI embedding, it will be much more faster. So here I search for what is transformer. And here you can see input to chat prompt template missing chat history, expected chat underscore history, received input chat history. Okay, I think this is some bit of mistakes that has been happened over here. We will just go ahead and check it out. Let's see which line it is basically saying. Input chat history, chat underscore history is over here. Here chat underscore history is basically over here. And down what I've used here also chat underscore history is there. Here, okay. So here I have to use chat underscore history. So it's fine. Some smaller mistakes will happen. Now it is just going to give me the output. Okay. So I have to make sure that all the things are correct, right? So one more error. Response of answer. Okay, st.success assistant. Okay, I've given two parameters over here, right? Take two positional arguments, but three is given. So let me do one thing. Instead of writing success, I'll just go ahead and write st.write for now. Okay, now it should basically give me the output. And here you can see in the default session, it is basically getting displayed. Transformers are type of neural network. They use self-attention to weigh the importance, and all this information is basically there. Okay, fine. Let's go ahead and ask about this. What is attention? Or I'll just say provide a detailed summary of transformers with attention is all you need. I'll go ahead and search for this. Let's see whether I'll be able to get the answer or not. So here is my entire output. This paper, attention is all you need to introduce the transformer architecture with all the information. You can see over here, and in the chat history also, you're able to see this. You can also get the detailed summary. I can say provide a detailed summary, provide a detailed summary, provide a detailed summary of the conversation we had. Okay. So here you can see the output. I hope you're enjoying this videos, right? Because at the end of the day, I know I'm creating this amazing models. This can be integrated wherever you want, right? So here you can see once your conversation started, you asked me to ask about transformers. I provided a concise explanation. I also outlined out advantages of transformer, emphasizing their parallelity ability to handle. You can upload any PDF and you can start working, right? So I hope you understood this particular video. I hope you were able to understand the entire implementation. So yeah, this was it from my side. I hope you like this particular video. I'll see you in the next video. Thank you. Take care. Bye. Hello guys. So we are going to continue the discussion of creating end-to-end generative AI projects with the help of LangChain. And in this video and in the upcoming series of video, we are going to develop an end-to-end search engine Gen AI app with the help of tools and agent. Now these words that you'll be seeing, tools and agents, these are very important words. You may be thinking that this may be a simple search engine project wherein you just ask a query to the LLM models and you may probably get the response. It is nothing like that. You know, what is the main intention of doing the specific projects and why I really want to integrate tools and agents over here? Because right now, if I just consider the functionalities with respect to tools and agents, it makes your generative AI application amazing with respect to solving more complex problems. Okay. Now, what exactly we are going to do in this particular project? Let's say if a user asks any queries. Okay. Now, first of all, you really need to understand what exactly is tools and what exactly is agents. Okay. First of all, we'll try to understand this. So, in order to understand this, I have opened this documentation page of LangChain itself. Right. So here you can see it says that tools are interfaces that an agent, chain, or LLM can use to interact with the world. They combine a few things like name of a tool, description of what the tool is, and all. Right. So what I will do, I'll just take this sentence and let me copy it over there. Okay. In my sheet. Okay, so here I have this. Okay, what are tools? So if you really want to see this definition, you can go ahead. I'll keep this notebook something like this where you'll be able to see it. Okay, so tools are interfaces that an agent, chain, or LLM can use to interact with the world. Let's say one specific example. Okay, let's say I have an OpenAI LLM model, right? So if I just consider OpenAI LLM models, okay, it can be multi-model also. So if I just consider one example of the multi-model right now, it is nothing but GPT-4o. Okay. Now this model, if you probably go ahead and see the documentation of OpenAI, this model is trained till December 2023 data. Okay. Till this data. So whatever questions you specifically ask with respect to the data that is available till December 2023, you will be able to get the response very much easily. But right now, we are in this particular world, we also require current information. And there are a lot of changes that are specifically happening right now, right? With respect to the extent of, let's say, current news are there. I want the current weather. I may probably require new information. Let's say the documentation of entire OpenAI has been changed recently, right? And I really want to, or if I just consider the LangChain documentation, recently LangChain documentation has completely changed. It has come up with version 1 and version 2. Right now, we need to refer version 2, right? Now, if I want that specific information from my generative AI application or from my multi-model, how can I specifically do that? So what we basically do over here is that here we will try to create a generative AI app in such a way that I will try to integrate this generative AI with multiple tools. What are these tools? If we just consider it, you'll be able to see that these tools are interfaces that acts as that an agent, chain, or LLM can use to interact with the world. Now, let's say one of the tools that that LangChain actually provides. So I hope everybody knows about this website, which is called as Archive. Okay. Now, this website, whether you want any information regarding any research paper, you can specifically use this tool and you can have an interaction. You can get the information. Okay. One more tool, if I probably consider Wikipedia, right? Now, you know that Wikipedia has a lot of information, a lot of content, right? Now, I can also use Wikipedia for this particular purpose, right? I can probably do any kind of search with respect to Wikipedia, right? Now, these are some of the tools that are already provided. This can be with respect to any new content, any new research that is basically happening. I want some information. Now, these are two tools, right? And these two tools are by default provided by LangChain. You may also want to probably go ahead and create your own custom tool, right? Own custom tool. Let's say one of the tools that you have actually created is one document Q&A, right? Now here, what you have is that you have a lot of documents and you want to probably explore the content from this, right? You want to ask any question from this. You can go ahead and ask this. So like this, what we are going to do in this that whenever we create this search engine, here we are just not dependent on only LLM model. Instead, let's say if I search for anything from the LLM model, I may not have that particular information from the LLM model. I may not get the response from you. So what LLM model should do is that it should go ahead and interact with these tools, and based on the content that I'm actually trying to search, it should redirect to that specific tools itself, right? So that we will be able to get the response. Now, if I really want to use all these tools and execute it, so for this, we will be requiring another important component, which is called as agents, okay? Which is called as agents. So as I said, in this module, first of all, we will talk about tools, we'll talk about agents, how to create your custom tools, how to work with the tools, and later on in the series of video, we will try to create an amazing end-to-end project, which will be nothing but a search engine, which will have all these functionalities, right? I hope you're quite excited, and trust me, it is lovely to use this. And for this, I'm using LangChain because LangChain provides that entire ecosystem. There are also some other libraries, like I'll be showing you as we go ahead, which is called as Crew AI, right? Here also we'll be using multiple tools and agents. And the best thing about it is that I'm just not going to just use these tools and execute it, but I'm also going to make the interaction happen between all these tools with the help of these agents, right? I'll make sure that all the interaction should happen and you'll be able to see all this information that how the interaction is basically happening, right? And this is what I'm actually going to develop in this specific project, okay? Now, let me just go back to the documentation if you want to see the agents, what exactly is agent. The core idea of agent is to use a language model to choose a sequence of action to take place, right? In chain, the sequence of action is hard-coded. So here what we'll do first LLM, then probably go to Archive, then probably go to, Wikipedia, like that. We can actually implement it. Just to talk about what are the tools that are provided by LangChain. So if I just go ahead and search for this many tools are there, right? Some are paid, some definitely requires an API, some are completely free. Even weather map tools is also there, Wikipedia is there, Yahoo Finance News is there. You can probably go here and use any of this, like YouTube is also there, right? Whatever things you specifically want, you can actually use it, okay? And similarly, if I talk about agents, so here you can see how we can actually create an agent type, everything is given. And this is what we are going to do as we go ahead in the series of video, right? But I think you got an idea with respect to the definition of tools and agents and how exactly it works, right? So in the next video, I'm going to probably first of all go with some practical implementation with respect to tools, how to probably go ahead and create a tools with the help of LangChain, and then we'll also be discussing about agents, and finally we'll create an end-to-end project with respect to search engine. So yes, this was it from my side. I hope you like this particular video. I will see you all in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to tools and agent and search engine. So first of all, I will try to show you some important functionalities where I will try to create my own custom tools, and then I will also try to use the inbuilt tools that are available in the LangChain. Now just to talk about some of the inbuilt tools that we have in LangChain are like Wikipedia, Archive, then already we have actually seen about these tools, okay? So you can probably go over here and you can see all the tools like Google Finance, Google Places, like Google Server is there. If I just consider one example over here, let's say that I want to go ahead with Wikipedia, okay? So if I just go ahead and click on Wikipedia over here, you'll be able to see how, first of all, we have to install Wikipedia, then probably go ahead and implement all these things, okay? So quickly, what I will do is that I will just show you with respect to the code so that you'll also get an idea. So first of all, let's go ahead with a simple mechanism. First of all, I'll select the kernel over here. I'll say, hey, let's go ahead with something called as Archive. This is for my research paper. Now, this tool will be responsible in interacting with the Archive website itself, where I'll be able to get the information. Now, first of all, whenever we do this, you have to make sure that we have installed this library. So here, if you see, I will go ahead and write Archive, okay, and I will go ahead and install this. Along with this, I'm also going to use one more called as Wikipedia, okay. I have installed both these libraries, but just to show it to you, I'm actually doing it. So I'll just go ahead and open my terminal. I will open my command prompt. Sorry, I'll place this. I'll open my command prompt, okay. And here, I will just go ahead and write pip install -r requirement.txt because this is the environment variable that we are using. So pip install. So here you can see the installation is taking place, and already once the installation will take place, yes, it is completed. So I'll close this. I'll start it. Okay. So I've installed Archive. So Along with that, I've also installed Wikipedia. So let me go ahead and first of all start creating tools. Okay, so I'll write tools creation. So first of all, the tool that I'm actually going to create is something called as Wikipedia, and then obviously RCF also I'll try to create. Okay, so for this I will go ahead and write from langchain underscore community dot tools. I'm going to import RCF, or let's see whether we'll get this RCF query run. See, one tool is this RCF query run. This is for RCF itself, and this is Wikipedia query run. Then we are going to go ahead and write from langchain underscore community dot utilities import Wikipedia API wrapper. Okay, so this is a kind of wrapper. See, along with this, see, this is query run. Okay, the difference between this tool and this utility is that whenever we really need to run any of this query, so whenever we use this library to run a query, this is basically interacting with the tool itself, with the outside world, with the information that is present in RCF or Wikipedia. Okay, similarly, to run this entire query, we also require some kind of wrapper, right? So here also after this, I will just go ahead and write RCF API wrapper. So both these are very much important libraries that will be required over here. Once I execute this, here I will go ahead and create my API wrapper, and this API wrapper will be for my wiki. Okay, I'll write Wikipedia. Now I will go ahead and say, hey, Wikipedia API wrapper. Now this API wrapper will have some information. So if I probably see it is a wrapper around Wikipedia API. To use, you should have the Wikipedia Python package installed. Okay, which we have already done it. Okay, this wrapper will use the Wikipedia API to conduct searches and fetch page summaries. So this is a wrapper which is responsible in fetching and conducting searches and fetching the page summaries. Now here we require some parameters, such as top underscore k underscore results. So this is basically saying that how many number of results you want. Let's say that I just want one right now, and I'll also give one more very important parameter which is called as document content character max. Like how many max characters you want. I'll say go ahead and do it for 250. Okay, you can even increase this number of characters. It's up to you. Now, once I've created this particular wrapper, right, I need to run this wrapper. So to run this particular wrapper, I will be requiring this Wikipedia query run. Okay, so here I'll write Wikipedia query run is equal to whatever wrapper I've actually created, my API wrapper. This is what is the parameter with respect to that, and this will basically give my tool, right? So this becomes one tool. I've actually created my tool, and this is the inbuilt tool that we have. And if I go ahead and just write wiki.name, you'll be able to see that this is a Wikipedia tool, right? So here in this code, we have used the inbuilt tool of Wikipedia. Okay, perfect. Done. Now, similarly, if I want to probably go ahead and create RCF tool also, how do I write it? Similarly, like first of all, we need to create a wrapper. So I'll write API underscore wrapper underscore RCF. Okay, and this will basically be nothing but RCF API wrapper. And inside this, I'm just going to use my top underscore k results again. Here it will be 1, and doc content max characters here also it will be 250. I'm keeping it to 250. Then I'll go ahead and write RCF is equal to RCF query run. I'll use the same API wrapper is equal to API wrapper RCF, and then I will be calling this. Let's go ahead and print my RCF dot name. So this becomes my RCF tool. Okay. Now, if I really need to combine both these tools, see, at the end of the day, there are two tools I want to use in my application, so I'll combine them in the form of list, right? So first of all, I'll say wiki, then I'll go ahead and ask my RCF, okay? And this is fine. And this becomes my tools, okay? Now, you should know that if you really want to run these tools, how do you run these tools and all, okay? And obviously for that, you require a model itself. Along with that model, you specifically require one more very important thing, which is called as, obviously LLM model will be there, then we have to also create our chat prompt template, and then we can probably go ahead and create all the specific tools, okay? Now, let me do one more thing over here. This is the inbuilt tool that we have created, right? Let us go ahead and create our own custom tools also, okay? Now, in order to create the custom tools, let's take a specific example. I will import all these libraries, okay? And this will basically be my RAG tool, let's say, okay? I'm saying, hey, from langchain underscore community dot document loaders, import web-based loader. Then from the vector store, I've used Fias. Then I'm using OpenAI embeddings, okay? You can also use Ollama embeddings, no worries as such. Then you have langchain underscore text underscore splitters. Then you have import recursive character text splitter, okay? So you can also use this with respect to character text splitter. And with respect to OpenAI embeddings, instead of OpenAI embedding, you can also use Ollama embeddings. And as we go ahead, I've already shown you how to use Hugging Face embeddings, okay? So if you want, I will just go ahead and use this Hugging Face embeddings. Let's see. Let me just go ahead and pick up Hugging Face embeddings. So here is my Hugging Face embeddings. Now, in order to use Hugging Face embeddings, I have to use this particular token. I've already shown you, okay? And then we can use this particular Hugging Face embeddings itself, right? It is up to you, whichever you want to use. I've given so many options, but I want to go ahead with OpenAI embeddings because again, I'll be able to get quickly the results, and I'll be able to show you the examples. Okay, you can use Ollama embeddings. So Ollama embeddings also will take some amount of time. If not, you just go ahead and directly use Hugging Face embeddings. That is up to you. Okay, and then I'm also using recursive character text splitter. So let's execute this. So environment agent variable not set considered instance. Okay, let this warning come. So if I execute it again, it will go off. Okay, now here what I will actually do is that I will have my own one page, okay, one website page. I will try to load that page, and based on that, I will try to create that into a vector store, and I'll use that as a separate tool. Okay, so here what I'm actually going to do is that I'm going to write web-based loader. Let me give one of the Langsmith page that I have. Okay, so here I'm giving it this URL. I'm going to use this specific URL, and then I'll go ahead and write docs is equal to loader dot load. So after this, this will basically give us all the documents, and then I will go ahead and create my document file. Documents is equal to, and here I'm going to use my recursive character text splitter. The chunk size will be nothing but it will be equal to 1000, and finally you will have your chunk overlap, okay, which will be equal to 200. Okay, and I will go ahead and split these documents, which we basically write in our next line code, and I will say, hey, split all these documents. Okay. Once this is done, then I will go ahead and create my vector store. So I'll write vector db. Vector store db is nothing but Fias dot from documents. And from this particular document, I'll give my documents over here. And then along with that, I'm also going to give my OpenAI embeddings. Okay. So this will be the embedding techniques that I will use. And finally, I go ahead and create my retriever, right? Where I'll write vector db dot as retriever. Okay. And then finally, you can see the retriever over here. Okay. So all these things we are basically doing it over here. And quickly, I'm able to get this entire vector store retriever. Okay. So perfect till here, everything looks good, right? Now this retriever, you can probably query any information, and you can probably get any results from this particular page, whatever it has the documents. Okay. But in order to use it as a tool, I have to convert this retriever into a tool. Okay. So in order to convert this retriever into a tool, what I will do, I will say, hey, from langchain dot tools. Okay, dot retriever, import something called as create retriever tool. Okay, I will use this. So this will basically be my retriever underscore tool, which I will go ahead and use this create retriever tool. And let me write which is my value. This is my retriever. I will give my tool name. I'll say, hey, this is my Langsmith search. Okay, this is my Langsmith search, and I will give some brief info like search. Let's say I'm just going to write over here I'll write, hey, search any information about Langsmith. Okay, done. Perfect. So this basically becomes my retriever tool. And if I go ahead and write .name, similarly, I'll be able to get this. See, it is basically coming as Langsmith search. Okay, so these are how to probably use the inbuilt tools, and this is how you can actually create your own tools, right? At the end of the day, you just need to have a retriever, and from that retriever, you'll be able to create this. Okay. Now let's go to the next step, and this time when I'm creating these tools, right, I will go ahead and add this particular retriever tool also. Okay, so this basically becomes my tool. I'll go ahead and execute it. And if you go ahead and see this, it is nothing but it is a list of tools which is added with respect to each other, right? So all with respect to the description, everything is available over here. Perfect. Now what I'm actually going to do is that I'm going to, in the next video, right, we're going to run all these tools with agents and LLM models. Okay, so this will what we will be discussing in our next video. So I hope you like this particular video. This was it from my side. I will see you on the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to tools and agents. Now, already in our previous video, we have seen that how we have created tools. Even we have also created our custom tools, right? Now it's time that we combine these tools along with our LLM model, along with, if I really want to execute this, I will be using something called as Agent Executor. And that is where we are going to learn about agents. So first of all, let's go ahead and use some LLM models. And again, for this, I will be using the Grok API, which we have specifically used over here. So in order to use Grok, I will just go ahead and open this quickly. I will go ahead and search for this .env. And I also require my OpenAI API key, right? Let's go ahead and use this LLM model. So here, this is my entire code, right? And for this, I will, okay, st.secrets. Okay, I have to go ahead and just write import OS. And finally, you'll also be able to see that I'll go ahead and write os.get.env will be with respect to my, and similarly os.get.env will be my OpenAPI key, right? And for this, again, I will go ahead and import OpenAI because I will require this. And since I'm using Chat Grok API, so obviously you know how to probably import this. So for Chat Grok, I will be using langchain_grok, okay? And I will go ahead and import it over here, right? So I'm actually going to use this Llama 3 model, and already I've actually shown you how things are basically done, you know? So OpenAI API key is basically set to the API key. The reason why I'm using OpenAI API key because for the OpenAI embeddings, right? So here, the kind of embeddings that I'm trying to apply for this particular documents, it will be from OpenAI embeddings itself, right? So I will be doing that, and here I will go ahead and use this with respect to the get environment variable. Okay. Now this is my LLM model, right? And I'm using Llama 3 specifically LLM models. Okay. So this is the first step that we will need to do. I'll go ahead and execute this. I'm getting an error saying that okay, Chat Grok, okay, this os.get.env. Okay, this is the problem. I'll just go ahead and use my brackets. Okay. Now it should work. It's okay. I am not deleting this error, whatever error we basically face. Okay. Whenever you get an error, never hesitate to solve it. Okay. And don't be afraid. Errors are something which are simple, common mistakes that we do, and it is fixable. Okay. Now we will go ahead and create our prompt template. Now see guys, one example of creating the prompt template I've already shown you. In LangChain, there is also something called as hub. You know, some different types of, if I probably consider with respect to a prompt, you know, is already created and uploaded in the hub. Okay. So today in this video, I will talk about one way. So I'll write, hey, from LangChain, okay, LangChain, I'll say import hub. Okay. And from this particular hub, you know, I'll just go ahead and write prompt is equal to hub.pull. Okay, I'll say pull one of the type of prompt that has already been created. And when I was searching in the hub itself, right, you'll be able to see something like OpenAI function agent. So let's talk about this. Okay, so here what I'm actually going to do is that I'll just go ahead and search about this OpenAI function agent prompt. Okay, so in the OpenAI function agent prompt, if I go ahead and see it, right, see to it. So it this is the prompt that is basically there, and this prompt is basically getting displayed. Right, here you have a system prompt message template, you have message placeholder for the chat history, then you have human message prompt template, then you have this message placeholder. So this kind of prompt is basically getting created, and over here it says, hey, you are just a helpful assistant, right? But again, my best practice will be that use always chat prompt template and then try to create a prompt. But here I wanted to show you varieties of ways, so that is the reason I'm actually going ahead and showing you. Okay, and here you can go ahead and write prompt.messages. Okay. So once I execute this, here you'll be able to see this entire prompt is basically getting displayed. Now I'm going to combine this prompt along with this LLM and all the tools that I've actually created, right? So if I want to execute all together in the form of chain, so I have to specifically use agents. Okay. So what I will do, I'll write from langchain.agents. Okay. I'm going to go ahead and write import, create one of the easiest way of creating agent is by using this OpenAI tools _ agent, and you also have OpenAPI agents. But I'm just going to use this OpenAI function agents is also there. See, so all these agents, right? So if I go ahead and show you in the documentation, right? And it's always necessary that, see, this is one tool and all are there, right? Types of agents, tool callings. This is OpenAI tool, right? So here you'll be able to see newer OpenAI models has been fine-tuned to detect with one or more functions. Like the goal of the OpenAI tools API is to be more reliable return. You can basically go ahead and check out this documentation. What is this OpenAI functions? You saw one example over there, right? And here it says that certain OpenAI models like GPT 3.5 Turbo have been fine-tuned to detect and all. See, I'm using Grok right now. I don't know whether it is going to work or not, but let's see, you know. So there are multiple ways of calling different tools also. So here you also have with Google, you have with Mistral. I don't know whether it will work with Grok or not, but I'll just give my best try. If it works with Grok, it is well and good. Otherwise, I'll just go ahead and change this entire LLM model. Okay, that is what I'm actually going to do. So from LangChain agents, I'm just going to use one called as create table OpenAI tools agent. So I'll go ahead and with this again. Please make sure that you watch these documentations, right? Go ahead and check the documentation. Agent is equal to, I'll go ahead and write create OpenAI tool agents, and here I'm just going to specifically use my LLM model, my tools, and my prompt. Okay, so I'll use this 3, and over here this specifically becomes my agent. I'll go ahead and execute it. Go ahead and execute it. So here is the entire chain that is basically getting created, and I've used Chat Grok. I think this should also work. That is what I feel. But let's see. Okay, once I've created my agent, I need to run this agent, right? So for running this agent, we basically go ahead and create our agent executor. Okay, so I'll go ahead and write from langchain.agents import agent executor. And from this agent underscore executor, I will go ahead and write agent executor. And here, first of all, I need to give my agent. The agent is a combination of all these things, which will be in the form of chain, LLM tools, and prompt. Then along with this, I will also go ahead and give my tool section, which will be equal to this tools. And I'll go and write my verbose is equal to true, so that I'll be able to see the interaction, how it happens, right? So once I go ahead and execute this, so this basically becomes my agent executor. So here you can see chat prompt template is also included, input type chat history, LangChain core message and all, right? Just to give you an idea, I've used a hub over here. So that is the reason you'll be able to see the variable name will be chat history over here, right? All the information, the default variable name is input. You can also go ahead and create this. I think it'll hardly take 2 minutes, okay? So now let's go ahead and finally execute our agent executor, okay? So I'll go ahead and write agent executor, okay, dot invoke, and here I'm just going to go ahead and write my input, because this is the key that we really want to know. And let's say I go ahead and ask a question, tell me about Langsmith. Okay, so Langsmith obviously should go ahead and interact with our tool, right? Let's see what happens. So, okay, invoke. Let's go ahead and execute this. So here you can see entering new executor chain, and suddenly this Langsmith search has been opened up, and this is what you're able to get the answer, right? Tell me about Langsmith. The result of the tool called ID is a web page about Langsmith, a platform for building production grade application. Perfect. Let's execute more, okay? I'll go ahead and say, hey, let's see, I'll go ahead and ask, hey, what is machine learning? Let's see from where it will go ahead and pick it. Whether it is just going to use the LLM model, send a new executor. Oh, it's meant to Wikipedia, right? See, automatically, amazing. Machine learning is the field of this, all the information is over here. It is also going into the Langsmith, see? But finally, you can see, get started with Langsmith. It was not able, I hope this response provides a global overview of machine learning and Langsmith. Okay, it is also using the previous history. So this is the amazing thing, right? The main reason of using this hub was making sure that this one, OpenAI agent function. So here, it is also recording the entire information about the chat history, right? So here you can see that I'm able to get the answer. Okay, let me just go ahead and ask one more question. I'm just going to go ahead and ask about, let's see, what is in RSIV, you know, if I go ahead and search for attention is all you need. This is one of the famous research paper. I'll just go ahead and search for this number. Okay, let's see where I get that number over here. So this will basically be that number. Okay, and I will just go ahead and ask it over here. Okay, so I'll say, hey, agent.executor. And I'll say, hey, just let me know what is this research paper all about. Okay, so let's see, it should probably go to Archive. See, beautiful, right? And then we're searching about Wikipedia. See how beautifully it is combined, and here you can see all the response that is probably getting, right? Now, a part of the entire search engine is actually completed over here, but now in our next video, I'm going to combine everything of this and probably implement it. But at the end of the day, please make sure that you watch the documentation page. You really need to understand how agent executor is here, what all options are specifically there, how to probably combine this, how many number of tools you have to create, how to create a common tools and all. But later on, the maximum thing will be with respect to more about exploration, right? So yes, in our next video, I'm going to create our end-to-end search engine project. So I hope you like this particular video. I'll see you in the next video. Thank you. Take care. Bye. Hello guys, so we are going to continue the discussion with respect to creating this amazing end-to-end search engine Gen AI application with the help of tools and agents. Already in our previous video, we have seen that how we can use LangChain in order to create tools and how we can execute it with the help of agents. And in our previous video, we have already seen about creating your own custom tools. Along with that, we have also seen how to use the inbuilt tools that are supportable by LangChain. Now let's go ahead and quickly start our project. So here in my search engine folder, you will be able to see that I've created my app.py project. So folder by folder, I'm trying to execute this specific project. So let's go ahead without wasting any time. So first of all, we will go ahead and import Streamlit as ST. Along with this, what we are basically going to do is that we're also going to import all the other things that we require. Okay, so I just remove this. I don't know why this suggestion usually comes, but can't help. Then quickly, I will go ahead and use something called as LangChain underscore Grok. We are going to use Grok over here to access the open source models. So I'm just going to go ahead and write chat Grok. And then from this, I will also be using LangChain underscore community dot utils. Okay, I've already shown you how to probably go ahead and create your wrappers, right? So here also we are going to use the same wrappers. So I'll go ahead and write utilities import. One is the RSIF wrapper, and then I'm going to use the Wikipedia wrapper. So let's go ahead and use this 2 wrappers for right now. And again, you can go ahead and explore other tools also. In this, I will also add one search engine tool. Okay, let's see that also. Okay, along with this, you'll be seeing that I will go ahead and import from LangChain underscore community.tools. Inside the tools, we will go ahead and import RSIF query, and then I'll also have this Wikipedia query run. Okay, so RSIF query run, and then I'll also be having this Wikipedia query run. Along with this, I will also add one like capabilities to search from the internet, right? So for that, I have this DuckDuckGo search run. Okay, so I'll be using this also, which will actually help you to search anything in the internet, right? So all these are the important imports that we are specifically going to do. Now, I will also be importing something called as from LangChain. I will be importing something called as agents. So let's first of all go ahead and initialize the agent over here. Along with this, there's an option of putting something called as agent type, which I will be discussing. What is the importance of this? I will go ahead and discuss about this also. Along with this, so let's go ahead and import our next library. So here we are also going to use something called as LangChain.callbacks, and I'm going to import something called as Streamlit callback handler. And this is important because this will allow you to communicate with all these kind of tools within themselves, right? So all these libraries will be using initially, right? Now, Streamlit has also been imported. I will go ahead and import OS if I want over here. Along with this, I will go ahead and write import OS and from .env import load underscore .env. I'm also going to use this. Okay. If you remember in our chatbot also, right, we specifically did not even have to call any APIs, right? I was directly copying and pasting in the web application itself. So I will try to also develop in that specific way. So if I go ahead and open this OpenAI chatbot, here you'll be able to see I created this all slide bars, right? So here I will also use one of the slide bar. Okay. And I'll keep this handy when I will be using it. Okay. So I'll just paste it over here to keep this sidebar settings, and I'll say, hey, enter your Grok API key. Okay, so I'll go ahead and enter the Grok API key. So I'll keep this also handy so that I don't have to even call my load underscore .env, right, for the same thing. Now the next thing after this, what I am actually going to do is that after importing all these things, let's also take this entire things. And first of all, I will go ahead and create my RSIF wrapper, API wrapper, and the Wikipedia API wrapper. And already I've actually shown you how to do that. This is for my RSIF tools, which I had actually shown in my previous video, RSIF and Wikipedia tools, right? So here we have initialized it. Along with this, as I said, that I'm also going to use a DuckDuckGo search. So that is what I'm actually going to do. In order to use that particular tool, I will go ahead and create a variable which is called a search is equal to DuckDuckGo search run. And here the kind of task that I'm telling it to do, or the name that I'm actually going to give this is something called a search. So here the name will be Wikipedia, here the name will be RSIF, and this will be my search functionality, which I really need to search from the internet itself, right? And after doing all these things, now let's go ahead and create my Streamlit app. So first of all, I will quickly go ahead and write st.title. I'll just go ahead and write LangChain with chat with search. Okay. Let me just give a simple reminder or comment over here saying that, hey, in this example, we are using something called as Streamlit callback handler to display the thoughts and action of the agent in an interactive Streamlit app. Okay, so this will actually help you to, the Streamlit callback handler will actually help you to understand like what thoughts and action of the agents will be when they're executing all these kind of tools or when they're interacting with the tools. Okay, then I have imported this specifically for my Grok API. Okay, now what I'm actually going to do, since I also need to make sure that now my entire conversation over here should happen along with the chat history. So I will go ahead and create one simple, I'll just say, hey, if messages, I'll basically create my session state. So I'll go ahead and write session underscore state over here. And along with this, I'll write, hey, st.session state of messages. Okay, so I'm just going to go ahead and create this messages equal to, and here I'll just go ahead and give some of the important message roles that I'm actually going to provide. So first one information that I really need to put is something about role. So role will be nothing but assistant. And then I will say, hey, this is my content. So let me just go ahead and write the content. It will be again colon. I'll say, hi, I am a chatbot who can search the web. Okay. Or I'll also put one message. How can I help you? Okay. So this will be the default assistant information that you have. So this I'm saving it in the session state. Okay. Then I will go ahead and say for every messages, we will go ahead and traverse it. So I'll write for message in st.session state, session st.session underscore state dot messages. Okay. And here I'm just going to use st.chat underscore message. I'm basically going to give my message role. Okay. Now inside this message role, I'm just going to go ahead and write over here as my message content. So with respect to any conversation that I get, because I'm going to put all this specific role information like how I put over here inside my session state as we go ahead, right? So right now in this key value pairs, I'll keep on adding it, and we will be making sure that we add all these values in our session state. Okay. Now let's go ahead and do one thing. Let's go ahead and create my prompt. Okay. Now prompt is something by default some text message will be there. So I'll write from prompt colon equal to, okay, I'll go ahead and say st.chat underscore input. Okay. And here I'm going to just go ahead and see chat underscore input is also one very important component in Streamlit. And here we are just going to go ahead and put a placeholder. So I'll go ahead and write my placeholder and I'll say, hey, what is machine learning? I'm just going to put a simple basic message, okay, regarding this chat underscore input. Now this prompt by default will be having the specific placeholder. Now I will go inside this. If this particular prompt is specifically written, I will go ahead and say, hey, let's go ahead and create this st.session state, session underscore state, and I'm going to take this messages. Let's see, yes, messages dot, I'm going to append some role, right? And initially, whenever I try to put any, if I try to ask any query, the role, you know what it should be added. It should be added as a user. So this will be my role, okay? And the content that I'm actually going to add is nothing but my prompt, okay? So here I'm going to probably go ahead and create my prompt. Perfect. So once we add this, then the next step will be that I'm going to go ahead and say st.chat underscore message. And here I'm going to basically use user, and we're just going to write this prompt. Dot write of prompt. Okay. So what we are basically doing is that whenever we write any prompt, it is going to get appended in this particular message so that we'll be able to read this and all, right? So this is also done. Now the next step will be that inside this, right, inside this prompt itself, we will go ahead and create our LLM. So I'll write chat grok, and I will go ahead and use chat grok underscore API underscore key, okay, which will be equal to, I think I've written right, chat grok, and here have I imported chat grok or not? Yes, I have imported chat grok. So here I will be using my grok API key. So let's see whether the grok API key has been imported or not. It's okay. So we are going to get this grok API key from our parameters, right, which we will be getting it through from the input itself, right? So here what I will do, I will just use this API key that I'm actually going to use over here. Okay. So once this is done, this will basically be my model, and here I'm just going to use my model underscore name. You can use any model. For now, I'm using Llama 3, 8 billion parameter, and this will be with 8912. Okay. So this will be my model, and here I'm also going to keep my parameter as streaming is equal to true. Let me just go ahead and write it over here, and streaming will be equal to true. Okay. So this basically becomes my LLM model altogether. I've initialized all the tools, whichever I really want to use it. Okay, and these are the tools that I initialized. Right, one is the wiki, one is RCF, and one is search. So I will go ahead and create a variable called as tools, and I will initialize all these tools over here. Okay, so let's say I will go ahead and write. One is search, then one is RCF, and one is wiki. Right? All these tools is specifically been added. Now I need to convert this entire tools into an agent so that I will be able to invoke this specific agent. So I'll say, hey, this is my search agent, and here I'm going to basically use this initialize agent function, and along with this I will be using my my tools will be going over here. So this will be my tools. These tools will be in the form of list that you have over here. So all this search, RCF, and wiki we're going to specifically use over here. And along with this, the second parameter will be my LLM, which I'm actually going to use. The third will be something called as agent. So the agent that we are going to basically initialize over here is my agent type dot. There will be something called as zero shot React description, and there is also something called as chat zero shot React description, and there is one more, something called as structured chat zero shot React description. You can definitely see the documentation what exactly this means, but let me give you a brief idea. What is the main difference between zero shot React description and chat zero shot React description? It basically lies in how they handle our context and memory, how they generate prompts for the language model. See, in the case of zero shot React description, they don't rely on the chat history, right? It makes a decision based on the current input only without considering any previous action. Similarly, on the other hand, if I use chat zero shot React description, it uses the chat history to remember the context of the chat and the history of the conversation, and it accepts a certain structure in the chat history and might raise an error if it does not find it. Okay, so in our case, I will just go ahead and use this zero shot React description, and here I'm also going to make sure that I give one more additional parameter which is called as handling parse. So here I'm going to go ahead and write handling underscore parse is parsing underscore errors is equal to true. I'm also saying that if you face any errors, please make sure that you also parse those errors. Okay, so these are the basic parameters that I specifically require over here, right? So here inside all these things I've actually given this. Let me make the spelling right, search underscore agent. Okay, and this is how we basically create this agent. Now it's time that we go ahead and have this kind of conversation, and it should be able to give us answers. So I'll start with st.chat underscore message, and I'm going to give the history over here, message of assistant, right? So I'll go ahead and give for like assistant. Okay, whenever the assistant is giving me any kind of response. So what I'm actually going to do is that I'm also going to call this Streamlit callback handler. I know there are multiple things that I'm actually showing you, but this is the best way of creating this, right? So once I use the Streamlit callback handler, understand over here what it is doing. It is used to display the thoughts and action of an agent in an interactive Streamlit app. So now, whenever my agent is basically communicating with itself, right, we should be able to see that, and that we'll be able to see once I will execute it. So here I will be using an st.container, so container over here, and if you see what exactly this container, it in turn insert a multi-element container, inserts an invisible container into your app that can be used to hold multiple elements. This allows you to, for example, insert multiple elements into your app out of order. Okay, that is the reason we are specifically using. We'll be able to see that block-wise, you'll be having that entire information, and then we will go ahead and create one more parameter called as expand underscore new underscore thoughts, and I'll say, please, whatever thoughts you have, show me that detailed explanation. And if I say expand, right, so every thought will probably just get opened. We can also open this, but right now I'll just keep it to false. So again, this expand new thoughts you'll be able to see once I probably run my entire application. You'll be seeing that by default it'll be closed. You can also open it. Okay. Now let's go ahead and get the response. So quickly I will go ahead and write response is equal to search underscore agent dot run. I will run this, and while running, I will also give all my session state dot messages. Okay. And I will say, hey, you can also make a callback. So there's a parameter which is called as callbacks with whatever callback we have actually created, right? Streamlit callback handler. So I'll go ahead and say st, cb. Okay. Once I do this, now the next step will be that I will go ahead and again append it, st.session_state.messages.append, and here I'm going to specifically use my role as assistant because this will be given by the assistant itself. Okay, and my whatever response I'm actually specifically getting, it will be inserted into the content part. So here I have this response. Okay, now quickly let's go ahead and write st.write response. Okay. So this is what it is, and I think we have executed this entire thing. Let's execute this entire thing and see whether everything is working fine or not, but I think it should work. Just to give you a quick revision, we have created all the tools wrapper, then we use this tools parameter over here, which will be included. We created our search agent, LLM, agent type is this, and we are good to go with respect to this, okay? And this is completely with the open source LLM models. Now I will quickly go ahead and write CD, which folder it is in, 5 search engine, so I'll go ahead and write 5, tab search engine. Now quickly, let's go ahead and run it, Streamlit run, app.py, okay? So once I run this, I hope so it should get executed, okay? So here it is. HTR object has no attribute. Let's see. So it says on line 36, I'm having this particular error. Let's see. Okay. Line 36, I'm having this particular error. Let me go ahead and check to this. What is exactly the problem over here? So if I probably see this message, 36 it is, chat underscore message, okay, I made one specific simple mistake. I should have closed the brackets over here and no need of the specific brackets. So whenever you get an error, don't feel afraid of the things that you are seeing. Instead, just try to fix it. Now this looks absolutely fabulous, right? Quickly, let me just go ahead and take my Grok key. I'll copy this entire thing over here. I'll go over here and press enter. And let's go ahead and, okay, I did not write one more condition over here, okay? And that is the reason it may give us an error. I'll say if prompt and, right? And the API key. I have to probably give this API key, okay? Now I think it should run. Oh, let's go ahead and copy and paste it. I'll press enter. Now, I'll go ahead and write what is generative AI. Oh God, it is getting displayed. Why it is getting displayed? We'll see through it. But at least the functionality is working over here, right? So this is my key. The key should not get displayed over here, but it got displayed. Okay, let's see. Am I printing somewhere the API key? So API key is over here. Okay, it is also getting appended in the specific message, okay? But let's see whether everything is working fine or not. So here you can see, I asked what is machine learning, okay? Or here you can see, what can I search? Okay, let's see. I'll ask what is machine learning. Let's hit one more time, okay? So again, this is getting displayed. How can I help you? Search. Okay, there is some problem over here. Let's see. Some problem. So whenever I'm hitting a query, right, prompt, then it is writing the specific prompt. The simple reason is that because it is considering this as a prompt, okay? So that is the reason you'll be able to see that when I'm hitting this and I'm putting this particular condition, okay? Let's do one thing. Let's remove this for now onwards, okay? And let's reload it. We'll go ahead and reload it. I will quickly do one thing. I will put my API key, I'll press enter. And now I'll just go ahead and write what is machine learning. So now I'm getting the input because the API key was basically getting, hidden over there. So now you see the perfect thing. As soon as I search what is machine learning, it went directly to Wikipedia. Now see the interaction is also basically happening, right? Here you can see automatically Wikipedia is able to give some more information, okay? Then it automatically took the examples. Then Wikipedia is saying, hey, I have more details. Go ahead and see this, right? And here you can see, hey, Wikipedia is also there, right? And all the information here is the response. All the information is basically coming up, right? And finally, this is the output that I'm able to get. See, so much interaction is basically happening, right? This content is basically getting displayed. I'm printing it, right? Action, everything is going on, okay? Okay, tell me about the research paper, okay? Attention is all you need. And I'll go ahead and press enter. See, it went to Asif. Amazing, right? So here, now it is thinking. Now Wikipedia came into picture, okay? Then suddenly it went to search. Attention is all you need, Asif paper. Then again it went to search. See how the interaction is basically happening, right? I thought I understood that the user wants to know more about the research paper, right? Over here, this is the thought. Here's the continuation. The Wikipedia search found a relevant, but it is not a research paper. See, attention is all you need. You don't want to know about this Asif. Attention is no good Asif result was found. Amazing, right? So this automatically, this is like, you have independent tools who are interacting with the outside world. It's like I'm having 4 people who's probably doing all the search and who's probably, making sure that all the things basically happen. And one error is over here, handling parsing errors, okay? An output parser, this is that I could not parse LLM, thought I have found multiple research paper, okay? So let's see, we'll try to fix this also, but I think this is just because they've actually got multiple results, like no one is coming to the right purpose, right, over here. So now, let's see, I'll go ahead and write attention is all you need, okay? And I'll just go and search for this research paper, okay? I will say, hey, provide a summary of. So here you can see that automatically all this summary will be found out by Asif, right? Here, all the information. Once the summary of attention is all you need, then again it is doing this. It did not have to probably go with or ask any other tools. The user is asking title this. All the information is over here. The user is asking for summary of the research paper, which is a published paper on Asif. Right? So this is going on, and this interaction will keep on going ahead, and finally you'll be able to see some output. It will be able to probably provide you. Okay, but here I see that it is also going into that entire loop. Agent stop due to iteration limit. Yes. So this can also be one type of problem. We'll see in the upcoming videos how we can fix this kind of problem also. Okay. So let me just go ahead and ask just like this. Okay. I want tell me about the research paper. Nothing but this. So here you can see the user is asking about a specific, I have a tool to search for it on RCF, right? Then Wikipedia, then all this interaction is coming, and this paper is this, authored by so and so, all the information is over here, right? Let me just go ahead and search for something like what is generative AI. Now I think it should probably go with Wikipedia or search, right? So search is DuckDuckGo search, right? Thought the user asked multiple ranges ranging for general topics like what is the machine learning to specific. See, it is also using the chat history, right? And based on that, it is giving you the entire response, right? I've already provided brief overview. See, it's saying that again, I'll not go ahead and provide it. I've already provided it, right? Generative AI, right? And here are all the answers. So I hope you're able to understand this. Again, if you want to go ahead and explore more examples, you can go ahead and check it out over here, right? So yes, this was it about this entire end-to-end project. So we'll see some more errors that we are getting. I think I need to have a look why we got that specific error, but I don't think so. It is a major issue with respect to that. Unless and until we're having a good interaction between the agents, I think we can work out. One assignment that I really want to view is that try to integrate a PDF document Q&A along with these tools and try to add it also and try to see that how the interaction will basically happen. So yes, this was it from my side. I'll see you on the next video. Thank you. Hello guys, so we are going to continue our LangChain series, and in this video and in the upcoming series of video, we are going to develop this amazing end-to-end project, which is chat with SQL DB. So first of all, I will go ahead and show you the entire demo, what we are going to basically do. Over here, you'll be able to see that you'll be able to connect with SQLite 3 database, and this particular database is basically created in my local system. If you really want to connect to your SQL database also, you can go ahead and connect it. Okay, I will also show you how you can actually go ahead and connect this. I will be using Grok API key over here so that you'll be able to use open source models like Llama 3, Gamma 2, or any other models that are available or supported by Grok API. Okay, so let me quickly go ahead and show you the demo. So first of all, I will go ahead and show you with SQLite 3 database student.db. This is basically created in my local machine. So first of all, I will be requiring my Grok API. So quickly, let me go ahead and paste it over here. Once I press enter, here you can see how can I help you. It is basically saying. So let me just go ahead and ask display all the records in the student table. Okay, so once I press enter, you'll be able to see that the list of records, it starts interacting with it. It is going to automatically create the query, and finally I'll be able to get the entire response. Okay, so here you can see Krish, John, Mukesh, Jacobs, Dipesh, everybody's over here, and the records is basically been retrieved, right? And if you see over here, it is first of all going to see like which all tables are present over here. Then, and this all are exactly done by the agents. And in LangChain, there's a SQL toolkit that is provided by LangChain itself. We will also be using that. So here you'll be able to see all the information. Finally, your query will be SQL select start from student. This is the action, this is the action input, and this is the output, right? And finally, we are able to get the output. So this is through one way. The other way is that you can also connect to your own SQL database, and here you have to provide your SQL database connection. So let me just go ahead and write it over here. So let's say if I go ahead and write MySQL. So this is my host. Let's say the SQL is installed in my host itself, right? So here I will be going and hitting this. I will remove this. I don't require this. So this will be my SQL host, and this is where my SQL is there. I've installed in my local machine. I will show you how you can probably take out this host information and all. My SQL user is root. I will go ahead and give my password as 12345. Let's say my SQL database is student. Okay, I will go ahead and hit it over here. And finally, I will just go ahead and press enter. Okay, so once I press enter, here you'll be able to see that if I go ahead and ask the same question, display all the records in the student table, I will be able to get an answer. Let me ask some other question. Display the record where the student name is Krish. Okay, I'm just going to type like this. Let's see whether it will be able to retrieve or not. Now it is basically hitting my SQL database over here. So here you'll be able to see that the entire record has been displaced. It has been displayed over here. And what are things it basically used? It used SQL DD list tables to get the list of tables in a database, which was 3 databases that actually created. If you see over here, there are 3 databases inside my table. Let me just refresh this quickly. So here is search info, student, and student info. It was able to capture that. Then it went and saw the student table. It contains the column name, and then it is using the SQL DB query checker internally, which is available in LangChain, and found the original query was correct. And here you can see all my responses over here, right? So overall, an amazing project to work with. Here the most beautiful thing will be that we will be using LangChain toolkit, right? So if you go ahead and write SQL toolkit, right? So we will also be using this, right? SQL agent toolkit. Again, which is the kind agent type, will be using this. I will be showing you how we can actually go ahead and set up for our entire project, right? So I hope everybody understood about the problem statement, what we are trying to solve. Step by step, we'll try to solve this. And as shown in the previous video, like how the interaction happens with respect to each and every agent, and conversation basically happens with the help of toolkit. Everything will be happening over here. And this is how we'll be able to get the final answer along with the explanation, right? So yes, let's go ahead and start this particular project in the next video. I hope you all are excited. So I'll see you all in the next video. Thank you. Hello guys, so let's continue the specific project, and now we will go ahead and implement it step by step. Initially, what we will do is that we will work with creating our data in our SQLite 3 database, and along with that, I will also be showing you how you can run the query in your SQL database. The prerequisite is that you really need to have some knowledge with respect to SQL database itself. You should at least know how to install this MySQL workbench, which is available in my system right now. But I will just give you an idea from where you can go ahead and install it, and then you can probably continue, right? So first of all, let's go ahead and create my SQLite.py file. Now inside the SQLite.py file, I will write all the code that is actually required in order to create a database in my SQLite 3 with the help of SQLite 3 database. So first of all, we will go ahead and import SQLite 3. Remember, SQLite 3 is it will be inbuilt available with Python 3 itself, right? With the recent environment with respect to Python. Right now I have Python 3.10, so obviously you'll be able to have SQLite automatically installed. So I'm going to import SQLite 3 database. Then we will go ahead and write a code to connect to SQLite. Okay. Then here I'm going to basically go ahead and write connection is equal to SQLite 3.connect. I will say, hey, SQLite 3.connect, and I will give my database name. Let's say the database name is student.db. Okay. Then we are going to create a cursor object to insert record create table. Okay, so we are going to basically go ahead and do this. And one more thing over here is that you really need to have cursor.connection.cursor. Okay, so we will be having this. Okay, and I will go ahead and create this. Then let's go ahead and create the table. Okay, we are going to create the table over here. In order to create a table, first of all, I'll give some table info, and I will go ahead and write my command that is required. So the SQL query for this will be create table name, which is nothing but student. I'll say student. Here, the first parameter that I'm actually going to take is name. Name will be varchar. So I will say varchar with respect to 25 characters. Then I'm going to put my another feature inside this particular table, which will be my class. So I'll say, hey, class is nothing but, again, it should be a varchar. So here I will go ahead and, or let me just go ahead and write all these things in the capital letter. Okay, so that we'll be able to distinguish with respect to a common query statement. So here I'm just going to say, hey, let's go ahead and first of all create the student table over here. Okay, and then I have my name varchar with respect to 25. Then I have my class varchar. Okay, it will be a varchar. Varchar basically means it will have alphanumeric values and the maximum limit will be 25. Okay, then we have, let's say, one more parameter I'm going to take over here as section, and this will also be my varchar of 25 length. And finally, I'll have my marks. Marks can be of integer. Okay, so all these values, this is the skeleton behind the entire table that we are going to create. Okay, now in order to execute this SQL query and probably create this particular database and table in MySQLite 3, I will just go ahead and use the same cursor and I'll go ahead and write dot execute, and I will give the table underscore info over here. So once I give the table info, that basically means this entire query is going to get, quickly, this entire table will be created automatically. Now, the next thing is that after executing this, we will also go ahead and insert some more records. Okay. So for inserting some more records, what I will do is that I've written again this cursor.execute, and here you'll be able to see that I've used this insert into student values over here. And I've added values like Krish, data science A90. So this basically means the first name of the student is Krish, the class that Krish is present is in data science, and then you have the section information, and finally you have the marks, which is an integer value. Similarly, I've added more records over here with respect to John, data science B, insert into student values Mukesh, data science A, then you have insert into student values Jacobs, DevOps A 50 is the marks, and finally you have this particular last record that is basically being inserted. Okay, so once I go ahead and execute this cursor.execute, automatically it will make sure that it will insert all these records. Okay, next I will go ahead and display all the records. Okay, and here I'm going to go ahead and write print, and I'm going to say, hey, the inserted records are. Okay, and then what we will do, we will go ahead and use another cursor.execute, and I'm going to basically go ahead and write select star from student. Okay, so I'm just going to say, hey, select star from student over here in capital letters. Okay, and I'm going to probably retrieve all this particular result. Okay, now once I execute all this select star from student, obviously I'm going to get 4 to 5 rows. So rows will be in the form of list over here. So what I will do, I will go ahead and write, hey, for row in data. Okay, data, and here I'm going to go ahead and print my row. Finally, we will go ahead and commit your changes in the databases. So for this, I will go ahead and write connection.close. Always you need to write this one whenever you execute any query. Okay, so before the connection closing, I will also go ahead and write connection.commit. Okay, so this is how you basically go ahead and write this entire query. You quickly, just under 5 to 10 minutes, I've written this entire thing where I've inserted some number of records. Okay, perfect. Now what I will do, I will go ahead and open my terminal over here. So I'll go ahead and write cd dot. I will go to cd6, my chat SQL. Okay, I'll clear the screen. Now let me quickly go ahead and write Python SQLite.py. So once I execute this, here you'll be able to see that it will go ahead and create this particular DB. And inside this DB only we are creating this table, right? So let's go ahead and execute it. And right now you can see nothing is there inside this particular file, inside this folder. So let's go ahead and execute it now. Once I execute it, here it shows, okay, cursor has no attribute cursor. Did you mean cursor? Okay, line number 7. Let's see. Connection.cursor. Okay, perfect. No worries, we will usually get this kind of error. Now I will go ahead and write Python SQL.py. So here you can see the inserted records. I will also make sure that the spelling is right for this. So inserted records is all these things, and here you can see student.db. So I have actually prepared my data with respect to one of the SQLite database, and now you have the student.db available over here. Now, similarly, I will also go ahead and do the same thing for my SQL server, which will be a standalone application which you can also install it in your local machine. Okay, and that is what I'm actually going to show you in the next video. As a prerequisite for this project, you at least need to have some idea about the SQL database. Okay, so that is the reason why I'm telling you that. Without that, if you don't know how to install SQL Server, then it'll be difficult for you all to understand. Okay. Hello, so we are going to continue discussion with respect to this particular project. And now in this video, I'll just give you an idea how you can go ahead and install the MySQL Workbench. So just go ahead and search in Google SQL Database Workbench, and then you'll be getting a button which is called as Download MySQL Workbench. After you get this, so here you can probably go ahead and select your operating system, like whether you're using Windows, Linux, Fedora, macOS, or anything that you want. Let's say you want to go ahead with Windows, so just go ahead and click on this. After you click on this, I'll just go ahead and I don't want to log in it, so just say no thanks, just start my download. Automatically the download will start. Once you do this, again you can double click it and you can just click on next. Make sure to press all the check buttons that is available over there and go ahead and do the installation. Anyhow, I as a YouTuber have also created an amazing playlist in YouTube regarding complete MySQL and the tutorial itself. I will be giving you the link just before this particular video, I guess, and then you can also make sure that you can watch those videos like how to do the installation. But after you do the installation and once you do the SQL connection, right? So this is how things are going to look at. Here you can basically go ahead and write your query. You can use your database. So this definitely requires a lot of tutorials with respect to SQL itself. So for my sake, like what I'm actually going to do, I'm going to probably go ahead and create my student table. So what I will do, I'll just say, hey, drop table student. First of all, since I've already created the student over here, so I will go ahead and execute this. So I'll just select this and execute it. Okay. So once I drop it here, you can see I'm not getting this particular student table. So this is my database that I've actually created. I will just go ahead and create a student table over here, right? So here you can see I've written create student table student name varchar, class varchar, section varchar, marks end. The same. All the commands are almost same like how we have actually used it. And I'm going to use this particular database. So once I execute it, here you can see it has got executed perfectly. Now quickly, let me just go ahead and write select star from student. And once I execute this, you will be able to see all my records. So here are all the records that I have, right? So this is the basic way of just executing a query in my SQL database. And in my MySQL database, what I'm actually going to do, I'm going to read this entire table, right? And I'm going to probably get it. As I told you before, this particular module only, I have given you the entire SQL playlist from my YouTube channel. You can definitely go ahead and watch it over there. But once you prepare this entire student table, now it's time that we'll start building our project in our next video. So let's go ahead and I'll see you all in the next video. Thank you. So guys, now finally we will go ahead and start our development of our application. So here inside this, I will go ahead and create my app.py file, and this will be my Streamlit app.py file. So initially what I will do is that quickly go ahead with installing some of the basic libraries. So first of all, I will go ahead and import Streamlit, okay, as ST. So once we import the Streamlit, which we are basically going to use for our entire application, I'm also going to install one more library which is called as pathlib, so that I will be able to get my absolute path over here. In in LangChain, we have an agent, right, which will actually help us to create the SQL agent itself. As I told you, at the end of the day, there will be a kind of SQL toolkit that we are going to run, and that entire toolkit will be able to run with the help of SQL agent itself. So in LangChain, you have something called as create SQL agent. So you can probably go ahead and just see the definition around it. So let me just show you once, like how you should probably go ahead and refer it. So here I'm going to go ahead and write LangChain SQL agent. Okay, create SQL agent. So let me just go ahead and write create SQL agent. So this is just like creating a different kind of agents itself, right? So once I click this here, you'll able to see about the create SQL agent. So that is what we are going to use over here, right? And with the help of this create SQL agent, right? So here you can see while using OpenAI function called API to drive this, we use this. And specifically, if I go ahead and see this particular reference of create SQL agent, so here we are going to use this. It creates a SQL agent from an LLM and toolkit or a database, right? So this is what we are going to basically use over here, right, in our application. So for this, we will be using create SQL agent. One more important thing that we use specifically for the SQL database is this particular library. I'll talk about it. Why do we use it? Now, after importing this particular library, let's see what all other libraries we will be requiring. And as I said, first of all, there will be an agent that we really need to create, and the inbuilt SQL toolkit is also available. So for this, we will be first of all using one agent type. Then this Streamlit callback handler, which we have also used in our previous project. And this is what I'm actually talking about, the agent toolkits, which is nothing but the SQL database toolkit, which we are going to specifically use. Okay. Again, you can go ahead and see the documentation about this entire toolkit more detail if you really want to know and understand. Okay. Now, finally, what I will do is that I will go ahead and write from SQL Alchemy. Okay. This is also what I'm actually going to use. SQL Alchemy will actually help you to map with respect to the output that is specifically coming from your SQL database. Okay. So here we are going to import this something called as Create Engine. This is one of the another library that we will be using. Okay. Along with this, since we are also going to work with SQLite 3, so I'm going to write SQLite 3 over here. Okay. And then finally, since we are using LangChain underscore Grok, I'm going to go ahead and import chat Grok. Okay, so this is what we will be using to interact with our open source LLM model. Okay, now quickly we will go ahead and set our page configuration of our Streamlit and of our title. I'll say, hey, LangChain chat with SQL DB. This will be the page title. Icon, I've used this particular bird symbol, which is very much famous in Streamlit. Almost everybody who's creating this kind of application uses this kind of bird symbol. Okay, one major problem with Streamlit is that with the chat with SQL DB is that there may be some kind of vulnerable prompt injection. Okay, so prompt injection kind of warnings I can actually give it. So use a DB role with limited permission. So please make sure that you give this kind of warning so that it will be shown in the red color. Okay, so till now I'll just remove it. I will just try to add it in the later stages. Now quickly I will go ahead and create my two local variables, two global variables. One is my local DB. I'll say, hey, I'll create this particular variable. I'll say, hey, use local underscore DB, local DB over here. Okay, and then I will say, for MySQL, I will create this particular variable value, use underscore MySQL. Okay. The reason is very much simple because I am trying to implement with respect to two databases. Okay. Now, what we'll do on the left hand side, we will create some radio option. Okay. So here I'm going to basically go ahead and define some radio options, radio button, like kind of thing. So here I will go ahead and write radio opt, and here we are going to specifically use SQLite 3 database. By default, I will give two options with respect to this particular radio option. I'll say, hey, the first DB is interact with the student.db, and the second DB is nothing but connect to your SQL database. Okay. So these are the two things that I'm going to specifically use. Okay. Then you have the selected underscore opt. Okay, selected underscore opt, and here I'm going to basically use, I'm going to say, hey, create this two radio button on the sidewise. So I'll say use ht.sidebar.radio, and here I'm going to basically use label. I'll say, hey, choose the DB which you want to chat. Okay, something like this. And here I will give two options, which I've actually defined in my radio opt. Okay, so here my second parameter is something called as option, and here I'm going to basically define it to radio opt. So this in the left hand side in the sidebar, it just gives you a kind of two radio buttons which you can probably select. Okay, so all this information is done till here. Now let's say if I am selecting, so I'll go ahead and write if radio opt dot index. Whenever I probably select this radio opt buttons, I will be getting some kind of index. So here I'm going to write if this opt dot selected operation or selected option is double equal to 1, I am going to say that, see, if you're selecting, and every index in Python starts from 0. Similarly in radio option also. But my first option is with respect to the student.db. First, zeroth option. This is my zeroth index, and this is my first index. Since I'm selecting the first index over here, then my DB URI will be, DB underscore URI will be nothing but I'll just set it to MySQL. Okay, MySQL over here I had created this particular variable. So MySQL is nothing but it's saying use MySQL. Okay, and whenever we select MySQL, we need to show 4 more options, and this MySQL is with respect to my local database that I've actually installed, the MySQL workbench. Okay, so here first of all I will be requiring MySQL host, and with this I will go ahead and write ht.sidebar. Again, I say for this MySQL host also I will be requiring some information, right? Without this information I will not be able to connect it to my MySQL workbench. So for connecting it I will be requiring some information like MySQL ht.sidebar. I'll be using a text input and then say, hey, provide MySQL host name. Okay, I'll say like this. Okay, so this will be the first parameter that I will be requiring in order to connect it to my SQL workbench. Okay, then the next thing that I actually require is my MySQL user, and here we are basically going to again go ahead and write ht.sidebar.text underscore input, and here I'm going to basically use MySQL user. Okay, what is my username? Okay, so this will be the second parameter that I'll require. First, provide MySQL host, then MySQL user. Along with this, I will also be requiring my password, right? MySQL underscore password. These are the basic information, and I'll try to show you how we can map this with our MySQL workbench. Okay, so here I will just go ahead and create this particular variable MySQL password, and here also I will go ahead and write my ht.sidebar.text underscore input, and here I'm actually going to give MySQL password, and with respect to this I will go ahead and write type is equal to password. Okay, here we are going to specifically give the password itself. Finally, I will go ahead and write MySQL underscore db is equal to ht.sidebar, because here also I have to give my database name, which database I really need to interact. So text underscore input, and here I will be having my SQL database. So this all information the user needs to provide from the application itself. Okay. So that is the reason we are taking this information. Now, what does this basically mean? Like, if I go ahead and select connect to your MySQL database, okay, if I go ahead and write like this, that basically means we are going to connect to our MySQL workbench. So for this, you require information like MySQL host, user, password, and DB. Okay, this is all the information that we definitely require. If we select the first option, so I'll go ahead and write in the else block. If we select the first option, then my DB URI will be nothing but it will be just pointing to this local DB. Local DB is nothing but it says use local underscore DB. Okay. Now finally, if this selection is done, and you know that this all information will be displayed, By taking all this information, I just need to connect it in the later stages. Now, I also require one important API key, that is my Grok API key, right? So here, what I will do, I will use this. I'll say, hey, let's use this sidebar st dot sidebar, and I'm just going to say, hey, while we are using this, let's go ahead and use our text input. And inside this text input, I'm going to give my label. The label will be Grok API key, and the type will be password over here, because I really want to keep this all things hidden. Okay. So through this we will be getting our API key, we'll be getting our DBI URI and all, right? So now, first of all, I need to make sure that all this radio option button needs to be selected, and this API key needs to be given, right? Unless and until these two are not given, we cannot chat with the database. So what we'll do over here is that we'll write two important conditions. Okay. One is if not DB underscore URI, then I will just go ahead and write st.info. So inside st.info, I will go ahead and say, please enter the database information and URI. Okay. So I'm just going to go ahead and tell you this information that I really want. Other than this, if the API key is not given, so if I go ahead and write API underscore key, I'll say st.info, and here also I'll say, hey, please add the Grok API key. Okay, so some kind of message if I'm not giving this to information. Okay. Now the next thing is that I will quickly go ahead and call my LLM model. So here I will just go ahead and call my LLM model, and here what we are going to basically use is nothing but we are saying chat Grok. First of all, I need to give my API key, which is nothing but the API key that I have actually created. Okay, so this will basically be my API key. Okay, it should be Grok API key, I guess. Okay, and this will basically be set to my API key over here. Then you have this model underscore name. I will try to give my model underscore name over here. For this case, I will just use Llama 3. Again, it is up to you with respect to Grok. You can use any model that you want. Okay, so I've written Llama 3 8,000,000,8192. And finally, I'll go take one more parameter, that is streaming is equal to true. Okay, so once I get this LLM model, I'm going to use this LLM model over here with my SQL toolkit, right? Now, I will go ahead and create one very important function that is called as configure. So here I will say configure underscore DB. I will go ahead and configure our DB itself. And for this, I will use a decorator which is called as st.cache resource. We want to probably cache this because we don't have to connect each and every time. And here I will take the TTL time is equal to turnaround time, total time limit, I guess. Yes. So this will be somewhere around 2 hours. I'm saying that till 2 hours you can keep it in the cache. Here, the first parameter that I'm actually going to give is my DB underscore URI. The second parameter that I really want to give is my SQL underscore host is equal to none. Okay. Because all this information I definitely require, right? MySQL host I require, then I require this MySQL user. So I will go ahead and copy it over here. I'll set it to none, right? Along with this, I also require my SQL password, right? So I will just keep this as none. With all this information, we are just going to explore it or take it from there. And by default, we will be keeping it as none. Okay. And then you have also MySQL DB. So this will also be none. Okay. So all this information I'm actually specifically giving over here, and then we will close the bracket and open the function from here, right? So I will go ahead and open the function. So this will basically be my configure DB. Now here I will just go ahead and write if my DB URI, okay, is equal to if my DB underscore URI, whatever DB URI that I'm assigning, if it is double equal to local DB. Okay, if it matches the local DB, what we will do, we will go ahead and set up the file path to our DB file that is present over here, because here this local DB is nothing but your SQLite DB, right? So here we'll go ahead and write DB file path file path is equal to, here I'm going to quickly write path, and let me just give the file path like this by default file path, and I'll say this is just mainly to get your if you really want to understand what we are specifically doing this, if I just go ahead and write dot parent, okay, this dot parent, if you just go ahead and print this particular information with respect to this particular file, and the file information that I'm actually giving is student.db, okay, this I will try to give it in the string wise. So this in short is creating an absolute path, okay, absolute path. So this will basically be your parent path itself, right? Above this what exactly is present, and then here I will just write absolute, get the path, complete path, and actually get the absolute path of it. Okay, so if you just go ahead and print it, you'll be able to understand. So if I go ahead and print over here, I'll say df file path. Okay, so this is my, it's not df, it should be db. Okay, db file path. So here also I'll go ahead and write my db file path. I'll just go ahead and print it to just show you what will the path that will be connected over here. Then again, there are two lines of code that I'm going to execute after this. First of all, I will go ahead and write creator lambda SQL connect, and this will be the same path that I will be using over here. The mode will be on read bytes, right? We will be basically reading bytes from this particular SQL. So for this, we use SQL3.connect to connect to that particular file, and URI is equal to true. And for this, we'll be using a lambda function. Okay. Finally, after executing this, you'll be seeing that we'll be returning the SQL database, which will be an engine inside this. So that is the reason you can see that we have imported LangChain.SQL database, import SQL database over here. So it is nothing but create engine, SQLite over here, all the information with respect to this, and creator is equal to creator, whatever information is present with respect to this particular file path. Okay. And that is the parameter that is required in create engine. Now similarly, here I will just go ahead and write elif db underscore URI is double equal to MySQL. Okay. If it is double equal to MySQL, then what we do over here, if it is not equal, if it is double equal to MySQL, and first of all, I'll say condition. If any of the parameters is missed, like if MySQL host, MySQL user, or MySQL password, or MySQL DB, if any of the information is not provided, then we are just going to go ahead and display st.error. Okay, this is important so that we'll be able to handle the exception over here. Otherwise, we will go ahead and return, and this is how you connect to the MySQL database. Okay, so this is important. Okay, so here, what we will specifically say that if this is working absolutely fine, I'm just going to say, hey, return this entire information. So what we are returning over here, SQL database, create engine, but here we are going to use MySQL connector. Usually when you're connecting to the MySQL workbench, we basically use the MySQL connector. After this entire URL will be basically created. Here you will be having your MySQL user, then you will have your MySQL password, then you will have your MySQL host, and finally you will have your MySQL DB. Okay, and this is the way how you specifically connect to your MySQL database. And for that we use this particular create engine along with the SQL database, right? So this is how you basically go ahead and connect to the MySQL. Okay, so this all information is done. Either of these two options when we select. This is how we configure the entire DB. Okay, now in our next video, okay, in our next video, and before this I go ahead, I have to call this configure DB, right? So let's say if I go ahead and say if I DB underscore URI is it double equal to MySQL, then what we are going to do is that we are going to basically configure it. I'm going to write db is equal to configure. I'll call this configure db function, and inside this I will give my db URI. First parameter is my db URI. The second parameter is my SQL host. Okay, my SQL host over here. The third parameter is specifically called as my SQL user. The fourth parameter that I'm actually giving is MySQL password, and the fifth parameter that I have is nothing but MySQL DB. Okay, so all these parameters we are passing it over here for this particular database, and automatically it will configure this particular database. I will be getting this particular data phrase from this particular function, right? It is returning the SQL database itself. In the else section, what I will do, I will just go ahead and say DB is equal to configure underscore DB, and here I'm going to give my DB URI. So in this particular local DB case, I just need to give my DB URI, and automatically it will be able to take this entire information and it will be able to execute it. Okay. Yes, I think all the information is specifically done over here till here. Now in our next video, I will start creating our toolkit. So this is for our whatever work we have basically done. This is mostly about connecting your database, which database you are specifically connecting. Okay. Now, whenever I try to use this toolkit, what I will do is that I'm actually using an LLM model. I say, hey, please display the records of all the records in the student table. Then this LLM model will probably create a query for us, and then with the help of that particular query, we will try to interact with this, right? Interact with our database. So that work is basically done by the toolkit itself. So that is what we are going to see in the next video. So I hope you are able to understand till here. I hope we are going on good. So yes, in the next video we'll be discussing more about it. So yeah, I'll see you in the next video. Thank you. So guys, we will be continuing with respect to our end-to-end project. Already we have developed all these things where we have configured our LLM, we have configured our entire database, which database to connect when. Now let's go ahead and run this. I also want to probably check whether this is running fine or not. So I'll go ahead and write streamlit run app.py just to verify is everything fine. So here you can actually see my page getting loaded. So here you can see both the options are over here, right? To select this, and if I select, I'm able to see all my other details. And it is asking for Grok API key. So that is what I'm going to provide. I've already provided the field over here. Now, as soon as I put the information, I'm able to configure that part. Also, I've actually done it. Now the thing is that I need to probably create a text box this side, and whenever I fill up all this information, I should be able to interact with my database. So that is what is basically remaining. And for this, we really need to work with something called as toolkit. Okay, so that is what we're going to design in this particular video. Okay, so let's go ahead and let's quickly start working on this. So first of all, I will go ahead and create my toolkit, and this will be nothing but it will be a SQL database code toolkit. I'll use my DB is equal to DB, whatever DB I have actually I'm getting from configuring it. So once I call this particular function, I'll be able to get the DB and my LLM model, which I'm going to assign with my ChatGrok API, right? So this is done. Now what I'm actually going to do, quickly go ahead and create my agent, and here I'm going to use my create SQL agent. Okay. Now inside this, I have to probably pass my LLM model, which will be required for creating my SQL agent. Along with this, I'll go ahead and provide my toolkit details. What toolkit I really want. I'll also make sure that to keep this parameter verbose is equal to true, because I really want to see all the interaction and each and everything. And finally, we will go ahead and set up our agent type. The agent type will be nothing but the same agent type, and this I will also go ahead and use zero shot React description, which I've already told in my previous video itself, in the previous project that we have developed. Okay. Now quickly, what I will do is that I will go ahead and make my session state like how we did it, because we also need to maintain our chat history. So here you can see if message not in session session underscore state or st.sidebar button clear message history. I also will have a specific button. If I click on that, it will remove the entire history. Okay. So here you'll be able to see that st.session underscore state of message. I'm first of all adding this role and assistant, and I can say just how can I help you in the content. Okay. So this is the default message. Now what I'm actually going to do is that for every session message, right, I have to make sure that I have to integrate this like how we did it in the previous project. So I will just go ahead and copy paste. Oh yeah. So for message in st.session underscore state messages, I'm saying I'm appending everything inside this chat underscore message so that it has all the information. So finally, I will go ahead and create my user underscore query, and here I will go ahead and write st.chat underscore input. Okay, so let me just go ahead and write chat underscore input, and inside this I will go ahead and put a placeholder and ask anything from the database. Okay, so I'm going to put this entire information over here. If I go ahead and put my user query, okay, the next thing what I really need to do is that I need to append my session state with that specific message from the user, right? So for that, what I will do, I will quickly go ahead and add like this st.session underscore state.messages.append, where I'm going to give the role as user and content, whatever user query is basically getting added, right? Along with this, what I will say is that I will also make sure I have to add it over here in st.chat message. So st.chat message of user dot write user query. So we're going to write it over there with respect to the whatever the user query is there in the screen. Okay. Now we will go ahead and write for the st.chat underscore message, and here we are specifically going to use assistant. Okay. And again, in this, I will go ahead and create my callback. Okay, so I'll write streamlit underscore callback is equal to streamlit callback handler, and here I'm going to write st.container. Once I write this, this will be the callback which will be responsible in showing what are the chain of thoughts, and that will also be getting displayed. Finally, I'm going to go ahead and create my response, where I will be saying agent dot. We will be running this entire thing by taking the user query. Along with that, I'm also going to give my callbacks, which will be nothing but it will be the same streamlit callback which we are using. Okay, and finally, what I will do is that after this, let's see, I will just close it over here itself. And here in the next message, I will go ahead and write st.session underscore state dot messages. We need to append once we get the specific response. So that is the reason we are going to write dot append. And here again, we are going to use a role, since it is probably coming from the assistant itself. So I will be giving the role as assistant. And finally, you'll also be seeing that I will be giving my content. Inside this content, it will basically have the response. Okay, that's it. And let's go ahead and write this particular response so that we'll be able to see in the page. Okay. So this is the same thing. See, if you remember already in my search engine, I'd actually told you about the same thing, right? So this was the streamlit callback. The same thing I copied and pasted over there. So that is what we're going to use it, and that is how the entire interaction is going to happen. So let's go ahead and run this. So first of all, I'll go ahead and write streamlit run app.py. Let's go ahead and run it. I think it will open it. Okay. Now quickly, first of all, let's go ahead and interact with our SQLite 3 database, student DB. So for that, I really require a Grok API. So I'll quickly open this, go to my environment variable, use this Grok API, which I have actually used it, right? So I'll go ahead and paste it over here, press enter. Okay. So there is an option, see, clear message history. If I click on this, all the message history will go. Now I'll go ahead and say, hey, tell me how many records are, or show me all the records from the table. Show me all the records from the table. Now I think the interaction should start, right? So here you'll be able to see that everything is happening, empty string complete, select start from table, select start from student. See, over here it says, I did not even say that which table it is, student's table or not, right? So automatically, see, over here it went and says search for select start from table, right? And it gave us an operational error. So it again went back and it started seeing from select start from student, right? Then there was a syntax error, select start from database.student name, then student, right? Let's continue from where you left off. It looked like a query, I tried to execute the result. And finally here you can see all the data is basically getting displayed. So definitely was this entire interaction. This is all possible because of the SQL toolkit from LangChain. LangChain is quite powerful with respect to creating all these things. And that is the reason we basically use this. If you see in this code, what all things we have actually used it, right? So here, after configuring, we are making sure that we add this, and because of the Streamlit callback handler, right? This is making sure that it is interacting in such a way, and the features of functionalities of the toolkit is making sure that all the information is basically getting displayed, right? So if I go back again, let's see some more thing, okay? Display all the records from the student table whose marks is greater than 45, okay? Greater than 45. So I'll just go ahead and press enter. Let's see how this will work. Now, quickly, it is trying to get all the information. See, this is beautiful, right? I'm not doing anything. It's just like 3 to 4 people are working for me. And finally, you should be definitely able to get the answer. The final answer is that Krish Data Science greater than 45 and this, right? If you see from the query, select start from student when marks is greater than 45, right? All the specific information is going. Okay, let me do one thing, okay? I'll say display all the records whose marks is greater than 35 and less than 60. If I go ahead and write like this, I should also be able to get this, right? So see, so automatically the query is basically getting generated, which is quite amazing over here, right? And finally, you'll be able to see the students thinking, right? This is the thought of chain that is probably happening. And here I can probably see that I'm actually getting one record. Okay. Now, the second one that you can actually do is connect to my SQL database. Now, see, connecting to my SQL database is very simple. Let's say that I'll close this connection. Okay. You can see there are 2 connections that I've opened. So if I double click this, right? So over here, you can see localhost 3306, right? And if I go back over here, so, right? First of all, MySQL host is nothing but that local host, right? If I go ahead and write this one, right? So this is the same thing, right? And I'll just go ahead and remove this. And along with the port, I'll just go ahead and write localhost 3306, right? And over here, you'll be able to see that when I use root and use the password 12345, which is the default one that I've actually set, while installing it, I'll just say, okay, right? It goes back to this particular page. Now my SQL user is nothing but root, okay? My SQL password is 12345. My SQL database is nothing but student, right? So once I do this, once I press enter, you'll be able to see that no model name MySQL, okay? We really require this MySQL library. That is the thing that I did not do it. So let me do one thing, okay? Let me go back over here, go to requirement.txt, and I need to import 2 important libraries. One is SQL Alchemy and MySQL connector Python, and that is what we basically require, right? So let me just go ahead and write or create another command prompt, okay? So now I'll go ahead and install pip install -r requirement.txt. SQLite is working fine. This is giving us some error. Let's see why it is giving some error because of this package. And now once this package gets installed, I think it should be fine to run it, right? So now let's go ahead and run this. I will go back to my command prompt over here and let's run this, okay? Now here you can see I will close this one, I'll close this one, okay? So I'll connect it to my database. So first of all, I require this entire information from env. I will go ahead and take my Grok API key and go back to my, so first of all, I will go ahead and write my local host, and this is my local host, sorry, SQL host that I want. My SQL user is nothing but root. My password is 12345, and my database is nothing but student. And Grok API is this one. I'll go ahead and press enter. This looks fine. Display all the records from student table. Okay, I'll just go ahead and write this. So automatically, let's start from student. Everything is happening, thinking, right? And here you can see all the results is basically getting displayed. So this is how you can probably go ahead and create it. And this will just not support the simple queries, more complicated queries, inner loops, inner nested functions and all. Inner nested queries, you can definitely go ahead and try it out. Okay. So I hope you like this particular video. This was it from my side. I will see you all in the next video. Thank you. Have a great day. Bye bye. Hello guys, so we are going to continue the discussion with respect to LangChain. In this video and in the upcoming series of video, we are going to discuss about this module which is called as summarized text. Let's say if you have any kind of data source, it can be an unstructured file, it can be a structured file, it can be different types of file. What we will be doing is that we will be reading the specific files and then we will summarize the entire information that is present in that. Whenever we talk with respect to summarization, you will be seeing that there are 3 ways specifically in LangChain, okay, and those 3 ways also will be using, like stuff is one of the way, MapReduce is one of the way, and refining is one of the way, right? So first of all, we'll just get to know about this basic implementation, how to probably use stuff, MapReduce, and refine. And as we go ahead, we will be creating an end-to-end project, and in that end-to-end project, we will try to summarize text from both structured URL, or let's say from website content, or from an unstructured content also, right? Unstructured content can be YouTube videos, it can be Twitters, it can be Wikipedia page, and structured content basically means like how you have a data in a tabular format, right? So we will be using different data sets, and we will try to perform this end-to-end project. So that will be coming in the upcoming videos. But in this video, let's go ahead and start with this. I will show you all the 3 different types of techniques specifically in text summarization that we use. Okay. So first of all, what I'm actually going to do over here, you can see that I have imported the OS. Then from .env, we have imported load_env. This is just to import the environment variables. And I'm also going to use the Grok API because Grok actually helps you to connect with the open source LLM models. I don't even have to use OpenAI over there. Okay. Now quickly, what I will do is that I will make some cells. Okay. Now first of all, what I will do, I will just go ahead and write from LangChain. Okay. Dot schema. I'm just going to import 3 important things. Okay. So here I'm going to import AI message. Okay. AI message is specifically with respect to the response that we get from the LLM. Then you have this human message, and then you have the system message. So till now I've not even discussed about this. So that is the reason. In every module you'll be seeing, I'll be adding some of the new things, right? And LangChain is completely vast. Like I don't know, like what all developments will be happening in the future, right? So here what we're doing is that we're using this kind of schema, which will have AI message. AI message specifically refers to all the response that is coming from the LLM model. Human message is the kind of queries that we are specifically asking, and system message is the instruction given to the system how they really need to behave. Okay. Here text summarization will be showing. I will be showing you with the help of prompt template with the different types of techniques also. Okay. So first of all, let's go ahead and import all these things. Now I'm going to take a specific speech. Okay. It is a long speech from our honorable Prime Minister Narendra Modi ji. Okay. So this particular speech, specifically in India, you have this famous speech over here, and I'm taking this. It's spoken like mostly the things that are spoken over here are related to Indian government and what all developments are specifically happening. So I'll just go ahead and execute this. So what I'm actually going to do, I'll take the speech, okay, and we will probably go ahead and summarize this entire speech, right? That is what is our task. So what I will do over here, I will just go ahead and give some basic prompts. I'll say, hey, let's go ahead and create this chat message. It will be a kind of list, okay? The first default instruction that I'm giving is with respect to system message. I'll say, here is my content, and you need to behave in this way. So I'll say, hey, you are an expert with expertise in summarizing the speeches, okay? So there is your first one. Then let's go to the next one. Here I'm going to probably go ahead and write human message. And again, with respect to the content over here, I will go ahead and use an F string. And I'll say, hey, please provide a short and concise summary of the following speech. Okay. And here I will just go ahead and give my text placeholder. Okay. And this text placeholder will be assigned with a variable which looks like the speech. Okay. And this speech will be is given over here, right? So here we are just setting up this chat underscore message over here with respect to system message and human message. In the human message, we are just telling from the human side what information is basically going and what we really need to, what the LLM model needs to do. And the system message is the kind of instruction, like what that LLM model has to do with respect to its functionality. Okay. So all the things are specifically mentioned over here. Now, quickly, what I'll do is that I've already initialized my LLM model. So I will just go ahead and execute this. Okay. First of all, now I will go ahead and write LLM dot get underscore tokens. Okay. So I think there should be get underscore num underscore tokens. So this will first of all determine how many number of tokens are basically present in the speech, right? So if I execute this, it will take some amount of time based on the kind of LLM models that you're specifically using. And then we should be able to see over here, right? Let's see why it is basically, okay, it is showing 909 as your, the tokens, number of tokens over here, right? So 909 is specifically the number of tokens in your speech, okay? Now, if you specifically want to see the content from this particular thing, or let's say, I'm just going to go ahead, and here you can see in this particular LLM model, I have created this chat message, okay? This chat message is also acting like a basic prompt, like what I'm saying that what the LLM model needs to do, and what is the human message that is probably going over here. Based on the chat message, I can also go ahead and pass this particular chat message over here, and if I just go ahead and explore the content, this will be my summarized text. So here you can see summary. The member of the parliament emphasizes the importance of ensuring the government schemes reach their standard beneficiary. He highlights the Viksit Bharat Sankalp Yatra as an initiative to access the effectiveness of government. So this is the entire summary, and this is one way of creating the summary where I probably go ahead and create a list of chat message where what is my system message that I'll mention and what is the human message that I'm going to mention. Over here I'm going to provide it as a parameter which with respect to the entire speech, and with respect to the chat message if I call with respect to LLM, I will be able to get the entire summary. Okay. If I just remove this dot content also, you'll be able to see that I will be able to get the entire response AI message. Now this is very much important. As I said, AI message is the response from the LLM model, and this is one way how you can specifically go ahead and summarize the entire content. Okay. Here you can see the output tokens. Here output tokens, input tokens were 895, right? And now you have this output tokens to 108. So this entire 895 tokens has been summarized to 108 tokens. Okay. So this is one way of getting the summary. Okay. Now, similarly, I will show you multiple ways, right? This is one way, right? But this, do you think it will work if your messages or if your entire speech is very huge? If it is of 100, 200 pages, then at that point of time, what you'll do? Now, the second technique that I am specifically going to use is nothing with, I will create a prompt template first of all, and I'll say with this prompt template, I'll try to perform my text summarization. So this is my second step that I am going to show you, a second way, okay? And remember, all these ways will be very important when we are actually creating our end-to-end project, okay? So here, first of all, I will go ahead and write from LangChain, okay? Or from LangChain.chains. I'm going to import LLM chain. Now, let me just go ahead and talk about this LLM chain. What exactly is LLM chain? Whenever we combine a prompt template with an LLM, right, we basically say that as an LLM chain. Okay, you have actually seen in the initial stages of our course, right? There we had specifically used, like we used to create an LLM. Along with the LLM, we used to also create prompt. Along with the prompt, we used to also create our string output parser. So all these things we used to create. Now, in order to create a chain, we used to combine something like this: prompt, LLM, and your string output parser, right? Something like this. But in the case of LLM chain, we just use this too. We don't use a string output parser because whatever will be the default string output parser, that will get the response with. Okay. Now in this case, what I'm actually going to do, I'm going to use this LLM chain. Along with this, I'll go ahead and define my prompt template. So I'm just going to from LangChain, I'm going to import and I'm going to import the prompt template. And prompt template is specifically with respect to the kind of prompt that you really want to create. Okay. So here, let me just go ahead and create my generic prompt template. So here I'll go ahead and write generic prompt template, and let's go ahead and write my prompt. Okay. So now with respect to this particular prompt, you need to understand one very important thing. How do we write a prompt over here, right? So I'll say, hey, write a summary of the following speech. Okay. And I'll say, hey, this is what I'm actually giving as a prompt. Okay. Now I need to give my speech. The speech will be given in the form of an input. So this will basically be my input over here, right? Speech is called speech. Now I'll also add one more task. Let's say I'll go ahead and say, hey, translate the precise summary to this specific language, whatever language I have. Okay. Now I'm doing one more additional task. I'm just not getting the summary. I'm also converting that entire summary to a specific language. Okay. So this actually becomes my generic template, and this is what prompt engineering is all about. Here I'm actually giving two inputs. Okay. Now in order to convert this into a prompt, I'll just go ahead and use the same prompt template. Inside this prompt template, first of all, I need to go ahead and mention my input variables. Okay. So when I mention my input variables, there are two input variables, and this needs to be provided in the form of list. One is speech, and the other one is something called as language. Once I give the speech and language, then I also need to give my template over here. So the second parameter that is basically used is something called as template, and this template will be assigned to my generic template. Okay. Now if I just go ahead and execute this prompt, you'll be able to see that this is my prompt template with input variables, language, and speech. This is my template. Write a number of summary of the speech, and here I have assigned this particular placeholder. Now if you just pass this input variable, you can also see the entire prompt. So for that, I'll just go ahead and write prompt.format, and inside this, I will give my two input variable. One is speech, okay, one is speech over here, which will be assigned to our speech value that we have given as a parameter. And then I will also go ahead and pass our language. Let's say I want to convert this into French, this entire summary into French. So once I execute it, now you can see, write a summary of the following speech. Okay, the entire speech is over here. It is placed it completely over here, and in the end, you can see translate the precise summary to French. Okay, so this actually becomes my entire prompt. Okay, now what I'm actually going to do over here is that once I get this specific prompt, okay, I will just save this in our prompt. I'll write, okay, this is my complete underscore prompt. Okay. And this is what I will go ahead and execute it. Okay, I'm just saving it in a variable over here. Now let's execute this specific prompt. Okay. Now in order to execute this specific prompt, you could see, right, initially my number of tokens were 909. And now if I go ahead and see with respect to my token, it is nothing but LLM.get num tokens. Okay. And in order to just pass this complete prompt, I'll pass it over here. And if I execute it, here you can see now it has increased to 931. Why it has increased to 931? Because along with the speech, I've also put some more additional information over here, right? This all. And this will also be added in the form of tokens. Understand, with respect to every LLM model, there is a restriction with the number of tokens, right? Right now, it is fine, 931 tokens. Most of the advanced LLM models will just consider this many number of tokens in a very much easy way and will be able to execute and give you the response. But there are also some limitation with respect to other LLM models with respect to maximum number of tokens. Let's say if in our case, our speech was somewhere around 25 pages. At that point of time, our token would have increased more than 10,000. If I see with respect to OpenAI GPT 3.5, there was a limitation of 4096 tokens with respect to the input that we give, right? So it is necessary that whenever we try to give this kind of tokens, we also try to split it. But till here, just fine. Let's run this entire thing now, okay? Based on this complete prompt over. So I'll go ahead and write LLM underscore chain. Now I'll go ahead and create my LLM chain. As I said, if I have an LLM model, along with this, if I have the prompt prompt is equal to prompt. Okay. Only in this two case, I'll be using an LLM chain, and this chain will be responsible based on the prompt how the LLM needs to execute and provide the response. Okay. That is the information that you'll be able to see over here. Then I will just go ahead and write my summary, and here I will say LLM underscore chain dot run. Okay. Now, in order to run it, what I will do is that quickly I will go ahead and write speech. What will be my input that I need to give as my input variable? Speech, which will be colon equal to speech, and then you'll also be seeing I will go ahead and write something like my language, and this language will be nothing but, let's say I will go ahead and write French. Okay, and then finally I'll go ahead and see my summary. So this is going to take some amount of time, I guess. Okay, perfect. See, that is the power of you can basically see the power of Grok, right? How fast it was. And here is your entire information in French. Obviously, I cannot understand it, so let me just go ahead and convert this into Hindi. But I think Hindi will be able to understand. So summary is that विषय में it is written. I'll just read it in front of you. I don't know how many of you know Hindi, but विषय में लोक सरकार राजनीतिक और सामाजिक गतिविधियों में शामिल होकर. So this is one way of doing another summary where you can actually use LLM chain and you can design your entire prompt by using a generic prompt template. Okay, so all this information is specifically there. Now, this is fine. See, here what is basically happening is that you have just a limited number of text, right? When you have a huge PDFs, when you have bigger size PDFs, at that point of time, we definitely have to use different summarization technique. Here, what we are doing, the entire document, whatever we are getting, entire speech, whatever we are getting, we are just giving to the LLM model, and LLM model is able to handle it because the token size is less. Based on the context token size, that is the limitation with respect to any LLM model. Now is the main types that I'm actually going to discuss. The first type is something called as stuff document chain, okay? And here we are just going to go ahead and write text summarization technique, okay? Now, let's do one thing. Let's discuss this entire thing in the next video, okay? And here, one by one, we will go ahead with this. There are three types. One is the stuff documentation chain that we use, and for this, I will be using a bigger PDF when compared to the previous one. I'll be using at least 5 to 6 pages PDF, okay? And after completing this, that is using stuff document chain, we will also see other types like refine. There's something called as refine document chain, and if I also show you the documentation, right? Let me show you the documentation over here. So here you'll be able to see map reduce. So stuff document chain basically means it's simply concatenate document into a prompt. Map reduce basically means it's split document into batches, summarize those, and then summarize into summaries. Refine basically means which updates a rolling summary by iterating over the documents in a sequence. So I will just show you with this, and I'll also try to draw a diagram in order to make you understand. This is what I'm going to discuss in the next video. Thank you. I will see you in the next video. Hello guys, we are going to continue the discussion with respect to text summarization. Now, in this video, we are going to see the most important text summarization techniques that we can use with LangChain. The first one is something called as stuff document chain text summarization. So we will discuss one by one what exactly it is, right? So first of all, we are just going to go ahead with text summarization, stuff document chain. The second one that we use is something called as maps reduce summarization technique. And the most amazing thing about this map reduce is that this is specifically very much important for larger files. Okay, if I have a larger files or larger data source, I will be able to use this because let's say in one of my PDF file I have 100 pages. So at that point of time, I cannot directly use stuff document chain. And obviously, what exactly stuff document chain? I will just talk about it. Now in this map reduce summarization technique, we can also have two important types. One is just with the help of single prompt template, and the second one is with the help of multiple prompt template. We will discuss about this. I will go ahead and probably show you multiple examples also. And the third technique that you will be seeing as we go ahead, it is something called as refine chain summarization. So what we are basically going to do is that we are going to first of all understand one by one, right? What is exactly stuff document chain? What is the problem in stuff document chain? And because of that, why do we use map reduce and when should we use refine chain? Okay. So all these things we will go ahead and discuss about it. So let's go ahead and talk about the first one over here, which is called as stuff document chain summarization. Now, this is the most basic type of summarization technique. Okay. Let's say that we have our PDF, something like this. This is my external data source. It can be PDF, it can be text file, it can be anything, it can be a website, right? What do we do for this PDF is that, or it can be a web URL also. First of all, I will take this particular website, I will take this particular content, I will read this entire content, and then we go ahead and use a prompt template. Like let's say in this prompt template, I go ahead and say, hey, I want you all to probably summarize this entire PDF, right? So this PDF information. So I give the entire text in the form of documents, let's say inside this prompt template, and then we pass along with this prompt template, we pass it to the LLM model. And with the help of LLM model, we specifically get the response or the output. And this is what we earlier did it, right? So over here in the stuff document chain, you'll be seeing that if this PDF is basically of 100 documents also, or if it is of 10 different documents, let's consider it, okay? What in stuff document chain happens is that these documents are all together getting combined, and then it is sent to this particular prompt template, okay? Let's say this entire PDF has 10 documents. This is my doc 1, this is my doc 2, right? This is my doc 3, doc 4, like this I have not. This entire document's content will be combined together, and then it will be sent to the prompt template, okay? And wherever in the prompt template, when I say 10 different documents, and when it is combined, we specifically get the text from all these particular documents, the combined documents, and then we probably send it to our prompt template. So with respect to the prompt template, where we will be having the placeholder called as text, right? This entire text will get replaced over there. Now this is fine, but let's understand what are the challenges. Now in case of challenges, if this particular PDF or if any document is of a smaller size, then it is fine. But if I have a specific PDF or it can be a website which has, let's say, more than 1,000 documents, at that point of time, what happens? This document becomes very large. Right, very large or very big. I can basically say it becomes very big. Now, when it becomes very big, obviously it will not be possible to send it directly to the prompt template along with the LLM model because there is a limitation with respect to the context size, right? context size. So let's say in case of GPT 3.5, if I use this, there is a context size of 4096 tokens, which I can actually send, right? There's a limitation with respect to this. So it will not be working well that much, right? If we directly send the entire documents back to the prompt template and then to the LLM model. So considering this, what we do is that we use the other technique, which is called as map reduce summarization technique. Now in the map reduce summarization technique, what exactly it happens? Okay, so second one, we will talk about something called as map reduce summarization technique. Now in map reduce summarization technique, let's say if I have a document, okay, all these are my documents. Let's consider this. Instead of combining all and giving it once to the prompt template, first of all, we will divide this into chunks. This can be a smaller chunk, this can be a smaller chunk, this can be a smaller chunk. Okay, as the name suggests, map reduce. Okay, this can be a smaller chunk. So this all will be a smaller chunk. Then what we do is that along with this smaller chunk, we pass it to a prompt template, right? We pass it to a prompt template over here, right? And we get the summarized. Along with the prompt template, we'll also go ahead and pass it to our LLM model. Okay, we will go ahead and pass it to our LLM model. And here you'll be able to see that I will get a summary 1. Similarly, I'll get summary 2 for this. Then I'll get summary 3. Then I'll get summary 4. So after getting all this summary, finally, we combine all the summary and get our final summary. This is what happens with the help of MapReduce. Okay. Now, let me just explain it once again. Let's say if I have a document, what will happen? First of all, we will divide this into smaller chunks. Then for every chunk, we will pass it to the prompt template along with the LLM to get the summary 1, summary 2, summary 3, summary 4. And we finally combine all the summary to get the final summary. Okay. That is what we exactly do, right? And this final summary will be the summary of this entire document that we are going to get. Okay. Now there are I told you already, right, over here in MapReduce summary, I have one option of single prompt template, I have another option of multiple prompt template. Now let me just go ahead and explain it, okay? So here you'll be able to see that one prompt template that I have applied, right? So this all prompt template will be same for all these chunks that we have, right? And you will get this entire summary. Along with the summary, I can take all the summary and then finally apply another prompt template to get the final summary, okay? See, I can also use this prompt over here, but let's say from this summary, I want more information. Let's say I want the title of the entire page over there. Right, I want a title from this entire summary. I want to say that, hey, based on this entire summary, please try to find out the motivational quotes from it, right? So that can be another prompt template with another prompt message. Okay, so here I will be having another prompt message, right? Here I will be having another prompt message. Right? So this is basically called as MapReduce. Why do we say this as MapReduce? Because initially we are mapping this particular documents into chunks. We are doing individual tasks. I'm getting the summary of this individual. It's just like reducing the things and then mapping the content itself, right? So here when I get summary 1, summary 2, summary 3, summary 4, these are summaries with respect to all these particular chunks, and then finally combining all the summary with another prompt template, which is having a different prompt message and getting the final summary from the LLM model, right? So this way we will be able to solve this problem, right? Where the document is very big and where you have a limitation of the context size, right? So let me just go ahead and show you the documentation also over here, right? So here is one amazing diagram which you can specifically use. So this is my docs, right? Please focus over here, okay? Or let me just go ahead and use this. I will copy this entire thing, okay? And I'll paste it over here. There's two techniques what we have discussed, right? It will be over here so that you'll also have this entire materials, right? So over here, let's focus on this diagram. What all things we basically did. We are having this particular documents, okay? Here you can see that if it fits in the LLM context window, then what we do, we directly make a prompt, then we give it to the LLM model. So this is basically done by using stuff, where we combine all the documents and then we are going to get the final summary as an output. If it does not fit in the LLM context window, please see this, okay? So what we'll do, we'll create another prompt which says summarize themes into a group of documents, right? So here is my document 1, document 2, document 3, chunks of document. So first of all, I will go ahead and create a chunk of documents over here, okay? Then pass it to the LLM model and get the summary. So these are all my summaries. Then from this summary, I will take another prompt template, extract the final summary of the list, I will pass it to the LLM model and finally I'll get the summary. So this is basically a combination of map reduce technique, okay? So these are the two types. First type I've basically discussed about stuff, and second type we have discussed about MapReduce. Now let's go ahead and quickly see the implementation, and obviously you need to see the implementation. The implementation part, what I will do, I'll not make the video long, so I will try to show you with some examples in the next video. But I hope everybody is able to understand the difference between stuff and MapReduce. Again, let me repeat it. If it fits in the LLM context window, I will directly give all the entire documents along with the prompt, go to the LLM and get the final summary. If it does not fit in the LLM context window, then what we do, we divide that into chunks, we get multiple summaries, and then we combine with another prompt, and then we finally get a final summary. So yes, in the next video, we will go ahead and see the practical implementation. Thank you. Hello guys, so we are going to continue the discussion with respect to text summarization. Already in our previous video, we have seen the theoretical intuition behind stuff document chain and map reduce text summarization technique. In this video, I will show you the practical implementation, how you can specifically implement it. So first, we will go with the stuff document chain text summarization technique. So here I've written a code of PyPDF loader, where we will be loading a specific PDF. And this PDF that I've actually taken over here, you can see it is something called as apjspeech.pdf. Now inside this particular PDF, there is an amazing speech that was given by, and probably the last speech that was given by our former president, Dr. APJ Abdul Kalam, who was a famous personality. And this specific PDF, I will try to read it. Okay. So now let's go ahead and do this, and we'll try to summarize this entire PDF. Okay, entire text inside this particular PDF. So now if I go ahead and just execute this, so here I'm actually going to get this one. So as soon as I read this PDF, here you can see I'm getting so many number of documents, right? And in order to just write pages over here, I'll just go ahead and write documents. So here are all the documents that I've got from reading from this particular PDF file. Now I will take up all these particular documents and then we will try to summarize it first of all by using the stuff document chain. Now in order to summarize it with respect to the stuff document chain, first of all, you know that we need to go ahead and create our prompt template. So for that, we'll create our template first of all. So let's go ahead and write it down over here. So I'll go ahead and write, hey, this is my template, and I will make I'll just make a triple quotes for multi-line comments or sentences that I really want to use. Okay, so inside this template, I will go ahead and say, hey, write a concise and short summary of the following speech. Okay, if you remember, in our previous video, right, what did we basically say? If I want to use a stuff document chain, first of all, if this document fits in the LLM context window, I am going to first of all create this prompt template itself. I'll say extract a final summary from the documents, and then I'll pass it to the LLM, and finally I'll get the final summary. So this is the same fundamental thing that I'm going to apply, the same chain I'm going to specifically apply over here. Okay, so quickly let's go ahead and continue it. And here I'm going to basically say, write a concise and short summary of the following speech. And here I will just go ahead and give my speech itself. The speech will be nothing but with this, and I'll use an input variable where I'll say it is a text. Okay. After creating this particular template, now let me just go ahead and define my prompt. So prompt will be nothing but I will use the same prompt template, and inside this I will go ahead and use my input variables. And inside this input variables, I will just go ahead and write my input variable as text, because this is the information. This will be the text that I'm going to pick it from here, right, from this entire document. So here I've actually went ahead and probably created my prompt template. So if I just go ahead and execute this, so one error you can probably see, speech is equal to text. Okay, I think so. I have not given my, okay, after this, the second parameter that we really need to give is our template, right? Because it is expecting template over here. So I'll just go ahead and write it, okay? So once this is getting executed, this has basically created my entire prompt template. Now, the most important thing that we are going to discuss, how do we apply this stuff document chain text summarization on this entire text by using this particular prompt template? So in LangChain, we have something called as, from LangChain, let me just go ahead and import this, and then I'll explain you. So in LangChain, you have something called as chains, and inside this, you have a module which is called as summarize. And whenever you want to create this entire text summarize chain itself, you can use this import library called as load summarize chain, okay? Load summarize chain is just going to combine this entire thing with respect to the implementation that we are doing for the text summarization, okay? So I'll just go ahead and execute this. Now, what I will do, I will just go ahead and create my chain. In this chain, I will just use load summarize chain. Now, understand what we are basically using. First of all, we need our LLM model. The LLM model is used as ChatGrok, that same LLM model that we're going to use. And then we have our chain type. Okay. Now, inside this chain type, these are the three chain types that I'm going to use. One is stuff, one is MapReduce, and the other one is refine. Okay. We have already discussed the theoretical intuition between, we have understood the theoretical intuition with respect to stuff document chain and MapReduce. So let me just go ahead and give the parameter as stuff. Okay. Then the third parameter that we have to give over here is nothing but my prompt, which will be my prompt over here. And then finally, I'll go ahead and write verbose is equal to true to see all the information whenever I probably run this particular chain. Okay. Now, the most important thing, what exactly is happening when I keep this particular chain type as stuff? It is just going to combine all these documents, and it is going to pass it to the prompt template. Along with the prompt template, it is going to pass it to the LLM module, right? Now, this is the chain that is specifically created. So let me go ahead and explain what this load underscore summarize chain will basically do. So here you'll be able to see that I have a list of documents. So whenever we use this chain type is equal to stuff, what it is going to do is that it is going to combine all these documents. Once it is going to combine all the documents, then it is going to create a chain wherein this documents will be passed to the prompt template. From this prompt template, it will be passed to the LLM model, and finally we get the entire text summarization of all that particular documents. Okay, and this will happen when you go ahead and execute this chain, right? So for that, you just need to write chain dot run, and inside this, I will go ahead and pass my documents. Okay, now with respect to these documents, I will be getting my output summary. Okay, and I will just go ahead and execute it. Now see the magic. Okay, I'm just going to display the output summary. So docs was written over here. Let's see, I have not executed this. Now I have executed this docs. Now it's fine. We should be able to get the output. Now see, it is entering into the new stuff document chain. It's entering into the LLM chain that is basically been created with the help of prompt and LLM model. And here is my entire prompt. Write a concise and short summary of the following speech. And this is the speech where you will be able to see APJ Abdul Kalam. This is the entire speech. And finally, you can see that there's some more content which you're not able to see, but we get the final summary over here, right? So it shows APJ Abdul Kalam departing speech. In this departing speech, former President APJ Abdul Kalam highlights the remarkable progress made by India in various sectors and emphasizes the potential, right? So this entire information is basically my summary. So how easy it was basically to do with the help of this stuff document chain type for text summarization, okay? Now, similarly, what we will do is that we will also go ahead and I'll show you one example for your MapReduce. Okay, so MapReduce to summarize large documents. Okay. Now here, with respect to MapReduce, I've already told you like how it is going to work. First of all the document chunks will be made, right? All the document chunks will be made. Then for each chunk, we will try to create a prompt template. That prompt template can be same, and it's going to summarize for that particular chunk. And finally, we'll be able to get the output. Okay, once we combine all the chunks and then we send it with another prompt template, finally to get the output. So just to show you what all things we are basically going to do over here, I will also go ahead and import from LangChain dot text splitter. I'm going to import recursive character text splitter because we need to divide that into chunks, right? So we're going to import this. Okay. Now you know that this is my documents, right? My documents I've already read it. So this is my documents. Now for this particular documents, what I'm actually going to specifically do is that I will go ahead and probably create a chat prompt template. But before that, what I will do is that I will go ahead and use this text splitter. I will say, hey, create an object of text splitter where I'll say recursive character text splitter, and I'll say, okay, let's go and make this chunk size of 500 or let's say 2000. Okay, and here I'm also going to make a chunk overlap. So first of all, I'm going to divide these documents based on this chunk size and chunk overlap. Okay, and I'm considering that the document that is basically present with me, it fits, it is more than the context size or context window size of the LLM models, right? So here I'm going to use a chunk overlap of 100. Okay, so this is what is my text splitter, and here what I will specifically do is that I will take this entire text splitter. Okay, I will say from documents. Okay, so it should be from underscore documents. I hope so. It is right. Text splitter dot. Okay, or instead of this, if I just use split documents, let's say. So if I just use this function of split documents, I will be able to get my final documents. I can also do this. Okay. So I don't want to write much line of code line by line. Okay. Then finally, I can see my final documents. So documents. Okay, I have to provide my documents over here. So let's go ahead and give my docs. And here you have this. So here, you have seen that already. I had this kind of chunks of document, but I still divided this into many more chunks. Okay. Now, what is going to happen if I use MapReduce? Okay. It will first of all take this chunk. It will pass to the prompt template, and then it will summarize this with the help of LLM model. Similarly, it will send the next sentence or next document to the prompt template along with the LLM model in a chain, and it will summarize this. So all these documents will get summarized in a separate way. And finally, whatever summary we get, we can combine them with another prompt template and get the final summary. That is what I am planning to do it over here. Okay. So here you can actually see, and if I also go ahead and see my length of the final documents. So this many are like 13 documents are basically there. Okay. Now, quickly, let's go ahead and create our prompt template. And you know that our prompt template, how it is basically created. Over there, we have specifically used something like this, right? So this is my prompt, right? With respect to this particular prompt, right? So what I will do, I will just go ahead and say, okay, and let's go ahead and create that all prompt over here. So this will be my first prompt. Let's say for this, I will create another prompt, okay? So here is my chunk underscore prompt. I'll say, please summarize the below speech. And speech is equal to text. Summary is so much information. And over here, I'll get the summary, right? And this is my prompt template. Here, my input variable is text. And template is nothing but this chunk prompt, okay? Finally, I'll go ahead and execute it. This is my map prompt, okay? Now, understand, for all the chunks, I'm going to apply this particular prompt, okay? So in order to execute it, what I will do, I will go ahead and create my summary chain again. So this will basically be my summary chain. Okay, I'll create a variable and I'll say, hey, I'll call that load summarize chain again. Again, if you remember, the first parameter was nothing but LLM. LLM is equal to LLM. The second parameter was something called as chain type, right? Previously, we gave the chain type as stuff, but in this case, we will give it as map reduce. Okay. And the third one, what we will do is that we will give the map prompt template. Sorry, map underscore prompt. Okay. Map underscore prompt is equal to, and here I'm actually going to give my chunk prompt. Okay. So this will specifically be my chunk prompt. Instead of giving chunk prompt, I'll give this map prompt template because I need to give a prompt template over here. Now, understand one thing. Okay. This prompt template that we have created, this is for the chunks, right? Finally, when I get the summary of all these things, right? Separate summary for all these documents, I also need to create another prompt template, right? And that will basically be my final prompt. So I'll say, hey, this is my final prompt. And this will be for my all the summarized text with respect to the chunks, right? So here I will just go ahead and write this quickly and let's write it over here. So what I will say over here is that provide the final summary of the entire speech with these important points. I'll just go ahead and write like this. Okay. First of all, I'll say, hey, go ahead and add a generic, or I'll say, hey, go ahead and add a motivational title. Okay. Then start the precise summary with an introduction. I'm just writing my own prompt. Okay. And provide the summary in number points for the speech. Okay. So I basically want the entire summary in the form of numbers. So that is the reason I'm writing this. Okay. Finally, I'll go ahead and write my speech. And this speech will basically be having my text. So here you can see that this ad is got added. So let me just go ahead and bring it. Okay. So this basically becomes my final prompt. Now I'm going to combine this as my final prompt template. Okay. Prompt template. This will be my final prompt. Remember when this will get applied? When the entire summary of the chunks have actually got, right? So in order to show you the diagram over here, right? Let me just show you the diagram okay, quickly. And then here you'll be able to understand it. So here you can see I'm implementing this. The first prompt has been created for the chunks, right? I will get all the summarized. So second will be my final prompt, which I'm actually implementing. Okay. So let's go back to my code. Okay. So final prompt template, you can see over here. I will go ahead and say, hey, this will basically be my prompt template. In this, my input variables will be nothing but it will be text. Okay. This is how we specifically write. And here you'll be able to see template is equal to final prompt, or I can go ahead and write this final prompt. Okay, I have to close this, right? So this will basically be my input template. Okay, done. So if I go ahead and execute this final prompt template, this is what is the template I'm going to use over here in the summary chain. Now this became my first template. The second template parameter that we have in load summary chain is something called as combine prompt. Okay, so if I go ahead and write combine prompt. Now what does combine prompt basically say is that this map prompt is the first prompt template which we are going to use for, and this will give the summary. This will basically combine with the LLM and summary and will give the summary of the smaller chunks, right? Once we get all the summaries, then we can combine them with this specific prompt template. That basically means all the summary will be combined and sent to this prompt template, right? So here I will go ahead and write this. And finally, I will go ahead and write verbose is equal to true so that you will be able to see the details. Now quickly, let's go ahead and execute this. Here I'm going to write output is nothing but I'll write summary, whatever summary chain we are basically going to create, summary chain dot run. And here, what I will be giving, I will be giving my docs, right? Whatever docs I have. Not docs, sorry. I should be giving this final documents. Not docs, but final documents. Quickly, let's go ahead and execute this. I'll go ahead and execute this over here. So this will basically be my output. Now let's execute this, see the magic now. So entering a map reduce document chain, it has entered the LLM chain. First of all, it took this prompt template. I am getting the summary, right? Then it went into a new chain with the final prompt. So here you can say, please provide the final summary of the entire speech, add a motivational title. So this is the output that you're getting, right? And this is how you are displaying your output. Introduction, this. So based on this, when I did this verbose is equal to true here, you could see that initially when we applied this map reduce documentation, the first prompt template that got applied was this, right? For every chunks. Then we got all the summaries and finally we combined all the summaries and passed into another prompt template, which is nothing but your final prompt template. And here you get the complete final response. So this was the two types of text summarization techniques, which we specifically use in load summarize chain. Okay. I'll just make one more change over here. I'll just make the spelling right. Okay. Now in our next video, we are going to see about refine, right? And the differences between refine and all we will try to discuss, right? Refine text summarization technique and all. There's just minor changes which we are going to discuss in the next video. So yes, this was it from my side. I'll see you in the next video. Thank you. Hello guys, so we are going to continue discussion with respect to text summarization. We have already seen about stuff document chain summarization, then we saw map reduce chain summarization, and finally we are going to go ahead and explore about refine chain summarization. Now this is just a slight modification when compared to the map reduce. Let's say you have this entire documents, okay? Now when we have this entire documents, let me just go ahead and rub this again and write it in a better way. So let's say if I have a document over here, so these are my documents. Let's say I have divided these documents into chunks, right? Smaller chunks. So this is my chunk 1, chunk 2, like this. I have a lot of chunks. Now what we will do whenever we use this refine chain summarization, we will take this first chunk, we will give it to a prompt template. Along with this prompt, we will go ahead and pass to the LLM to get our summarization. So let's say once I get this summarization, then this is one specific output that we are going to get. Okay. Now for the second chunk, what it will happen before sending this to the prompt and the LLM, we are also going to take a reference of this summarization result along with this, right? So if I just really want to explain this, over here it is basically given by refine basically means updating a rolling summary by iterating over the document in sequence, okay? If I really want to just talk about refine, this basically means for every chunk, whenever we are passing it to the prompt and LLM, once we get the summarization of that, it is going to combine with the next chunk, and then again it is going to send to the prompt and LLM. We will get our next summarization over here, okay? So let's say that I've got my next summarization here, right? And then what will happen, this summary will be later combined with this, and here we will be able to get our another, like we'll be able to pass to another prompt and another LLM. So this is basically getting rolled up, right? So that is the reason when we saw in the documentation, it is saying that, hey, updating a rolling summary. We are taking the summary and we are rolling it over one by one as we go ahead with respect to the next chunk, right? So this is my chunk 1, chunk 2 like that. And finally, after covering all the chunks, we get the final summary, right? So this is one technique with respect to refine, and here you could see that how it is a little bit different from MapReduce and the stuff one. Okay, so guys, now let's go ahead and see the practical implementation of refine chain for summarization. So for this, we don't have to do much. Just use the same load summarize chain, and here we are going to use the first parameter as my LLM model. The second parameter will basically be my chain type. Whenever we use a chain type over here by refine, then we'll be able to use it. The third thing that we're going to use is something called as verbose is equal to true, to just see all the information. And finally, when I just go ahead and run chain.run with respect to our final documents, I think we should be able to get our output summary. So this will basically be my output summary is equal to this, and let's print this output summary over here. So here you can see, now see over here also, sending the food I could do for him, allowing this refining is basically happening, right? See, at the end of the day, refine summarization basically means it's more about refining the summary itself. The first chunk of summary, when we get it, we are sending along with the second chunk and again passing it to the prompt and LLM model. And finally, at each and every time, we are specifically doing that particular process to get a much better form of summary itself. And that is what we can actually do with the help of load summarize chain. So in this all series of video, we have seen about all the three types. One is stuff document chain, then we have map reduce, then finally we have about refine chain. We have also seen the theoretical intuition. Yes, this was it from my side. In the next video, we are going to develop an end-to-end project implementation for both structured and unstructured type of content. Okay, and that is what we are going to do in the next video. So yes, I will see you in the next video. Thank you. Hello guys, so finally we are going to create our end-to-end Gen AI project using LangChain, where we will be summarizing text from YouTube videos or any external website. So in this video, I am going to show you the demo, like what exactly this entire Gen AI app actually do, and I will just probably go ahead and enter all these particular values that you actually see on your screen, right? So here you can see on the left-hand side, we will be using Grok API key specifically to use our open source models. So here you have an option to just go ahead and give your URL. So your URL over here can be a YouTube URL or it can be a website URL, right? Any pages URL you can basically go ahead and give it from here. And as soon as I probably go ahead and click summarize, we should be able to extract the content from that particular URL and we should be able to summarize it, right? So let's go ahead and check this specific demo. So here I have this amazing video that I've created in my YouTube channel, which is called as AI versus ML versus versus generative AI. So I'm just going to go ahead and copy it over here. I will go ahead and paste it over here. Okay. Now let's go ahead and click on summarize. So here it shows please provide the missing values. That is nothing but Grok API key. So we have also made sure that the validation is basically added. So I'll go to my env file and I will just go ahead and pick up my Grok API key. So let me quickly go ahead and paste it over here. Once I enter, now I will click on summarize. So here you'll be able to see that it will go ahead and probably pick up the transcript of this particular video and it will summarize this in an amazing way. Okay. And the model that we are specifically using is Gamma model from Google. It is a complete open source model, and I tried it out with other models also like Llama 3, Mistral. But the best kind of results like this way that I was able to get was from Gamma model. Okay. So here you can see the video explores the concept of generative AI, a subset of deep learning focused on generating things. This, all the information is basically here. Okay. This is one functionality. This is with respect to YouTube video. Let's say if I want to go ahead and play with any websites, right? So let's say this is one of the website over here, docs.langsmith.com. I can go ahead and give this website also. So as soon as I click on summarize, what it is going to do is that it is going to pick this particular URL, get the content from it, and summarize the entire context or content that is basically present over here. So if I go ahead and click on summarize, so here you'll be able to see that it will tell you to please wait, and it is going to take the entire content. It is probably going to perform each and everything, like what all things it will be performing. We will talk about it, and this is the entire information, the entire summary of this particular website. Not only this, let's say if I go ahead and see any other websites over here. So let's say I go to LangChain itself. So I'll go ahead and write langchain.com. Okay, and I will go ahead and see the docs. Okay. Okay, let's pick up this particular doc, the introduction over here. And once I go ahead and use this over here and copy and paste it, and once I click on summarize, you'll be able to see that this entire LangChain framework, I'm able to get it. And all it is doing an amazing summary altogether, right? So this is what we are basically going to create in this particular video. Now in the next video, we're going to start the coding, and step by step, we'll be making sure that we implement each and everything. So yes, this was it from my side. I will see you on the next video. Thank you. So guys, finally, I'm excited to implement this amazing end-to-end project related to text summarization. So I will take the same folder. Inside this, I will go ahead and create API key. So let me just go ahead and create this. Sorry, not API key, app.py file. Okay. And this is where I'm actually going to write the entire coding. See, the reason why I'm creating this kind of folder structure, because you understand like how every project is basically getting created, and I'm just putting all the common libraries that we may be using in creating an end-to-end project, right? And that will be all at one place. So that is the reason I'm basically creating all the projects in this same way. Okay. So now let's go ahead and start our coding over here. So first of all, what we are going to do is that here we are also going to use some new libraries. Okay. So first of all, the library that I really want to use is something called as validators. Now, what exactly is this validator? Since we are going to use or work with URL. Over here, this validator basically is an inbuilt library, which is not an inbuilt library, but it is an external library, which actually helps you to validate the URL. Okay, so I will be using one of this particular version, that is 0.281.1. I think this is the recent version that is going on. Along with this, I will also be using YouTube transcript underscore API. Now, with the help of this, whenever we give any YouTube URL, okay, we will be able to read the entire transcript for that particular video. Okay, so this is another one library that we are basically going to use. Let's see whether when we are doing the coding, like any more libraries will be required or not. So now I will go over here. I will open my command prompt. First of all, I will go ahead and make sure that I do the installation of the requirement.php. So first thing that you really need to validate is that are we in our environment, right? That is venv. Yes, it shows over here. We will go ahead and write pip install -r requirement.php. So once I go ahead and execute it, here you can see remaining all the libraries that shows requirement already satisfied. But now YouTube transcript underscore API validators, you can see it has got successfully installed. So now let me just go ahead and close this and let me start writing my code. The first thing first, what I really need to do is that I have to import this validators. So I'll go ahead and write import validators. And then I'm going to also import Streamlit as ST. Okay. I'm going to use this. Then from langchain.prompts, okay, I'm going to import my prompt template, which I'm going to specifically use. Okay. Then again from langchain_grok, we are going to import chat grok, which I'm actually going to use to communicate with my LLM models. Then from langchain.chains.summarize, because we're going to use the summarize for using any of the summarize techniques that we have already learned. So here we will be importing this load summarize chain. Then again, one more library that I'm going to specifically use with respect to YouTube and any other websites, right? We also require some kind of document loaders. So if you remember, in the initial stages we discussed about document loaders, right? So langchain_community.document loaders, I'm going to import. One is YouTube loader. So for this, I will be using this YouTube loader. You can also take the audio if you are really interested, okay? And then we will also go ahead and take a unstructured URL loader, right? And there are so many, like see, unstructured HTML is there, CSV is there, email is there, pub is there. But here we are just going to use URL. Let's see. I'm going to go ahead and write unstructured URL loader. Okay. And basically means directly from the URL, we will be able to load the content. Here you can also use CSV, you can also use any other things. So like let's say you want to upload, go ahead and upload CSV, you can also do that. Okay. As I said, guys, it is vast. LangChain is really, really vast. Okay. So finally, let's go ahead and create our Streamlit app. Now, initially to create the Streamlit app, what I will do, I will go ahead and set up my page config and ht.title and ht.subhead. Okay. Then I will quickly go ahead and get the Grok API key that I really want to use. And I will also create a URL field to which URL we really need to summarize, right? To be summarized, I will write over here. Okay. And the URL field, I'm going to say URL to be summarized, whatever URL we really want to summarize. It can be, I'll write over here as it can be YT or website. Okay. So once this is done, then I will go ahead and write with ht.sidebar. Okay. And here I will go ahead and create the sidebar itself. Here I will go ahead and first of all get my API key, right? So for this, I will go ahead and write ht.textinput. So I'm just creating a field on the sidebar like text input where I will be giving my Grok API key. So let me just go ahead and write Grok API key. Okay. And here we are basically going to take the value as blank, right? Initially it will be, and type will be password. Okay. Perfect. Till here we have done it. Then let's go ahead and create our URL. It will be nothing but ht.text_input. And here I'm going to basically give my URL. Okay. And over here I will keep my initial label visibility is equal to false or collapsed. Okay. The reason over here why I'm writing it as collapsed because it should not be highlighted unless until we go ahead and click it. Okay. So this will be collapsed. This is perfect. Till here we have done this. Okay. Next, what I will do, I'll go ahead and create my button. Okay. So for that, I will go ahead and write if st.button. I will go ahead and create my summarize the content from YT or website. Okay, so this will basically have the information in the button. Okay, now let's go ahead and first of all validate all the inputs, right? So while validating, I'll go ahead and write if not, okay, Grok API key. If the Grok API key is not given, okay, we'll also do it as .strip, or I'll also go ahead and check for not URL.strip. So we'll also put a condition with respect to the URL. I'll say that hey, if the URL is not given, okay, .strip. Strip basically means removes the empty characters. I will just go ahead and give an error saying that st.error, and I'll write please provide the information. Please provide the information. Okay. A generic information like that, right? Otherwise, I'll also give an else if condition where I'll say whether my URL that I've actually given, we need to validate also that, right? So here I will say if not validators.url, and here I'm going to basically go ahead and give my URL. So this URL can be your website URL, it can be a YouTube URL. So I'll go ahead and just write a generic URL over here, and here will be my API key, here will be my generic URL itself, right? So all this information is over here. I'll also go ahead and make this particular check, okay? So I'll say, hey, please provide the information to get started. Okay, something like this, some errors, we will try to put it over here. So now we are checking whether this URL is a validator, you're validating URL or not. It is a valid URL or not. So here, if it is not a valid URL, I will just go ahead and write st.error. Please enter a valid URL, okay? And here I'll also go ahead and write, it can maybe a, I'll just go ahead and write this error message, it can maybe a YT video URL or website URL. Okay, so I'm giving some validation also so that you'll be able to check it out. And then finally in the else block, what I will do is that if all these conditions are satisfied, and this is where we have to start our coding, whatever happens in the backend. So I'll say, hey, go ahead and create a try block, okay? And we will also handle the exception with respect to this. And I'll say, hey, with st.spinner, okay? And I'll say waiting, okay, waiting till this entire information is basically coming up, we will first of all load the URL itself, right? The URL data. So the first step over here is that loading the website data, okay? Website or YouTube video data or YT video data. Okay. So once this is done, we go to the next step. I'll give a condition in my URL whether youtube.com is present or not. So if youtube.com is present in this generic URL, then what I'm actually going to do, I'm going to create a loader, and inside this I'll be using this YouTube loader, which I've actually initialized. As soon as we use the YouTube loader, there is an inbuilt function over here, like from YouTube URL, where we can give the generic URL, okay, and we can also say whether I want to add the video information or not. So here there will be one more parameter which is called as add_video_info is equal to true. I'll keep it as true. Okay. So these are the basic information with respect to whenever we upload a YouTube URL, I should be able to load this. Okay. Otherwise, in the else condition, I know that if I'm giving if the generic URL is in the web form of website, I will be using this loader, and we can go ahead and use this unstructured URL loader. Right? This is also one kind of loader over here, and here we will just give our URL. The URLs will be nothing but it will be a list of. I can also give multiple URL if I want. Okay. So here I will be having this multiple URL. One more thing, I will also go ahead and make some checks saying that hey, whether it should be SSL verified. You can probably keep it as true or false. Right now, I'll just keep it as false just to take any URL if I'm given. I'll probably go ahead and do this. Here it should be generic URL. Okay. And one more information along with this will be that the kind of header. See, whenever you work with any kind of let's say you're serving from any browser, right? So in that browser, you'll basically set up some kind of headers by default, so that just to validate you're browsing from the right browser itself, right? So I will be keeping this specific information over here, and this headers you will be giving it over here, right? So headers like user agent, Mozilla 5.0, Macintosh, Intel, Mac OS, Apple WebKit, like Gecko, Chrome, Safari. So all these browsers are basically supportable. So that is the reason we're providing this entire information over here, saying that if this header is basically there in the website, we should be able to probably go ahead and use this. Okay, so this is the header that we are setting, and unstructured URL loader will be making sure that it's just like how we browse in the browser, right? We are able to browse different pages, and when we are browser, there also headers will be set up with respect to every request. Now here also, when we are using this unstructured URL loader, in short, this is hitting this particular URL. So whenever we are hitting this particular URL, the web server will also be demanding the kind of headers you are putting on top of it with respect to user agent, from which browser. It's just like from which browser you're trying to execute it. That information you are able to put it over here. Okay. Now once you are able to do this, the next step, let me just show over here. So the next step over here will be that I will get this particular data. Okay, and once we get this data, so I'll say, hey, once I've set up a loader, I'll say loader.load, and I will be getting the data itself. Okay, so this is done. This is enough over here with respect to the try block. Now we are going to initialize. There's always a good idea that we initialize the block model outside our our entire application. So here I will only initialize it over here. I'll say, hey, LLM is going to chat Grok with all this information, and let's pick up the Grok API. So Grok API is basically coming from here. I will go ahead and set it over here, right? So this is where we are basically setting it up. I'm not just putting it inside. I could have loaded my Grok over here, but here will be my Grok API. Okay, and with respect to this Grok, this will be my Gamma model that I'm using. Using Grok API, right? Grok API. Once this is done, we will also go ahead and set up our prompt template. Okay, so here I'm just going to go ahead and write my prompt template, and for this prompt template, I'm going to specifically use a simple prompt template. Say I will just use this. Okay, I'll write, hey, go ahead and write over here, provide a summary of the following content in 300 words. Okay, so this is what I'm actually going to give over here, and this will basically be my text, the text info that I'm actually going to put over here, right? So I'll just go ahead and say this is this, and this is my content. Okay, the content is equal to text. Okay, and then after this, what we do, we basically go ahead and define our prompt. So with respect to the prompt, I will go ahead and use my prompt template. The template will be equal to my prompt template, and finally my input variables will be nothing but it will be equal to text. Right, so I have to basically give it as text. So perfect. I think everything is working fine till here. So what I did is that instead of writing my prompt over here, I have defined the prompt template and LLM outside. Okay, now it's time we go ahead and create our chain for summarization. Okay, so for this, you know what, we will need to use it. So I'll go ahead and say chain is equal to load summarize chain, and here I'm going to use my LLM chain underscore type. Let's go ahead and use stuff initially. Okay, because the content may be small, maybe bigger, it is up to you, right? So you can use stuff or map reduce or anything that you want. Along with this, I will just go ahead and define my prompt. Okay, so let's go ahead and write my prompt is equal to prompt. Okay, and here we will go ahead and run the summary.chain. Okay, so once I write, sorry, it should be summary is equal to, or I'll just write output underscore summary is equal to chain dot run. And here I'm going to give my data. Okay, the data, whatever data we are specifically getting. Over here, instead of data, we will just go ahead and write docs, because documents is what we usually get, right? So here also I will be giving my documents. Perfect. Till here everything looks good. And finally, I will say ht.success, right? And that is the reason you get green color in the demo, right? I'll just go ahead and display my output summary. Perfect. Done. This is good enough. Now in our except block, we can probably go ahead and write our exception. So I'll go ahead and write exception as e, and then we are just going to write ht.exception as exception colon e, right? Perfect. So still here everything looks good. I think it should run. Okay, let's go ahead and execute it. So here I'm in my v environment. Let's go back to my folder that is 7th text summarization. So I'll go ahead and write 7 text summarization. Here I will go ahead and write streamlit run app.py. So let's go ahead and write app.py. Now I think everything should work fine. So this is my page. It looks fine. Go API, summarize the content from the YouTube website. Let me go back to my code. Let me open my env file, right? And let me just pick up this Grok API key, right? All the API keys you can specifically use it, okay? Just to practice. So I'll press enter, okay? Now let me do one thing. Let me use any website, Docs, Landsmith, whatever website you want. I will go ahead and copy this, put it over here. Module has no attribute exception. The reason exception, okay? Let's see this. ht.exception. I think it should be in small letter. Okay, now it should work. Always run. I will summarize. So it is saying me to install this unstructured because we have used this unstructured over here. So let's go ahead and install this. And these are some of the errors that you may get if you have missed any requirement.txt, right? I want to show you all these errors. Okay. So quickly, I will go ahead and open my another command prompt. Okay. So I'll say, hey, pip install. Please make sure that you do the installation in your venv environment, right? Requirement.txt. Once I do this, so here you'll be able to see this. I think one more error we may get it, but let's see whether we'll get that error or not. Okay. So once this unstructured is basically getting installed, YouTube transcript API I've already done it. Validators I've already done it. I think I do not have to probably get any kind of errors other than this. So now if I go ahead and summarize it, let's see. I think it should work. One more error can come again for the library, but I think other than that, it should work. Okay. Why is it taking so much time? So it's better. Okay, yeah, perfect. So it shows you the output, right? Let's try some other URL. Okay. So what I will do is that I will quickly go ahead and take some more URLs if I want. Okay. I can go and search for this. So let's take this entire URL. Okay. My entire page URL over here. And with respect to this particular URL, I will just go ahead and open this. And if you can try it with any YouTube channel video. Okay, so this is one of the URLs, so it is necessary to probably test each and everything. So here I've given my YouTube video. I have to probably go ahead and install PyTube. Okay, and this is one of the requirements, I guess, with transcript API. So I will quickly go ahead and copy and paste it over here. Let's go ahead and do the installation now. I think it should work. Okay, so basic requirements, and that is the reason you have to probably create another environment for this, right? So this is the version that you are having. Okay, so let's summarize. And now we should be able to get the output. Here you go, right? Generative AI explain. So yes, this was it from my side. I hope you like this particular video, and I hope you're liking the entire course. So yes, I will see you in the next video. Thank you. Hello guys, so we are going to continue our discussion with respect to our LangChain series, and now in this video and upcoming series of video, we are going to discuss about another amazing new project. And the project is nothing but innovative math and data search assistant using Google Gamma 2. Google Gamma 2 is another open source model from Google, which is quite amazing with respect to LLM, and it actually gives you an amazing result. So that is the reason I'm going to go ahead and use this. Now, what is the main idea behind this is that whatever question you ask this GPT, right, or this generative AI application related to any math problem, it should be able to give you the answer. And the question that you can actually ask can be in the form of text, okay, and automatically it should be able to understand your question and it should be able to give you the answer. Now, there are some more information that you probably want to know in your whenever you're studying maths. Let's say formula of you need to know the formula. Let's say formula of what is the area of a circle, or what is pi r square. So this kind of questions whenever you want to ask. You may also want some kind of external data source which should be able to give you the answer. So here what we're doing is that we're integrating Wikipedia so that you'll be able to use it. Now let me just go ahead and show the demo for this particular project first of all, and then we will go ahead and build this completely from scratch. So first of all, I'm going to go ahead and give my Grok API key. I'll press enter. So here it says, hey, I'm a chatbot who can answer all your maths questions. So I've given a default question over here. I have 5 bananas and 7 grapes. I eat 2 bananas and give away 3 grapes. Then I buy a dozen of apples and 2 pack of blueberries. Each pack of blueberries contains 25 berries. How many total pieces of fruit do I have? So whenever you give this kind of text, it should be able to understand your entire mathematical question and it should be able to give you the response. So let's go ahead and click on get answer. So here you'll be able to see that it will be generating the answers. Here is your entire process of probably getting all the updates with respect to the numbers, and finally you can see there are 69. I hope you do the calculation. I think it is absolutely fine. Let me just do the calculation again. So here you can see 5 plus 7 is 12. Then 12 minus 5, you can probably do 7. After 7, 7 plus 12, 1 dozen of apples. 7 plus 12 is 19. Then 19 plus 50, okay? Because 2 packs of blueberries is 19 plus 50, which is nothing but 69. So I've done the calculation over here. So here you can see all the steps it has probably done in order to solve this entire problem. So what we will do is that you give any kind of sentence with respect to the problem statement, and it should be able to solve your maths problem, okay? So yes, let's go ahead and build this entire application. And in our next video, we are completely going to build it from scratch. First of all, we'll develop the left panel, then we will go ahead and develop this entire Streamlit app, and how we are basically using Google Gamma for solving this particular problem. We will be seeing that. So yes, this was it from my side. I will see you on the next video. Thank you. Hello guys, so let's go ahead and build our end-to-end generative AI application with respect to the demo that we have already seen. So quickly to go ahead with what I will be doing is that I will be requiring the Streamlit library. Again, I'm going to create this entire end-to-end project with the help of Streamlit. Then we're just going to go ahead and import ChatGrok because we're going to use Google Gamma model. Now, along with this, I will be using two important chain. One is called as LLM chain and then one is LLM math chain. Okay, since we need to do the entire mathematical calculation, so this will be the library that will be useful for us. Okay, along with that, as you know that we will be since I also want that thought of chain to have an interaction between the agents also. So I will be using Wikipedia. I'll be using prompt template. I will be using agent type. I'll be using initialize agent, and all the tools will be created with this specific library called as tools itself, and this is basically coming from LangChain underscore agents. Load_env needs to be used if you really want to use the API key, but since we are completely giving the API key from the website itself, I'll not be going to use that. And from LangChain.callbacks, we'll be using the Streamlit callback handler. Now, the main importance of the Streamlit callback handler will be that the thought of chain, right? The kind of interaction that is basically going to happen between the two, everything, we should be able to see it, and we will also be able to understand how the entire conversation has started. Okay, so these are some of the libraries that we will be using, and I think in all our previous session we have discussed about all the specific libraries. Now, quickly, let's go ahead and set up the Streamlit lab or Streamlit app. So I'm going to go over here and create our Streamlit app. Then I'm going to write st.set page config, and we're going to specifically use our page title, which is called as text to math problem solver, okay, and data search assistant. Since I'm also going to create some tools, right? So this will basically be my, the page title itself. And with respect to this, I will also go ahead and use some page icons so that whenever I see in my browser, right, I should be able to see this, right? So this will basically be my page icon that I'm actually going to use. Along with this, the next thing that I'm going to basically do is that provide my st.title. So let me just go ahead and write st.title is equal to, and here I'll say, hey, this is my text to math problem solver, okay? And I'll just go ahead and write using Google Gamma 2. Because the LLM model that I'm going to use is Google Gamma 2. Okay? And I can still write more information that you want, like whatever things you really want. You can go ahead and write it with the help of st.write if you want more description over here. Now quickly let's go ahead and create our Grok underscore API underscore key. Now with respect to this Grok underscore API underscore key, what I'm actually going to do, I'll just go ahead and write st.sidebar dot text underscore input so that I get my input for the Grok API, right? So here I'm going to basically go ahead and write Grok API key, okay? Once I get this Grok API key, then the next thing that I'm actually going to do is my password. I'll go ahead and say, hey, it is basically a password. I really need to get this. Now my entire application will start with this. So I will be giving a condition if Grok underscore API underscore key, I'll just go ahead and write st.info, okay? And I'll say, hey, please add your Grok API key to continue, okay? So we'll go ahead and write this, and here I'm also going to write st.stop, okay? If we are not providing our Grok API key, that should really be the condition. If I'm saying, hey, if Grok API key, that won't make sense, I'll go ahead and write if not. If the Grok API key is not provided, you have to first of all go ahead and provide this. Now let's go ahead and initialize our language model. Now here my language model will begin by using ChatGrok. The model, that name that I'm actually going to specifically use is nothing but Gamma. So this information, I hope you will be able to get it from the cloud API, the Grok cloud API, right? So here I'll be going and writing 9b IT, and here you can go ahead and see Grok with respect to the Grok API key. Here we're going to initialize the Grok API key. Perfect. So this basically becomes my large language model, okay? Or I will just go ahead and write LLM over here. So we'll be able to refer it anywhere we want. Okay? Now the next thing will be that we will start initializing our tools. So let's start initializing the tools over here. Now, first of all, the tool that I'm actually going to use is Wikipedia. So I'll go ahead and create my Wikipedia wrapper, which we have again discussed in the tools and agent types. So here I'm going to basically go ahead and call this Wikipedia wrapper. Whatever is the default value, the one result or two result, whatever things you really want to use it, you can use it over here. Then I will go ahead and create my Wikipedia underscore 2, which will be nothing but this will be my tool over here, which I've initialized it. And then I'm going to go ahead and write name is equal to Wikipedia. Okay. So once I go ahead and create this, then I will just go ahead and write my function. So my function will be equal to I'll just go ahead and say Wikipedia dot run, okay, or dot search. I think it should be search dot run. Okay, so run is my function name. So there is a parameter with respect to, like, if I really want to run this particular app, I can just go ahead and use this wikipedia dot run, and I'll provide some description for this so that I'll be able to see some information while I'm doing the chat. A tool for searching the internet and solving your math problem. Okay, something like this. So Wikipedia is no, just solving the internet should be the math, solving the math problem, and searching the internet to find the various info on the topics mentioned. Okay, so this should be my entire thing. Okay, so Wikipedia tool is there, and I will just go ahead and initialize the math tool. Okay, so let's go ahead and initialize now. See, Wikipedia is there. This is just used for search, right? Now, if I really want to solve the math problem, so there is a tool over here, even in LangChain, which is called as LLM Math Chain, which we have actually imported. So I'll just go ahead and write math underscore chain is equal to LLM math chain. Okay, and here I'm just going to say from underscore LLMs, from underscore LLMs. Okay, so this is an inbuilt method, and here I'm going to pass my LLM model. Okay, so LLM is equal to LLM. Okay. So what it is going to do is that the specific math chain is going to interact with our LLM model with respect to any kind of calculation or any kind of arithmetic operation that needs to be performed. Then I will go ahead and create a variable. Let's say I'll go ahead and write calculator. So I'll just name it as calculator, right? And I will initialize my tool. I will give some name parameter over here. So this will be nothing but calculator. The function that we will be using is nothing but math underscore chain dot run again, okay? Like how we used it for Wikipedia. And finally, we'll go ahead and give our description, which will be nothing but a tool for answering math related questions. And here, I will just make a note. We only need to provide only input mathematical expression, nothing else than this. Otherwise, it will give us an error. Okay, expression needs to be provided. Okay, so all this information is basically there. This is basically my calculator tool. Now it's time that we start, solving this entire problem. And first of all, I will just go ahead and define my prompt, and I'll say, hey, let's go ahead and do this. Let's create our prompt. So I'll say, hey, you are a agent tasked for solving, okay, users mathematical questions. Okay, I'll just go ahead and write like this: mathematical questions. Okay, mathematical questions. Logically arrive at the solution and provide a detailed explanation, okay. And display it point wise. Okay, point wise. Okay, so I've just written some basic comment prompt, and here point wise. So for the question below. Okay, so here I will just go ahead and write my question, and I'll give my input as question. Okay, so this is what I'm actually going to do. And finally, I should be able to get my answer like this, and just close my brackets. Okay, so this is basically my prompt, which I'm actually going to use. And now let me just go ahead and define my prompt template. Okay, so I will go ahead and write prompt template is equal to, and here also we'll go ahead and initialize our prompt template. The input variables that we are going to use over here is nothing but question. But I hope you are much more familiar by seeing all the tutorials before. Now everything needs to be familiar, right? I think you will be definitely familiar with all these things. So template will nothing be, it will be my prompt. Okay, now let's create now the chain which will combine all the tools that we have created, like Wikipedia and all. Okay, so first quickly let me do one thing. Let me just go ahead and first I will say math problem tool. Okay, so with respect to the math problem tool, what is the tool that I'm actually using? That is nothing but LLM chain. So I'll go ahead and initialize my LLM chain, and okay, LLM. First of all, see, when I really want to, let's say, combine all the tools into chain. Okay, now what I'll be doing is that I'll be using this Wikipedia, I'll be using this LLM math chain, I'll combine with the entire prompt template. Okay, but before combining them, right, first of all, I need to create my LLM chain. My LLM chain usually has two important things. One is your LLM model, so I'll go ahead and initialize it, and the second one is something called as prompt template. Okay, so once we have both the important things, that basically means my chain is ready. Okay, so here I'll go ahead and create my chain. Let me do one thing. Instead of writing prompt template over here, let me first of all give my prompt over here. Okay, so this prompt should be equal to my entire prompt template that I've actually created over here. Okay, the same thing. So this is the first thing that I really need to create is my chain, and then one more. See, I also need to make sure that I add reasoning inside this. Okay, so for that I will create a reasoning tool, and I'll say, hey, let's create this particular tool, and this tool name should be given as reasoning tool. Okay, I will add this one more thing, and my function will be nothing but whatever chain that I am actually creating this, I will run this chain. Okay, so I'm running this entire chain from a specific tool. The reason why I've named it as reasoning, because since there are multiple things that is probably going to happen in the specific chain, so we will also be running this in the form of a tool. Okay, and here I'll be writing my description, and let's say I'll say, hey, tool for answering logic based and reasoning questions. Okay, so this is done over here. So this basically becomes my description. Okay, this is all good now. Now we are just going to go ahead and initialize our agents. So let's initialize the agents. Okay, now in order to initialize the agent, I will first of all go ahead and write assistant underscore agent is equal to initialize the agent. And here I will go ahead and say tools. What are tools I want? I will just go ahead and combine it over here like Wikipedia tool. Okay, the second tool will basically be my calculator tool. Oh, callback manager. My calculator. Okay. So this will be another one tool, and along with this, we will go ahead and add one more, which is called as reasoning tool, which will be responsible in running the entire chain. So in short, what I have done is that my LLM chain, I've converted this into a tool. Okay, and I'm saying that hey, this LLM chain should actually give you the entire answers, but I'm saying hey, it is a reasoning tool because it has some thought of chain that may be going right because it is interacting with the LLM model. Now finally, I will go ahead and create my LLM is equal to LLM, and let me just go ahead and create my agent. So here I'll be using agent type dot zero short react description, and I've already discussed what exactly this is. I'll also go ahead and write verbose is equal to true just to see my detailed thought of chain process, but I'll keep it as false because this will get printed in the console itself, right? Sorry, in the terminal, right? So here I will also go ahead and write handle underscore parsing string underscore error is equal to true. Okay, so I'm also going to keep this particular parameter over here, right? So almost each and every thing is basically being used, and over here we have also used the initialized agent. So this is good to go now. Okay, but always remember we also need to make sure that we create our session state. So let me just go ahead and write if messages. So here I've written if messages not in st.session underscore state, so that I will create this particular state, session underscore state. Okay, and here I'm just going to write st.session underscore state if for messages. Okay, now inside this particular messages, I am going to go ahead and add my role. So let's say by default, the role that I'm adding is two roles. One is assistant, and this assistant will also be in string. And the second thing that I'm actually going to add is my content, my default content. I'll say, hey, content, colon. I'll say, hey, hi, I am a math chatbot who can answer all your maths question. Okay, something like this. So yes, this was my role that I've actually added it over here. Now quickly, I'll go ahead and say for message in st dot session underscore state dot messages, and here we are specifically going to use this st dot chat underscore message. Okay, chat underscore message, and here I'm going to use my message of role. Okay, comma dot write of message of content. So I'm just going to go ahead and write this entire content with respect to all the conversation inside the st dot chat underscore message. Okay, now finally I'm going to go ahead and create, and this is something that we do commonly whenever we want to use session state in every project that we really want to do. Now I'll say, hey, function to handle or to generate the response. I'll go ahead and create my own function, and for this I'll write definition generate underscore response will be nothing but it will be user underscore question. Okay, and here I'll go ahead and create my response assistant underscore agent, and here I'm just going to go ahead and invoke. Okay, so this assistant agent that you'll be seeing, right, what it exactly is, this is it, right? And I'm writing dot invoke over here, and I'll be giving my input, right? So this will specifically be my input, and here I'm going to give my whatever question that I have. Let me just go ahead and remove this, and let me write it over here. So this will basically be my question. Okay. Now, along with this, I will go ahead and write return response. Okay. And this are all my values. Remember one thing, guys, I forgot to tell you that when we initially imported, right, I'm considering that all these things are have installed in your requirement.txt. So from the starting session till now, whatever requirement.txt we have actually created, I've just kept everything in one place so that you can just go ahead and install it and start using. Okay, so you can also go ahead and do that. Now this will basically give us the response. Now let's start the interaction. So I will say, hey, let's start the interaction. Okay. Now here, what I'm actually going to do, I'll write st dot button, and I'll say find my answer. But before this, before I start clicking the specific button, I will also go ahead and create my question. And here I'll say st dot text area, and by default I will put one question over here. I'll say enter your question. Okay. And here you'll be able to see that I will go ahead and write my question. Okay. Now one of the question that I have taken over here, I have to create it over here is like this question, right? The same demo one which we saw. I have 5 bananas, 7 grapes. I eat 2 bananas and give away all these things, right? So all this information will be given by default, and we can also use it if you want. Otherwise, leave it. Okay. So here if I go ahead and write if question after clicking the button, right, get answer. I'll say, hey, if there is a question, right? If there is a question, then what you do? Run st dot spinner. Okay. So these are some components in Streamlit. So here I will write with st.spinner, and let me say that there is some message that is basically getting generated. So I'll say generate response, and here I will go ahead and write like this, and then I will just go ahead and write st.session underscore state dot messages dot append. Okay, and here I'm going to basically write role colon user. Right, so this will basically be my role that I have to probably set it up before we start this conversation, and the content will be equal to the specific question that I'm passing. Okay, so this is what we was first of all appended, and then we will go ahead and start st.chat message. Okay, chat message, and here I will set my user along with that. User, and I will write the user question. So it should be visible in that particular chat message, right? So that is the reason I'm putting this entire information. So this will basically be my question. Now quickly, let's go ahead and write st.cd, where I will be creating my Streamlit callback handler. And inside this, I will say st.container. I'll initialize the container, which will basically display the entire thoughts of action. And I'll say, hey, go ahead and make the tab false. It should not be visible in the initial stages. Later on, I can click and I can probably expand it. Now I will go ahead and get my response. So for this, I will say assistant. I can either call this function like generate response. Okay, it is up to you what you really want to use it. Okay, or what you can do is that you can directly call assistant. So let me just remove this because again, why to create this particular function? I know it's not a best practice, but I will just go ahead and write it over here because I just need to call it from here itself. So assistant.run. But if you are probably developing a bigger application where you have front and back and many things as such, you have to probably go ahead and create a function. So here I'll write st.session underscore state dot messages. Okay. And here I'm going to also integrate with it callbacks. So callback will be st comma cb. Okay. So this is it. And then finally, I'll just open my new braces. New line. I will say st.session underscore state dot messages, and I'm just going to append each and everything over here. I'll go ahead and write append. So it should be messages. Let's see. Messages over here. Messages over here. Messages also over here. Okay. So it should be matching each and everything. Okay. So append, and here I'm just going to go ahead and add my role. So the role will be with respect to assistant, because once I get my information, right, what role we need to assign, it needs to be assistant. It needs to be assistant, and then we'll go ahead and add our content, which will be response. Okay. So finally, let's go ahead and print the response if you want. Okay. So I'll go ahead and say print the response, just to print it in the terminal. Otherwise, instead of writing this, I'll just go ahead and say st.write, and let me add my response colon. And here I'll say st.success. This will be my final response. Okay. If the question is given, that is fine. Otherwise, I'll say else st.warning. अरे भाई कोई input डाल दो. Please enter your input. Please enter the question. Okay. That's it. So quickly, I think within 10 to 15 minutes, I was able to do the entire coding, and step by step, I've actually showed you. Over here, let me just go ahead first of all and show you what all things we did. We had one Grok API key text input so that we can put all the information. Then we have this we initialized our LLM model, then we created our tools like Wikipedia, math, then we had our prompt, then we had our prompt template, and finally we combined the prompt and the LLM model using LLM chain. Then we converted this LLM chain into a tool, right? That is what we really did. And then we initialized the agent by combining all these tools with the LLM model agent type, what we really need to do. Then we created the session state, and we are making sure that every time whatever input specifically comes, we append in this particular session state. And now here I have my question, and once we click this particular question, it should probably go ahead and interact with the agent and probably give you the output. Okay. So this was overall the entire thing. So let me do one thing. Let me just go ahead and write cd dot, and I will go ahead to cd. If you see over here, this is my Math GPT 8th lesson. So I'll go ahead and write math cd 8 Math GPT. Okay. And now in order to run it, streamlit run app.py. App.py. Now before that, I will go to my environment variable, take my Grok API key, and just run it. Let's press enter. So here you can see it. Let me close this. So here I have my API. So I'll go ahead and press enter over here. So here you can see one positional argument is missing in Wikipedia because of description. I know what is the error. I think there should be a spelling mistake. Okay, this is description. Wikipedia. That was a spelling mistake. Okay. I'll say always rerun. Okay, it is asking for installing num expression. So let's go ahead and do that. So quickly I will go ahead and open my another command prompt, and this will be one of the requirement. I'll just go ahead and update in my requirement.txt. Let me go ahead and paste it over here. And let me press enter. So I'll say pip install minus our requirement.txt. So let's go ahead and do this installation. One of the dependency, I think this is just for the numerical expression, how to probably use this numerical expression, how to calculate it. So once it is successfully installed, I'll go over here. Now let's reload this. Okay, let's go back to my env. I will go ahead and copy my Grok API key. So 2 errors we have faced till now. I'll press enter. And here you have this. Hi, I'm a math chatbot. You can answer all your mathematical questions or maths question. Just go ahead and click on find answer. So here you can see thinking. Let's break down. Reasoning is basically happening, right? And over here some funny logos has also been used. Okay, so finally you can see 69 is the answer. Okay, I'll say what is let's say I have 20 apples. I have 5 friends. I have 5 friends, and I give each friend 2 apples, and later takes 1 apple back from them. So this is most like a logical reasoning, right? So how many apple do I have? Okay, I'm just trying to make so. Okay, so I'll go ahead and click on find my answer. So let's see. See over here, all this question response will also be over here, right? So here you can see I've got 69 now. The next question over here, I'll go ahead and see this one minus 10, 10 plus 1. Okay, you take 1 apple back from them. Okay, they don't understand from each of them. Okay, so they're saying, okay, I have 11 apples left. If I write from each of them, I think I should be from each of them. Okay, now I think it should be able to give the answer. Let's see. So it should be able to give you 15, right? So yes, go ahead and try it out. This is another amazing project that we have actually developed. You can give any kind of complexity, just try to give it in the form of sentence, and then try to see that whether you're able to get all the answers or not. So yes, this was it from my side. I hope you like this particular video. This is amazing text to math problem solver using Google Gemini 2. Google Gamma 2. I hope you like this particular video. I'll see you in the next video. Thank you. Have a great day. Bye-bye. Hello guys, so we are going to continue our discussion with respect to LangChain, and now we are going to get started to work with Hugging Face. Already in our previous videos, we have seen how we can use Hugging Face embeddings. But in this module itself, I will be talking more about Hugging Face. And you can see over here on May 14, 2024, there was an article that was published by Hugging Face itself. Hugging Face and LangChain, a new partner package in LangChain. Okay, and we previously, like before May 14, right, everybody who really wanted to use LLM models from Hugging Face, they had different set of libraries that they usually used from Hugging Face itself to call it, and it was really a daunting task. But by this specific integration of Hugging Face and LangChain, now it has become really, really easy. And since our course, we are completely focusing on the LangChain ecosystem, so LangChain has this Hugging Face integration also. So we'll be talking about this as we go ahead. So first of all, what I really want to do is that I want to go to huggingface.co. So please make sure that if you do not have an account, go ahead and create an account in huggingface.co. Now, what exactly is Hugging Face for? It's an amazing company. It has, if you just go ahead and click on the models over here, you'll be able to see it has tons and tons of models. It's just not like 1 or 2 models. It has a huge repository of every kind of models that are probably available. So here you can see Google Gamma 2, 9 billion parameter model is also available. Right? Let it be open source, let it be paid. Everything is there. Some of the models like OpenAI models will not be available over here, but other than that, I feel every model is available. Paid models, and over here you'll also be able to find both open source and paid models also, paid models itself. And to access paid models, you have to probably use Hugging Face API endpoints. You can create your endpoint with respect to any model itself, but there you will definitely require a credit card and all. Other than that, Hugging Face still provides you so many different open source models which you can completely easily use it at any point of time. So just to give you an example, let's say I want to probably perform something like image text to text. So see over here, there are 3 categorization of models that you will be able to see. One is multi-model. Multi-model basically means all those models which will be able to work both with text and images. So here they will be able to understand both text and images. So some of the models over here, visual question answering, document question answering. Let's consider this particular model like image text to text. We will go ahead and see one example over here. Florence too large, right? And here you can actually see this is the model. All the requirements is basically given. Code is given how to call this particular model, right? And you can also use this particular model with the help of transformer library, which is available in Hugging Face. Okay. But again, as our main aim is that our main aim is to simplify this calls to the LLM models that is available in Hugging Face, and for that we will be using a LangChain package which is integrated with Hugging Face. Okay. Other than this, if I go back, you will be also able to see other multiple models like computer vision. In NLP, you have text classification, you have question answering. Let's say if I go ahead and click on question answering, you'll be seeing so many different models. Like there's a tons and tons of models, right? So Hugging Face is one of the most popular company who are specifically working in this field of generative AI with respect to any open source model also that comes. First of all, it will be available in Hugging Face and Kaggle, and there are also other companies like whichever companies basically launching it, they'll also put there in their own website. But at the end of the day, they are going to do the integration in Hugging Face. They're going to do the integration in LangChain and all, right? So all these particular models is also available. You can go ahead and check it out. Text summarization is there. Let's say text summarization. I want to go ahead and see Gamma 290. I'll be able to see over here. I'll also be able to see check the inference API. I'll say, hey, my name is Krish and I like something like this. And if I go ahead and compute it, you'll be able to see Gamma 2 model is too large to be loaded. Please use spaces. Okay, now it's telling you to use spaces because 9 billion parameters there, right? But you can go ahead and check out with any other models that you like. Let's say I want to go ahead and try Meta Llama 8 billion parameters. I don't know whether I'll be able to check or not. So let's see. Over here also the same issue, right? But smaller model, you can actually go ahead and check the inferencing. Okay. So what we are basically going to do is that now I hope you've got an idea with respect to what Hugging Face exactly is. You can go ahead and see more about it, the kind of documentation, amazing posts are there, and slowly we'll be discussing about many things as we go ahead and how we can actually create an end-to-end generative AI application with the help of both LangChain and Hugging Face. That is what I'm actually going to discuss in the next video. Okay. If I go ahead and see the documentation page, so here is what Hugging Face is basically there in the LangChain documentation. You can see how the installation is basically done, and then we'll be talking about Chat Hugging Face, we'll be talking about this, we'll be talking about Hugging Face embeddings, right? Hugging Face embeddings, I think I've already spoken about, and some of the examples after doing this will create an end-to-end project with the help of Hugging Face itself. So yeah, this was it, and you can probably read more about it. So there's a new Python package that is designed to bring the power of the latest development of Hugging Face into LangChain, right? So yeah, in the next video, we will be discussing more about Hugging Face and we'll be seeing some practical implementation. And after that, finally, we'll implement an end-to-end project. So yes, this was it from my side. I will see you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Hugging Face and LangChain. As mentioned, Hugging Face and LangChain, they have combined together, like they are working together, and they have actually created a new partner package which is called as Hugging Face, LangChain Hugging Face, right? So in order to show you the entire practical implementation, first of all, what we'll do is that we'll go ahead and install LangChain underscore Hugging Face, okay? And before I go ahead, you'll be able to see that I've created this 9th folder, right, with this experiments.ipy NB file. We will be using the same virtual environment to execute it. So I've selected Python 3.10. Along with that, you'll also be able to see that in the requirement.txt, I've installed LangChain underscore Hugging Face. Okay. So this is the library that is basically required. If you have not installed it, so you can go ahead and mention it over here. And what I will first of all, I'll just go ahead and install this. So see, as soon as it is installed, and already I've done the installation, so it is showing requirement already satisfied. Okay. If you want to do the installation from requirement.txt, so just make sure to update it over here, and I will just go ahead and open my terminal. Right. I will write cd dot dot. Okay. I'll go back to my file where the requirement.txt is present, and I'll just go ahead and write pip install -r requirement.txt. Okay. So once I do this, all the installation will start taking place. So please make sure that you do this particular work from your side. Okay. But anyhow, I'm also making sure to show you that how from the Jupyter notebook only you'll be able to do it. Okay. One more thing that we are going to install is something called as Hugging Face Hub. Right. So I will also go ahead and do this, and I'll write Hugging Face underscore Hub. Okay. And we'll also check whether it is available in the requirement.txt or not. So here you can see it is not available. So I will go ahead and install this also. So let me quickly go ahead and install this, and this will also be important with respect to the requirement. So here I will talk about why we'll be using this, but let's go ahead and do the installation. Okay. So here also you can see the requirement is already satisfied, and I have done the installation. Now, why Hugging Face Hub will be there? Because this will be very much handy when we have to do a API call. Okay. Like how do we do an Grok API call? Similarly, we can use Hugging Face. We can use this Hugging Face Hub to do the API call for all the models that are available in the Hugging Face. Now, one thing that you really need to make sure that Hugging Face also has a paid plan, right? So there you can also create your own endpoint address, and you can actually start with that. I'll show you that, but I'll show you just one example how you can actually do it. But again, I don't want you to put your card and unless until you're working in a company for the same purpose. Okay. So here, first of all, what we are going to do is that we are going to import OS. So I'll go ahead and write import OS. Along with that, I will say from .env, I'll be importing my load underscore .env. Okay. And then I will go ahead and initialize load underscore .env. The reason is very simple because if you remember in my .env file, there will be something called as HF token. So we will be using this specific token in order to do the API call. Okay. So here I've made sure that I will call all my environment variables. Okay. Now the next thing is that the first way of probably calling your any models that is available in the Hugging Face, and I think all the models should be accessible. I've tried multiple models and I could find that okay, it was accessible, but there may be scenarios that some of the models may not be accessible also through the endpoint. Okay. So let's consider one of the examples which is called as Hugging Face endpoint. Now, how to access Hugging Face models with the API? If you want to access any Hugging Face model with the API, then you specifically require this Hugging Face endpoint. It is just like how you create a Grok API key and you're communicating with the Grok model. Similarly, if you just have a Hugging Face API, you'll be able to communicate with all the models over there. So there are two ways to use this class. You can specify the model with a repo ID parameter. Those endpoints use the serverless API, so they don't need to have any server also. They'll use a complete serverless API. This is particularly beneficial to people using Pro accounts or Enterprise Hub. Still, regular users can already have an access to fair amount of requests by connecting with their HF token in the environment, right, where they are executing the code. Now see, usually the serverless API is given to people who are having Hugging Face Pro account and Enterprise Hub, right? And for the people who just have a free account, for them also some fair amount of requests is basically given. You cannot go ahead and hit 1,000 requests at a time, right? For the people who are having Pro and Enterprise Hub, they can actually go ahead and do that 1,000 requests they want. Okay. So here what we will do is that I will try to show you how this Hugging Face endpoint works. So for this, I will go ahead and write from LangChain underscore Hugging Face. Okay. Hugging Face. I'm going to import Hugging Face. See, there are so many options: Hugging Face endpoint, Hugging Face embedding, Hugging Face pipeline. Okay, so I'll talk about each and everything. Okay, and then I'll say you that which will be the best one if you're just doing it in a local machine. So from LangChain underscore Hugging Face, import Hugging Face endpoint. So here what we'll do is that we will go ahead and use one of the models. Okay, let's see some of the models that we can actually go ahead and use it. Okay, so I'll go back to my Hugging Face. Okay, models. Let's say I want to go ahead and you can directly search the model name also if you want. Let's say I'm going to go ahead and do Mistral. Okay, Mistral 7B. Okay, let's go ahead and do this. Okay, Mistral 7B instruct. So I'm going to use this specific model, right? So now here all I have to do is that I'll just create a variable which is called as repo underscore ID, and I'll initialize this particular model name. Okay, so this is the path of the model that we are specifically going to use. Okay, now if I want to call this LLM model, now if you want to know more about this model, you can go ahead and see this. This Mistral 7B instruct large language model is the instruct fine-tuned version of Mistral 7B. Okay, it has the following changes compared to this. It recommends this, and what kind of task you'll be able to do? Text generation. See, hey, my name is Clara. How are you? Hey, Clara, I'm just a program. Tell me about yourself. Okay. So it is a text generation LLM model. So if I go ahead and click on send, I should be able to get the answer, right? See, as a computer program, I don't have any personal experience. So if I really want to just use this specific model through this Hugging Face endpoint, all I have to do is that give this repo ID, and then we will go ahead and create our LLM. And here I will call this Hugging Face endpoint. I will initialize it. First of all, I need to give my repo ID as my parameter. So let me just go ahead and write repo ID is equal to repo ID. Okay. The next thing that I'll be saying that hey, we will set some max length parameter for the tokens. Let's say I'm going to set it to 150. Okay. Now once I set it to 150, next I will go ahead and set my temperature. Like how do I set for other LLM models like this? And finally, I'll give my token. And now this token will be very important and will play a very important role. Now in the ENB, I have actually created a token which is called as HF underscore token, right? And how do I create this token? I have to just go over here, go to the settings button. Okay. In the settings button, I will be having this particular access tokens, right? So I will go ahead and take this access token. You can go ahead and create a new token and you can actually use it, right? So we will specifically be using this particular token. So here I will have pasted the same token over here. I'll just go ahead and click on this, okay, and go to my page. And here I have to call that particular token. So for that, I will be using os.getEnv, right? And I'll paste it over here. So this basically becomes my LLM model. See, now I have downloaded it, right? Not downloaded, I'm accessing that particular API, right? So here it says that token has not been saved to the grid credential pass, so and so, and now it has been saved to my, and it is showing login successful. So finally, once the API is authenticated, the API key is authenticated, then only we'll be able to do the access. So finally, here you can see Hugging Face endpoint, repo ID, Mistral, this is there. Okay. Now the next thing, what we are basically going to do, just use this LLM, and how we usually invoke with the help of Hugging Face, we will go ahead and write LLM.invoke, and let's say that I ask a question, what is machine learning? Okay, and I go ahead and execute it. So if I just go ahead and ask LLM.invoke what is machine learning, now that is going to interact with the Mistral that is available in the Hugging Face, right? By using this Hugging Face endpoint, right? Similarly, I can go ahead and ask LLM.invoke, and here let me just go ahead and write what is generative AI. Okay, I'm just going to ask another question, what is generative AI? Done. Now if I go ahead and execute this again, I'll be able to see what is the response that I'm getting. Generative AI refers to the type of artificial intelligence, all these things like that. Let's try with other model. You may be thinking, Krish, how many models will be accessible? If you're lucky, I've been lucky all the time, and I was able to see multiple models. Let's see some more models. Okay, so I'll go ahead and select models. Let's go ahead with Google Gamma 2. Okay, I don't know whether this is a completely new model, and it has recently come into. It has been announced by Google. Okay, I'm recording today at 7/7/2024. So let's see whether we will be able to access this model or not. So here, instead of writing this repo ID, let me copy this entirely, paste it over here. Okay, now I will just go ahead and call this specific model, and this model needs to be just put up over here itself. Okay. Now here, let me just go ahead and execute it. So login successful. Google Gamma model is also accessible. That's amazing. Now let me just go ahead and search for LLM.invoke, and let me write what is machine learning. Okay, and I'll just go ahead and execute it. So here I'm getting an error saying that the model, okay, it is too large to be loaded automatically, so it is not, we are not able to access it. So for this, we need to create a dedicated endpoint. Okay, and there are scenarios where you cannot use some of the models, right? These are some of the disadvantages over here. And obviously the size is very huge, so you're not able to upload it. Okay, the Hugging Face default spaces are only not able to upload it. Now let me do one thing. Let me just use the same LLM model over here. So this will basically be my LLM model, and I will show you with the help of Hugging Face endpoint, can we create a RAG application kind of thing where we can integrate with, where we can also integrate with prompt template, right? So now this is my LLM model. Now what I will do, I will quickly go ahead and write from LangChain import prompt template. And along with that, I'll also import LLM chain, right? We have discussed already about this. Let's say I will just go ahead and create a template. I'll say, hey, let's make a simple question over here, something like this. Okay. I'll say, hey, this is my question. Okay. Question. And here I'm basically going to write my answer. My answer is like, let's think step by step. I'm just adding this prompt. Okay. Just to make it a little bit curious. Okay. So this basically becomes my prompt. Now I'll go ahead and create my prompt templates. So I'll just go ahead and define this, and I will go ahead and write my template. And then finally, I will also go ahead with input variables. So input variables is nothing but it is your question. Okay. And then I can go ahead and just display this print prompt. Okay, so once I execute it, so here you can see input variable is question, template is this, question is this, answer, let's think step by step. Okay, perfect. So this basically becomes my prompt. Okay, now here I have to give question as an input, right? So first of all, what I will do, I will go ahead and create my chain. So you know how to create a chain, right? LLM underscore chain, let's see, and I will be initializing to my LLM chain, and here I will write LLM is equal to LLM, and finally prompt is equal to, it's nothing but prompt. Okay, whatever prompt template we have defined. Now if I just go ahead and write LLM.invoke, and inside this I'll give my question. Okay, now instead of giving this question, I will write something like this, question colon, what is machine learning? Okay, I'll execute it. I'm getting an error. Class dictionary might be a prompt value or list of. Okay, I should not be giving in the form of dictionary. Instead, I can just directly go ahead and write this particular question. Okay, so the question will be, what is the, or I'll just write, who won the World Cup? Who won the Cricket World Cup? Cricket World Cup 2011. Okay, I'm just seeing the previous information. So once I execute it, you'll start thinking the question along with that, what will be the next. So here you can see the 2011 was the 10th World Cup, which was held in Indian subcontinent from February 9 to this. India on 2nd April. The final was played in Wankhede Stadium. The tournament was won by India, who defeated Sri Lanka by 6 wickets. All this information is nicely, completely given over here, right? So this is good enough, right? Now you can go ahead and try whichever models that you want, but always make sure that that model is accessible, right? At least it should be accessible. This was mostly about the Hugging Face endpoint. Again, there are ways. There is, let me just go through this particular way and show it to you. But what I feel is that by using Hugging Face endpoint, you will be able to do most of your tasks, right? So if I go back to the documentation over here, you'll also be able to see, I've already shown you how to probably load any embedding techniques. Also, you can also use this specific embedding, right? So in order to use this, you can also use this Hugging Face embedding if you want, right? From langchain_community.embeddings and all, you can probably use it, right? And similarly, Hugging Face embeddings also. So here you can see, BG model and Hugging Face are the best open source model. BG model is created by Bridging Academy of this. It's a private, non-private organization engaged in AI research and development. You can also go ahead and see some examples with respect to this and execute it. Let's see some examples over here. So I'll just go ahead and click this. Over here, see, so easy it is. That's it. How you basically call this Hugging Face embeddings, right? From langchain_community, you just give the model name. Let's execute this. LangChain documentation is really powerful. You should definitely know how to probably read all these things. So here, I'll go ahead and copy and paste it. And let me just go ahead and execute this also. So it will basically create a 384 embedding, right? So if I just go and search for this one, this is getting executed. Let's see. Okay. This has got executed. Okay. Now, if I go ahead and execute this, so this is my embedding for this particular text, right? So this is also an open source embedding which you can actually use it, right? In your projects, we have used some other embedding over there, right? If you probably go ahead and see, right, what all embedding techniques we had actually used. So over here, okay, LangChain embeddings and Hugging Face embedding, right? We use something called as all mini LM L6v2, right? So Hugging Face sentence transformer is a Python for state of art. You have seen this, and here also I've actually shown you, right, with respect to the embedding. Now, in Hugging Face, there is also very important one library which I will also talk about it, which is called as chatting Hugging Face. Now here, you'll be able to see that, see, in Hugging Face you can create your own endpoint URL, right? So in order to create an endpoint URL, what you have to do is that just go ahead and search for creating an endpoint in Hugging Face, okay? Once you do this, you just go ahead and click on this inference endpoint. Now here, with respect to this inference endpoint, right? Let's say it says that deploy your first model. If you click over here, okay, you'll be able to see that you can create your endpoint address, but at the end of the day, you need to put your credit card and all. So that is the reason why I'm not showing you. See, right now, if I just go ahead and click on endpoints, these are serverless endpoint, which I was able to access it. I was able to access version 0.2, version 0.3, version 0.3, right? So many number of requests I did. But if you want a dedicated endpoint wherein you will be able to access everything, so for that, some charges will definitely be there, right? So for that, you need to probably go ahead and add your credit card, right? You have to probably use this HF paid services, okay? But if you're interested, just go ahead and use this. But I would again suggest, unless and until you're working in a company, don't put your money over here, because other than that, Hugging Face endpoint actually helps you to probably work with almost most of the LLM models that are available. Other than that, you can also have Grok API that you can use it. So I hope you were able to understand this, and now you can just understand how easy it really becomes to work with this, right? Now in my next video, I'll take up any one example and I will try to implement an end-to-end project with the Hugging Face endpoint itself, right? So yes, this was it from my side. I hope you like this particular video. I will see you all in the next video. Thank you. So guys, we're going to continue the discussion with respect to LangChain and Hugging Face integration. In this video, I'm going to show you an end-to-end project with the help of Hugging Face endpoint. If you remember, guys, previously there was one amazing end-to-end projects that we had actually created, right? And if I talk about that specific project, it was about text summarization, where we were specifically using a YouTube URL or any website URL. It was able to summarize the entire text and give it to us, right? So I hope everybody remembers this. If you don't remember it, don't worry, I have copied the same content inside my 9th folder, Hugging Face with LangChain, in my app.py. Okay, so let me just go ahead and run this quickly, and then we will see that how we can, and over here you can see that I'm calling Grok API key. And the model that is specifically used is Gamma 7b, right? Now instead of using Gamma 7b, what I will do is that I will use my model from Hugging Face, right? And that is also Mistral, the same model that we used it over here, right? In which we discussed in our previous video. So let's first of all go and see this particular demo. So I'm in my 9th Hugging Face with LangChain folder. I will go ahead and write Streamlit run app.py. Okay, let's go ahead and see this. So here you'll be able to see that fine. This is my entire model. Or let me just copy this quickly and let me go back to my page. Over here I will try to load it. Okay, so here is my entire page. Here first of all it is asking me for the Grok API key, so I will go ahead and take my Grok API key, which is present in my env file. Sorry, Grok API key, not a HF token, but Grok API key is required. So I will go back over here, copy and paste it, and press enter. Okay, then I will take this particular URL. Okay, AI versus ML versus generative AI. This is my video in my YouTube channel, just to test it out. And I'll paste this link over here, and I'll say, hey, summarize the content from the YouTube or website. And remember, right now we are using Gamma 2 model from the API itself, from the Grok API. And here you can see the entire output. Similarly, if you go ahead and see any other website page, right, like let's say docs_dots.smith.langchain.com, if I'm giving this particular URL in my summarize URL, and if I say to summarize the content from the YouTube or website, you'll be able to see that I'm able to get the entire summary. Okay, so this is perfectly fine till here. I think you'll be able to get it, right? So all the information is there. Now instead of using this Grok API and Google Gamma 2 model, I will try to use Hugging Face endpoint. Again, it's completely for free with respect to some of the models that we have. Okay, so I will go over here, go back to my API. I'll just close this because I don't want it right now. Okay, and let's see what all changes I will do over here. First of all, you'll be seeing that this all will be same, right? First of all, I will go ahead and change this API, right? Instead of writing Grok API, I'll say, hey, Hugging Face API token. Okay, I'll say provide my Hugging Face API token. Okay, and I will write HF over here. Okay, so first thing is this. Then you'll be able to see that I will also make sure that I'll comment out this particular code, because LLM model I need to call with respect to that. Now, if I really need to call the LLM model from Hugging Face endpoint, I need to import this library from LangChain_Hugging Face. So quickly, I will go over here. I will import it over here. Okay. Once I import it, now it's time that I should be calling my Hugging Face API. And let me just do one thing. Let me also make sure to put this particular condition over here for my API, HF_API. So I'll say if HF_API.strip, and here I'm using LLM. So LLM now I have to create, right? So I will go over here. I've commented out this particular LLM, and instead of writing like this, I will go to my experiment page, and you know that how I've called this, right? So I will just copy this entire thing, like Mistral 7b and all. I will paste it over here. That's it. That is the change. So simple, right? Now, your task will be that whatever end-to-end projects we have created, right? Just try to see whether we are having something or not related to this, right? Now, inside this token, you'll be able to see that I'm calling os.getEnv, right? HF_token, right? So this particular token needs to be replaced with whatever token I am going to get. So this is nothing but it will be a HF API key, right? Whatever token I'll be getting from my website. That's it, right? It is so simple. That's it, right? And here you have actually done that, changed this entire LLM model where you have calling this particular LLM model from the API with the help of API itself. So now let's go ahead and execute this. I'll say Streamlit run app.py, and now finally you can see that I've executed it. Now let's do the same thing. I'll take this. Now my LLM model is completely changed. Before that, I'll just go ahead and put my Hugging Face API token. It is present over here in my env file. And here I will go back. I will paste it over here. Okay. Now let's try the same YouTube URL. The content will be different when compared to Google Gamma 2, because Google Gamma 2 is a much better model. It is a huge 9 billion parameters, right? And this is just a smaller model that we have, but it is also a very good model. So here you can see in this video, Kushnaik discusses the differences. It says Kushnaik, okay? Whenever I say Krish, it assumes Kush, okay? And all the information is there with respect to the summary. The same thing what I'll do, I will also do it for this particular website. And here easily you could see that, okay? So beautifully we are able to do all these things, right? Now I'll go ahead and summarize the content. Any page, you should be able to summarize it in a much more easy way, right? So again, this model somewhat time is taking, but now you can see this entire information, right? So yeah, this was it from my side. This was with respect to LangChain and Hugging Face. I hope you like this particular video. And now one of the tasks that I really want to give, go ahead and explore other projects and try to integrate with Hugging Face endpoint with using any models that you really want. Okay, see what kind of issues you face, and then you can probably proceed ahead with that. So yes, this was it from my side. I hope you like this particular video. I will see you on the next video. Thank you. Take care. Bye bye. So guys, in this video, we're going to create one amazing LLM project, which is nothing but PDF query with LangChain and CassandraDB. CassandraDB will be probably creating a platform which is called as DataStax. So if you have probably heard about this particular platform, which is called as DataStax, which will actually help you to create CassandraDB in the cloud itself. And why this platform is quite amazing, because from this, you will be able to perform vector search. And whenever we talk about this kind of documents, or if you want to really create a Q&A applications from huge PDFs itself, vector search is the thing that you really need to implement. Now, before I go ahead, let's first of all understand the entire architecture. We will be solving this entirely step by step. What are the steps specifically that will be taken to probably complete the specific project that we really need to understand? So let's begin with the architecture. Initially, let's say you have a specific PDF. This PDF can be of any size. and any number of pages. First of all, we will read the documents and understand here we are going to use LangChain, as I said, because LangChain has some amazing functionalities which will actually help you to perform all the necessary tasks to create a specific application. Now, first, we will go ahead and read the documents, that is specifically the PDF. And the first step, usually whenever we work with this kind of data set, is with respect to some kind of transformation we really need to do. So after reading these documents, we will convert this into various test chunks. That basically means to split the data set into some kind of packets, right? So this text chunk will be of some specific size based on the tokens that we are probably going to use. So over here, you can see some example, reading the document, and then we have divided this into some chunks. Then we will convert all this chunk into text embeddings. Now for here, we will be specifically using OpenAI embeddings, okay? OpenAI embeddings actually helps you to convert text into vectors. Now, why you specifically require these vectors? I hope you have heard about text embedding techniques in machine learning, right? There we have specifically used bag of words, TF-IDF, and many more things. That is already present in my YouTube channel. They have also used word-to-vec, average word-to-vec. What are the main aim of all these techniques? To convert text into vectors. Because once we probably convert into vectors, we can perform various tasks like classification algorithms, like similarity search algorithm, and many more. So that is the reason we will specifically be using OpenAI embeddings, which will be responsible in converting a text into vectors itself. Now, once we convert every text into vectors, we will also say this as text embeddings. Once we get this embeddings, what we are specifically going to do now, this will be quite amazing because understand if we have a huge PDF document, right? So definitely the vector size will keep on increasing. So it is better we store entirely all these vectors into some kind of database. And for this, we are going to use Cassandra DB. So in short, what we are basically going to do is that we will take all the specific vectors and save it in a vector database. Here, currently, we are going to use Cassandra DB. Now, what exactly is Cassandra DB? So in order to understand about Cassandra DB, I have opened the entire documentation page over here. Apache Cassandra is an open source NoSQL database, and it can definitely be used for saving massive amount of data. So it manages massive amount of data fast without losing sleep, right? So again, understand this is a NoSQL database, and for vectors kind of thing, we definitely have to save it in this kind of database itself. Many bigger companies are basically using this Cassandra DB for this specific purpose. So if you really want to read more about Apache Cassandra, you can probably see over here. Apache Cassandra is an open source NoSQL distributed database trusted by thousands of companies for scalability and high availability. This is the most important point, for scalability and high availability without compromising performance, linear scalability, and proven fault tolerance on commodity hardware or cloud infrastructure, making it as a perfect platform for mission critical data. Now, how we are going to probably create this specific database? For that, we will be using this DataStax platform, wherein it will actually help you to create this vector Cassandra DB, so that you can store entirely all these vectors into this specific DB. And at any point of time, if a person is trying to query from this particular DB, you will be able to get that specific response from that, right? And the most similar response that you'll be able to get it. Now, that is the next step. What we are basically going to do, all these vectors, we are going to save it in some kind of vector database. As I said, we're going to use Cassandra DB, or we can also say Astra DB, and this will be created in this DataStax platform, wherein you can actually perform vector search. Now, the next thing is that after you probably save entirely all your vectors in the database itself, then a human, whenever a human tries to query anything that is related to that particular PDF document, it is going to probably apply similarity search along with text embeddings, and is going to get that specific response. So this is the entire architecture that we are specifically going to perform in this specific project. All the steps will be shown step by step. Everything will be explained in an amazing way along with the code and along with the explanation. Now let's go ahead and start our specific project for this PDF query with LangChain and Cassandra DB. So guys, now let's go ahead and implement this specific project. I will be going step by step. I will also be showing you how you can create the Cassandra DB, specifically in the DataStax platform itself. We'll be seeing step by step all the comment regarding this code and all is given over here. I will also be providing you the code in the description of this particular video. So first of all, what exactly we are doing? We are going to query PDF with Astra DB and LangChain. It is basically powered and understand it's powered by vector search. So first of all, you need to understand what exactly is vector search. So there's an amazing documentation that is given in the DataStax documentation itself. So vector search enhances machine learning models by allowing similarity comparison of the embeddings. Embeddings basically means whatever text is basically converted into the vectors. That is basically embedding, right? And over there you can definitely apply multiple algorithms, right? Machine learning algorithms on the fly, right? As a capability of Astra DB, vector search supports various large language models. So large language models is supported in an amazing way in this. The integration is very much smooth and easy, right? Since this LLM are stateless, they rely on vector database like Astra DB to store the embeddings. See, understand? Because when we say stateless, that basically means what? Suppose if you have embeddings, once we lose it, we cannot again query it, right? So it is definitely require a database to probably store all these things. And what you can do after that, you can query any number of times. So let us go step by step and let us see. Okay, so first of all, we need to create a database on Astra DB. So I will probably click the specific link. Everything is basically given over here. For this, we will be going to astra.datastax.com, right? So first of all, it will probably ask you to sign in, right? And here you can probably sign it with your GitHub or with your Google account. So here I'm going to go ahead and sign it with GitHub. And probably once I probably sign in over here, you will be able to see that I'll be providing the link along with everything in the code itself, right? So it will be very much easy for you. So once you go to astra.datastax.com, the next step is basically to create a database, right? So this database, what kind of database we are going to probably create? It will be serverless vector, and this is specifically a Cassandra DB. Okay. So here I will probably give my database name. Let's say I want to do PDF query, right? So this will basically be my PDF query DB. Okay. This will basically be my database name. You can give anything as you want, and here I'll basically be giving LangChain underscore DB or key space name. It should be unique. The provider that you can specifically use, you have multiple like Amazon Web Services, Microsoft Azure, but here I'm going to probably use Google Cloud, which is the default that is selected. In the next step, we will go ahead and select the country region, which is by default US East 1. So as soon as you probably fill all these details, and as you know that we are specifically going to use this vector database itself, because at the end of the day, the algorithms that we are probably going to apply, it will be easy with respect to this kind of database, right? So finally, we will go ahead and create a database. Now, once we create the database, you'll be able to see that my database is basically created over here, right? So this is what is my database that looks like, right? PDF query underscore DB. Now, if I probably go to my dashboard, I've already created this kind of database a lot. So let me consider one database which I've already created. And over here, some important information that you really need to take. First of all, I will go and click on connect. Okay. So when I probably click on connect, some information you will definitely require. One is generate token, right? And the other one is the DB ID. So DB ID is basically present over here, right? The token is basically present over here. Now I'll talk about where this specific information will be required. Okay. So here I will go with respect to my code. Now let's start our coding. Initially, we will be requiring some of the important libraries like Castro, Dataset, LangChain, OpenAI, and TikTok. So here I will go ahead and execute it, and I will go ahead and install all the specific libraries. So it will probably take some time, right? I've already done that installation, so for me it has happened very much quickly. Now the next thing is that, as we know that we are specifically going to use Cassandra DB, so in LangChain you have all these libraries which will actually help you to connect with Cassandra DB and perform all the necessary tasks like text embeddings, creating vectors, and probably storing it in the database itself. So here I'm going to probably import all these libraries from langchain.vectorstores.cassandra. I'm going to import Cassandra. Along with this, I'm also going to use this vector store index wrapper. It's going to wrap all those particular vectors in one specific package so that it can be used quickly. Then I'm also going to import OpenAI, because OpenAI is the thing that we really need to use. Along with this, we are also going to use OpenAI embeddings, which will be responsible for converting your text into vectors. Along with this, if you want some kind of data set from Hugging Face, you can also use this. And one more important library that we're going to use is Casio. Now Casio actually helps you to probably integrate with the Astra DB, right, in LangChain, and it'll also help you to initialize the DB connection. So all these libraries we are going to use, I'm going to execute this step by step. You're going to probably see, and this is the first step: installing the libraries and initializing all the libraries that we are specifically going to use. Along with this, what we're going to also import is one PDF, which is called as PyPDF. This will actually help you to read any PDF, read the text inside the PDF itself. So this is one amazing library to probably use. Okay, so here I've basically installed PyPDF2. So let me just go ahead and execute it. And inside this, you will be able to see it shows requirement already satisfied because I've already installed over here. Then from PyPDF, you're going to use PDF Reader, because this will be the functionality that will be used in order to read the document. Here is the document that I have specifically taken. So this is one budget speech PDF. So this is the Indian budget that is probably of 2023. It's a big document with somewhere around 461 KB file. It has around 30 pages. So I'm going to specifically read this PDF and then convert it into vectors, store it in the database itself, and then query from the database anything that you have any information about that particular PDF. Now let's go ahead with the setup. Okay. Now with respect to the setup, you require three important information. One is the Astra DB application token. One is the Astra DB ID. Okay. So where you can probably get this two information. So go to your vector database in the data stacks. So here is what you're specifically logged in. Okay. As I said, inside your DB, just go and click on connect. Here you need to click on generate token. As soon as you probably click on generate token, then you will be getting some code which looks like this. This token you will specifically be getting. So this will be probably found in your token JSON file. So it will probably show you a JSON file which will have this information. Okay. The first information that you have over here is the Astra DB application token. So here you can probably see it starts with Astra CS. So what you need to do, just click on the generate token and you'll be able to see it. This is the first information. You just need to copy and paste it over here. The second information is Astra DB ID. Right. Astra DB ID is nothing but this specific information. That is your database ID. Where do you get it? You just need to copy it from here. So this is the information with respect to your Astra DB ID. So this two information, once you do it, you paste it over here. I've already pasted it. And then you can also see that I've also used some OpenAPI key, and this specific API key, don't use this only because I made some changes. I've already executed the code also. Okay. So I'm going to take this three information. This two information is basically used to connect to your Astra DB, right, which has a Cassandra DB hosted over there in the cloud, right? And the other information is basically to use the OpenAI API features, right? So all this information is basically there. I'm going to probably execute this, and then we will go ahead and read our budget speech PDF. So this is the first step. According to this, we are reading the specific document. Before that, we have initialized everything with respect to this. Okay. So once we specifically do this, I will probably be reading this. Now after reading, as I said, we are going to divide all our content into some kind of chunks, right? So here is what chunks we are basically going to do. Now first of all, I will read all the raw text. So for this, I'm going to use from type extension using concatenate. I'm going to read from each and every pages. I will extract all the text. So here you can probably see for I, page in enumerate PDF reader.pages. Page.extract text will basically take out all the text from those pages and it will concatenate in this particular variable, that is raw underscore text. So once I probably execute this, what will happen is that you will be able to get all the text inside this particular variable. So you can probably see over here, raw underscore text has all the entire text. So this is the entire text from that specific PDF, right? Slash n basically means new line. So this step is basically done. Just imagine before, if you did not have this specific library, it was very difficult to read a PDF, right? And we have actually done this just with writing 4 to 5 lines of code. Now the next step is that we will initialize the connection to your database. I have all my database information, right? Like token ID and a database ID. I'm going to use that Casio. Casio is basically used as a library over there for initializing of this particular database. So Casio.init, here I'll be giving one parameter which is called as token, which will be nothing but Astra DB application token, and then your database ID, which is nothing but Astra DB ID, right? So I've taken this two information, I will execute this. You'll get some kind of warnings, so don't worry about the warnings. It is just like it is showing you some kind of warnings, okay, with respect to some drivers issues and all. But this will basically get executed, and now I have basically initialized my DB itself, right? Now we're going to create the LangChain embeddings LLM objects for letter use. So for that, I'm going to initialize OpenAI with my OpenAI key and embeddings also. OpenAI embeddings with my OpenAI key. So I have my LLM, I have my embeddings. Okay. Now is the main step. I need to create my LangChain vector store. So over here, this is what we are basically going to create now, right? And for that, we have initialized Cassandra, right? We have imported Cassandra. Now what we'll do is that in this Cassandra, we will provide three important information. What is the kind of embeddings we are going to use? What is the table name inside this particular database? Session none, key space none. So this is the default parameters we have specifically used. QA mini demo is my table name, okay? Just like a question answer table name. And what kind of embeddings we are going to specifically use? That basically means whenever we push any data in my Cassandra DB, in my Astra DB itself, what it is going to do? It is going to probably convert all the text using this embeddings into vectors, right? And this is the embeddings that we have initialized over here. So here is the next step. We will go ahead and execute this. So this is my Astra vector store. But still, I'm not probably converted my text into vectors. Only when I'm pushing my data inside my DB, that time this entire embeddings will probably convert that particular data into vectors. Then what we are specifically going to do is that we will take this data and we will try to we'll take this entire data, we'll convert into chunks, and we'll also do the text embedding, right? Text embedding while inserting, right? So here you first of all we are dividing the data, the entire document into text chunk. So for this we are using character text splitter, which is basically present in langchain.textsplitter. We need to split the text using character text splitter. It should not increase the token size. So here I've given character text splitter. I'm saying use the separator slash n. Use chunk size, some chunk size of 800 characters. Chunk overlap can be 200. And how much is the length with respect to that specific length? You can probably provide it over here, right? And once I probably do this, you can see text splitter.split text. Here you will be able to get all the text. And if I see the top 50 text, you can probably see that I'll be able to see all the top 50 text over here, right? All the data itself. This is amazing, right? And this is basically from the PDF, right? All the data, right? It is basically taking the top 50, right? And understand the token size is basically over here as the chunk size is somewhere around 800, okay? Now this is done. We have the text. I'm going to just use top 50 and probably store it in the vector database to see if everything is working fine. Now, how to add the specific text? Now, what will happen when I add this text inside my Cassandra DB? See, Astro Vector Store, what is this? This is basically initialized with respect to the Cassandra library, right? So here you'll be able to see that I've used embedding. So now when I'm inserting inside the Cassandra DB, what it is going to do is going to apply the specific embeddings also. So that is the reason you'll be able to see that when we write extra underscore vector underscore store dot add underscore text, and I'm taking the top 50 text over there, this will also perform embedding. So that basically means if I see over here, it is going to perform this task and it is going to insert in the Astro DB, which is having the Cassandra over there, right? So it is going to do this both the steps with respect to this particular code. So we are going to add this text and then we are also going to wrap this entire inside a wrapper. Okay. So these are the information. This is the index that we'll be getting with respect to those texts. So once I probably execute it, you'll be seeing that in the same database, it is going to insert all this headlines. Okay. Now, finally, let's go ahead and test it. That basically means I have my vectors inside my database. Now it's time that we just query and we ask some kind of questions. Now I have read this entire PDF, guys. I could find out some of the questions like what is the current GBD, how much agriculture target will be increased and all. So I will take this particular example and let's say I'm writing first question is equal to true. While true if first question, I'm just say that input. Okay, to just ask like what kind of question you want to type. Else, it is just asking you to put more questions itself. If I write quit, it is going to break. Otherwise, it is going to continue. Now see, this is the most important. As soon as I give my first question, it will go ahead with Astro Vector Index and it will query whatever query text we are specifically using and the LLM models that we are specifically initialized. And after that, we will be getting the answer. Along with this, we'll also be providing some information, right? Like for doc score, similarity source score, like some other information also, right? So let's go ahead and execute it. And as I said, I'm going to use this question. Okay, how much is the agriculture target to be increased and what focus it will be? Okay, so I'm going to paste it over here. I'm going to press enter. As soon as I press enter, you can see that it is now taking the information. See this, you can probably see over here we are querying this particular DB, right? And it's going to give me the top 4 results. Okay, so here you can see that agriculture credit target will be increased to 20 lakh crore with the focus on animal husbandry, dairy and fisheries, right? Why it is giving only this much data? Because I've told that take the 84 characters or 84 words, 84 characters text till there and probably give the results, right? If I increase this, it will give you more results. Along with this, you can probably see that it is giving me stock K queries. That is the 4th query. Hyderabad will be supported as center of excellence. Some more information, but the most suitable answer that you have specifically got is this one, right? And this is what probably if you go ahead and search in the PDF, if you give the same question, you will be able to see the same answer, right? Along with this, probably if I want to probably see what is the current GDP, if this information is present over there, it will also be giving you that specific answer. It will just do a similarity search, right? So here you can the current GDP is estimated to be 7%. Isn't it amazing? Now you can probably take any huge data because at the end of the day, you're specifically using DB, right? And finally, if you want to quit it, I'll just go ahead and write quit, and this is basically quit, right? So in short, we have performed each and every step. Now this is what it is happening. Whenever a human is giving a text query, text embeddings will happen, and based on the similarity search, and then you'll be probably get the output, right? And this is the entire steps we have basically done step by step. Now, amazing shout out to DataStax Astro DB because you can also create your own free account. Vector search, which is super important. Not just understand any type of Q&A applications you can definitely develop with the help of vector search, right? And that is where this DataStax Astro DB is basically used, right? And internally, it is specifically using Cassandra DB. In this video, we are going to create a code assistant, an end-to-end project code assistant with the help of CodeLlama. Okay, now what exactly is CodeLlama? It is again brought up by Meta, completely open source, and with the help of CodeLlama, you can also build your own personal code assistant, which will actually help you to write any code with the help of any custom prompt that you want. Okay, so step by step, we'll be seeing how we can actually implement it, and here I'll also be using Ollama. So let's go ahead and first of all understand about CodeLlama. Now, what exactly is CodeLlama? It is a state-of-art large language model for coding. So here are some of the examples. If you give any prompt, let's say that you want a Python programming language for Fibonacci series, so it will probably give you the entire code over here. Right now, if I probably talk about CodeLlama, so the latest update is from January 29, 2024. So CodeLlama, what exactly it is an amazing performing model in CodeLlama. They have launched 3 main things. One is 70 billion parameter with the foundation code model, Python 70B specialized for Python, CodeLlama 70B, Instruct 70B, which is fine-tuned for understanding natural language instruction. But if you want to understand about CodeLlama is a state-of-art LLM capable of generating code and natural language about code from both code and natural language prompts. Okay, CodeLlama is free for research and commercial use. As I said, it is a complete open source, so it will be very much good if you're also using for solving your own custom use cases. Okay, and some more things if you want to know, CodeLlama also comes. It is a code specialized version of Llama 2. Okay, Llama 2. So again, the main base model, the base model, the pre-trained model is Llama 2. On top of that, fine-tuning is done specifically for related to code, and here you have this specific model. Now you can use this, and you can probably use for different languages like Python, C++, Java, PHP, TypeScript, C# and Bash. Okay, so let's go ahead and see how does CodeLlama work, and we'll try to develop an end-to-end solution. Now quickly, to probably just show you what I'm actually going to do is that I'm going to open my command prompt, and as usual, as I said, I'm going to show you this with the help of Ollama. So if you don't know about Ollama, I've already uploaded a video, right? Ollama basically helps you to access all these kind of open source models, LLM models in your local. Quickly, you'll be able to execute it while you're doing the deployment also in the cloud. Anything you can actually do it with the help of Ollama. Okay, so first of all, we'll go ahead and download this. So first, to download Ollama, again, Windows also you have this now. So as soon as you download it, just click on this. There'll be an exe file, and then you just double click on the exe file and start installing it. Right? When you install the Ollama, it will be running in your background process. Okay, now IP address, I'll talk about IP address also, like localhost IP address, it will be running up. Okay, since it is an exe file. Now once you have downloaded the Ollama, if you probably go ahead and see in models, in Ollama model, there'll be also a model which is called as CodeLlama, right? So a large language model that can use text prompts to generate and discuss code. Quickly to check it out, what I will do, I will open a command prompt, and here I will write Ollama run, and let me see whether it is there or not, CodeLlama. So I will go ahead and click on CodeLlama. So as soon as I hit this, I've already downloaded the CodeLlama within my local itself, so I will just be able to write any message and probably get the response. So let's say provide me a Python code to perform binary search. So this is my question. If I probably search it over here, you'll be able to quickly see that I'm able to quickly get the response along with the code. Right now, this entire thing I'll try to create it as an end-to-end application, and we'll try to do it. Right now, this CodeLlama is also like a model itself. What I will do is that I'll create my own custom ChatGPT application, which will specifically be using the CodeLlama model. So quickly, let's go ahead and open my VS Code. So in the VS Code, you'll be able to see that I have a requirement.txt file. I've installed LangChain and Gradio. So I'm going to use Gradio and LangChain. Gradio for the front end and LangChain which will be interacting with the Ollama itself. Right. So all these things will be there. And first of all, I've also created an environment. I hope you know how to create an environment itself. Right. So quickly, let me go ahead and open my app.py file. Okay. Now the first thing, along with the app.py file, since I am going to create my own custom models, which will be using this entire CodeLlama, I will create my model file, right? So this model file, I will go ahead and write from CodeLlama. Okay, I hope the spelling is right. Let's see. Yeah, from CodeLlama. Okay, and this is what I specifically write with respect to custom application, right? Because I want to create my own custom prompt, okay, from CodeLlama. The second thing what I'm going to do is that I'm going to set the temperature. I want my model to be very much creative, so I will create a parameter over here, and this parameter will be nothing but it will be a temperature with 1, okay? So I'm going to set the value to 1 because I really want this application to be very much creative, okay? The next thing that I'm actually going to do over here is that I'm going to set the default system prompt, like how I want this CodeLlama to behave, okay? So here I will go ahead and write my system parameter, and this I'll be using 3 quotes. Now I will give my prompt over here, okay? So I'll say you are a code teaching assistant named as Coder, created by obviously myself, Krish C. Nayak, or Krish, created by Krish, okay? Named as Coder, I've already given over here, so I will say that, or I'll say Code Guru, okay? Created by Krish, okay? And then I will say answer all the code related question being asked, okay? So this is asked over here, right? So this is my simple system prompt that I've done, okay? Now I've created my model file. The next thing what I will do, quickly go ahead and find I will reveal this in this one folder. I will just take the folder name. I will open my command prompt, okay? Now I will run this and I will initiate this code group, right? So quickly I will go and write cd this one, okay? Let me go to my E drive, okay? Now in order to run this as your own custom model, what I will do, I will go to that path, and then if you go ahead and see in the GitHub, right? There are ways how you can specifically run by using Ollama, right? So quickly I will go ahead and write this one. See, code create -f model file, right? So here I'm going to execute it like Ollama create. I will say code guru, okay? Code guru -f model file, okay? So this is done. And model file, instead of writing model file, I should write my correct name of the model file over here. It is model file itself, small model file, okay? Model file. Now this is what is going to happen. The CodeLlama is being used anyhow in those, right? Because see, at the end of the day, what I'm actually doing, I'm using CodeLlama over here, right? So I'm creating my own custom GPT type of application, a code assistant application over here, which is basically using the functionalities of CodeLlama itself, right? Or to be using the LLM model in the backend as CodeLlama. So if I probably execute it, now you can probably see over here that it is running fine. Now the next thing I will do over here is that Ollama run, and I will just say code guru to just check whether it is working fine or not. So here is my code guru. I'll say, hey, who are you? Okay, so here it says, hey, I'm Code Guru, an AI assistant designed to help code related queries and tasks, and all, who has created you? Who has created you? I did not say Meta, instead myself, okay? I was created by Krish, a software engineer who is also my developer. He's also trained on a wide range of programming languages, so and so and so, okay? Nice. So my Code Guru is running, absolutely fine. Now let's go ahead and integrate with my app.py, okay? Now, in order to start with the app.py, now see, if somebody asks me anything that is related to this kind of code and I can want to quickly create a POC, right, I can actually do this, right? So what I'm actually going to do over here is that, quickly, I will go ahead and import requests, okay? Now I'm going to use the API, right? The Ollama is running in the backend. My Code Guru is also running in the backend. I just need to access it with the help of API, right? So I'm going to import JSON. Along with that, I'm also going to import Gradio as gr, okay? Gradio is also done. Now what I'm going to use is my URL. As usual, as I said, the URL that you're actually going to do, right, or get as in the form of API, and I've already referred to the GitHub, is this specific URL. That is localhost :11434/API/generate, okay? And then I'm going to create my headers. Now inside this headers, I will go ahead and write content type, and this will specifically be of application JSON, right? Application JSON. Now, where do you think I will be getting this information? Because if you go ahead down and see, right? If you see like how you can actually call in the form of API. See, this is the URL, right? And this is the prompt. This is the model name that you really need to give, right? And the messages you can also put roles and content. So I'm using that same API documentation over here. Okay. So quickly we'll go ahead and write. So content type will be application JSON, and now I'll create a function. We'll say generate_response. Okay. Generate response, and here I'm going to give my prompt. Okay. So whatever prompt I'll give over here, it will be able to give me an answer. Okay. So here I will write data is equal to, now let me go ahead and create my body. Okay. Now for creating the body, the first parameter that you require is model name. As I said, model name, obviously what is my application that I've actually created? It is code guru, yes, right? So I will write code guru because it is running in the backend. And then any prompt that I really want to give over here. So this will basically be my prompt over here. And with respect to this particular prompt, let me just quickly go ahead and write final prompt. I'll just name it as final prompt over here. Okay. And as you all know, this final prompt, I need to initialize it somewhere here. Okay. And before that, let me do one thing. I'll also create a history so that it also makes sure that the previous information it saves it. Okay. So here I will write history.append. And whatever prompt I'm specifically getting, that prompt will be coming over here. And the final prompt will be nothing but, since I need to make sure that history gets appended or joined in a new line. So I'll write /n.join. And here I'm going to basically write as history. So here it is, final prompt, this is there, final prompt has been appended in the prompt section. And then I will keep this parameter as stream is equal to false, because if I keep the stream value, what is going to happen is that it is going to give me in a lot of different values. Unnecessary values will also come, but I'm super interested only in the output, right? What output I get in the form of response. So this is what is my generate response. Now quickly I can go ahead and write my response. Response is equal to request.post. And inside this post, I will give my URL. The headers is already set up. Okay, URL, comma, headers is equal to headers, whatever headers I'm actually set it up. Okay, then my data will be JSON in the form of JSON.dump. Dumps, I will give the specific data. Okay, because I need to convert this entire data in the form of JSON. Once I get the response, then what I will do, I will write if response dot status code is equal to 200, right? If it is successful, in short. Okay, then I'm going to take this response. And from this response, I'm going to take the text, whatever text output I'm actually getting. Okay, quickly this will get replaced over here. Okay, once I get this particular test, then again I'll be using JSON.loads, and I will convert this back into this one. Okay, I'll be loading this in the form of JSON itself. Okay, I have that response, and then from the actual response, what I'm going to do, so inside my data, there will be another response parameter which I'm going to read it. Okay, and then I'm going to return this actual response. If the status is something else, then I will just give a return message saying that print error, and this error will basically be having my response.text. That's it. Perfect. So this is what is my function, which is taking a prompt. It is using this code guru, and it is giving me based on the input that I'm giving, it is giving some kind of response. Now this is my backend. Okay, complete backend. Now I need to create my front end. Okay, now let's go ahead and create my front end. So this will be interface is equal to gr.interface, and gr.interface. So here I'm going to create my function and go ahead and write my generate response. Let me go ahead and quickly create my inputs. This will be a text box that I really want to use over here because at the end of the day I need a text box where I get the input and another text box where I get my output. Okay. So in this text box I'll say number of lines. You can use it as 2 because 2 or 4, whatever you want. Okay, 4 I'll give it max to max, and then I'll also keep a placeholder. So placeholder is equal to enter your prompt. Okay, perfect. This is done, and then finally what will be my output? The output pattern also will keep. It will also be a text form, right? So whatever output we are going to get, and then I'm going to launch this interface. Launch. So that is how we launch in Gradio. So you need to have some basic idea. Anyhow, I'll give you the entire code also. Okay. Now quickly let's run this, and let me go ahead and write Python app.py. I hope it should work. Okay, we are getting an error over here. The reason is that I did not activate my env environment. So I will say conda activate venv. Okay. Now what I will do, I will quickly go ahead and install all my requirements. Okay. Once the requirement has been installed, you'll be able to see that all the requirements will get installed. The requirements is basically having this two library, that is LangChain and Gradio. And once I probably write this, then we are good to go and run this entire application in a very simple way. But at the end of the day, understand one thing, how beautifully, easily it becomes with the help of Ollama. And again, we are also using CodeLlama. See, at the end of the day, guys, you really need to know multiple models quickly to practice to create POCs. In companies, they are looking for all this kind of skill sets. It's good that you know multiple models, you have the knowledge of multiple models and all. Okay. So please make sure that you keep on practicing. I have been trying really hard to upload new videos for you every day. I try to come up with something new, something informative, which will be beneficial for your site. So please make sure that you practice, keep on practicing. Unless you don't practice more, you won't be able to become a pro in that. Okay. So we'll wait for some time till this requirement.txt is getting installed. I think another 10 to 15 seconds, and then we will go ahead and run this app.py. So guys, now you can see the requirement.txt is installed. So let me quickly go ahead and do one thing. Let me clear my screen. Okay. Now quickly let me go ahead and run Python app.py, and now I think you should be able to see the UI part with the help of Gradio and all, and we'll try to see the application whether it is running fine or not. Okay, outputs. Okay, output is missing. Let's see. Okay, this should be outputs. No worries. Okay, Python app.py. Now it should be working absolutely fine. I should be able to get an API. So here it is. Let's open this. So here you can see this amazing front-end Gradio application, and let me please, hello, who are you? Okay, and I should be able to submit it. And here on the right hand side, you can see that I'll be able to get the response. Okay, I'm a code guru, you code teaching assistant, your code created by Krish. Okay, perfect. Provide me Python code to perform binary search. Okay, and here is what I should be able to get the response. So how fast it is, amazing. Okay, you can probably see over here. Definition, here's the Python implemented. Perfect. Provide me, let's say Java code if I write. Should I be able to get the answer? Provide me a Java code. Okay, perfect. I'm able to get the Java code also. This is Python. Okay, this is Java. Oh, history is also getting added. See, oh yeah. So this is Python. This is Java. Provide me. Let's see. Provide me a Python code to create Atom Optimizer. This is difficult. Okay. Obviously, we use the library, but I think we should be able to get the output. But this is good, right? Your own custom code assistant. So I can probably keep it running over here, and whenever I'm implementing something, I should be able to quickly write anything that I want and get the answer itself, right? So here it is. Atom is an optimization algorithm. This. Perfect. Here is all your answer, right? Provide me a Python code to perform Fibonacci series. Let's see. I'll submit it. So I hope you like this particular video. I hope you're able to enjoy it. Now you can also create your multi-language code assistant, multi-programming language code assistant with the help of CodeLlama, which is completely open source. So yes, this was it. You can probably see all the answers are here. Java code is everything is available. Great. And history also is getting appended. This is very, very nice. Hello guys. Now we have developed so many different applications. Now I will just try to show you how you can go ahead and deploy this kind of applications. So from all these examples, you can take up any example that you want, but I will go ahead and take this particular search engine, which I had actually developed. So I will go into its file, right? So when I probably go over here, you'll be able to see all these files I have actually arranged in this way. So this is my venv folder, and this is my requirement.txt. Now to start the work over here, what I am actually going to do is that I will take this requirement.txt, I will copy this inside this particular folder, and this is what is my search engine, right? Now let me just go ahead and deploy this entire application in a Streamlit web app or Streamlit cloud. Okay, so since this is a Streamlit web app, I will try to go ahead and show you first the deployment with Streamlit cloud. So I will just go ahead and type Streamlit cloud. Okay, and I will go ahead and hit enter. Let me just go ahead and write over here Streamlit cloud. And now here you'll be able to see that Cloud Streamlit, a faster way to build and share data apps. But before that, let me go to my GitHub account. Now inside this particular GitHub account, I hope everybody has this particular account itself. I will go ahead and create my new repository, right? So let me just go ahead and click on new repository. Here I'm going to go ahead and write my search engine. Okay, search engine LLM. I will just go ahead and write like this. Then I will add a README file, and let's say I'm going to add a license of general public license. You can select anyone that you like. I will go ahead and click on the repository. One thing you should understand, the reason why I'm using the Streamlit cloud, because you will be able to deploy any number of apps over here, and you can probably go ahead with the specific deployment. Now over here inside this particular search engine, I will just go ahead and open my folder. This is one. Okay, I will quickly go ahead and select all these files, drag and drop it inside this. Okay, so quickly I will go ahead and drag and drop it. Okay, and I know I don't even require this IPYNB because I just require this app.py and requirement.txt. So let me just close this and let me commit the changes. So once I commit the changes, now I have my entire URL. Now quickly let's go to the Streamlit cloud, and I will go ahead and first of all sign in. Here you will be able to deploy any kind of Streamlit web app in a much more easier way. Let it be a generative AI application, let it be a machine learning application, anything as such. So here you can see some of the examples that I've already uploaded. Okay, there are a lot of advantages of using this because anyhow you don't have to pay anything with respect to the deployment, and you'll also be able to get one kind of URL. But at the end of the day, you'll be having the Streamlit.io at the end. Okay, so I will go ahead and click on create app, and it will say that hey, do you already have an app? So over here it has an option to integrate with the GitHub. So I will go ahead and click this since I've uploaded in the GitHub. And as soon as you probably click on GitHub, right, it will first of all ask you for the authentication. Okay, so please make sure that you do the authentication with your GitHub account. You need to have a GitHub account for that. Now, after this, I will just go ahead and search for my GitHub URL over here in my repository. So here you can see Krishnaik06 search engine LLM, and this is my branch main. I'm in my branch main. My main file is app.py. So I will just go ahead and click over here and hit on app.py. Please make sure that you need to have a requirement.txt file over here. Otherwise, it will not understand what all environment variables or what all libraries it basically requires, right? So you need to have this specific thing installed. Now, I will go over here, and this is the domain that it is showing me. I will be able to use with this particular domain. I'll be able to use my web app. Now, along with this, let's say you also need to add some kind of key value pairs, right? Let's say you want to add some secret keys. You can just go ahead and give your secret key name is equal to whatever name you have. You can probably go ahead and display it in this particular manner. Once you upload it, by default here you can see you are having Python 3 version 3.1. I'll be using this particular version. And along with this, any key value pairs, like how we have key value pairs over here, right? Like OpenAI API key, my LangChain API key, LangChain project, HF token. I can also give this particular key by just copying and pasting it over there. But in order to access this, in my app.py, if I'm using this key anywhere, I just need to use st.secret. Okay, I have to use something like this, st.secret, and give my secret key name over here, right? With respect to any keys that I'm actually using, which is put inside my Streamlit Cloud. Let's say if I'm using HF token, right? I may copy this entire key over here. I may paste it over here. Okay. And then what I will do, I will go ahead and save this. Now, I'm using HF underscore token. Let's say if I go ahead and save this. Now here, I've just added one secret. Now, in order to access it, in my app.py, I'll just go ahead and write st.secrets. Okay. And this is how I will be able to access this. Okay. So if you really want to know more about it, just go ahead and search for Streamlit secrets. Okay. And here you'll be able to see secret management, st.secrets, right? If you probably go ahead and use this. So let's say you're given your OpenAI key, you just need to write st.secrets with respect to your OpenAI key, right? OpenAI key over here. So in your Streamlit app, the following values would be true, right? Which is equal to your OpenAI key. So just by using this particular code, you'll be able to use it. But right now, the application that I've actually created, you'll be able to see, and let me just do one thing before I run this. So I'll remove it because here I don't require any secret key, because from the front end I will be putting my Hugging Face API token or any token that is required. Okay, and here I'm actually using this Hugging Face endpoint also, right, to access any kind of things. So this is my entire okay. This no, I'm in the wrong tool. Okay, this is my app.py, right? So in this particular case, you'll be able to see that I'm not using any kind of secret key. I'm just typing it from the front end. Okay, my Grok API key. So now what I'll do, I'll just go ahead and deploy this. Okay, so once I deploy this, you'll be seeing that in the backend. First of all, it will go ahead and install all the requirement.txt first of all, right? So the deployment is very simple with the help of Streamlit app, right? So now here you'll be able to see that the deployment is basically happening, and with respect to the deployment over here, you'll be also seeing that the requirement.txt will get installed in the backend. Okay, so once it gets installed, you will be able to see your entire application. Okay, so this is the most easiest way to probably do it. Before that, what I will do quickly, I'll go to my env file. Now, let me go back to my env file. I will take this Grok API key because this is what I will be required in my application, right? So again, based on the requirement.txt, it will take some amount of time, and let's wait for that time to do the installation of all my libraries and packages that I required for that particular project. And once it does, my project will be ready. Now you can see the requirement.txt has run, and here is my entire Streamlit app, right? Now this is how amazing and easy it is. So I'll just go ahead and paste my Grok API key over here. Once I press enter, I should be able to ask any question. Okay, tell me about machine learning. Now here I've created my search engine using agents, right? So here you can see Wikipedia is just thinking, okay, then Wikipedia invalid tool name. Some invalid tool name here, it is basically coming in search RCF. None is a valid tool. Try one. So finally you'll be able to see that from search and from RCF we are not able to get this information. So it will try to give me the information from machine learning, right? So machine learning is a field of study in artificial intelligence. Let me do one more thing. Let me just go ahead and search for attention is all you need research paper. So here you can see the number. It is nothing but I'll just search for this RCF, this particular code. Okay, so if I go over here and search for it, I should be able to get my answer. So now it is going to my RCF. It is probably communicating over here. Okay, and here you can see again it is probably, and finally you get this particular input, right? Tell me about generative AI. I'll just go ahead and ask this particular question and see how the cloud is probably providing this entirely completely for free. So you can go ahead and probably do this, right? So here you can see machine learning, generative AI, Wikipedia, all the communication is specifically happening. Again, we do not have to probably go to RCF also, because this tool will be more than sufficient with respect to giving your output, right? And to know more details about it, here you can see the user is asking about machine learning and generative AI. So both this information, the chat history is also basically being used, right? And here you can probably see everything as such, right? So I hope you were able to understand this deployment technique. One more deployment mechanism that I would definitely like to show is from Hugging Face, which is nothing but the specific spaces. Okay, so I will show you how you can go ahead and create your own space. Now, Hugging Face space is something very amazing. Hugging Face, it provides some amount of space with respect, some amount of space or deployment server for you all, so that you will be able to deploy your entire LLM application, and you'll be able to use it completely over here and deploy with the URL itself, right? So let's say there's so many spaces over here. If I go ahead and click on any one of them, right? Let's say I will go ahead and click on this OpenLLM leaderboard instead of using leaderboard. Let's see. Right now everything is running on 0 to 0. So if I just go ahead and click this, right? So here you can see ID documentation recognition. You can drop this particular image over here, right, like this, and I can probably go ahead and click on check document details, and I will be able to get all the information. So this entire deployment is specifically happening in the Hugging Face space itself, right? So similarly, what I will do is that I'll take this entire application and deploy it over there itself, and let's see what exactly we'll be able to get it or not. Okay, but again, if I talk about Hugging Face spaces, you can read more about it. Hugging Face spaces. Okay, so here you will be able to discover, and many people usually upload this, right? And you'll also be able to deploy your entire application. So that is what we're going to see in the next video. So I hope you like this particular video with respect to the deployment. I'll see you in the next video. Thank you. Take care. Have a great day. Hello guys, so we are going to continue our deployment series. Already in our previous video, I've already shown you how you can deploy your generative AI application with Streamlit web app with the help of Streamlit Cloud, and probably the steps were quite easy. We just need to put all the code in our GitHub repository, and from this we just need to connect it in our Streamlit lab. Now, Streamlit lab or Streamlit Cloud, you can basically say in that way. Now, I'm going to deploy this entire code solution in Hugging Face spaces. Okay. Now, spaces actually provides you, you will be able to probably deploy your generative AI applications over here or any machine learning applications over here. So step by step, we will probably go ahead and I'll try to show you completely in a very much easy way. Here, if you just go in spaces, you'll be able to see many use cases which are specifically deployed, and you can go ahead and check it out, and you can also check out the code, right? So let's go ahead and do this. There are many steps that it will be involved while probably deploying this entire solution in the Hugging Face spaces. Over here, we are also going to use something called as GitHub Action. Okay, so here if I go ahead and search for Hugging Face space, okay, GitHub Action. Okay, so here you'll be able to see managing spaces with GitHub Action. So if you probably go ahead and see this repository, this is the code that we are specifically going to use. So we will be creating a YAML file, and we will say, hey, you need to push in this particular Hugging Face space and probably do the deployment. Okay, so here I will be going ahead and showing you step by step how these things can be implemented. So first of all, I will go ahead and create a new file inside this repository. Now, first of all, here I will be using one folder called as .github. So usually whenever you create a CI/CD pipeline, you really need to create a YAML file, and the entire configuration inside that YAML file will actually tell you that how you're going to push the code in the deployment servers, right? So for that, I will be creating this .github/workflow. Okay, workflows. So this is the folder that I'm actually going to create, and inside this I'm going to create this main.yaml file. Okay. Now with respect to this main.yaml file, what I'm actually going to do, I will go ahead and copy this entire thing. So here you'll be able to see this is the important code that I will be copying, right? So this code is responsible, and as soon as we do the commit in the GitHub repository, this will be pushing our entire code repository into this particular Hugging Face token. Okay, so Hugging Face space. Okay. Here, please observe each and everything carefully. What is the necessary information? Here you'll be able to see it out. Okay. So let me just do one thing. Let me just hide this if possible. So first of all, over here you'll be able to see that whenever we work with GitHub Action, most of the parameters will be in the form of key value pairs. So this is nothing but syncing to Hugging Face Hub. We are pushing the branch main. Job is basically to run this entire thing in the Ubuntu latest version. We will check out all the code, and finally we'll push this to the hub, which is my Hugging Face hub, and we will be using some secret token, that is our HF underscore token. I will show you how to probably create this particular token, and where we need to push on this specific space ID. Okay. Now how to get the space ID, I will be talking about it. Okay. So let's go back to our Hugging Face space, and let's go ahead and create our new space. Here I'm just going to write search underscore engine underscore LLM. Okay. So this will basically be my application name over here, which I'm actually creating in my space. After that, I will go ahead and select a license. Let's say I go ahead and select Apache 2.0. I know this is a Streamlit app, but other than this, it is for Grady also it is supported. For static templates also it is supported. And if you really want to work with Docker, it is also supporting that, right? And here you have a space hardware free. By default, they'll give you CPU basics with 2 vCPU and 16 GB free RAM. Okay, you can actually go ahead and use this. This will be more than sufficient to go ahead with, right? Then whether you want to make this space public or private, let's say that I want to go ahead and probably create this particular space in public. So I will go ahead and click on create space. Okay, as soon as I probably click on create space, here you can see that I can clone this entire thing and I can start working. Okay, if you want to go ahead and see how many files are basically present over here inside, none of the files are specifically present. So what I'm actually going to do from my GitHub, whatever files is it there, I need to push to this particular Hugging Face hub, right? Where this all files will be present, right? Now, the most important thing is that how do I generate this HF underscore token or this particular token, right? So for that, what I will do, I will go back to my Hugging Face hub or Hugging Face. I will click on settings button. Okay. Now inside the settings button, I will go and click on something called as access token. Now over here, you'll be seeing that I've created so many access tokens. To start with, I will just go ahead and write new, and let's say I will go ahead and create my token over here. But please make sure to select the type as right. Okay. So let's see whether it is right or not. No, it is fine grained. Let me just go ahead and create an access token once again. So I'll be going over here. I will click on new token. I will write token 1. Okay, this will be the name of the token. And type I will go ahead and select as right. The reason I'm selecting as right because I need to push something into the Hugging Face hub inside this particular space, right? So all the files I need to push it over here. So for this I need to write. I need to get a right access token. So I will go ahead and generate a token, and I'll make sure to copy this specific token. Okay, and this particular token I will store it in my notepad so that I will be using this. Where I will be using it and talk about it. Okay, so let me just go ahead and close this after creating the token. Now I'll go back over here. This is the first step. I created my token, right? Now the next thing that you'll be seeing over here, I have something called as git push, git https Hugging Face underscore username. Now what is my Hugging Face underscore username? It is nothing but krishnaik06. So I will just go ahead and write it over here. Krishnaik06. Okay, so this is my first Hugging Face token information that I have. Sorry, the username information that I have, that is Krishnaik06. Then I will be using the same Hugging Face token over here. Then Hugging Face.o. Then here you'll be able to see I have to also mention the Hugging Face username here too. So let me just go ahead and write Krishnaik06. Along with this, my space name. My space name is very simple. I need to use this search underscore engine underscore LLM. Okay, so now here I will just go ahead and write search underscore engine underscore LLM. Okay, and then this basically goes to the, and please make sure to make the spelling right. And finally, this is going to my main branch. So that is the reason we are pushing this entire information into the main branch. And this is my main branch, right? Inside my Hugging Face space. So yes, this was all the information that I need to put over here. Now the next thing is that I will go to my settings. Okay, I will click on settings over here. Okay, inside the settings there will be something called as secret and variable. Okay, now inside the secret and variable I will click on actions, and here I need to go ahead and create my secret key, repository secret key. The new repository secret key that I'm actually going to go ahead and create, right? It should be the same name, right? HF underscore token. So as soon as we call this code secrets.hf underscore token, it is going to take this particular token from here. Okay, and this particular info that I have will be this key, right? I will be assigning it over here. And then we will go ahead and click on add secret. Once we add the secret, here you can see it is my HF underscore token. Perfect. Now this work is done. This is also updated. This my entire this run where we need to push the code is also updated. And as soon as I do this, I'll just go ahead and commit the changes. Okay. So once I commit the changes, now an amazing thing is going to happen. Suddenly just click on this actions. Now see this entire CI/CD pipeline is running. If I go inside this, these are the steps that will happen on push, right? Now it is starting the job, and here you can see that I'm getting some kind of error. Okay. Let's see what is the error. So here you can see to Hugging Face spaces crush engine rejected main fetch failed to push some reference things. This is usually caused by another repository pushing to the same reference. Okay. Now hint have locally this is used by another repository pushing to this, right? So here what it is basically saying is that before this I tried to test one of the repositories, and based on that I was just trying to push it. Okay. So I will go back to that particular repository and I'm pushing it the same thing. So that is the reason it won't make any sense. Let me just go back to my repository over here. Okay. Let me open that particular repository. Okay. Search engine LLM, right? So this is my repository. Here you can go ahead and see that I have my GitHub workflows. And now again, what I will be doing, I'll be having this entire thing right over here. Now let me do one thing quickly over here. That what I will do is that I will go back over here in my code. Okay. And don't worry, because of this error, you may be getting confused because I just tried it before earlier, right? I will just go ahead and update it just to show you how things happen, right? So here I'll just update one of the file. Okay. One of the file, yeah. And then I will just go ahead and commit it. Okay. So here let me just go ahead. So here you can see I will just edit this file. Okay, I will just go ahead and commit it. Okay, I will just commit this particular changes. As soon as I commit these changes, if I go back to my code, one amazing thing is basically going to happen. Go to the actions, and here you'll be able to see I have updated the app.py. It is telling me to sync to hub. Now this entire code is basically a push, right? Now this push has actually happened in my Hugging Face space, right? So I will go ahead and see this particular link. now you'll be able to see the magic, right? So once I hit this link, right, it is giving me an error. Okay, first of all, this readme file, it's okay, we'll try to fix this. But if I go and see in my file section, you'll be able to see that I have my app.py, I have my requirement.txt, and along with this, I also have my GitHub workflow, right? The entire GitHub workflow. Perfect. But still, we are getting an error. How to fix that particular error, right? So what I will do, I will just open my readme file, okay, and we need to edit this readme file. Okay, so what I will do, I'll just remove this because it requires some special characters. Like I need to add what kind of license is there. I'll go ahead and say, hey, this is my search engine. Okay, then I will add the SDK, that is Streamlit. I'll add some kind of emoji. Okay, something like this, and I'll add some color form. Let's go ahead and add this and short description. So this is nothing but search engine with LLM. Okay. Now once I update this quickly, let's commit this changes to the main file. Now here, if I go back to my apps in this Hugging Face space, now see this entire thing. The entire build will start running. First of all, it will go ahead with installing all the requirement.txt, right? So if I just go ahead and see this, right, see over here, all the requirement.txt is basically getting hit, and the container is going to get built up right now. And once this is built, my entire application will show up over here, right? So we'll just wait for some time to just show up the things over here that we are looking for. And till then, if I just go back to my files over here, okay, in my files, please make sure to download this README file because I need to use the same README file inside my GitHub, right? So I will make sure to update this entire thing. So I will just copy this and I will go back to my app.py and let's go ahead and update it over here. Okay. So in order to update it, I will just remove this and I'll paste it over here. I'll commit the changes. Okay. Now, as soon as the commit will happen, automatically this particular code is there, but again, the action will go ahead, and this is all because the CI/CD pipeline is running. Whenever I do any kind of commit and all, automatically the push will basically happen in the hub, right? In my Hugging Face space. Okay. Now, finally, you can see my entire application startup will start running. It's taking some amount of time because there are a lot of inbuilt, all the requirement.txt libraries will get installed, and we will just wait for some time. It's still building the entire container, and the entire application that we really want to run will be shown over here. And this is how you can actually do the entire deployment just by using the CI/CD pipeline. Right? And this is what is an example of GitHub Actions, right? Here in this main.yaml file, what I have actually done is that I've told, hey, on push, you have to push it to the main branch. Where we need to push it in our Hugging Face space, and that is the information that I've actually given over here. Right? So this was one of the most easiest way to probably do the deployment, and you can probably do any kind of generative AI applications that you really want to do, right? So let's do one thing. Let's wait for some time and let's let the build specifically happen. And once it happens, I will probably show you the next steps. Okay, and we will also test out the entire application over here. So yeah, let's wait for some time. So finally, you can see guys, this entire application has started. So we will hide this, and here is our entire application working on this particular Hugging Face spaces. And you can probably pass this particular URL, share this URL, and you can show everyone that what you have actually developed. Right now, we will quickly go ahead and I will be using my environment variable, and I will update my Grok API key. You can probably get the Grok API key over here, paste it, press enter, and after this, I'll just go ahead and search for what is machine learning, and I think I should be able to get the answer. Okay, so thinking, search, thinking, invalid tool, Wikipedia, no need. Then from the search itself, you're able to get all the information. It did not think to probably go to Wikipedia, and here is my information. Right now, still, if I go ahead and ask what is generative AI, I should be able to get my response. Again, it is searching from this DuckDuckGo search, search for generative artificial intelligence and all. So here you can see the question tool, Wikipedia, search archive, and Wikipedia. Right, Wikipedia, if I keep on second, okay, and it is saying that it is not a valid tool, it is not required. And here is the information with respect to generative AI. So I hope you were able to understand this entire deployment mechanism. So I hope you're able to understand this entire deployment mechanism. You can probably go ahead and deploy anything that you want, and I think this Hugging Face space will be more than sufficient. But at the end of the day, I have actually shown you how you can create this entire thing with the help of this GitHub workflows, where we have also used GitHub Actions. So yes, this was it from my side. I will see you on the next video. Thank you. Take care. Bye. So guys, we are going to continue the generative AI on cloud series, and in this video I'm going to probably discuss about the Gen AI project lifecycle. Now, since you already know that we are definitely going to develop a lot of applications specifically in cloud, from the basic data ingestion till the deployment, so it is very much necessary that you actually understand a generic workflow of the Gen AI project lifecycle. So let me quickly go ahead and write some amazing things for you in this particular notebook, and I will be explaining you completely step by step how you can probably see or follow a project lifecycle. And as we go ahead, there will be a lot many things that will be coming, like LLMOps platform, and we will be working specifically with Azure AI Studio, AWS SageMaker Studio, and also definitely both the clouds will get covered. So before I go ahead, please make sure that you keep the like target of all this kind of videos till 1,000. That will definitely motivate me, and I've been exploring many more things so that you get the right kind of guidance and knowledge. So let me go ahead and let me start the Gen AI project lifecycle. With respect to this Gen AI project lifecycle, I would like to make this entire lifecycle into 4 to 5 steps. Okay, the first step, that is nothing but here I'm just going to write over here. It is basically defining the use case. Okay, so what kind of use case are you solving? Now, this use cases can be a RAG application, can be a text summarization application, can be a chatbot. So based on different use cases, that actually depends on your requirements, your company requirements. So this is the first step. You really need to define the use case that you're specifically doing. Now, with respect to this particular use case, we usually take this entire module into the scope part. Okay, so this is basically my scope, right? If I basically use a generic term. Now, once you define a use case, let's say that I'm going to probably develop a RAG application. In that, I'm going to definitely use vector databases. I may have a lot of PDF files. I also need to probably convert that into vectors and store it in some kind of vector store DB. So some kind of use case you really need to define, and all the requirements that is required in that particular use case. Coming to the next step, which is super important, because these steps will be involving 2 important things. Okay, and that is nothing but choosing the right model. Okay, the right model. When I say choosing the right model, here there are 2 different things that you can probably split this into. One, whether you are using or you are probably using some kind of foundation models. So here I'm going to probably write whether you are using foundation model and solving a use case. So this is the one category that I would like to divide this particular model into. The other category is that whether you want to build your own custom LLM. Right? Custom LLM. Now see, there are 2 things over here, right? When I say foundation models are already those larger models like OpenAI, Llama 2, Llama 3, right? You have Google Gemini Pro. So these all are very huge foundation models. And for most of the generic use cases, you can directly use those kind of foundation models and you can solve the use case itself, right? Now, with respect to these foundation models, we can also further go ahead and do fine tuning, right? So let's say I have a foundation model which I am specifically using to solve my business use cases. On top of that, if I really want to make this foundation model behave well for my own custom data, then what I can do on top of this foundation model, I can use LoRa, Clora techniques, and I can probably fine tune all these kind of models. Okay, so this is one of the steps. The second step that I've written over here is custom LLM. Custom LLM is nothing but it is building your LLM from scratch. Building your LLM from scratch, right? And obviously, this one. There's a lot of benefit also if a company is building an LLM model completely from scratch for the specific use cases, but a lot of resources will definitely be required. We have to really take care of model hallucination, many things and all as we go ahead. But yes, I've also seen many companies developing their own custom LLM model. Okay, so choosing the right model or what kind of models you're specifically using to solve this particular use cases, that becomes the second important module with respect to this Gen AI project lifecycle. And obviously, I've spoken about foundation models both in AWS you have, in Google you have, in Microsoft Azure you have. Currently, Microsoft Azure AI Studio specifically have all the access of OpenAI services. Obviously, it is investing a huge amount of money over there. Okay. Now, once you probably select the right kind of model, there are main three tasks that you probably do for going forward. Okay, so the main three tasks. Okay, the first task is nothing but you can specifically use prompt engineering and solve a use case. Prompt engineering and solve a use case. The second task that you actually can do is nothing but fine tuning, right? Fine tuning. So with the help of fine tuning, also you can probably develop your own custom LLM model, and on top of that, you can basically do it. Let's say you're completely creating your LLM model from scratch. One more important mechanism that you have is nothing but aligning, or you can probably say training with human feedback. And this is one of the very important step that is actually used while you're training your LLM models. How a LLM model is basically trained, I've already created a video in my playlist with respect to the LangChain and all, generative AI playlist. You can probably go ahead over there. Fine tuning, how to specifically do fine tuning and all, that also I've actually shown you. The reason why I'm showing you the generative AI project lifecycle, because tomorrow when I'm probably creating videos, let's say in upcoming videos when I'm creating videos related to AWS series, over there you'll be seeing all these particular steps going ahead. Okay. Now, once you probably do all the steps, the further step is something called as evaluation. Okay, evaluation is basically seeing that how your model is performing by performing all these particular steps. There are also different performance metrics which we are probably going to follow. Okay, these two steps I would like to combine and say something like this. Okay, so I'll say probably adapt and align models. Okay, so this will be the specific model that we specifically use for this purpose. Now, over here, your model will be ready. Everything is perfect. You are able to solve the use cases. Let's say your performance metrics is increasing over here. So your metrics is specifically increasing, and it is saying that now your model is ready. Now it comes to the deployment part, right? So with respect to the deployment part, I would definitely say deployment. Further, you also need to do a lot of integration with different applications. So I will probably say application integration. Okay, application integration. And here, what we do, we specifically perform two major steps. One, we optimize models. Okay, I'll just write optimize and deploy models. Optimize and deploy models. Okay, and this deployment is specifically done for inferencing. Okay, and here is where most of your cloud platforms, here is where your LLM ops is used. Different inferencing techniques are there. One technique I've already covered with respect to a platform which is called as Grok, right? It uses an inferencing technique which is called as LP. So it is always a good idea that you should definitely know multiple ways of inferencing. See, at the end of the day, whatever models you specifically create, unless and until the inferencing is not fast, you definitely cannot use those things, right? So it is very much necessary that you know the idea of this module extensively, because tomorrow building all these things is very easy. Fine tuning is very easy, right? You definitely have a template, a framework, a data set preparation and all, and you can perform this particular step. So that is the reason in this series of videos you'll be seeing that how much I will be focusing on this LLM ops platform, right? And I will also show you multiple platforms like which can definitely make your inferencing very much good. So this is the most important thing here. Definitely we'll be using AWS, Azure, right? You can use all these things, GCP, and we'll see what all services they have specifically provided, probably for the inferencing purpose. Again, but initially our focus will definitely be on AWS. Okay. Then the second step, after we do the deployment in the application integration, what we do next is that we build a LLM powered application. Because your integration is done, your API is created. Now it's all how well you can actually build a solution. You can solve different use cases and all. So this overall gives a brief idea about the entire Gen AI project lifecycle. Since we have already started the generative AI on cloud, so this is necessary to know, and you should probably follow all the steps. And whenever I create any videos with respect to Gen AI on AWS, all the steps will be considered in mind, and it will be shown to you. Guys, here is an amazing crash course on Amazon Bedrock. Many people were requesting for this. Now, what exactly is Amazon Bedrock? It is the easiest way to build and scale generative AI applications within your AWS platform itself, right? Right now, many companies are using this. They're using this because understand one thing, that there are so many different companies who are providing LLM models for, or LLM models for different text generation, animation generation tasks, right? There is OpenAI, there is Cloudy2, there is Google, there is even Amazon also has its own LLM model, which is named as Titan. And similarly, there's also Facebook, which is like Llama 2 model. So understand each and everything is that what is the main problem right now? If you want to use these APIs, if you want to use these models, everybody has a different setup, right? Now, what Amazon Bedrock actually provides you, it provides you one AWS platform where all the models will be available, and through their API calls, you can probably use any of these kind of models. Right now, OpenAI is not there, but other than that, I could see almost each and every model that was available in Amazon Bedrock. Now, why this is important? Because a single platform, here you don't have to worry about scalability, you don't have to worry about other things. With respect to the cost that is in the Amazon Bedrock, right, it is slightly more than the OpenAI, and probably in the future it may also get reduced. But at the end of the day, you should know what exactly Amazon Bedrock is, and probably I'll show you in this particular video different tasks. I will try to code it, and I'll try to show you how you can use these APIs itself. So here is what is Amazon Bedrock, an easiest way to build and scale generative AI application with foundation model. I'll also discuss about what are these foundation models. As I said, so many different companies are coming up with some LLM models. Right? So that is the foundation model. You can do the fine tuning here itself. You can use any of these models, perform any task, and even directly you can use it in your application wherever it is required. Okay. So if I talk about Amazon Bedrock, it is fully managed service that makes FMs, that is foundation models from leading AI startup and Amazon available via an API. So you can choose from a wide range of FMs to find the model that is best suited for your case. So with Bedrock serverless experience, you can start quickly, privately customize FM foundation models with your own data and easily integrate and deploy them in an application using AWS tools. So here you don't have to even worry about the deployment, the scalability, and everything as such. So let me just go ahead and click on get started. So this is how it looks like. Now, what all companies it specifically support? Because I'm also going to show you the entire coding also, right? How you can use all these models. Right now in this foundation model, there are different models like from AI21 Labs, you can see Jurassic 2 series is there. From Amazon, you have Titan models. From Cloudy, you have this Cloudy models by Anthropic. You have Llama 2, you have Stable Diffusion by Stability AI. you have this command by Cohere. So through this you'll be able to perform different use cases like chat, text, image, right? And it also provides you hands-on lab along with that some kind of learning course, some basic learning course which you can probably get started to. Now here are some of the examples. Here you can see what all different use cases you can solve with respect to different models, right? So with the help of Python text G1, you can see action items from a meeting transcript, advanced Q&A with citation, with Llama 2 chat 13b, right? So there's 13 billion parameters you can create chain of thoughts. Then here also you have with 70 billion parameters. With Cloud you can have character role play, code generation, content generation, contract entity extraction, create an image. Here you can see creating a table of product description. Then you have debug code with Llama 2 13 billion parameters, Llama 2 chat. Then you have Jurassic. Then you have this, right? So as soon as you probably click on anything, let's say I want to go and see that how it is going to create an image. So here it is what it looks like, right? This is the entire API request that you have to probably call, and with the help of this image will be generated. Let's say I will probably, let's say here, okay, I can open this in Playground and I can give my own HD image of a beach. So this is the Playground where you can with sunset with sunrise. I can basically write like this, right? So as soon as I give this prompt and if I run it, you'll be able to see that I'll be able to see this entire image. So it actually creates this. This is from the Stable Diffusion itself, right? So here you'll be able to see once we create it, we'll be able to run it. And now here you can see this is an amazing image that's created. And you can use HD image, cinematic display, all different things you can probably put over here. I still go with respect to the overviews. So I just showed all these things are there. Examples, you can probably see all these things are there. You can go ahead and check out in the Playground. Let's say there is something called creating table of product description. Here you can see this is the prompt, right? Sunglasses, keywords, polarized, this is there. Let's say this is your table. You can probably ask any kind of questions and get with respect to the answers also over here, right? So different use cases is there. At the end of the day, let's not show you these APIs. Now let's go ahead and implement all these things, right? And there's some steps which we will be seeing completely from scratch. Again, you can use any of the services as such. Yes, there is some pricing because at the end of the day, you're using some cloud services, right? It always depends on the tokens that you're specifically getting. So based on that, Amazon Bedrock basically charges you. So if you want to see the pricing, you can probably go ahead over here and write Amazon Bedrock and you can click on pricing, right? So Bedrock pricing, here is a link. Here you'll be able to see the pricing overview. Different pricing is there. And this is per 1,000 input tokens, right? Price per 1,000 output tokens, input tokens, output tokens. So all these prices is there. You can compare it with OpenAI models and all, but still this pricing will get reduced as we go ahead. Most of the custom solutions will probably come up, right? So this is there, all good things, and you'll also be able to understand. See, Python is also having this multi-model embeddings. But at the end of the day, we should know that how we can actually create entirely completely from scratch. So let me go ahead and start this. Let's see whether I've opened any VS Code or not. So I will go ahead and start my VS Code. So let's see over here. Here is a folder that I've created over here. Let me rename this to AWS Bedrock. Okay, and let me show you. Okay. Bedrock, okay, and let me just quickly show you how you can probably start it. Okay, so I'll show you the entire setup from starting and all, what all things is basically required over here, and you also require an IAM key over here itself, right? So first of all, I will open the terminal. After opening the terminal over here, I will open the command prompt as usual. We will go ahead and create a new environment. That is always a good idea. Okay, so for creating a new environment, I'll write conda create -p venv Python double equal to 3.1 o with y. Okay, so I hope everybody knows about this. So this will basically create my venv environment. And once that environment is created, I will activate it. Till then, I will also go ahead and install requirements.txt. Okay. So once I install requirement.txt, I will be requiring some libraries like Boto3. So Boto3 is a library which will actually help me to connect all the services that we have in Amazon Bedrock, right? AWS Bedrock also. So this is some of the things. Along with this, I will also go ahead and import or install AWS CLI, right? So guys, now after creating the environment, I will go ahead and activate the environment. So venv. So my environment has been activated. Now what I'm actually going to do over here is save this requirement.txt, and then we will go ahead and install these two libraries. One is pip install -r requirement.txt. So once I specifically install all these requirements, so one is two only libraries are required, Boto3 and AWS CLI. Now the next thing, till this requirement is getting installed, we also need to create an IAM user so that we will be able to configure it with the AWS itself, right? So what I'm actually going to do, I'll go ahead and click on the home page. Okay, I will sign into the console again, and here I will search for IAM user. Okay, so once you go to the IAM user, you will be able to see that I will go ahead and create a user itself. So right now there are multiple users. So let me do one thing. Let me go and see the user. Already Krish is created, but I will just create one more user. Let's say test admin. Okay, so this is the user that I will specifically create, and I will click on next. I will say attach policies directly. I'll select this option, and I will give the administrator access. Okay, so administrator access basically means that we are giving the administrator access itself, right? But again, when you're working in the company, you will definitely not get this access. Instead, based on the services that you are specifically using, that access you will get. Okay, I will go ahead and create the policy. So let's see. Once I go over here, then it'll ask for some permission. So okay, forget about policies. Then I will go ahead, and here you will be able to see that I'll select the next button. Okay, after selecting the next button, you can see I'm getting the administrator access. Along with this, what I'll go ahead and create the user itself. Now this is the user that you can see over here, test admin, right? And now let me click on this create access key, right? So I definitely require an access key. So for that, I will go ahead and create this. Over here, you can select command line interface since we are going to use it for CLI. I will go ahead and click on this I understand, and then I will go ahead and click on the next. Once I click on the next, you'll be able to see there's some description value it will ask for. I will say test key, okay? And let me go ahead and create the access key. So here you can see I have the access key, I have the secret access key. Now what you can do is that in this particular case, you can download this, right? So that later on you'll not be able to see this. So it is a good idea that you download this in the form of CSV file. So I'll download this in the form of CSV file, and inside this CSV file, I'll get these two values. One is access key, one is the secret access key. So let me quickly go ahead and copy this, and now I will go ahead and configure it, right? We need to configure it over here. So already you know that we have also made sure that this AWS CLI is available over here and it is installed. Now what we are going to do quickly is that we will go ahead and configure it from the command line. So let me go ahead and write AWS configure, right? So here you'll be able to see it is asking for AWS key ID. So I will copy and paste it over here. So I will copy this and I will paste it over here. Okay. So once I probably paste it, you'll be able to see that it will also ask for secret access key. So here I will copy it and let me quickly go ahead and paste it over here. So here is what. See, right now you're able to see the access key, but don't hurry, I will delete this as soon as I complete this video. Now the default region it is basically asking. So right now it is US East 1. So if I go ahead and see my Amazon Bedrock right now where I'm pointing to. So please make sure that you point it to US East 1. If you are not pointing over here, you can basically whatever region you're pointing, you have to write it over there. But right now, according to me, I'm going to point it over here, right? That is with respect to US East 1. Now one more additional setting you really need to do is that go to the model access, because see, initially when you are in this US East 1, this model access will not be given, right? So over here you have to access, you need to have the status of access granted, then only you'll be able to use the specific models. Now for that, when you click on manage model access, right, automatically the selection will come, and here you'll be able to just save the changes. Here one option of activate changes will come. See in the bottom side, like save changes is over here, no? So here I've enabled it, and this access is granted. Right now, if it is not granted, then this all will be disabled right now, right? So what I will do, just to show you an example, let me just reload this page. Let me show you whether I have granted some other, say let's say with respect to Singapore. If I'm in Asia Pacific Singapore region, right? Now inside the Singapore region, you will be able to see that. See, something is not available over here, right? Like these two are not available. So I will skip Singapore. Let's go to Tokyo. Okay. Just to show you an idea, because I've already activated in US East 1. So if I probably see with this region, here you'll be able to see this much access you have. Available to a request, available to request. So if I probably click on manage model, and if I probably just click on this, let's say these are available, right? I just need to click on request model access. So for this region, only these 3 models are available. These 2 models are available. So my always suggestion would be that you go to US East 1, right? In US East 1, you'll be able to see multiple models like this, right? Multiple models you'll be able to see it. Okay. So you have to request for the access, right? If I probably, you can select US East 1 also, or you can also select US West. It is up to you. US West 2. So here also, they provide you the access of all the models, right? So understand one thing, why I'm showing you all these things, because initially you really need to request access. And this is also what I've requested already. So here you'll be able to find out more use cases, right? So everything is available, right? But by default, I will go ahead and use this US East of N Virginia. Okay. So right now, again, my access is granted. So if your access is not granted, you have to request for it. Okay. So once this is done, I'll go back to my command prompt. Here, the default region is US East 1. So I'll press enter. This is what I really want. And default output format I want in the form of JSON. So I'll go ahead and write JSON. Okay. So this is the initial setup you really need to do. Now let's start working on different models. So guys, now once we have actually configured, now we will go ahead and use any of these models as an example, and we'll try to perform various tasks. So in this example, let me do one thing. Let me take an example of content generation in cloud. Okay. So cloudy one we can specifically take, or let's say I want Llama 2, you can actually take Llama 2. So it's up to you. So let's first of all start with this Llama 2 itself. And for this, I'm going to specifically use Llama 2 70 billion parameters. Okay, the chain of thoughts. Okay. And with respect to every model, you will be getting some model ID, content type. So this is how the API request needs to go. So we'll form this entire API request throughout code, and then we will go ahead and hit this. Okay. So let me quickly go ahead and start my coding. Okay. So here I will rename this to Llama 2. Llama 2. So here is the file, guys, llama2.py. So I will start my code over here. So first of all, let me go ahead and write import Boto 3. I'm going to import Boto 3. Along with it, I'm also going to import JSON. The first thing, as usual, you will be able to see that whenever I see this files, right, say chain of thought over here, I have to create my API request with the help of model name, model ID. Then I need to also put content type, then accept. Then my body should look something like this, prompt with all this information. See, in Llama 2, so basically your prompt intro will start with, or prompt first character will probably start with, first word will start with this. Okay, it's just like an instruction. Okay, INST. Then here you have multiple options. You can probably see this, right? You have options like max, gen length, then temperature, then top P, 0.9, something like this. Okay, so top P basically I think it is with respect to the probability. So let's quickly go ahead and set up that entire command prompt. So what I will do is that I will copy this entirely. Okay, and I will create one JSON. Okay, I will write test.json so that I have that format over here. So this is the JSON. I have to make sure that I have to put all my API requests in this form. Okay, for using Llama 2. Now quickly, I will go ahead and write one prompt underscore data. I will say, hey, this prompt data I want to do something like that. I'll say act as a Shakespeare and write a poem on machine learning. Let's say this is my prompt that I specifically want to use. Okay. Now the most amazing thing is that Amazon AWS Bedrock is quite good. You know, it provides you easy APIs. The APIs request, you just need to use it and start serving it, start using it in your application. So I will first of all go ahead and use this Bedrock. So I will write Bedrock is equal to boto3.client. And then I will specifically use my service underscore name. Service underscore name is equal to, and I have to give the service name as Bedrock dash runtime. So this is the first thing that we really need to do. This is the client name. Like this is the service name that we really need to use. And with the help of Boto3, we'll be able to connect to the Bedrock itself. So this is my Bedrock over here. Now the next thing is that I need to form the payload, right? So this will basically be my payload structure as a dictionary. I will try to give the values in key value pair. As usual, if I probably see the test JSON, this is what is my body. So I need to have in the form of key value pairs. Prompt is equal to some value. Then you'll be able to see max gen length some value, temperature some value, top underscore P some value. So similarly, I will also give my payload in this format. So here I will write prompt colon. And here I will go ahead and write INST since this is my intro, right? And this intro will be concatenated with my prompt underscore data, right? So this I'm concatenating with my prompt underscore data. And in the end, I have to probably also end this instruction. Okay. So this is how my prompt, this prompt body has got created, right? This is what it has got created, right? Because the prompt will get inserted over here. Now, along with this prompt, I need to provide some more different values, right? What all values I need to provide? One example is that I'm getting from my API max gen underscore len. Okay. And this will also be in the form of key value pairs. And here I will mention 512. Okay. And then the next thing is that I will go ahead and write temperature with colon 0.5, comma, top underscore P, colon 0.9. Okay, so these are my initial values that I've actually set up, and this is nothing but this is my payload, the payload that is specifically going over here. So once we do this, the next thing what I will do, this is basically my body. So I will write body json.dumps. I'll basically convert this into a JSON, and I will use my payload over here. Okay, so once my body is basically created, the next thing what I'm actually going to do over here, I'm going to basically write my model ID and use model ID name. As usual, the model ID name is this one, meta, this one, version 1, something. Okay, so I'll paste it over here. So this basically becomes my model ID itself. Now I'll go ahead and create my response. Now in the response, what I need to do, I just need to write bedrock, the bedrock object that is created over here, dot invoke underscore model. Okay, now inside this, I will give my first parameter. The first parameter is nothing but body. The body will be initialized to this specific body itself, whatever body we have actually created. The second parameter is nothing but my model ID. So model, just a second, bedrock. So I have to use this model ID. Okay, so this will basically be my second parameter that I will need to give model ID. And this I will initialize to what we need to initialize to this model ID. Right. So my second parameter is also done. Body is done. Model ID is done. After model ID, I need to give my accept token. As usual, what is accept token in test.json? It is nothing but application/json. So I'll paste it over here. I'll paste it over here. Done. The next parameter after this will be nothing but, let me see, content type. Okay, so I have to also give my content type over here. This will also be my application/json, I guess. Again, I'm just seeing this API. So whatever value are, my body is ready, my accept, model ID, content type. Everything is ready. These are the 4 parameters I need to give in my invoke model, right? What model I'm specifically invoking. Now, once I get this, you'll be able to see that Once I probably go ahead and write response underscore, this will basically be my response. Inside this response, understand once I get this specific response, I'll take the body part. Okay, so inner part, because there'll be a lot many different contents that will be coming up. So if I write json.loads, I will take this value and I will say response.get. So inside this, there will be a key which will be called as body. Okay, inside that body, you will find out entire information of the response that you're able to get. In this particular case, whatever text I'm writing, act as a explain, write a poem on machine learning. So this is basically my prompt, and it will give that specific text inside this body. Okay, so I will write this. Okay, just body.read. This is done. Now I will go ahead and print. I can also print it, but I don't want it. So let me go ahead and write response underscore text. Now inside this, one thing that you'll be able to see that whenever we use Llama 2, if you don't know, I've also created videos with respect to Llama 2, the open source model. If I use this response underscore body, there will also be a key. See, inside this body, there'll be a body key. Inside that, there will be another key which will be called as generation, which will have the entire text of the response that we want. Okay, so I will just go ahead and print this response underscore text. Done. Now let's see if everything is working fine or not, and whether we'll be able to see each and everything. So this is very simple. A prompt is over here. We have invoked the bedrock. Then there is a payload. Then here you have this entire body. I've created in the form of JSON. Then model ID, accept, content type. The main thing is understand this test JSON, right? And then you'll be able to do it. So perfect. Let's execute this now, and let's see whether everything is working fine or not. Okay. So I will just go ahead and write Python llama 2. Oops. Clear the screen. Okay. Python llama 2.py. Okay. So it'll take some time. Again, as you all know, some response time it will take with respect to the APIs that we have. And again, now we are getting the specific API from the cloud, from the AWS server itself, right? In AWS Bedrock. So here is the entire text. Here you'll be able to see. In the fair digital realm where data dot flows free, a wondrous art dot rise called machine learning. Yes, see, this is a science, a craft, a mystic spell. The dot enable machine to learn and tell. With algorithm sharp and data set vast, our computers don't gain wisdom and their insights dot last. And again, based on the token size, it will be charging. Okay, so all the information. See, now whatever prompt you want to give over here, right? Let's say I'll go ahead and write what is generative AI, like write a poem on generative AI. You'll be able to see this. You'll get some response over here. So I'll save this. Now I will go ahead and run it. Okay. Now, similarly, you can actually do it with Cloudy too. You can do it with Stable Diffusion. I'll also show you an example with respect to Stable Diffusion, and then you can also explore that. As said, now let's go ahead. We'll try to do it with the help of Cloudy too. And again, with respect to that, also we'll try to see. Okay, so this is one text generation. So here also you can see, in the realm of code and circularity, marvel of man's ingenuity, creation that dot rival the generative AI wanted to see. So all the information is specifically coming over here. Now let's try another API, and then after this we will go ahead and try, the image generation with the help of Stable Diffusion. So Cloudy, let's see where is Cloudy. Cloudy content generation. Okay, so here is my API. I'll copy this. It's always good to keep a test JSON like this. Okay. Now almost each and everything is same. Okay. I'll talk about like what all changes will basically happen. Okay. So Llama 2, let me just copy this 4 lines of code. Will be almost same. Then I have my payload. I will also copy this, and then we'll change the payload. Okay. So we'll change the payload. So inside this payload, you have prompt is equal to human. You are an expert social media generation. So whatever prompt, basic prompt data, right? So here I don't have to probably create this. I don't want this. Okay. So this will basically be my prompt data. Done. Then let's go with the next parameter. So what are the next parameter? Come on guys, till then hit like. I'm working so much hard here. Come on. Okay, anthropic version is there, stop sequence is there, temperature, this is there, max token is there, say max token to sample is there. So let me just quickly go ahead and write what all things I require over here. So I will go ahead and write max tokens. Okay, so this will be 512 for max tokens. Then I have my temperature. Then I have my this top P parameter looks something like this. Okay, point top P will be 0.8. Okay, something. I'm putting some values. Temperature, let's keep it to 0.8. Let it be more creative. Okay, so this is basically my payload. Okay, now everything almost looks same. You'll be able to see that I will. Okay, I think there is another one. Let's see. Content generation is also there. This is also there. Okay, fine. No worries. Okay, so I think I've used another version. Let me use another one also, which I've already tried. So it is looking good. Okay, so Cloudy 2. So let's quickly go ahead and create my body. So here you have this one. So body JSON.bounce payload. Model ID will be this one, right? Bedrock this. Everything is there. Body, model ID, application, and content type. So once we get the response, this time when we get the response body, okay, like this, when we get this specific body, now inside this body, you'll be able to see that there. In the case of Llama 2, inside this body we have generation, but here inside this body we will be having some more steps. Okay, so that will be some more key value pairs. So here I've written it. So it will be nothing but completions of 0, get data, and then get text. So in completions, there it is just like a list of key value pairs. So I will just take the first one and then probably display the data inside that whatever text is basically coming, and then we will go ahead and response underscore text. Okay, so now everything works fine. I think I've used this model or other model. So this is version 2. Okay, in Cloudy, let's say in Cloudy some other version is also there. I don't know from where I found out, but it was available here only. Advanced Q&A. Yes, I used this one, I guess. Yeah, advanced Q&A. I use this model ID, I guess. Okay, perfect. So once we do this, let's go ahead and run it now. Now I'll go to my terminal. Now let's see whether each and everything will run fine or not. Once I tried with Llama 2, I'm tried with Cloudy 2, right? So I'll write Python Cloudy 2 Cloudy dot py. Okay. So here also you'll be able to see the print statement. Oh, this was quite fast, right? So here you can see, oh, gentle AI with your boundary power to think and create with no efforts. So you are specifically getting the specific output also. So this was with respect to Cloudy. Again, you can try anything that you want. Just take this JSON, just try to play with it. Let's say I take this information only and use this model. Let's see. I will paste it over here. I will take this entire thing and paste this model. So here itself, I'll change it. I think Cloudy, I may get an error because I don't know whether we are able to manage it or not. So I saw access denied. See, so this model is not available. The version 1 is available, I guess. I think I explored this earlier. Find it somewhere. If I probably search this, you'll be able to find it, I guess. Let's see. But anyhow, you try it out from your end. Anyhow, I'll be giving you the code. Like this, you're not able to search. Advanced Q&A and all. Okay, fine. Next start with, I think, see, in US, why that is not working, right? Because if I go ahead and see the model access, the Cloudy model is not available. See, Cloudy instant is not available. So that is the reason that version 1 was available and I was still exploring things, right? And I probably got in that. But no worries, I will now go ahead with Stable Diffusion. So let's go to the base model. See, version 2.1, these all models are specifically there. If I go to examples, let's see with respect to Stable Diffusion. So 1.2 is there, 0.8 is there. We'll go with the recent one. And again, I will go ahead and copy this. Okay. So this will basically be my next text JSON. Okay, so I'll keep all these things over here itself. Now let me quickly create one more file. Save this. One more file, Stable Diffusion. Now here we will try to create an image in AWS itself from aws.py. Okay. Now for Stable Diffusion also almost all the things will be same. I've already created the code, but here what I will do, I will just show you what all things I will do. See, Stable Diffusion basically means I have written a prompt data. See, provide me a 4K HD image of beach. Also use blue sky, rainy season, and cinematic display. Okay. Now with respect to this text JSON, here you can see body has something called as text prompt, and then you have text information. And with respect to the text information, this is basically my prompt. Along with this, you have parameters like weight, CFG scale, seed. This is there. So what I do, first of all, I will set in that format only. So first of all, I create my prompt template where I have my text, my prompt data with weight. Okay. So this becomes my entire this information. Understand this thing, right? You just need to set it. That's it. Text is equal to this information with weight. So I've kept it in the form of list with key value pairs. So that is what I'm getting it over here inside this prompt template. Then I've used Boto client, I've used the service name runtime. Now remaining is all my payload. So inside this, what all payload you require? See, first of all, I require text prompt. The second thing that I require is seed, steps, width, height, right? Width, height. So let me do one thing. I will change this to 1024. I will also change it to 1024. So these are all the parameters I've set. Step size is nothing but 50, width is 1024, height is 1024. So this becomes my entire payload. I have converted this into the JSON. I've used this model ID because this is the same model ID I'm able to get it over here, right? Stability.stable diffusion x1v1. It's very simple. Once you do one, right, everything will be able to use it. So here I've used that. Then I've invoked this model with content type, model ID, body, everything. Once I get the response, now see what response you will get in this format, right? When you probably see the response body, there you'll be getting key value pairs with something called as artifacts. Inside that, you will find a base 64 encoded response of the images. So what we did is that we took this particular artifact of 0, we took that base 64, we encoded it with UTF-8, and this is how you read any encoded image, right? From that encoded image, we have converted that into bytes, and then we have saved that particular image to some output directory. So output directory, output folder will get created, and I'm creating one image over here, right? So that is what we are specifically doing with respect to this, right? So a file name will be nothing but inside that particular output directory, and then we can open that specific image if you want. Okay, we are writing that image. Sorry, we are writing that image inside this particular PNG. That's the same. See, whatever things we did over here, only the thing that is changing how you're converting that bytes information that we're getting into an image and saving that in our folder. Okay, so let me quickly execute and run it and show it to you, and then you will be able to understand. Okay. So here I will be showing you Python stable diffusion.py. So once I execute it, here you now okay, request steps 400 generation error. What is this error? Let's see. Okay, there is an error. Let's see what is the error. Bedrock invoke model. Let me see. I think there was a small minor mistake. Which one version? This is Glider 3. Okay, Windows. Let me see over here. So now it is working. I did some minor mistake over there, which I have fixed it. Okay. So this is the byte information that we're getting. See the image bytes. Now if I see my output folder, this is my image. Okay. So if I go ahead and see find in folder, okay, sorry, I will go ahead and preview in folder, reveal in file explorer. So if I go ahead and create this image, see this image, this is how the image is basically created, and it's look good, right? So what is the prompt I've used over here? If you see with respect to this, my stable diffusion.py. Here we have basically created something like this. Provide me a 4K HD image of a beach. So I hope you got an idea with respect to this. Now in the coming videos, what I'll do is I'll create some using projects by using the specific APIs. But in short, once I deploy these projects, I can deploy it anywhere I want, right? Hugging Face spaces, anywhere itself. So my suggestion would be that try as many as you can. See different like character role play. What is the input prompt you will need to give? Based on that, try to create use cases, which will be amazing for you, right? So this was it from my side. I hope you like this. So guys, in this particular video, we are going to discuss an end-to-end LLM project with the help of AWS Bedrock and LangChain. This was also one of the most requested video from many people out there. What we are going to do in this particular project is that we are going to develop a document Q&A application where specifically we'll be harnessing multiple models that are provided by AWS Bedrock like Cloudy, Llama 2, and you can also use Amazon Titan. Whatever models you specifically want that actually provides, we can actually use them and we can implement this entire application. So to go ahead with, I will just go ahead and show you the quick demo over here. So what is this specific entire application? This is a RAG, right? We are trying to create a RAG system wherein we have multiple PDFs. All those PDFs is stored in the form of vector embeddings inside vector store. And whenever we ask any query, we will be able to harness the power of AWS Bedrock, which provides different models like Cloudy, Llama 2, and based on this particular question, we can retrieve that question from the PDF files. So let's say I'm asking what are transformers, and if I go ahead and click on Cloudy output, that basically is going to hit the Cloudy API, Cloudy model, and I'm going to get the entire response. Okay, so currently this is running. If you probably want Llama 2 output, I can also go ahead and click on Llama 2, and I can actually get that specific response, right? So whatever questions you have with respect to this particular PDF documents, what the set of PDF documents also I'll show you, and you'll be able to get the entire response over here, right? So why it is taking some time, because I still need to write that optimized version of the code, but once it runs, right, for the first time, I think then after that it works absolutely fine. Now let me just go ahead and write what is YOLO, right? So if I go ahead and click on Llama 2 output, before, see, I showed you also Llama 2 in my local system itself. Over there it was taking a lot of time, but this is directly coming from the API model itself. So here is what is the response I'm specifically getting, and I'll be able to get the answers. Now this is what I'm going to develop completely from scratch. Already, if you remember, guys, in our previous session, yesterday I had uploaded a video where I showed you the power of Cloudy.py, how to invoke the model and all. Then we also saw with respect to Llama 2 and all. Now let me just go ahead and create a new file over here. So let me just go ahead and write this as app.py. Now inside this app.py, I'm going to write my entire code. Now before I go ahead, I really need to do some installation with respect to some of the requirements. As said, here we are going to use not only Boto 3 and AWS CLI, we are also going to use some more libraries like PyPDF. So let me just go ahead and write this over here. So we require PyPDF. Along with PyPDF, we also need LangChain, and then we will also be requiring Streamlit, right? Along with this, we also require Fires CPU, right? So this is what we're going to use, because from our local environment, we're going to do the vector embeddings. So for this, I'm going to use the Fires DB, right? So through this only, we'll be able to create the vector embedding into the vector store. So these are some of the basic requirements that I actually require. Now, AWS CLI is also there because we really need to configure it. Now, let me quickly go ahead and open the terminal. Let me clear the screen because yesterday I was creating the images over here. The first step, again, you have to create a virtual environment, do all this pip install and all, right? I hope I don't have to tell you all those things now because I've repeated many number of times. So let me go ahead and write pip install -r requirement.txt. If you are not able to understand it, guys, please make sure that I'll be providing this entire playlist in the description of this particular video. You can go ahead and watch it, okay? But you have to follow the playlist, right? Again, I'm not going to repeat everything from scratch. Otherwise, it is just a waste of time, right? So till this installation is basically taking place, let me just go ahead and talk about what all things we are going to basically develop, right? So this is the document Q&A search. So in short, my PDF will be stored in the form of my entire PDFs. We probably consider this. My entire PDF will be stored in vector store, and from this vector store, we can specifically query any information that we want. Along with this, we are going to harness the power of LangChain along with the LLM models from AWS Bedrock. Okay, so this is what we are going to do in this project. So please make sure that you prepare well, understand the architecture of what we are trying to do. So our entire project deals with two important steps. One, 2. And before this, we are also going to do a very important step, which is called as data ingestion, right? Now in data ingestion, what we are going to do is that we're going to read from the entire folder. How many PDFs are there? All the PDFs we are going to read it, okay? So once I probably get this entire PDF, then my next step actually starts over here. I'm going to take all those documents, the PDFs over there, split this into chunks, create the embeddings, and here we're going to use this Fias database. So here we're going to use this Fias, right? The vector database. And through that only we'll try to create this vector store, right? So step by step, I'll show you how to do this. What embeddings also we are going to specifically use here. See, understand, we're going to create the embeddings. So for embeddings, we are going to use, today I will show you a new model, which is basically called as Amazon Titan, okay? So that you understand, you have multiple options, you may have implemented multiple options with respect to that. Because tomorrow in companies, if you go, definitely they're going to use this AWS Bedrock because it provides a lot of features, right? So for creating these embeddings, I will specifically use Amazon Titan. Other than this, if you don't want to use this, you can also use OpenAI embeddings, right? It is up to you. I've also shown with Google Generative AI embeddings, multiple embeddings techniques in my playlist with respect to Google Gemini and all. So after we create this vector store, now how are you going to use the LLM? So in the second step, whenever we ask any question, first of all, the similarity search will happen from the vector store. Whatever relevant documents and chunks we get, we have to take these chunks, give it to my LLM model along with the prompt. Like let's say that I say that, okay, please summarize this entire information based on the query that I've asked in 250 words. So this LLM model along with this prompt is going to take this particular data and is going to give the answer itself, right? So this both I'm going to develop completely from scratch. Step by step, we'll try to see it, okay? So let's quickly go ahead and let's start our coding without wasting any time, okay? So here is my app.py. I said that I'm going to do it completely from scratch. So there will be some installation, there will be some errors that may be probably coming up. So we will try to also import all the libraries based on the pipeline that we have created, based on the steps or architectures that we have already discussed. So first of all, quickly, let's go ahead and import JSON. So I'm going to import JSON, I'm going to import OS, I'm going to import sys. I think I'll not be using sys, but let it be. These are some of the common libraries that we'll specifically use. Along with this, we're going to use Boto 3. And again, guys, in my previous video, I've shown you how to configure the AWS CLI. Please make sure that you watch the playlist. Otherwise, you'll not be able to understand. Okay, if you directly go into and jump in this particular video, no, you'll not be able to understand. So in the description, I will give you the playlist. The first video only I've shown you how you can actually configure the AWS CLI. Okay, so please make sure of this. Okay. The next thing is that, as I said, right, we will be using Titan embeddings model, right, for creating vectors or to generate embeddings. Okay, so we will create this model. The reason I'm showing you because I've never used in any of my videos. Now this Titan embedding, what I will do, I'll call from the LangChain library or LangChain framework. LangChain provides you multiple functionalities, multiple options to probably interact with the Bedrock, right, AWS Bedrock. So as I said, this framework is compulsory for you all to know. One is LangChain and Llama Index, right? So what I'm going to do, I'm going to write from LangChain.embeddings. I'm going to import Bedrock. Let's see, BED. Bedrock embeddings, right? So I'm going to specifically use this. This will be small letter. Okay. So guys, I'm also verifying it from the documentation. Okay. So there's a documentation that is given, not very much clearly, but I've implemented this entire project also. Right. So from LangChain.embeddings, import Bedrock embeddings. The next thing that I'm going to use from LangChain.LLMs, like we can also use LangChain to call these LLM models that are present inside Bedrock. So that is also integrated, right? From LLMs.Bedrock import Bedrock. Okay, I'm going to specifically use this two. One is from LangChain.embeddings, Bedrock embeddings, and from LangChain.LLMs.Bedrock, I'm going to import the Bedrock. Okay, so this is specifically for the embedding part. Okay, now there will also be some libraries that I need to import for data ingestion because I really need to load the data set, right? So over here, you'll be able to see I will write import NumPy as NP. Okay, this is NumPy I'm going to specifically use, but I think by default NumPy will be available. Import NumPy as NP. Perfect. So NumPy as NP. Then from LangChain.TextSplitter, I'm going to use TextSplitter so that as soon as I load the document, I need to probably use this recursive character text splitter. Okay, so this is what we specifically use, and in my LangChain series, I've discussed everything about this. Then again, I will go ahead and write from LangChain.document loaders import. We will specifically use this Py. So let me just copy this PyPDF directory loaders. So this is what we are specifically going to use, PyPDF directory loaders, and it is actually present inside LangChain.document loaders. Okay, so this is specifically required for the data ingestion. With this, what I will do, I've already created one folder over here, which is called as data, which has these two PDFs, right? I need to load all these PDFs from this particular folder and then perform all the vector embeddings that I require. So in data ingestion, first of all, we'll load it. We will split the entire documents by using recursive character text splitter, and then after this, we will convert this into vector embeddings. So let me just go ahead and write vector embeddings and vector store. Here, I'm going to specifically use Fias index. Okay, FiasDB or ChromaDB also you can use. It is up to you. Again, I've shown both the ways in my playlist. So from LangChain, let me just see this again. So Bedrock embeddings. Is there something called as from LangChain_community? Right? Let's see. Okay, from LangChain_community. Let's copy this. Is this correct or not? We'll try to see. Yeah, Bedrock embeddings was there. Let's copy this here also. So PyPDF directory loader is also there. I think there will be some warnings that will be coming. I think some of the libraries LangChain community. Okay, so here what I'm actually going to do from LangChain. Let's see if we get an error again. I'll revert it. Okay, from LangChain.TextSplitter. Sorry, not TextSplitter. I'm using TextSplitter already. I've actually done it. So I'm also going to use for this vector embedding specifically. I have to use vector Fias, right? So I will write vector stores import Fias. Okay, so Fias is one library I'll be using. Again, this Fias will be present inside community, I guess. Okay, so vector LangChain_community dot vector stores import Fias. Let's see, Fias is not accessible, so I think it is inside LangChain only. Okay, otherwise you can see the documentation. Okay, at the end of the day, no worries. Then after doing this, I will also write from LangChain.indexes. Okay, I'll not use this also. Let's just use Fias because we have already installed Fias CP. Okay, then after doing this, what we are specifically going to do is that now this is for the vector embedding. Now we need to go ahead with the LLM models, right? So for LLM models, the LangChain already provides ways to load models from the AWS Bedrock. Okay, so for here I'll write from LangChain_community dot one. I will specifically use prompts. From LangChain.prompts, I'm going to import prompt template. Okay, and then the other one is from LangChain.chains. I'm going to specifically use one chain where I'll be using import retrieval QA. right? So since I'm going to create a Q&A chatbot with the documents Q&A in short, so that is the reason I'm using this. And this is basically to create my own prompt template. Now, let's call the Bedrock client so that we get the access of all the models, okay? So I will go ahead and set up the Bedrock clients over here. So here, let me go ahead and write Bedrock is equal to boto3.client. And here I'm going to give my service name is equal to Bedrock dash runtime. Okay, so I've already shown you yesterday also in my playlist of this Bedrock. I've also shown you how you can actually call the client itself and access the models. Okay, now as said, as I already told that the embedding that we're going to specifically use is called as Bedrock embeddings, right? So let me quickly go ahead and call this. I will go ahead and write Bedrock embedding, and let me show you how you can actually call this embedding from the AWS Bedrock. So I will copy paste this. Let me give the model ID. Now this model ID you'll be able to see it over here, right? So if you probably go ahead in AWS itself, let's say I will go ahead and write embedding. Okay. So here on in Titan, I think you will be able to find it out. So foundation model, base models. So if you go ahead and search inside this, any of the embedding models you can specifically take, but I'm going to use this Titan embedding model. Okay. So if you probably click over here and see down, you'll be getting the entire details, like what is the embedding, what is the model ID and all. Okay. So I'm going to specifically use this. So let me quickly go ahead and call this model ID. So for this model ID, I've already copied it from that this particular website. So here you can see I will have copied this entire thing and I will paste it over here on my model ID. So you also have to do the same step. Okay. So once we do this, the next thing in this that we really need to give is the client. And client, you know that we have not yet called any client or what. So we have called this Bedrock client. So this will basically be my client over here, right? So once we give this Bedrock client, that basically means it knows we're going to call this particular embedding model from this particular client, that is Bedrock itself. In short, we're going to use the AWS Bedrock. Now, let me quickly go ahead. And this is what is all step by step we'll be going. First, we will create this data ingestion model. See, this step is done. We have created our client. Now we will go ahead and implement this data ingestion. So quickly, let's go ahead and implement this data ingestion. And please make sure that you follow this. So here I'm going to basically write data ingestion. Okay. And I'll create a step which is called as data ingestion, a function. Now inside this data ingestion, what things we are specifically going to do, right? I have a folder. So let me go ahead and write loader is equal to py_pdf directory loader. And here I'm going to give my folder which is called as data, right? From that data folder only I need to pick up all the PDF files, right? So this is the first step. Then I will go ahead and write documents is equal to loader.load, right? So from this loader, we are going to load this entire documents. Now, in our testing, we will specifically use something called as character text split, right? So that is what we have already implemented, right? Recursive character text splitter. Now, how do you implement this? It's very simple. I will go ahead and write text splitter, right? And this with the LangChain I've already shown you. So it will be recursive text splitter, and here first parameter will be my chunk size, chunk underscore size. Chunk size I will give it to 10,000. Right? And along with this chunk size, the second parameter I would like to give as chunk overlap. Please give this number a little bit more value so that you'll be able to understand it. Okay? So these two are there: text splitter, recursive character text splitter, and that's right. Once we get this text splitter, I will go ahead and write docs is equal to text splitter dot split underscore documents. Okay, and then here I'm going to give my entire document. So in short, we're going to split it, right, based on this recursive character text splitter. Once we do this, then we will return the docs, all the docs. We're going to specifically return the docs. So data ingestion is done, right? With respect to this particular data ingestion, here what we are doing, we're reading all the PDFs from the data folder. We are doing recursive character text splitter with this chunk overlapping, and then we split all those documents, right? So this completes our data ingestion. Now the next thing is that we will go ahead with vector embedding and vector store, right? And this is where we are going to specifically use the Titan embedding that we have imported. Along with that, what we are specifically going to do is that we're going to use this FIAS, right? So let me quickly go ahead and write it down. So here I'm going to write my definition, and quickly let's go ahead and write that vector store. I'll create one more function. Now inside this vector store, I'm going to first of all give the documents, whatever documents is coming from here, because we take these documents and then we do the embedding techniques and we perform all the embedding techniques. So in my next step, what I will go ahead and write, I'll write vector store underscore FIAS. Okay, so this will basically be my variable, and then I'm going to use FIAS dot from underscore documents. Right, and we are going to implement this, right? So in the first parameter inside FIAS, we give docs, and the second parameter that we specifically give is my Bedrock embeddings, right? So this is the embedding specifically we are going to use. Okay, one is the Bedrock embedding which we have initialized over here. See over here in the Bedrock embedding we have initialized, and that is what we are going to use it over here. Now after we get that vector store FIAS, this is basically my vector store. I will go ahead and save it in my local disk. So let me quickly write dot save underscore local. And inside this, we're going to basically write FIAS underscore index, right? So this will basically be saved in my folder over here itself, right? In my hard disk. You can also save this in any database as such if you want. So this is my vector embedding. I've done it, and this step is also completed. Now let's talk about the next step. In the next step, based on the import, we have to work with LLM models. Now what we are going to do over here is that I'm going to create some LLM models. Let's say I will go ahead and write first LLM model that I'm going to work with is Cloudy, right? So I'll say Cloudy LLM, and inside this Cloudy, we will create the Anthropic model, because I should see already AWS Bedrock is giving you the power to harness multiple models, to use the multiple models. So we can specifically develop in this application itself. It's just like having different models in different ways. But here I'll try to make it much more generic. So here we are going to write co-ed Anthropic model, and I'm going to create my LLM. Along with this, we are going to use this Bedrock. So Bedrock, before, if I probably show you in my previous tutorial, the way of invoking a model was something like bedrock.invoke model. But now since we are already using LangChain, we don't have to basically use invoke model. So what we specifically do, we just call this Bedrock, and you can probably see how where this Bedrock is present. It's present inside LangChain. So they have actually created a wrapper, and internally they will invoke that specific model. But this is a way that how you can use this frameworks like LangChain in a generic way. So now I'm going to use this model as Bedrock. Now with respect to this, I will go ahead and write my model ID. Already I have searched my model ID. So this is what is my model ID over here. How do you get this information? Again, from this particular examples. Go and click on any model. You will be able to, let's say I'm going to generate code. So with respect to this will be my model ID, right? So it is a generic way of finding the model ID. So you don't have to even worry about it, right? So I have my model ID, which I did it in my previous tutorial also. And then I will go ahead and write my client. My client will be nothing but Bedrock. And the next thing that I'm going to specifically give after this, right? One is model arguments, right? So model arguments with respect to this. Now this arguments that you'll be seeing, right? Where do you find it again? If you probably go over here inside the body, and if you go at the last, right, there will be some arguments that will be added like this: match tokens to sample, temperature, this. You can also add it over here. Now with respect to this particular model that I am actually using, this was the argument that was present inside that particular body. So that is the reason I created this, right? All this JSON file separately so that I can refer it. Okay. So I hope you're able to understand it. If you're able to understand, please make sure that you hit like till now. And now let's go ahead and here what we are specifically doing. Whenever I call this function, that basically means my cloudy model has got loaded. So I'm going to return the LLM model. Now suppose similarly you want to probably go ahead and call the Llama 2 model. So I will go ahead and paste it over here. I'll say get Llama 2 LLM. Like this, you can actually create any number of functions as you want. Okay, so this will basically be my Llama 2. Now inside my Llama 2, let me just copy this again. I'm going to see my, so this is the Llama 2 model over here. Okay, only the model ID change and whatever is the argument that will change. So in the case of arguments with respect to this is nothing but max gen length. Right? How I'm getting it? Let me show you again. Okay, so let's say this is chain of thoughts. Let's say that I'm going to use this. Okay, so here you can probably see this is my model ID. Okay, and then inside my arguments, this is from where we'll be able to get it, right? So this API request is pretty much important with respect to this, okay? So return LLM model, and this is where is my LLM model that I'm getting with respect to Llama 2. So now you know how to create, how to call any models itself, right? Data ingestion is done, vector store is done, everything is done. Now let's go ahead and create my prompt template. Now this prompt template that I'm actually going to create, I'm going to use something called as LangChain. So in my prompt template I've written, see this, okay? So I've given a simple prompt template, which you can also use it. So I've written human in this format. Use the following piece of context to provide a concise answer to the, and at least summarize with 250 words with detailed explanation. If you don't know the answer, just say that you don't know. Just don't try to make up the answer. So context and question is there. And based on this assistant, whatever assistant output is there, it will get appended over here. Now with respect to this particular thing, we use the LangChain prompt template. We write context and question and we use it. Okay. Now this is fine. Everything is good. Now let's focus on the response part. So here I will go ahead and write get underscore response underscore LLM. And here the first parameter is my LLM. The second parameter is my vector store fires. The third parameter that I'm going to give is my query. Right. So these three parameters we are going to play with. One is obviously if I want to get the response from a specific LLM, then I have to give this three information. Okay. Get response LLM, the LLM model which I'm calling. This is my fires index and this is my query. Okay. Now once we get this, as you know that we have imported something called as retrieval QA. So retrieval Q&A here also we're going to use it, and this is how you basically call it, right? So I'm just going to copy it, paste it over here. Again, I've seen the LangChain documentation. So retrieval QA from chain type, I'm giving my LLM model. Chain type will be stuff. I've already shown you what is text summarization, different text summarization techniques. So stuff is there. Over here, this is the most important thing. Retriever. How from where the similarity search will basically happen. So this is where we are doing, right? Our fires index basically has the entire index itself, right? And then we are trying to do the similarity search along with the argument top K3 or top 3 prompts, and then we also saying return source document with respect to this one, and then I have my prompt over here, right? So all these things are basically done, and then after this we'll be able to get the response. So now once we specifically write this chain type arguments, then here we are specifically giving the prompt. The prompt is getting created by the prompt template over here, and then in the next step we will go ahead and write answer. I'll create a variable called as answer, and we can use this QA variable, and inside this we will give in the form of query colon, and here we're going to give the query itself. So this query is the query that is coming from the as an input, okay? And once we get the answer, see when this QA is basically using, right, it is nothing but retrieval QA. So it will retrieve the response and it will store it in this particular variable. Now inside this variable, there will be something called as result as a key, which will give you the output. So if you print it, right, initially I printed this answer, I've already implemented this. So there is a variable called as result, which has the entire answer. So this is my response LLM where I'm getting the entire result. Now let's go ahead and create a Streamlit app. Now quickly, there are two important things with respect to the Streamlit app. One place, I have to make sure that whenever a document is updated, that it should get converted into a vector embeddings. So what I'm actually going to do quickly over here, I'll create a main function. Let me show you what I will be doing, okay? So quickly, first of all, I will import Streamlit as st. Streamlit as st. Fine, we are going to use Streamlit. Now see this, the thing that I've copied and pasted. So I've written chat PDF, chat with PDF using AWS Bedrock. This is my user question, like what kind of question I want from the PDF file. Then a sidebar is basically created, and I will say update or create vector store. Like that basically means inside this, I will create a button saying that vectors update. That basically once I click, right, then it should go ahead and call this data ingestion. Now data ingestion, what it is going to do? It is this data ingestion is going to read all the files from the data folder. Then it is going to take this documents. It is going to perform this recursive character text splitter. And then after doing this, it is going to return this entire documents, right? After this, we are going to call this vector store. So one by one, we will be calling it. So here you'll be able to see data ingestion and vector store we are calling. We get this docs. Now inside that vector store, what is happening is that we will save this in our local folder itself in the hard disk in the form of files index. So as soon as I click this button, that is vector update, which will be available in the sideways, inside the sidebar. Sidebar means in Streamlit is in the left hand side. So the vectors will get created, the vector stores will get created, and it will also saved in a local folder itself, right? So over here, our folder will come with this particular name that is called as files index. This is one step. Now the second step is that I can go ahead and create a cloudy output. Okay, I will create a button which is called as cloudy output. Now see this is important to understand. Okay, so this is my button. I've created another button. When I say cloudy output, that basically means I have to use the cloudy model API. So the first thing, as soon as I click on the cloudy output button, my files should get loaded from the local. So that is the reason I'm writing dot load underscore local with this files index and the Bedrock embedding, the same embedding which I've actually used. Then I will go ahead and call this cloudy LLM. Right, I'm going to call this cloudy LLM because I will get the LLM itself. Now if I go inside this function, if I go ahead and write F12, okay, so here you'll be able to see where it is cloudy LLM. So cloudy LLM, it is going to call this particular model and return our LLM over here, right? So here I'm going to get my LLM with respect to this, and this LLM will specifically be used inside this function, that is get response underscore LLM, where I have given my LLM vector store files and query, right? When I get this three information over here, I'll get my response, and I'm writing this particular response over here. Very much simple, very much easy, right? So let's execute this and let's see whether this is working fine or not. Okay, so this is my main function. So what I will do, I will create this if underscore name with respect to this main. Now let's see whether we will get any error. Okay, so I will clear my screen. But in short, we have executed each and everything, right? So I will go ahead and write Streamlit run app.py. Let's see whether we will get any error first of all. Okay, it's working fine. I will close this. Okay. Now this on the left hand side, I will get this vector update of create vector store, and here I have chat PDF using AWS Bedrock. Okay. Now the first step, as I said, what I'm going to do here is my data folder. It has this PDF file, attention.pdf, YOLO.pdf. So what I'm going to do, I'm going to probably click on vector update. As soon as I click on vector update, now what is going to happen? See over here, as soon as I click on vector update, what is going to happen? So if this is clicked, that basically means the data ingestion folder it will go. It will read both this PDF and then it will convert that into vectors, and we will save that vector over here. Right now you cannot see any folder in the name of Files Index. But now if I go ahead and click on vector update, now what is going to happen? See, as soon as this vector update will finish, now processing is basically happening, and this will probably come up with like done. Okay, done status, unless until we don't get any errors. Let's see with respect to this, right? What will happen? So it is now loading all the PDF, it is performing, it is converting those into vectors, right? And then it has now stored that as a files index. Now, if you probably go over here and see this folder, my files index is created. It has index.files and index.pl, right? Now, this is the first step. Now, the second step is another button, which is basically cloudy output. Now, cloudy output is over here. Now, if I give any prompt, what is attention is all you need? What is attention is all you need? Okay, if I go ahead and click on cloudy output, now it is going to call the cloudy model, right? So if we probably go ahead and see the code again, what is basically happening? First, we will load this files index from the local. Then we will call the cloudy LLM model. Then we will call this get response LLM where we are giving all this free information, the user question. And now finally you'll be able to see I'm getting the output, right? Now this is with respect to cloudy output, right? So similarly, if I go ahead and write what is YOLO, I will go ahead and click on cloudy output. Now again, see, follow this pattern. Inside it will go, again it will load this files index, right? And then we will call this particular cloudy model. Now how the performance can be improved? This files index I'll not call each and every time. So let me do one thing. Let me call this once, okay? Let me do one thing. For the first time, I will just keep it outside this. Okay, but again, it'll give us an error, but I will give you that as an assignment. First of all, let's work on this. Okay, so here you can see my YOLO is also coming. Now, see, if I want to add Llama 2 and all, what I need to do, I will go over here. My Llama 2 function is already created. If you remember, see over here, my Llama 2 function is where? Get Llama 2, right? So I will create another button. I'll copy it like this. If my st.button is Llama 2, right? So this will be my Llama 2 output. Instead of calling get cloudy LLM, I will say get Llama 2 LLM. So now we will go ahead and check whether for Llama 2 it is working fine or not. So I'll save this quickly. I will see now. I'll click on Llama 2. Now let's see whether we'll get the output or not. Again, the same thing is going to happen. First of all, it is going to load the files index. After that, it is going to take the LLM model. It is going to give all the information, and then finally you'll be getting the answer. Similarly, I can go ahead and write what is attention is all you need. Okay. So if I go ahead and click on Llama 2, then again I will be able to get the response. So this entirely everything is basically happening with the AWS Bedrock. So step by step, I have shown you almost everything. The data ingestion step, what are libraries are specifically getting used. All this code I've written it in front of you. The Streamlit file we have actually created. I would suggest go ahead and write from your side, and this is how you're able to get the response. But the best thing is that all these models are available in AWS Bedrock, and it is already scalable, and you can actually use it according to your wish. Hello guys, we are going to continue our generative AI on AWS Cloud series, and in this specific video, we are going to develop an amazing end-to-end generative AI application using various services that are present in AWS Cloud. I will give you a brief architecture, what we are going to implement, and then step by step, I will be showing you how you can use various services that are present in AWS and implement some amazing generative AI applications. So what we are going to probably do in this specific use case, this use case, I'm just going to keep it as block generation. So here you can probably see block generation is there. Initially, what we will do is that our main aim over here will be to create an API. Okay, so we will try to create an API. So we are going to use Postman to hit the specific API with some specific body. That body can include query. Okay, query from the user, like what blocks we need to probably generate. And as you know, in AWS, in order to create APIs, we use Amazon API Gateway. So we are going to also use this. As soon as we trigger this particular API, it is going to hit our Lambda function. What exactly is the Lambda function? You'll also understand about that. This Lambda function in turn will be interacting with Amazon Bedrock. Okay. Now, if you don't know about Amazon Bedrock, here all the foundation models will be available, right? Foundational models will be available. Like Amazon has a lot of different foundation models like Llama 3, Llama 2. You know, it also has paid from Cloudy, Anthropic, specifically Cloudy models and all of that. We'll go ahead and see what are all these kind of foundation models and how we can specifically use that. And this Lambda function will be responsible taking up the query, hitting this particular foundation model, and getting back the response. Once we get the response, in this particular case, will be our entire blog, the 200 words or 300 words blocks that we are probably going to create. And finally, what we are going to do is that we are going to take that specific block and save it in AWS S3 in the form of text file or any kind of files. Okay, we can also convert that into a PDF file and save it in Amazon S3 with a recent timestamp. Okay, so this is the entire thing that we are going to implement, and understand this kind of use cases is even available in AWS documentation, and many companies are implementing the generative AI application in this way. As we go ahead with respect to the series in the future, we will also be developing some amazing applications that are related to RAG, you know, different document Q&A, how we can actually use vector databases. I will be showing you all those things, and we will try to use all the ecosystem that is provided by AWS Cloud. One of the important, you can probably consider that in most of the companies, they are specifically asking this in interviews. They definitely want you to say that how you can probably implement anything in AWS Cloud with respect to the generative AI application. So, so many different things we are going to go ahead and see. So first of all, let's go back to your AWS account. So initially, you really need to have an AWS account and make sure that you have it. Then only you'll be able to use all the services. Now, first of all, what I'm actually going to do is that I'm going to go to AWS Bedrock and just give you an idea, like how does all the foundation model looks like and what are foundation model is specifically provided by Amazon Bedrock. Okay, so first I will go ahead and click this, and here you can probably see that my Amazon Bedrock will get loaded. Once it is getting loaded, you can probably go ahead and click on get started. Now with respect to this, you can see over here foundation models are specifically over there, and you can actually do chat, text, image. So it supports multiple models itself. Now which all companies model is basically there in this foundation model. Here you have A121 Labs, that's from Jurassic 2 series. You have Titan by Amazon, you have Cloudy by Anthropic, you have Command by Cohere, you have Llama 3, you have Mistral, you have Stable Diffusion. So you can actually work in images also, and you can generate your own image as you want. Right? Let's say if I really want to use Llama 3, so I will go ahead and see this. Here we can probably see all these things are there, like Llama 2 13B, Llama 2 chat 13B, and even Llama 3 is also there. I will also show you that. You can also go ahead and check it out in the playground, chat with it, and probably get it. Now the first step before we start all these things, right? Our first step is specifically to make sure that we have to take the model access. Understand with respect to different region, yeah, you'll be having the access of different models, so you have to request for it. Okay, here you can see that in my region, that is I've selected US East one. You'll be able to see that I've granted access to all these models. Anthropic Cloudy 3 models are not given because for this you really need to provide some use case details, and then you have to submit it. Then the Anthropic will give you the access itself, like what kind of use cases you are basically doing. But according to mine, you can probably see that I've got this access granted. In order to get this access, you just click on manage model access, select which all models you specifically want as access, and just go ahead and click on save changes. Okay, I've already done that. So here you can also see that the save changes button is over here. So here you and probably see save changes is there. You can go ahead and probably click on this. What all models you specifically want, just go ahead and check it out, and then in some time you'll be getting the access model. Okay, the model access will be granted. So this is the first step that you really need to do. Okay, now once you specifically do it, then I will show you how you can go ahead and invoke all these foundation models and how you can go ahead. Okay, so this is one of the services that we're going to use. The next service is specifically Lambda function. What exactly is Lambda function? We'll try to understand. So here I will go ahead and search for AWS Lambda. So here you can see what is Lambda console in AWS. Quickly to test an event, it is a serverless team managed application in. Okay, I will just go ahead and search what is AWS Lambda. Okay, so if you probably go ahead and see the definition with respect to AWS Lambda, it's saying that run code without thinking about servers or clusters. See, instead of AWS Lambda, I can also use the EC2 instance in AWS and then probably set up all the things, install all my requirements over there, set up all the libraries, develop my entire application, and then probably with the help of API gateway, I can probably interact with that. And within that EC2 instance, I will try to invoke my AWS Bedrock. That also you can probably do, and in the going upcoming examples, I'll also show you that if you want. But right now, we are going to use AWS Lambda. So AWS Lambda is a compute service that runs your code in response to an event. So suppose if I hit an API, this is going to get triggered, and then it will go ahead and call the AWS Bedrock. So the benefits of Lambda is that no need of managing servers, it is automatically scaling, and you have to probably pay as you go, like based on the number of requests. And then performance optimization will also be taking place in the AWS Lambda itself. Many companies specifically use that. If you have a smaller application, you can definitely develop this. So let's go ahead and let's try to see that how we can go ahead and work with AWS Lambda. So here you can probably see AWS Lambda. As soon as I click on AWS Lambda, this will get open. Here you can create multiple functions. I've already created one function. I'll show you how to create this. So let's go ahead and create the function over here. So as soon as I probably create the function, here you can see I can select author from scratch, use a blueprint, container image, whatever things you specifically want. Here what I'm actually going to do is that I'm going to give my function name, and my function name, what I can do over here is, let's say I'll give my AWS app, okay, with Bedrock. Okay, so this will basically be my AWS function name, Lambda function name. Runtime, I will go ahead and use Python 3.12 just to make sure that I have the recent updated Python. And along with that, whatever by default is there, you can go ahead and select that. But here I'll just keep it since we're developing it for the first time, and I'll go ahead and click on create function. As soon as I probably create the function, here you'll be able to see that my AWS app Bedrock Lambda function will get created. And again, this takes time, some amount of time based on the internet speed and the kind of application that you're developing. So here you can see that it has got created AWS Bedrock. I'll show you here are some options like layers, add triggers, add destination. Now see, my main aim is that as soon as I probably create an API gateway, right? Because I need to hit the API, then only this function should get triggered, right? Inside this function, I'll write my entire code, how to invoke the Bedrock, AWS Bedrock foundation models and all, right? So if you go down, here you'll be also able to see some amazing things like code, test, monitor, configuration, analysis, version. So if I go ahead and click on configuration, here you can see there's some timeout configuration that you can probably give. There are some environment variables if you want to probably give. You can also give it over here directly. Environment variables, I hope I've shown you in VS Code. We create a .env file, we create a key like OpenAI API key and all. Here also you can probably write it down and you can call that OpenAPI key in this particular code. So one general configuration, what I will do is that I'll keep this timeout to 3 minutes because just to keep it in the safer side so that it does not get hampered over there. And here I'm going to write my entire code. Okay. Now before I write my entire code, whatever code I'm going to write, I'll be writing over here. But again, this does not look very comfortable writing the code because here I will not be able to get much suggestion with respect to the code. It's better that I write this entire code in the AWS in my VS Code, and then I'll copy and paste it over here. Okay. So what code I'm going to write it down over here, I'll be showing you that specific code with respect to this. Okay. So let me just go ahead and open my VS Code over here, and here is one of my. I will just open my terminal. Okay. Oops. Let me just go ahead and open my terminal, and I'm here. I'm going to write my code completely. Okay. Command prompt. So first of all, I will just go ahead and create my environment. So let me just go ahead and write conda create -p VNV environment Python. As you know, I have taken 3.12. Okay, so this is the environment that I'm going to create because I'm going to write my entire code over here with some requirement.txt and all. So let me just create this. I'll create one file which is called as requirements.txt. So whatever is required for my project, and that I have to actually put it in my Lambda function, all I will be writing it over here. Okay, so requirement.txt. Let's wait till this entire is getting created. So here you can see a new version of this, and I'll just go ahead and click on yes, and automatically my entire conda environment will get created. So there are two important things that I'll do. First, let me go ahead and write the code for this. What all things I actually require, I'll be writing it. Let me create a file also, app.py. Okay, in requirement.txt, the first library I actually want is nothing but Boto3. I'll keep this Boto3 like this, and whatever is the recent version of the Boto3, that is only supported by Lambda function. Okay, not the previous one, because the recent version of Boto3 has lots of functionalities to invoke foundation models from AWS Bedrock. Okay, so you should know all these things. Okay, so let me quickly go ahead and write my code now over here. So first of all, I will go ahead and write import Boto3, and I'm just going to write import botocore.config. Okay, so this is two important libraries that we specifically use. Understand, Boto3 is used to invoke the foundation model. Okay, so here I will just go ahead and do one thing. Okay, so let me just go ahead and see. This is my VNV. I will just go ahead and activate. So conda activate VNV. Along with this, what I'm going to do, I'm going to just write pip install -r requirement.txt so that my Boto3 gets installed at any point of time. Okay, so this installation will take place. Let it take place. Till then, I'll go ahead and start writing my code. Okay, now what I'm actually going to do, my main aim is to create a blog. Right, I really need to write a blog. I need to create a blog, and for that, what are things I will be doing? I'll be showing you step by step. Let me just do one thing. I will keep my notepad over here. The reason why I'm keeping the notepad so that step by step, I've from the documentation I've taken all the steps. What is basically required, and when we have to create what services needs to be created and all. I will be writing all those things. Right. So I'll create a function which will basically be called as definition blog _ generate using Bedrock. Okay, so this will basically be my function name. And when I create this function, I will also use this. I will give my query or message or what blog topic. I can also basically say blog topic, and this will basically be a string. And this will also return a string. Okay, this will also return a string. Right, so this will basically be my function which will generate the blog. Here, what kind of blog I'm going to use that I will be discussing. Sorry, what kind of foundation model that I'll be using. So first of all, let me just go ahead and create all my prompts. Since I'm going to create a multi-line character, so I will go ahead and write this and create a live blog. Okay, over here. Okay, so sorry, my prompt. I'll write my prompt. And before I write my prompt, let's go and see which Amazon Bedrock model I will be specifically using. Llama 2 Chat 13B. I can specifically go with this. And here you can probably see this is my model name. Okay, model ID. Okay, you really need to remember this because these are all the things that I really need to give. The content type will be application/JSON and body. This is the most important thing. What is the prompt that I am going to probably put over here? What is the other information that you basically provide with respect to the body? Right. So these all information definitely you really need to provide. Similarly, if you go with Llama 2 chat, 70 billion parameters. So here you can see this is where you place your input text. Okay, and similarly, if you go ahead and explore Llama 2 13 billion, you can also see other information with respect to. So each and every model, how the API request should be, you should be able to get it from the AWS Bedrock itself. Okay, so all the information are specifically over here, and you can basically check it out. Right. So whatever model you want to use, okay, you have to make sure that what API request is specifically there. Based on that only, you have to probably create everything. Okay. Now what I'm actually going to do is that I'm going to create my prompt. Okay. Now in this specific prompt, I'm going to basically write S character, and let me just go ahead and provide like this S. So the first thing is that I will be using this keyword inst, as you all know in Llama 2 models we specifically use. I'll go ahead and write human, okay, and human is basically giving this particular query. Okay, I'll say write a 200 words blog on the topic, and the topic will specifically be my blog topic over here, which I will be giving from my input, right, whenever I hit that particular API. Okay, and after this, what I can actually do is that as soon as I give this particular instruction to as a human being over here, the next thing is that I will have my assistant, right? And now I will go ahead and write about assistant, and this will basically be closing the inst. This is the keyword that we specifically use for most of the Llama models, right? So very simple, write a 200 word blog on the topic, blog topic, and this will basically be my assistant. Now, as I said, I have to worry about the body. Now, my body has what all things, right? You really need to go ahead and check it out from here. My body has a prompt message, it has a maxgen message, maxgen length message, it has a temperature message, and it has a top_b. So these all parameters I really need to set it up. So quickly, I will go ahead and write it over here. So first parameter will be nothing but prompt, and this will basically be my prompt_text. Okay, so sorry, I'm not created my prompt yet. Okay, this will basically be my prompt. Okay. Now, after I will probably define my prompt, the next parameter that I have already written is nothing but max_gen_length. Okay, and this will basically get assigned to 512. Okay, and then you can probably see this will basically be my temperature variable, which will be my third parameter in my body that I will be sending, and another one will be top_p, which is another parameter that is specifically required in my body. So this basically becomes my body. Now, also what I am actually going to do is that with the help of Auto3, I'm going to call this foundation model. So that is my Meta Llama 2 13 billion chat model, and then further things I will try to go ahead and do it. Okay. Now, before I call that particular model, let me just go ahead and create a try catch block, so that it is always good that we really need to have a try catch block, so that whatever errors we specifically get. So I will go ahead and write bedrock, and let me go ahead and write boto3.client. And here I'm going to basically call bedrock_runtime. And if you have already seen my bedrock videos, I've already shown you how you can invoke the bedrock. We have to specifically create the runtime. The region of all the foundation models that I'm actually going to call will be nothing but US East 1. Okay, so this is the region that we are specifically going to use. And the next thing that I'm actually going to give is my config. So inside my config, let me write it like this. So this will basically be my config. Inside my config, I'm going to use my boto3.config.config. And here I have to set up some of the parameters, right? Read timeout. Okay, read timeout, and here I'm going to probably take up 300 seconds. And I'm also going to give one more parameter, which is nothing but retries. Okay, and this will basically be retries, and this will be set to a variable which is called as max attempt. Max_attempts will be nothing but it will be 3. Okay, so here I'm going to keep up all the values. So these are the basic configuration that I am specifically giving with respect to my number of tries, all the. So in short, this variable will be used to call my foundation model. Okay, now in order to call the foundation model, I will write bedrock.invoke_model, and here I'm going to give my body. The body is nothing but I'm just going to write json.dumps. Okay, json.dumps, and again I've not imported JSON, so let me just go ahead and do that. So I'm going to write import JSON. Okay, so once I probably write import JSON, so here json.dumps, and here I'm going to probably give my entire body. Along with this, I also need to call which model I'm basically calling. So for that, I have to mention my model ID, and this time the model ID is nothing but it. You have to refer it from here. So this is nothing but Meta 70 billion. No, let's go with 30 billion because the request again I have to pay based on the number of requests that is probably going, right. So model ID here I'm going to just paste it, and I'm going calling the 13 billion chat V1 model. Okay. So once you do this, then what we can do, we will get our response_content, and let me just go ahead and write response.get body. So for that, response_content, response.get, and here we are going to basically write body.read. Okay, .read. So we are specifically going to read this specific response. And one more thing that you can do, right? And understand one more thing, guys. Very simple. Whatever response you are probably getting, I'll just go ahead and import the response also because I'll be using this. Okay. So response.get body.read. Once I read that particular data, what will happen is that I will just go ahead and load this with respect to my response_content. Okay. Now here you should understand, right? When I invoke this particular model and when I give my body over here, I'm basically calling this particular model over here itself. That is my Llama 2 13 billion chat V1. And then with respect to this particular body, whatever body you are specifically getting, we'll read that particular response. And let me do one thing. Let me just make this particular spelling correctly. And as soon as I load this particular response content, let me go ahead and store it in my variable response_data. Okay. Now once I load this, let me just go ahead and print it if I really want to see my response_data. Okay. If you want to probably see it, this response will be having a variable. Understand one thing that whatever response we are basically calling, it is giving the response from our entire model, the model that we are using, the foundation model. And now here I will go ahead and write, this will basically be my blog details. Okay, blog details, and this blog details will be available inside response_data with respect to my key variable, which is called as generation. So this model, whatever response it is basically giving you, it will be saved in this particular key variable within your response data, which has been converted into JSON. And when you write response.get body.read, in short, you're basically getting the response from this. Okay, and finally I'm going to return the blog_details. So this function here you can see, and let me just go ahead and write my except block also. Exception. I'm just going to create my exception as E, and we are just going to print the errors. And understand one thing, guys, whatever printing that we are specifically doing, AWS Lambdas make sure that all the logs will be logged in the CloudWatch logs, right? So that is also very good advantages for you, so that you'll be able to see that. So errors generating the code, okay, error generating the blog, and I can probably display this particular error, which is basically over here. And let me return it with a blank screen. Okay, so here we have basically done almost each and everything. We have displayed the data. This is the blog details that we are specifically getting, and this is the function that is responsible in generating the blog. Okay, now let me quickly go ahead and do one more thing. Let me go ahead and see, by default, if I go inside my Lambda function, it has a function which is called as Lambda handler. Okay, so let me just go ahead and define this Lambda handler, because my API gateway, whenever it sends any post event, it will be captured from this particular trigger, and it will hit this particular function first. So we have to capture this event along with the context, and then we can probably retrieve whatever query we are specifically giving. See, here we are giving the block topic, right? That block topic will be captured in this specific event. Okay, that is what is my plan. Okay, so here what I'm actually going to do, I'll just go ahead and create my event. So event JSON.loads, and I will take this event, and let me do one thing. Let me keep a variable, right, which is basically called as body, because whatever post request we are sending, this will be available in the body key itself. Okay, you'll be able to understand it, and then this will basically be my block topic. So let me go ahead and write my block topic. My block topic will be nothing but, I will just go ahead and write event of, I can keep a variable called as message, or I can also keep a key called as blog. So you'll be able to understand inside this body, I will be giving in a JSON format where my blog topic will be in this particular variable name. Okay, so blog underscore topic. Let's say here I go ahead and write blog underscore topic is equal to machine learning, then I should be able to get this. Okay. Then once I probably get the blog topic, then I will go ahead and write generate underscore blog, and now I will go ahead and call my generate blog using Bedrock. Okay, so this will basically be my function, and here I'm going to probably give my blog topic name, which will be nothing but it will be your blog topic that I have actually created. So in short, this function, when I'm calling it, it will be responsible in giving me the entire blog by calling this particular model, that is Llama 2. Okay, so once I probably get this generate blog, now I'm going to go ahead and write if generate underscore blog. Okay, now as you know that I'm going to save this particular blog in my S3 bucket. Okay, S3 bucket, the reason why I'm saving it, I'll try to save it in a TXT file so that I will be able to access it whenever I really want. So let me do one thing. Let me go ahead and import from datetime. I'm going to import datetime. Okay, so the reason why I'm importing this datetime, because I really want to create all the TXT file in a way where I consider the current time. Okay, so current underscore time is equal to datetime dot now, and here I'm going to use dot strf time in the form of hours, months, and hours, minutes, and seconds. Okay, and then I will go ahead and create my x3 key name. Okay, S3 bucket key name. So S3 underscore key, how my file needs to be saved. Okay, so I'm going to create an f string, and let me just go ahead and create something like this blog output folder. So this will basically be my blog output folder, and inside this I will go ahead and write current underscore time dot txt file. Okay, so this will basically be my txt file, which will be saved in that particular S3 bucket. Now let me give my S3 bucket name, so S3 underscore bucket name, and let me go ahead and write AWS bedrock course 1. Okay, so let me create this particular bedrock name. Okay, and now I've given all the information. Now I can call a function. Okay, and let's say first of all let me just close the if clause. So here I'll say print no blog was generated. Right, no blog was generated. Perfect. Now the next step what I'm actually going to do over here is that once I get my key and bucket, I should be able to call another function. I'll create another function, and let me go ahead and write this particular function, and here I'm going to write save blog details. Okay, in S3. Okay, so this will basically be my function, and with respect to I require two information. One is my S3 key, and the second information is my S3 bucket. Okay, so in short, I'm taking up all this particular information, and here you can actually see that I'm saving it in the S3 bucket. Now the further code I can probably write it over here. Again, over here, what I will do, I will go ahead and write boto3.client. Okay, so this will basically be my boto3. Let me see, I've imported boto3 or not. So this client will be nothing but my S3 bucket. Okay, and again here I will go ahead and create my try catch block. And I will say that, hey, go ahead and create S3.put object is nothing but with respect to my S3 bucket, S3 key, body also I need to save it, and the body will be nothing but, let me just see over here. Okay, body will be nothing but whatever is the generate block that I'm actually getting. Okay, so here I will go ahead and give my generate block, which will be assigned to this. Okay, so in short, I'm taking my entire information block that is generated in this particular bucket with this particular file name. So here I'm going to probably call this function that is nothing but save block details, and with respect to this particular save block details, as I said, I require S3 underscore key. The second parameter that I require S3 underscore bucket. Okay, and the third parameter I require is nothing but my generated blog, which will be in the specific name. Okay, so done. This is good enough. Everything is probably given over here. But again, understand with respect to Lambda handler, I should be returning something, because once the execution is done, just for my verification, I will be returning something like a status code if there is no error. So I will set up a status code, which will be nothing but it will be equal to 200, and body will be equal to json.dumps, and I say blog generation is completed. Okay, just to get me a message. Okay, so done. This is good enough. I've got each and everything over here. It looks absolutely fine with respect to the functionalities. Whatever is required, I have actually given it over here, and this looks absolutely fine with respect to whatever information I see over here, right? And again, understand. Okay, this response variable I will save it over here. Okay, so since I'm getting this particular bedrock and this response, I can remove it. Okay, so that is those variables. So let me quickly copy this, and let me do one thing. Let me paste it completely over here, right? So here I'm just going to paste it, and this will basically be my entire Lambda function with respect to all the details and whatever things I specifically require. Again, to write it over here, it would have been difficult, but now there you could see that how easy it is, right? Now I'll go ahead and click on deploy. Okay, so once this is probably deployed, I can go ahead and create my API gateway and all. Okay, one more important thing, understand that this Lambda function requires a recent version of Boto3. And if you probably go ahead and see what default Boto3 version is basically present in this Lambda is the older one. Now, in order to create or have a new Boto3 library installed, what you really need to do. Okay, so here you can see, I'll be showing you one very important thing. I've actually created a zip file. Okay, so you have to probably follow this step. Okay, and this will basically be helpful for you. Okay, let me do one thing. Let me just remove this. Okay, so here you can probably see, I have created a folder which is called as boto3 underscore layer. Okay, now understand one thing, what I'm actually doing over here. This is important for you all to understand. Okay, unless and until you don't understand this. So I will go ahead and activate my VNV environment, or okay, VNV environment is not there. Okay, what I'm actually going to do, see over here. Okay, conda deactivate. Okay, now understand one thing. As I said, my Lambda function requires a new version of the Boto 3 installed. See, whenever we open a Lambda function, by default, the older version of Boto 3 is there. Now, in the older version of Boto 3, because at that point of time, you did not have Amazon Bedrock, all the foundation models, right? So what we need to do is that we need to update the packages with respect to the Boto 3. Now, how do you do that? Okay, how do you do that? And this, I would definitely explain you in a better way. See, what I have done is that I created a folder which is called as Python, okay? Now, inside this Python, what I have actually done, see, it is very much important. Now, inside this Python, I have installed a library which is called as Boto 3. So if you probably go ahead and see this, right? Here you'll be able to see Boto 3, Boto 4, all this information is specifically there, right? Now, this will be a task for you. Just tell me, how can you install a library inside a folder, okay? Just to give you pip install Boto 3 -t, right? And if you go ahead and write this, right? What it is basically going to do is that the entire Boto 3 library will get installed inside this particular folder. And once this folder is created, what I can do, I can make sure that I will go to this particular folder and I will make a zip file. You can compress this particular file and you make a zip file and you can name anything. Here I've given boto3_layer.zip, okay? If you want to install any packages in Lambda, first of all, you really need to create a Python folder, install all the packages that you want. Let's say by default over here, if I go ahead and write import pandas, pandas may not be installed in Lambda. So if you really want to install pandas, what you really need to do, inside this Python folder, you will go ahead and write pip install pandas -t Python folder / Automatically the installation will take place and then you convert it into a zip file. The zip file name can be anything, but inside the zip file, there should be a Python folder with all the packages, okay? So I'm going to specifically use this, okay? So I've created over here, boto3.layer.zip. Now I'm going to go down and let me do one thing. Over here, you'll be able to see layers, okay? So I'm going to click on layer, add a layer. Now inside this particular layer, this basically says that if you really want to add any kind of packages, you can add it in the form of layer, okay? So here you can see AWS layer, choose layer, custom layers and all, specify a layer. So what I'm actually going to do, I'll just go ahead and select my custom layer. See, over here, you can also create your own layers also, right? You can create your own layer information. So one of the layers you can probably see over here, it is written as Boto3_bedrock. And this is the layer that I've already created, okay? Now in order to create the layers, I can go ahead and click on this particular layer. I'll go back. I will click on create layer. See what I've done. So, okay, this is my Lambda function. Understand this thing, okay? If I probably show you my functions. This is my function, okay? Now I've already written the code. I've deployed that particular code. Now what I need to do is that I need to create a layer, right? So that I update all the packages, okay? So in order to create a layer, I will just go ahead and click on add a layer. And over here, what you do, just go back to this particular layers and click on create a layer. And here I will go ahead and write Boto3 updated layer, okay? And description I don't want. I'll upload a zip file. I hope everybody knows where the zip file is. So this is my zip file. So I will go ahead and click on upload, okay? And I will take this path over here and I'll paste it, okay? I will go ahead and write boto3_layer.zip, okay? And then there is also like which all version you really want to be compatible with. So I'll go ahead and write Python 3.12, Python 3.1, Python 3.10. Okay, so these all layers I really want to put that, okay, it is compatible with. And now let's go ahead and click on create the layer. Okay, so once this particular layer is basically added, created, then we can add this particular layer to my Lambda function. And this is just to make sure that all your packages are up to date. That is the main reason why we are specifically doing it. So it is going to take some amount of time, again, based on the internet speed. And based on that, we will try to see that what all things we can actually do. Okay, so let this thing get created and let me have a look with respect to this. Once it is getting created, okay, now this looks like it is created. Now I'll go to my Lambda function. Okay, create a function. Let me go back to my function. This is my AWS Bedrock. And let me go ahead and now add a layer, which I've already created. Okay, so now it should be my custom layer. I will go ahead and select this Boto3 updated layer version. I can probably give it as 1 and click on add. Okay, so as soon as I probably give as add, you will be able to see that over here my layer will get automatically added. So one layer has got added. So my code is ready, my layer is ready. Now all I have to do is that I have to probably go ahead and create my API gateway so that it will get triggered or integrated with AWS or with my Lambda function, and I will be able to trigger things. Okay, so now I will go ahead and call my API gateway. So API gateway is over here. This is how my API gateway looks like. Now let me do one thing. Let me quickly go ahead and integrate this API gateway with my Lambda function. Okay, so now my API gateway is opened over here. Quickly let's see this. As soon as I probably get this particular API gateway, I will go ahead and integrate it, and then whenever I trigger this particular API, it should be hitting my Lambda function, which is in turn interacting it. So I'll go ahead and create my API, and here you can see I will be using an HTTP API. Over here you'll be able to see should we add an integration, my API name and all are there. Let me just give my API name. So here Bedrock demo API. I'm just going to write it down, review and create. Okay, I will just go ahead and create it. Okay. Now once I create it, after that I will start adding routes. So here you can probably see I'm getting routes over here. So let me just go ahead and create some of the routes. So here I will go ahead and write post request, and here I can go ahead and write blog generation will be my API. And let me just go ahead and create over here. Let me select this post. Here there are two options. One, authorize this protect your API against unauthorized request. So if I really want to keep some kind of key for authorization purpose, I can do it. I can basically attach it over here. But right now I really want to show you that how the post request will basically get handled. So here I'm going to basically attach integration right now. So attach integration I will go ahead and click on. And with respect to this attach integration, I'm going to attach to my Lambda function. Now inside my Lambda function, I will go ahead and choose my Lambda function. So here you can see AWS app Bedrock. This is the Lambda function that I've actually created. And let me just go ahead and click on create. So once I probably create this, here you'll be able to see that my Lambda function is done. Okay. Now the most important thing. Okay. One thing is that here, this particular API, I can also deploy to multiple cloud platforms. See, whenever we do a bigger project, there is dev environment, there is QA environment, there is UI environment, there is production environment. So similar kind of environments also you can create. So for that, just go to the stages, okay? And by default, this is basically the default stage, but I will just go ahead and create my stage name. So I'll write dev environment, and I don't need to add the stage variable and all, so I'll just go ahead and create, okay? Now inside this particular dev environment, you'll be able to see that here, right? Okay, let's see this. So this will basically be my URL. And along with this URL, if I really want to call my API, so this will basically be my URL. So I'll just go ahead and deploy it. So no stages found. Let's see. Okay, dev is there. So I'll just go ahead and deploy it. Okay. So I'm deploying this entire URL, and this is the API that I have to specifically use for interacting with my Lambda function. Okay. This slash whatever will be my route name, I can actually use it. So this, if I go ahead and I'll copy this also. Okay, just a second. I'll just copy this. Okay, it has gone to this. Okay, no worries. I'll go back to my API gateway, and here now you'll be able to see all the API gateways that I've specifically created. I've also integrated with the Lambda function that is available over there. Okay, and this is how the entire interaction will take place. See, it's more about writing the code, understanding about each and every service, and that is why all these things are amazing, right? So recent date is 9. So let me just click on this. Okay, post over here. I've already deployed this. So let me do one thing. So this is the slash blog generation. If I probably go ahead and see with respect to stages, if I go ahead and click on dev, so this will basically be my API. Okay. Okay, done. Each and everything is done. This is integrated. This is in turn integrated to my Lambda. Now, one thing that I have to do is that I also have to create my S3 bucket. Still, I have not created my S3 bucket because with respect to the code that I've actually given in my AWS Bedrock, my S3 bucket name should be, let's see, what is the S3 bucket name that I have to write? So it should be AWS Bedrock course 1. So let me quickly go ahead and create my AWS Bedrock course 1. So I will just go ahead and create my bucket, and let me just go ahead and write my bucket name. Okay, and just let me go ahead and create the bucket. Okay, so this is the new, and understand one more thing, guys. This AWS Bedrock course 1 that I'm basically writing, the name should be unique. Okay, so this is the name that I'm actually selecting, AWS Bedrock course 1. Okay, and let me just go ahead and create the bucket because throughout the region, it has to be unique. Okay, now let me just go ahead and update in my name over here in my S3 bucket name with respect to this. Okay, now I'll just go ahead and deploy it. So my AWS S3 bucket is also created. The code is written where we really need to save all the files and all. Everything is ready. Now let's quickly go ahead and test it, and I hope everything will work fine. So I'll just go ahead and open my Postman. Okay, create my new file. It should be a post request. Let's see. I don't know whether it should work. Everything should work or not. If I'm getting any errors, definitely I'll let you know. So let me do one more thing. Let me just go back to this. So this is the URL I've already seen. I've already deployed it in it. Let me do APIs, block demo APIs. So this should be /block generation. Okay, so this should be my URL. I'll go back to my Postman. And you have to be patient, guys. Understand, you have to really be patient because there are multiple things that you'll be able to see. Now, let me just go ahead and set up my body. My raw body will be with respect to one key. And if you probably see the Lambda function, what is the key name that I've actually created? Let me go ahead and see it. I'll open the Lambda function. And once I open the Lambda function with respect to my function name, AWS Bedrock. Okay. And here down, if you probably go ahead. Come on, load it quicker. Come on. It's taking time to load. I don't know why. So code is getting loaded. I've already deployed this code also. You also have to deploy the code in order to use it. Okay. So Lambda function is getting loaded. Let me see. This is there. This is there. Okay. Over here, you can see this will basically be my block topic in the body. So let me just go ahead and write block topic, and let me just go ahead and write the block topic will be machine learning and generative AI. Okay, so this will basically be my key name inside my this entire thing will be an event. It'll be in the event itself. Inside that event there'll be a body variable, and then we will be able to explore this blog underscore topic. Okay, so let me just go ahead and click on send. Hope so it works fine. So it is hitting till then. Message not found. Why it is saying message not found? Because block generation is there. Let me see. Block generation. Let me see it. Block generation. Let me go back to my API gateway. And for this also, what I can actually do is that go to my configuration, go to my monitor, and inside that I can also see the logs, and it will be available in the CloudWatch. So here I can click on View CloudWatch Logs, and here is my entire CloudWatch logs so that you'll be able to see. Okay, but right now it is not working. Let's see why it is not working. We'll have the complete details that will be available over here. Now it goes to my log groups. Inside that groups, specifically where we are actually working with. Again, I'm not going to delete this entire part of the video because I really also want you all to see the logs. Okay, to specify log does not exist in this particular account. Why? Okay, the logs has been not created. Let me just hit it once again. Blog underscore topic, message not found, status 404. I think so. There is some problem with my API gateway. Stages /block generation. Is it correct? /block generation. This looks fine. My post request is this one. The integration in the background will save your request. Let me just go ahead and see my stages. My dev stage is this one. FPH. Let me see whether I've deployed that or not. Deploy. Successfully created deployment. The deployment is active for dev. This looks absolutely fine. Now let me just go ahead and hit it. FBH, this one. Message not found, still message not found. Let me see that what is the problem in this. So guys, one simple mistake that I've actually done over here is that, see, when I pasted this entire thing, right, there was an extra space that was added. And Postman does not resolve this particular space and it keeps the space like that. So I'll just remove the space. Now I'm going to search for the topic on generative AI. So I'll go ahead and write this 200 words block. Now let me just go ahead and click on send. And here you can probably see block generation is completed. Let's see whether everything has worked fine or not. I'm just going to reload this log groups. And obviously you know how to go to this particular log groups. Go to configuration. Okay, sorry, go to monitor and just click on view CloudWatch logs so that you'll be able to see the logs itself. Right. Now let's see whether the logs will be able to see the buckets also or not. I'll also go ahead and check the bucket. So AWS Bedrock. So right now nothing has got created. So I think there should be some kind of error over there. But we'll have a look whether there is an error and we'll try to fix it. Okay. So all the things usually happens over here. So here you can see AWS App Bedrock, and there is one log. So with respect to this particular log, let's see AWS Bedrock. No blog was generated. Generating the log, an error occurred when calling the invoke model. Is authorized to provoke invoke model and resource this because no identity-based policies allows the Bedrock invoke model action. So guys, from the error that you probably see over here, it is not provided. It is basically not providing you the access. So definitely the role that we have actually created for a Lambda function, right? We really need to change over here, right? So what we can do? See, initially it was in code, right? Now let's go back to the configuration and select the role name. So if you select the role name over here, okay, let me just go ahead and select this. And now within this particular role name, we can provide further access to it. Okay. So let's say over here, only the AWS Lambda function is basically there. So what I can actually do is that I can provide more access, more permission policies, so that I will also be able to access the AWS Bedrock. So to see like what kind of policies we can probably provide it, and over here right now what is basically provided only AWS Lambda. So let's see that how we can still add more permission. So here what I'm going to basically write, I'm going to basically select attach policy, and again based on like how your IAM console basically runs, right? I will basically provide it to administrator access. Again, if you're specifically working in the company, you can provide different access based on the services that you're using. But just to give a brief idea about it, so what I'm actually going to do is that I'm going to add this particular administrator access, so that you'll be able to see that particular access over here. Now once that is added, let me just go back over here and let's see whether it is updated or not. So I'm roll. This is there. Okay, perfect. Everything works fine. So let me just reload this, and now I think we should be able to work out and see that yes, now we'll be able to get the access. So here you can see all access is basically given. Now I'll go back to my Postman and again hit the same request. Now let's see. See if it is taking more time, right? That basically means my entire application is working fine, and it sees we are able to see that yes, it is taking more amount of time. Now I think our blog will be generated. 200 words blog will be generated, and we should be able to get, or we should be able to be storing that entire TXT file in S3 bucket. So let's see. I will go again back over here. Again reload my CloudWatch. So let's see whether my CloudWatch has basically created or not. Yes, new log has been created. So here is my entire blog that is got generated. Generative AI, the future of creativity and innovation. Here you can see everything is working fine. Code saved to S3 bucket. I can also see in the logs. Now it's time that let's go into my S3 bucket and see whether I will be able to find it out or not. So I will go back to my S3 bucket. Let's go ahead and hit this, and then I will be able to see this AWS Bedrock Course 1, and here is my blog output, and here is my text file, right? If you want to probably see this particular TXT file, I'll just download it. But usually when we are working with AWS services, we can probably see that. And here, let me open this, and here is my entire blog, right? And this specifically, we are using the Meta Llama 2, 30 million parameters. Generative AI is revolutionary. All the blogs has been generated. Again, the main aim over here was to just to make you understand the entire flow, because in the upcoming videos, the kind of projects that we are going to deal with will be quite advanced, will be quite better, because there we are also going to use more things like vector databases and all. But all in all, this is an amazing project, and these all services are specifically used step by step. If you are also following it, you will also be able to do it. So I hope you like this particular video. This was it from my side. I'll see you in the next video. Have a great day. Thank you all. Take care. Bye. So guys, we are going to continue our generative AI series on AWS Cloud, and in this video, I'm going to probably show you how you can actually deploy your Hugging Face model, let it be an open source model or any LLM model also, specifically in AWS SageMaker, that's Amazon SageMaker. Amazon SageMaker is one of the important services in AWS where you can probably complete the entire lifecycle of a data science project or an AI project completely, along with MLOps, till the deployment, each and everything. So in this particular video, I will be showing you how we can take up any Hugging Face model in short and probably deploy it in the SageMaker itself. So please make sure that you watch this video till the end. And one more very important thing, guys, just check out this particular video. There may be some amount of charges that may incur, so please be careful with respect to this. Whenever you start creating, and finally when you create that particular endpoint, make sure that you delete all the endpoints itself. And I will be providing you the entire guidance as we go ahead. So first of all, we are just going to go ahead and search for AWS SageMaker. And to start with, how to probably work with AWS SageMaker Studio and all, I will also be talking about that. So first of all, you can see, you can just go ahead and click on getting started. Okay. And with respect to this AWS SageMaker, the documentation is pretty much amazing, right? So if you don't know about AWS or Amazon SageMaker, it provides machine learning capabilities that are purpose built for data scientists and developers to prepare, build, train, and deploy high quality ML models efficiently. So what we are going to basically do is that step by step I'm going to actually show you. So I'll go to the domain part and I will go ahead and create the domain. So once I probably go ahead and create the domain, so here there are two options. One is set up for organization and the other one is set up for single user. Okay. So as soon as and right now we're just going to test it for single user. So what I'm going to do is that I'm going to select this. Here you will be able to get an IAM role automatically. It will be creating it with this Amazon SageMaker full access policy, public internet access, standard encryption, SageMaker Studio. You'll get access to this. You'll be getting shareable SageMaker Studio notebooks, SageMaker Canvas, and IAM authentication. So each and everything by inbuilt, it will be providing you this entire environment where you can actually do the coding. So just go ahead and click this. So once you probably go ahead and click this, you will be able to see something like okay, the setup is going to take place, and it's going to take some amount of time. Again, it depends on how much time it's probably going to take over here. It will automatically create the users and everything will be able to get it, right? So here, if I probably go ahead and just reload this, you'll be able to see that my third domain is probably over here getting set up. Pending is this, and it will probably take some amount of time based on the usage. But other than that, you can probably see that I've already created two. So since this is already getting created, I will just go ahead and show you some more examples with respect to this. So let me just go ahead and quickly click on this quick setup domain. You'll be able to see that by default it will be creating a user. Okay, you can add any number of users based on the organization that you're specifically working in. Let's say you want to provide access to multiple users in the same domain itself, you can also provide it. Okay, so by default, as soon as you provide the user access, also there is one very important thing that you will be able to see, right? And that is nothing but the user information over here. Along with this, let me just hide my face. Here you'll be able to see that you'll be getting a launch button. Okay, so through this you'll be able to access Canvas. I will be talking about Canvas as we go ahead for the video. TensorBoard. I hope everybody knows about TensorBoard. Profiler, but we are just interested in working on this particular studio, right? So once I probably click on the studio, and you will be able to see that I will be able to get this entire Amazon SageMaker. It will be a studio completely, which will actually provide you the entire ecosystem with respect to any kind of development that you really want to do. Okay, so here you can probably see Jupyter Lab is there. If you want to quickly start, deploy, fine tune, and evaluate pre-trained models specifically for LLM, you can also go ahead with this. If you want to probably go ahead and do some kind of AutoML, you can also see over here there's an option model evaluation. So you'll find this entire ecosystem. Okay, now what I'm actually going to do is that I'm just going to click on this Jupyter Lab, and right now you'll be able to see that nothing is running over here. Okay, nothing is running specifically. And what I'm actually going to do, I'm going to create a Jupyter Lab. Okay, over here, Jupyter Lab space, so that I will be able to work it. Okay, so here I'm just going to write test demo SageMaker. Okay, and this I'm going to show you with Hugging Face. Okay, Hugging Face models, right? So here it will first of all ask you to probably select the instance, right? Multiple instances you can probably select for my use cases. Again, this instances, if I go ahead and check over here, SageMaker instances, based on different instances, there is a different price. So you really need to be taking care of this, because see, if you're working in a company based on the requirement, you can probably select the instances. So here you can probably see on demand pricing. So let's say if I select ML33 medium, $0.05, here it provides you CPU with 2 core, 4 GB memory. But understand, if you're specifically working with generative AI models, right, you definitely require a huge amount of data, right? Huge amount of space. So if you probably go further, there will be good amazing system accelerating computing, which also provides you not only CPU cores but also GPUs, right? So as you keep on using more and more, you'll be able to see the charges will be going higher and higher. But just in this specific video, I really want to show you some demo. But again, if you just get this idea in any companies, if you go, you'll be able to work it out, right? So I'm going to take a small system and probably work with this, right? Now, which small system I'm going to specifically take? So if I go up, here is something called as ML.M5 too large. So if you go ahead and see over here, ML.M5 too large. So this is basically providing 8 core GPUs and 32 GB memory. The charges will be 0.461 price per hour for using this particular instance. The reason I'm doing this is that because I will just give you an example of one of the model, how it is deployed and all, okay? And we'll see to that. Okay, so here I'm just going to keep the storage to 10 GB. And now I will go ahead and click on run space, okay? So once the run space is clicked on, you'll be able to see that my entire environment will be ready and I should be able to work it out, okay? And with respect to this, any kind of code that you run, right? In my recent video, you've also seen that I have actually created entire one Lambda function with the API gateway. I've shown you how to probably create an endpoint and all. So all those things you can probably do with this also. But here, more amazing endpoints, you'll be more amazing ecosystem and features you'll be able to get, okay? So this is going to take some amount of time. So okay, now it is created. Now I can just go ahead and click on Open Jupyter Lab. Now, understand with respect to Hugging Face, there are multiple ways to load a specific model. Okay, there are multiple ways. All those ways I'm going to talk about, and this will be important for you because you really need to know, have an idea like how we can actually work in AWS system, right? So once this is loaded, first step, okay, what you can do, I will just go ahead and change my theme. So I'll make it Jupyter Dark. Okay, so here you have options. You have options for notebook, you have options for console, terminal, Python, anything you can specifically work with. I will just go ahead and open terminal, notebook, and the first thing that I will do is that just go ahead and write pip install SageMaker. okay, which is the upgraded version. Just go ahead and install that. Automatically the installation will be taking place, and all the recent updates that is basically there with respect to the SageMaker that will get updated. Understand this is my entire environment, the same Jupyter notebook that we usually specifically work on and all, right? So here you'll be able to see this. Now to go ahead with what we really need to do initially, so I will go ahead and import SageMaker, okay, and there are some steps that you definitely need to follow as we start, right? So I'm going to import both of three, and I'll be providing all the code in the description of this particular video. So first of all, we'll go ahead and create our session. The session will be nothing but SageMaker.session, okay, SageMaker.session. So by default, whatever is the session, we'll be able to get it. Initially, we have not set up any session buckets or anything as such. You can also create that particular session. So I'm just going to write over here in some comments so that it will be beneficial for you. So here you can see session SageMaker session bucket used for uploading data model logs. If you want to probably upload data, upload custom data, or download the Hugging Face model in this particular S3 bucket and probably retrieve from that or use from that, you can actually do that. SageMaker will automatically create this bucket if it does not exist. Okay, so you can probably go ahead and write this particular condition, and here you'll be able to see that if there is nothing as such, if it is none, I'm just going to probably make if the session is not there, I'm going to probably go ahead and create a default bucket. Okay, so this is the code that we do initially, and this bucket will specifically be used to upload any custom data or training data. It can be models after the inferencing and multiple things. Now, other than this, we really need to focus on the role management over here now, because since we are using AWS SageMaker to execute any kind of code, specifically by using the services of AWS SageMaker, we really need to provide the role access and all. So for this, we can just go ahead and write some try-catch blocks. So here I'm just going to go ahead and write try, and let me just go ahead and do pass over here, and let me go ahead and write except block. With respect to this particular except block, I will just go ahead and raise some value error. And the best thing over here is that you get all the suggestion, right? And that is pretty much amazing, right? Once you're specifically using it. Let's say my I'm user is not yet set, so it will obviously give an exception. So it'll go to this particular value error. And here I will first of all go ahead and set up my user. So I'm user in shop, so I'll go ahead and write boto3.client. And I'm also checking out the documentation page. It is always good to probably check out the documentation page and perform in that particular way. And then I'm going to basically set up my role. I'm going to use im.get_role. Now it is going to probably pick up those role that is configured with this particular Jupyter notebook, right? So I'm just going to write role name. Okay, it's equal to SageMaker underscore execution underscore role. Okay, and this is basically going to be set up with our role, and from that we're going to probably take a ARN number, right? That is how we specifically identify the unique role that we are probably trying to get. Okay, so all this thing is done over here. Let me just make some spaces that is actually required whenever we work with this. Okay, so here you can probably see my role is also set up. This is my exception, and let me quickly go ahead and write in a try once the role is set up. So I can basically go ahead and write SageMaker.get execution role. Okay, this will be responsible in getting the execution role. If by default nothing is set up, then you can probably call it out based on the role that it has. Okay, again, one common thing that I've seen that we have to provide spaces over here, so that is one of the things over here. So please make sure that you keep on working with respect to that whenever you're writing any code. After that, I will just go ahead and write session is equal to SageMaker.session. I'm just going to call my session, and here I'm just going to use my default bucket. So here one of the parameters that you can probably see is nothing but your default bucket, which will be assigned to my default bucket, or sorry, not default bucket, SageMaker session bucket. That is my default parameter that is specifically required. Okay, so this is the first step that you really need to do it. Okay, and then finally I can go ahead and print my. You can see how it is going to pick up the ARN role. Okay, SageMaker role ARN, and here I'm going to basically set it up to role. Okay, so this is the role that is going to get print up, and next the print is equal to, and here you can probably also go ahead and write your SageMaker session. So SageMaker session region, if I want to display it, okay, it'll be nothing but session.boto region name, right? So this is also there. So once I execute it, let's see whether it'll be working fine. So here you can see not applying HTTP defaults. This is there, not applying info. Okay, some error I can probably see over. Okay, let's go ahead and do that again. Okay, now it's working fine. You can probably see SageMaker role is basically this, and this is the default role that the domain has basically created with respect to the user, and then US East one I'm actually working on. Okay, so this is the first step. Now if I have the roles and all, now I can probably go ahead and call any kind of models that I specifically want. So first we will try to call one type of model, and I'll just go ahead and show you the code. Okay, so here I'm calling one model which is called as DistilBERT Uncaged Distil Squad, and this is specifically used for question answering. So I'm basically going to give the hub configuration. See, Hugging Face Hub, if you don't know about Hugging Face Hub, then there you definitely have a lot of models which you can probably use for multiple use cases. So here you can see Hugging Face model ID. I have to probably give whatever is my model ID, the kind of task that I'm looking for. I'll be giving in the form of key value pairs in this particular variable called as hub. Okay, then we go ahead and create the Hugging Face model, right? And for that we have already deployed or imported from SageMaker.Hugging Face model, import Hugging Face, right? And then finally you'll be able to see that I'm using this environment hub. Okay, role I've always used, transformer version which is provided, PyTorch version, and Py version 3.9. Okay, so this is how the parameters you really need to give with respect to this. Okay, so I've already executed this, and I don't want to again deploy this entire model in my another Jupyter notebook because it is going to definitely take time. So just to give you an idea, I've already done that. So let me just show you over here. This is my another instance which I was actually working on. So here is my second Hugging Face model which I have actually given. Third, how to deploy it to the SageMaker instances. As you know, I've selected ml.m5 xlarge. Okay, so I'm writing predictor by using the same Hugging Face model .deploy. I'll be saying the instance count as 1. Okay, because I just required one instance. And what is the instance type? Instance type is ml.m5.xlarge. Okay, where I'm specifically deploying. Other than that, I need to make sure that how should I give my input. So I will be creating in this particular format because this model that is DistilBERT based Uncaged Distil Squad will be requiring the input data in this particular format. That is question, what is the use for inferences, then context, my name is so and so. I've just given some examples so that my more charges should not incur, and then we'll go ahead and predict the data. So here you'll be able to see if I go ahead and write predictor.predict, okay, with respect to this particular data because this data is required in that particular use case. So here you can see score is this one, start is this one, end is this one, answer is SageMaker, right? So what is used for inferences? So here you can see from this particular question, you have that SageMaker it is going to pick up. Understand when I execute this code, it is going to take 5 to 10 minutes to deploy into this, and you'll be able to get your endpoint. Okay, just to give you an idea, how does an endpoint look like? I'll just go over here just a second. How does the endpoint look like if you really want to see? So here, if I go back to my SageMaker Studio, I've created multiple endpoints. So if you go to deployments, you'll be able to see endpoints over here, right? These 2 endpoints are there. Let's say I want to go ahead and see this particular endpoint. Okay, I can click on this particular endpoint, and once we deploy, that endpoint will be created. If I want to test the inferences, you'll be able to see that I'll be getting this application JSON and whatever body I'm specifically giving, like how I'm giving over here. This is my entire body, right? And with respect to that particular body, if I give over here also and just test it, I should be able to get. If I just click on send request, I should be able to get my output, right? And there are also multiple options like auto scaling. You can scale to whatever things you specifically want based on the charges again. But here you'll be able to see that I've deployed this model in this particular instance, and you'll be able to just use that particular endpoint wherever you want in your code, anywhere as such, based on your requirement, right? So this was the entire thing, right? Let's try some more thing. Okay, I will again create some more data over here, and my name is Krish, and I teach data science. I'll just give this, and I teach data science. Okay, So what does Krish like? Okay, I'm just going to execute this. Let's see. So I'm going to get the answer. I'm predictor.predict. So you have a predict method. Here you can see the answer is data science, right? What does Krish like? What does Krish teach? So you can basically do. Okay, you'll be able to get the answer. Data science. Okay. So in short, this is just a simple model, right? I've probably deployed this particular model. You'll be able to see that this is an entire SageMaker, and here, it took some amount of time. I think this dots are like every 1 minute, around 6 to 7 minutes, to deploy this entire model in this particular instance, which I've actually created. Now, just to give you an idea, like how does machine learning LLM model be like? So I'll be giving you multiple examples. So first of all, you have to probably go and update SageMaker. The same thing by keeping your role and region name. Then you are basically going to call the SageMaker image URI, right? Since we're going to run it as a container. So here you can see Hugging Face deep learning container in AWS SageMaker. So the entire LLM model will basically be put in a container. Then you can actually call that particular container over here. So in order to call the container, you'll be using from SageMaker.Hugging Face get Hugging Face LLM image URI, and then here is your version that you're specifically using and what kind of image you are actually coming up with. Okay, just to show you, if I probably give you an example, I will go ahead and install all this. Let's see. You'll be able to see the UI. Okay, and then it will probably download it and upload it. So there will be a lot of tasks in that, and a lot of money will be required because again, at the end of the day, you are over here. You have probably got this. Now, let me just execute this again. So here is your SageMaker role ARN. Then you can see that which URI I'm actually calling, right? So if I probably go and see, this is the URI that is basically required, right? Image URL. So if you know about Docker and containers, so once you get the URI, then you should be able to load the Hugging Face model. Now here also you can probably see here we are calling Falcon B40B instruct. Number of GPUs, how much you want, and just imagine the instance type that we are going to use is MLG512 into large. I'll just show you the cost, and you will be pretty much shocked to see the cost. So here you can see internal storage GB is 1 into 3800. Total GPU memory is 96. GPU 24 core. Bandwidth, internet bandwidth is 40. And the GPU model is NVIDIA A10H. Right, memory is nothing but 192. CPU cores is nothing but 40. Just imagine how much the charges will be. So that is the reason why I have actually taken a small model and probably shown it to you. Later on, you can probably do with respect to anything once you probably go to the company, right? So that is the reason we have selected all these parameters over here. Then we initialize the Hugging Face model. Then we deploy it. That's it, right? And then after that, you can probably use the same payload. You can structure the payload over here with the prompt, and then you'll be able to get the text. Okay. So anyhow, I will be giving you this entire examples in the description of this particular video. But again, yes, I've told that I've been uploading videos on AWS SageMaker and all, but definitely they require a lot of charges that is involved. But it is always good to have knowledge about it. That is the reason. That is the main aim for this particular video. So I hope you like this particular video. This was it from my side. Again, you can refer to multiple examples. Here I will also give you this GitHub link from the documentation of Hugging Face. So there are multiple labs which has been created, which you can also go ahead and refer to. Okay, so this from R6 companies. So this is an amazing lab details that is provided. I will be providing you this entire code itself. Other than that, you can always see the documentation of Hugging Face SageMaker. So yes, this was it from my side. I'll see you on the next video. Have a great day ahead. Thank you all. Take care. Bye bye. Hello guys, in this video, I am going to show you some of the amazing powerful features of NVIDIA NIM, and again, which was recently announced by NVIDIA. And if I talk about NVIDIA NIM, it is the latest breakthrough in the generative AI development. Okay, NVIDIA NIM is a set of inference microservices for deploying AI models, and it revolutionizes the way how we deploy generative AI enterprises. Along with this, NVIDIA NIM offers multiple AI models, right? It can be LLM model, LIM model, multi-model. Not only that, it also provides you NVIDIA AI Foundation model. Just with the help of APIs, you'll be able to integrate in your application. You'll be able to seamlessly run it, and it's quite highly scalable. So in this video, I'm going to talk about this. I'm also going to show you multiple examples with the help of coding. So please make sure that you watch this video till the end because this is an amazing feature. And as I always say, there will be many LLM models that will be coming up, but the clear winner will be the company that provides the best inferencing thing for us, right? So let's go ahead, and this is the page over here. You can see instantly run and deploy generative AI. Explore the latest community-built AI models, AI with API optimized and accelerated by NVIDIA, and then deploy in with NVIDIA NIM. You'll also be able to experience leading open source models, and I will be showing more about this. You can also do integration just by using an API callbay. Along with this, you'll be able to run anyway, accelerate your AI deployment with NVIDIA NIM. How to buy? So here it is, and the best thing is that just for you to try it out, once you probably create a page, you'll be getting 1,000 credits, so which will be more than sufficient to explore and probably call multiple models to you, right? So let's go ahead and let us see. So first of all, go to this particular page, and I will be giving you this link in the description of this particular video. Just click on right now, and once you probably go ahead and click on right now, here you'll be able to see all the models, right? So with respect to models, you can see Llama 370B. It has almost all open source model, foundation models. Along with that, NVIDIA AI Foundation models also it has, right? Even open source model also it has. So here you'll be able to see Gamma, you'll be able to see 85 images, multi-model, LM model, LI model. So here with respect to models, you can see reasoning is there. For reasoning, you can use all these models. Visual design, all these models are actually there. Retrieval, right? If you want to probably implement retrieval, it is also there. Then here you have speech, biology, gaming, multiple things are specifically over here. So let me show you one example over here, and then we'll also try to create an end-to-end application that will be a RAG application using this NVIDIA NIM. So let's go ahead and let's start our project. But before I go ahead, let me just go ahead and show you one of the things. Like so before I start any project, right? It is very much important that you also need to have an API key. How to probably get an API key? Let's say that in my project, in my RAG application, I want to probably use Llama 370 billion instruct, right? And right now, since the inferencing is happening in the NVIDIA NIM itself, so if you go ahead and click this particular model, here you'll be able to see something like this, right? Here you'll be able to chat. So let's say if I say hi, and if I send a message, you'll be able to see that I'll be able to get a response. How are you? Okay, any question that you want over here? How are you? So here you can see this is the code, right? And when I'm writing how are you, so this is the code that is basically getting set with respect to the content. So you can use this particular code, and you can also call it, right? And I'll also be showing you. So once I probably send how are you, you'll be able to get the response over here. Now, when you go to this build.nvidia.com, first of all, you need to log in, right? So here you can see I have logged in over here. If you don't have an account, I would suggest please go ahead and create an account. And here you can see I have 954 credits left. Initially, you'll be getting 1,000 when you are probably creating a new account. Okay. Now, this is the thing. Here you can actually see, right? The entire code is also visible, right? So I will show you how you can run this particular code. And again, over here you can see that there's an API key that is required. In order to generate the API key, all you have to do is that click on get API key over here, right? So here you'll be able to see get API key in this green color, and just click on this. This key authenticates your NVIDIA AI Foundation endpoint for test and evaluation, and just go ahead and generate the key. Now I will be making sure that I copy this particular key because I'm going to use this particular key for my coding purpose. Okay. Now let's go ahead and first of all let's go ahead and open my VS Code, and I will show you how we can go ahead and create this entire project. That code that you'll be able to see over there, right? This code also will try to run it. Okay. So let's go ahead step by step. Let's go ahead and do this. So first of all, let me go ahead and create my environment. So here I'm going to use Conda. So Conda create -p VNV Python double equal to 3.10. I'll just use 3.10, and let's go ahead and create this environment. Okay. Now over here you definitely require multiple requirements, multiple packages in the requirement.txt. So we will also go ahead and update that. Okay. So first of all, let me just go ahead and yes, one more thing that I'm going to show you, the RAG application that we're going to create, we'll do it with the help of LangChain also. So LangChain also has an integration for that. So first of all, let me just quickly go ahead and write requirements.txt. Okay. So let me go ahead and create my file requirements. .txt. So first of all, what all packages I specifically require, I'll be using OpenAI because in this particular code that I see, right, there was OpenAI over here. So let me just first of all copy this. Okay, I will be requiring this key. So I copied it in my notebook. So this is my entire code over here. So let me just copy this entire code. Okay, copy the code and paste it over here. So let me just go ahead and create my app.py file and let me paste it over here. Okay, and we'll go step by step. We'll understand what exactly this is. Okay, so first of all, in the requirement.txt, I am going to use OpenAI. Along with this, you'll also be seeing that I will be using python.env. The reason why I'm importing this because in my env file, I'll be creating that API key, so I'll be requiring that. Okay, this is the next thing. And along with this, right now I'll just keep these two packages over here just to run that code. Now let me go ahead and write pip install -r requirement.txt. Before that, let me activate my venv environment. So conda activate venv. Okay, so this is the activate environment that I will specifically be using. Now what I'm actually going to do, just go ahead and write pip install -r requirement.txt. Okay, so the installation will specifically happen over here. All the installation will happen, and here you'll be able to see that once the installation is taken place, I will go ahead and run this particular code because here I just require OpenAI. Now let's understand this particular code and what all things are there in this code. So first of all, I'm importing from OpenAI, import OpenAI, and then we are creating a client with respect to OpenAI. The base URL over here will be this integrate.api.nvidia.com/v1, which is given from the code. This is my API key. Okay, please make sure that you don't have this publicly visible API key. Instead, what you can do, you can, as you know that I have already imported python.env, so you can directly create an environment variable and use this. Okay, so I will do that. First of all, I'll create an environment variable over here, and let me do that first step so that I can actually use it when I'm creating my end-to-end project. So this is my .env. This is my environment variable that I'm going to create, right? NVIDIA_API_key, and this is my API key. Okay, and I can call this API key wherever I want by using this python.env file. Okay. And that I'll show you once I probably create a RAG project. Now, once I probably create this particular client, then we have to use client.chatcompletion.create. Here we are giving the model name. Again, it has been given, the entire code is given over here. See, I did not write it any, like NVIDIA name is already providing this. And just imagine just using this and directly executing it. It's quite amazing. Then messages, role is good user, content, how are you? Okay, so I've written this particular message. Or let me just go ahead and write, provide me a paragraph, provide me an essay, okay, on machine learning, okay. Okay, provide me an article on machine learning, okay? Something like this, okay. So then we are setting up the temperature value. Top_p will be 1, max tokens 1024, and stream is equal to true. When we are keeping stream is equal to true, that basically means the entire completion we'll be able to see in the form of streams. And this is basically there in OpenAI, right? Then from chunking completion, we are executing this particular code. Now let me just go ahead and run this and let's see whether we'll be able to get the output or not. So here I'm going to just write python app.py, and here see machine learning, all the answers is coming over here. It is streaming, it is giving the entire output. This is perfect. You are able to get the output. So that basically means you're just able to execute it. And how quick it is. NVIDIA NIM, trust me, the inferencing is very, very fast, and that is what is going to basically bring up a breakthrough, an amazing revolution, right? In the entire process of generative AI development. And at the end of the day, the company really needs to think about inferencing. And if I talk about NVIDIA, it is the king of GPUs, right? So the inferencing needs to be obviously very, very good. Okay, so this was it. Now here, this simple thing we have actually done. Now let us go ahead and do some amazing end-to-end project. And this time I'm actually going to show you a project which is basically a kind of RAG project and how you can use along with LangChain. That also I'll probably show you. So first of all, I will go ahead and update my requirement.txt. So here I'm going to use LangChain NVIDIA_AI_endpoints. This will be the LangChain integration, which will actually help you to call all the NVIDIA models that it has in name. Then you will be also importing LangChain_community 5 CPU. Along with this, since I'm going to create a Streamlit app, I'm going to use this. And one more thing that I'm going to use is PyPDF. Okay, so all this requirements I'm actually going to use it. Now let me just open the terminal. Again, with respect to this, I'm going to go ahead and write pip install -r requirement.txt. Okay, so the installation will take place. It is going to take again some time with respect to this. Let me close this. Folders are visible over here. Okay, so once this is done, I will go ahead and start my development. Okay, so here let me go ahead and write final app.py. Okay, now final app.py, this is where I'm going to specifically write all my code, and we'll be seeing what all things we are going to use. Okay, now as you know, whenever we are creating a RAG application, we will be using some kind of things, right? Let's say PDF or something as such. So I have some of the PDFs over here. Okay, so this 4 PDFs I have over here. I will copy this. Okay, and let me open this particular folder. So we are going to read all the PDFs from here, from this US census. So all the PDFs is over here. We'll read this and we'll try to create a RAG application wherein we will be asking any questions related to this. Here we are also going to perform embedding. Okay, now when I say we are going to perform embedding, so we will be using NVIDIA embeddings. Okay, and that is what I'm going to show you also. So quickly, let's go ahead and import Streamlit. Okay, so first of all, I'm going to import Streamlit as ST. Then I'm going to import OS. Okay, then from LangChain NVIDIA, I'm going to import embeddings and chat NVIDIA. So this is a library that I'm going to import over here. So this NVIDIA embedding will be again used with the help of APIs and chat NVIDIA to call any models that are available in NVIDIA NIM. Okay, and this is the library that is used in integration with LangChain. Then you have this web-based loader. So since I need to probably read from my directory. So for that, I will be using from LangChain_community.document loaders. Since I'm also going to use output parser, create stop document chain, and recursive character explainer. So I am also going to use this. So these are some of the libraries that I'm actually going to use for my entire course project, right? Where we'll be using this. So here you can see the entire installation has also been done. Now let me quickly go ahead and write from .env import load_.env. So then we are going to initialize load_.env so that we'll be able to call all my environment variables. Now load the API or NVIDIA API key because we need to load it. So for that, I will go ahead and write os.environment. Okay, and this will be nothing but NVIDIA_API key, and this is what I've actually created in my env file, right? So here you go, and then just go ahead and write os.getEnv, and here we are going to use NVIDIA API key. Okay, so my environment variable is ready. Now the next step, what we are basically going to do is that we're going to call our LLM model. So let me just go ahead and write my LLM model, and this time I'm going to use chat NVIDIA, right? So chat NVIDIA, and as you all know, I'm going to use which model? So chat NVIDIA is there, I guess. So chat NVIDIA, okay, chat NVIDIA, and I'm going to use my model name, the same model name that I've actually called. That is nothing but Meta Llama 3 70 billion parameter. Okay, so this basically becomes my LLM model. Now once this LLM model is loaded, since I have to read from this particular folder all the PDFs, so let me just go ahead and create my one function which is called as vector embedding, because I have to create vectors for all this PDF file, right? Here I'm going to specifically use sessions, okay, so that I'll be able to access it here and there. So here let me go ahead and write for if vectors, I'll create a session which is called as vectors, not in st.session_state, okay, and this I will create another line. Now I will go ahead and write st.session_state. Okay, dot embedding. So first of all, I'm going to create my embeddings, and I'm going to initialize to NVIDIA embedding. Okay, so this is the embedding that we're going to use in order to convert the document into vectors or the text into vectors. Okay, so this is the first thing. So here you have HT also, everything looks fine. Then I'm going to probably also create st.session underscore state, okay, dot loader, okay, and this time I'm going to use my PyPDF. Let's see, PyPDF directory loader, and I will be giving my folder location, that is US census. Okay, so let me quickly copy this over here. So this is my another library that I have to use it. Okay, so let's see till here if everything is working fine or not. I will just go ahead and open my terminal and see if I'm getting any error. Okay, Streamlit run final app .py. Okay, so once this is running, I think it should be running. I don't think any problem should be there. Okay, so this looks fine. Yeah, it's giving me a blank page. Now it looks fine. Everything is fine. Let me quickly go ahead and close this. Okay, perfect. So US census, I'm actually keeping it up in this. So basically, this PyPDF directory loader is going to read this entire PDF files inside this US census. Then what I'm actually going to do is that after reading from this particular loader, right, variable, I'm going to basically write st.session underscore state dot docs. Okay, and here we're going to specifically use st underscore session underscore state loader.loader. So loader.loader will specifically give me all the documents over here, and along with this I'm going to probably do the character text splitting because I need to probably do the splitting itself after this. So once I get my documents, so then what we are going to basically do is that we're going to write st.session underscore state.text underscore splitter, recursive character text splitter, chunk size I'm going to take it as 700, chunk overlap I'm going to take it as 50, and here you'll be able to see final document is there with split documents st.docs, and I'm taking the top 30 docs. Okay, so we are splitting this particular document with respect to this. So guys, step by step you have seen this. First of all, we created our embedding, then we read the entire directory, all the PDFs, we had it in the loader. This loader.load will basically give you the entire documents, and then we are taking these particular documents and applying the recursive character text splitter where the entire documents will be divided into chunks. Okay, here the chunk size is basically taken as 700 with overlap of 50, and finally we get our final document by using the split documents, and I'm going to take the top 30 records. Okay, so once I probably get the final documents, at the end of the day I need to convert this into vectors. So I'm going to basically write st underscore session state, okay, dot vectors, and here I'm going to use fires again, dot vectors is equal to, yeah, we're going to use fires from documents st.session finals underscore document and st.session state embeddings. So here we have also created our embeddings, and the same embeddings will be used over here. And finally, this vector will be nothing but it will be our vector database, in short, the fires vector database. Okay, so this function, what it is going to do is that it is going to read all the PDFs from that folder. It will divide all the documents into chunks, and then finally it will convert into a vector and store it in a vector database. So that is what this entire function is basically going to do. Now it's time we go ahead and probably write st.title, and here I'm going to basically use NVIDIA NIM demo. Okay, once I probably use this, as you know that I'm going to probably create my chat prompt template. So let me go ahead and define it. Chat prompt template, I have already imported it over here. Okay, so this chat prompt template, as I said, it is a kind of a RAG application. So I'll say answer the question based on the provided context only. Please provide the most accurate response based on the question. So here is my context, here is my question. Okay, once I probably have this, now I'll go ahead and create my entire single text prompt, text input. I'll say enter the question from the documents. Whatever question you have from the documents, you're going to probably ask it over here. Now I will also create a button. So I'm going to write from st.button. Okay, if st.button. And here, let's say I'm saying document embedding. If this is clicked, right? If this is clicked, I will specifically call my vector embedding function. Okay. And once I have my vector embedding function, I will go ahead and update this. And I'll say, hey, my vector store DB is ready. Okay. And this time the vector store that we are using is FICE, right? FICE vector store DB is ready. And by using which embedding technique is ready? Using NVIDIA embeddings, right? So this embeddings we have specifically used over here, right? So what happens is that as soon as I probably click this button, it is going to call this entire vector embedding, and it is going to make sure that you have this vector store DB ready, okay? And then finally, I will go ahead and so once this is done, I will go ahead and write if prompt1, if the prompt1 is there, if I am probably searching for anything, and if I press enter, okay, then the next thing that I'm actually going to do is that create my document chain, and for this I'm going to use my create stuff document chain. Here I have to give my LLM comma prompt, right? So this we have already seen in our LangChain playlist itself, right? So here you have this, and then finally you will be able to see retriever is equal to st.session underscore state dot vectors as retriever. So this vectors DB, when we use with as retrievers, this basically becomes an interface to retrieve all the data from here, right? So this basically becomes my retriever, and since this vector is basically stored in the session state, we are going to basically use this session state itself. Then after taking this entire retriever, what we are basically going to do, we are going to create our retrieval chain, okay? And here we are going to use create retrieval chain, and here we are going to use my retriever comma document chain. Okay, so these two things I'm going to basically use it and close it over here since already my LLM is basically called. Now this create retrieval chain will basically create my retrieval underscore chain, which I'm going to use it over here. But at the end of the day, this model that is basically getting called, it is from NIM, right? So NVIDIA NIM inferencing, right? Inferencing. Perfect. So here it is, and after you get this retrieval chain, all I have to probably do is that I will start the time. Okay, so import time. Let's go ahead and import time over here, because I'm going to use the time functionality so that I will also able to measure and see how fast this is. Start time, then we are invoking based on the prompt that we have, and we finally get the response, and we are writing the entire response. Okay. Now, along with this, this Meta open source model like Llama 3 also provides us some context information. So below, by using again Streamlit, we will try to display the entire. Context also. So here I'm going to write from with xt.expander document similarity search, and here we are going to basically display the context. Now let's go ahead and run this, and I think it should probably work. And we're going to basically use the chat in media itself. Now let's quickly open the terminal. So guys, now let's go ahead and run this code and see that whether everything is working fine. So here I'm going to basically write Python final app.py. Oh, sorry, I have to basically run with Streamlit. So Streamlit run final app.py. Okay. Anyhow, I'll be giving you the entire code in the description of this particular video. Go ahead and check it out, and definitely go ahead and use NVIDIA NIM. Now, the first thing over here is that I'll go ahead and click on document embedding. So as soon as I probably click this, what it is going to do from that entire folder, it is going to take out all the documents, convert that into vectors, store it in the vector database. There we have used NVIDIA embeddings. So we will just wait till the vector DB is ready, and then we will go ahead and ask any question that we want, like a RAG application. So still it is taking time. There are many files, 4 to 5 files. So obviously there are a lot of documents, and again, it is basically happening completely with NVIDIA NIM inferencing. So let's wait for some time. So here you can see the vector store DB is ready. Let me quickly go over here and see whether I'll be able to see my vector DB. Okay. So now the next thing what I'm actually going to do over here is that go ahead and ask any question that I want, right? So now over here I'm going to basically say differences in, let's go ahead and ask this question. What is the differences in the uninsured rate by state in 2022? So here I'm going to put this question. What is the differences in the uninsured rate by state in 2022? So it obviously needs to pick up all this information and probably give you us an answer. So here, according to the context, the differences in the uninsured state are, so here you can see a low of 2.4% and 16.6% compared to the national 8.0%. And from the help of document similarity search, you can see what all context it has basically taken and it has given you the results. And this entire thing is basically happening with NVIDIA NIM, right? All the models that are probably there, from NVIDIA Embeddings to open source model, and here we have specifically using Llama 3 itself. So go ahead and check it out and definitely just go ahead and explore more models that you want based on different use cases like reasoning. You have something different visual design, you have something different retrieval speech. If you want to probably check it out, you can go ahead and check it out. And here you also have a lot of open source models, foundation models. So it is up to you. Go ahead and explore this. So I feel NVIDIA NIM has done an amazing work, and definitely this solves a lot of problems. So yes, this was it from my side. I will see you on the next video. Have a great day, and all the information regarding this will be given in the description of this particular video. So thank you. I'll see you on the next video. Hello guys, welcome to this crash course of creating multiple AI agents for real-world use cases using Creo AI. If you haven't heard about this platform, so Creo AI is an agent framework which will actually help you to create multiple AI agents for various amazing use cases. So in this video, I'll be talking about this entire platform. Along with that, I will also show you with an amazing use cases. I'll try to create a complete end-to-end use case and how I can use this Creo AI platform or framework to develop multiple AI agents and where it will basically be required. See, in LangChain also you have an option to create agents, right? But here, the main thing with respect to Creo AI is that here your agent will be able to communicate with each other, right, in an efficient way, so that we will be able to implement the task much more in an efficient way. Okay, so this is the entire web page of the Creo AI, and right now many people are using it. They are creating multiple agent crews. You can see over here in the last 7 days, all these things are there. You'll also be able to work with the open source tools that is already provided over here, and in this video I'll be also talking about that and showing you with the most practical use case. So let me just go ahead and let me just start. First of all, we'll understand what kind of use case I will be solving. Okay, so let's say I have a project over here, and everybody knows that I have a YouTube channel. Now in my YouTube channel there are more than 1900 plus videos. Now what I really want is that for every video I need to have a blog page. Let's say I want to probably create a blog platform. Right now I want to create a blog platform. Just let's imagine. So what I will do, I will take up every video of mine, probably based on the content. I will go ahead and write my entire blog page itself, right? Whatever content is required in that blog page. Now this task is a really tedious task, right? Now what I'm actually going to do is that I'm going to automate this entire thing with the help of Creo AI framework, where this blog platform will be automatically created for all my YouTube videos with respect to all the things that I have said in my YouTube videos. That is most important. Okay, so with the help of Creo AI, what we are really going to do is that first of all, let's say that if a user queries any kind of videos with respect to AI, let's say I'm querying about Creo AI over here. So what it should happen is that it should go to my YouTube channel, pick that particular video, extract that entire content, and based on that particular content, summarize that information, put it into the blog page, right? Now, obviously, I know that I've created more than 1900 plus videos. Now, if I really want to probably work with multiple people over here, so I need to have a content writer, I need to have a researcher, right, who will probably go and explore every video in my YouTube channel based on the query it is writing, and then it will go and validate that content. And after probably validating the content, I need to have a content writer separately who will specifically write this particular blog page also, right? Now here, just understand for just one video it is fine, but if I have 1900 plus videos, it is going to take a lot of time because validating is also there. I need to probably go and check the content proofing, do multiple things over there, right? So with the Creo AI, we can automate this thing completely in a whisker of time, and that is where we'll understand how this AI agent. Okay, and here also you can see, right, if I'm involving multiple people, they also need to communicate with each other. Then again, there may be some kind of communication gap, how they are specifically going to work. So with respect to that, you're going to take a lot of time over here, right? Now with the help of Creo AI, so Creo AI, if I talk about, there are three main important components. One is the agents, one is the task, and one is the tools. Okay. Now here, if I probably consider this specific use cases, as I'm saying, first of all, we need to explore my YouTube channel, right? So I need to have a researcher over here who will probably go and query any query in my YouTube video, and he will probably bring that particular YouTube video. Okay. After seeing that particular YouTube video, he needs to listen. He needs to probably hear out what you have about that entire YouTube video itself. So here also we require an expertise, right? Expertise who's good at data science, who's good at data analysis, because my entire channel is based on data science itself, right? AI. So here, obviously, I need an expert person who will probably go ahead and watch each and every video and retrieve the content out of it, right? Then after that, I need to pass it to my content writer, right? So content writer. So here I have a domain expertise person, right? It can be a data scientist, it can be an analyst, right? So these two roles here you can basically consider in Creo AI. These are nothing but these are agents. Okay. So we are specifically going to consider this as agents. So agents are none other than the people who are having some kind of experience with respect to the work, right? It can be a domain expertise like in data science domain, it can be data scientist, data analyst, it can be a content writer, right? So it can be anyone, right? So this basically becomes an agent. So in the Creo AI, the first component is specifically agents. The second component that we specifically use in Creo AI is task, right? Now each and every agent does some kind of task. Let's say the domain expert people will probably go ahead and watch this particular YouTube video. They'll try to take out the entire information that I've told in the YouTube video itself, right? So that basically becomes a task for this particular agent, right? Similarly, content writer is an agent. Its task is to write the content, right? So that can basically be a task. So this is the most important second component, like what task an agent is specifically doing. That also we need to define. And the third thing over here is about tools. Okay, let's say the domain expertise is over here. I do not have a domain expertise. Let's consider. So if that domain expertise wants some kind of help, right? Let's say once it is searching from the YouTube video itself, right? Any of my video it is probably searching. Let's say that it wants to get the transcript of the video. So what may happen is that this person may use some kind of tool to do that. It can be a third-party tool, it can be an API, it can be anything as such. In this particular case, let's say I want to get the transcript of my YouTube video, then I may use a transcriber, right? And that transcriber can be a third-party tool itself, right? And that is where a tool comes into existence. Like with what will be the main way of probably, let's say that if I have some kind of dependency on some third-party tools itself to explore this particular task, right? How can I perform this particular task with the help of this particular tool? So I may also have a separate YT tool which will be able to provide me the transcription of the entire video, right? So that is where we can specifically use the tool. Other tool can be, okay, I want to probably do a Google search API, right? Google search. So this can be another tool, right? So similarly, multiple tools will basically be there which we can actually use. So agent will have some specific task, and this task can be performed by a specific tool. Okay, so this is how it actually works. Now similarly, here you can also see I've created two agents. One is researcher, one is content writer, because that is what I actually require. Researcher will explore the YT videos. From this particular YT videos, it may use some kind of YT tools to transcribe the entire content, right? Analyze the entire content. Once that thing is done, then that particular researcher will pass it to the content writer because it now has the entire information. This entire info will be basically there after performing this particular task. Then once it provides it to the content writer, what will happen based on the research, it will write the blog page, right? And finally, this will basically be my output, right? So here you can also see that interaction is there between the researcher and the content writer, right? And this process, now see, this is one way. So this process is entirely called a sequential process. There are also other processes which is called as hierarchical processes. So here in the sequential process, once the researcher completes his work, it is going to give that entire output to the content writer, and the content writer further, based on the task it is assigned, it will probably go ahead and create the blog page. So I hope you got an idea about what are the main important components of Clio AI. One is the agent, one is the task, and one is the tools. And based on this, we can automate this entire use cases. Now let's go ahead and implement it practically. As I said, in the agents, I'm going to probably create two agents. One is researcher, one is the content writer. Then I'm going to go ahead and define the task for this specific agent, like explore videos. It can be explore YT videos. It can be exploring another thing. It can be probably exploring Google Search API. Anything it can be. Now to complete this particular task, we have dependency on some tool which is called as YT tools, because at the end of the day, I require the transcription or of my entire YouTube video. So for that, I may require a tool, and this can also be a custom tool which you can also create by yourself, right? So once we get this particular tool, we will be able to do this particular task, and after that, we will be able to complete the researcher work. Once this researcher work is completed, we will pass this entire work to the content writer, because the content writer needs to write the entire blog page based on the research, right? So this entire process is also called a sequential process, because once this is getting completed, the next step is to get to complete this. There are also other processes like hierarchical process, where parallelly also you can actually do this particular task. Okay, now let's go ahead and implement this entire project completely from scratch. So guys, I have opened my new project over here in my VS Code. I will go to the terminal. The first step is probably to create our Conda environment. Okay, and this you really need to do it for every project. So I will go ahead and write Conda create -p vnb Python double equal to 3.10. So, okay, I will be taking 3.10. That's 3.10. After doing this, let's say installation probably happen. Once the installation actually happens, when a new environment is basically created, what we are going to basically do is that we are going to create our requirement.txt file. So let me just go ahead and write my requirement.txt file. Okay. Now inside this requirement.txt file, I will be using some of libraries that I really need to install. One is the Clio AI. Then one I'm going to write Python. Okay. Right now I don't require this, so let me just go ahead and write Clio AI underscore tools. Right. So these are the two important libraries I will be requiring. So let me save it. Now this environment is basically getting created, or it has got created. So I will go ahead and activate VNV. Okay. So conda activate VNV. Now let me quickly go ahead and let me do one thing, guys. Let me hide my face so that you'll be able to clearly see this. Okay. Now let me just quickly go ahead and pip install -r requirement.txt, and this both requirements will get installed. Okay. So once this installation is basically happening, we will continue our task. Now, first of all, as you know, we need to create our agents. So agents.py, I will go ahead and create it. The next will basically be tools.py. Okay. Agent tools, and I also require task. Okay. Task.py. So these three components we really need to create. So first of all, I will go ahead and create my agents. Now for creating the agents, first of all, I will go ahead and import from Clio AI import agent. Okay. Now since you know that we really need to create some kind of agent over here, right? And for creating an agent, so first of all, what all things I will create? So I will probably create a senior blog content researcher. Okay. So this will basically be my first researcher, which I will probably create, which will be an agent who will be doing my task. Okay. So these are like people who will be handling all my tasks. Okay. Now let me quickly go ahead and create my researcher. So this researcher will be my blog researcher. Okay. And this blog researcher will be of type agent. Okay. Now with respect to agent, there are some important parameters that we really need to use. Okay. First parameter we really need to give is role. What kind of role it is basically doing, or what kind of role it needs to do it. Okay. So here I'm going to basically say that, okay, these are nothing but they have to probably be a blog creator, a blog researcher from YouTube videos. Okay. YouTube videos. So these are some default information that we really need to give. One is the role. The other one is goal. Okay. So here we also need to specify the goal over here. Here we can basically write get the relevant video, content for the topic, whatever topic I say. Okay. From YT channel. Okay, so this will basically be my role for this particular agent. You need to get the relevant video content for the topic this from my this one. Okay, name I can basically write over here. Description also I can write. So let me just go ahead and write the name, but let it be. I don't require this too, but it is getting suggested by the Amazon Whisper that I've specifically used over here. But it's okay. I don't want this. Then I will go ahead and set up my verbose. So verbose will be true, which will be able to see some information out there. Here we also going to set one parameter which is called as memory true, so which will be initialized with some memory. And we will also go ahead and write some backstory about this particular agent. Okay, so let's go ahead and define some backstory. So I will keep a backstory something like this. This person or this agent is an expert. Okay. See this. Okay, so I'll just go ahead and write. This person is expert in understanding videos in AI, data science, machine learning, and Gen AI, and providing suggestions. Okay, so this will basically be my backstory. And then the third thing that I actually require is my tool. Whether I'm going to use some tools or not. So here I'm going to basically define my tool. And right now I'll keep the tool empty because I've not created any tool. Okay. And then for further, I will also say allow delegation. Delegation basically means will I be transferring after whatever work that I do or this agent does to someone else. So we will set this allow delegation to true. Okay. So this is all the default parameters that we really need to write for an agent. Okay. And based on this, you can create anything as such. This topic will be the topic that I will probably be giving for whichever topic I really want to create my blog from my YouTube videos. Okay. Now the third, right? Let's go ahead and define this. The second agent that we will be creating. So here I'm going to write a writer agent, blog writer agent, creating a senior blog writer agent. Okay. With YT tool. Okay. So right now I'm also going to create my YT tool, which I will also show you how to probably create. So this basically becomes my writer, or I can also say it as blog underscore writer. And this blog writer will be again an agent type. And here I'm just going to copy and paste some information with respect to roles, tools, and all. Okay. So now let me copy it over here and here. You can probably see that I've written some of the information. Like role is nothing but blog writer. I can basically write it as something like this, blog writer. Goal is narrate the compelling text stories about the video. I'm basically going to write with respect to any topic over here from YT channel. Okay. Verbose will be true, memory will be true, backstory. We are specifying some amazing backstory with the fear of simplifying the complex topic of your craft, engaging narratives that captivate and educate, bringing new discoveries to light and accessible manner. Then tool I have not yet created, and allow delegate because see at the end of the blog writer needs to just write the blog. So further we do not have to delegate his work to someone else. So we are keeping this as false. Okay. So this is what is my agent. So two agents I have actually created. One is my blog researcher and one is my blog writer. Now let's go ahead with the next step over here and let's go ahead and define my task. So task or tools. First of all, we'll go ahead and define my tools. So for tools, again, if I go to my documentation page in Creo AI, so get started. Let's get started. So here, if you go down, there are multiple tools which it supports, right? So here you can see Google Search, Surface Search, browser-based web loader. So many different tools are there. My the tool that I have actually used is nothing but YouTube channel search tool. Okay, so this will basically be searching my YouTube channel. Okay, so first of all, it says pip install Creo AI tools. I've already done that installation. If you remember, Creo AI _tools. Okay, and this is how we explore any tool name. Okay, sorry, this YouTube search tool. So first of all, we'll go ahead and import from Creo AI import YouTube search tool. So let me just go ahead and import this. Okay, and after that, we will go ahead and initialize our YouTube channel, which YouTube channel we really want to explore. And I want my YouTube channel to explore, so I will just go ahead and write my YouTube channel name, Krishna906. Okay, so this is my tool. So this tool is responsible whenever I get any query, it should be searching from this particular YouTube channel, and this tool we will be using. Now, since this tool is what we are going to use, so we need to update in our agents. So here I'm going to write from tools import. Okay, instead of writing tool here, I will go ahead and write my YT_tool. Okay, so this variable I will go ahead and initialize in my agents.py. Okay, and the same YT tool I will be using inside my tools. Now this is completed. Amazing, right? So my agents and tools are actually completed. If you want any other tool like Search API, Google Search API, you can just follow this particular page, right? So and don't worry, as I go ahead, I'll be creating more amazing videos. So let's say that I want to go ahead and do PDF RAG search, so you can probably use this particular tool for doing that same process, right? To ask any question from that. But this is the most efficient way of creating any agents in an easy way. Now the third thing that we really need to fill is our task. Okay. Now since you know that we have created two agents, right? One is the blog researcher and one is the blog writer. So similarly, two tasks needs to be created over here. So I'm going to write from Creo AI import task. Okay. From tools. Here also we are going to use tools, import tool. Okay, so these are the two things. And then I also need to probably call from agents, import blog researcher, comma, blog writer. So both the agents also I need to probably call. Okay, done. So let me just see the name, agents, blog researcher and blog writer. So both the agents have actually called over here. Now, the first task will be nothing but the research task. Okay. Now, in order to probably use this, I have to again use this task, and it is also very simple. So here I will probably go ahead and write and create my research task. So here you can see here some basic information is required inside this task class. One is the description, like identify the video. Okay. Get detailed information about the video from the channel. So these are the two information that I have given. Expected output is nothing but a comprehensive 3-paragraph long report based on the topic of the video content. And here I'm going to use this particular tool over here. But since this tool name is not there, I will go ahead and use YT tool. So let me copy paste it over here and let me copy paste it over here. So YT_tool will be there. So here you can see that I have updated this researcher task, what tool I'm basically going to use. So YT tool I'm going to use, and my agent will basically be my blog researcher. Okay, so these are the updated information that I have with respect to this entire research task. Similarly, I will go ahead and create my writing task, and again we will be using the writing class. So here you can see writing task description, get the info from the YouTube channel on the topic, this summarize the info about your video on this particular topic. Tools, I'm again going to use YT tool. Here also we are going to specifically use YT tool. Along with that, my agent will be nothing but my blog writer, which will be doing the task. Async execution. Okay, there is one parameter which is called as async execution. Async execution, if I set it to true, then both this agent will be parallelly working. Okay, right now I don't want that to happen because we are going to focus on sequential process. And finally, you also have an output file. So all the content, all the info that we are basically getting generated, we will put us in the new blog post.md. Okay, so here you can see the entire thing. Get the info from the YouTube channel, summarize the info from this. All the information is basically there. Summarize the info from YouTube channel video on the topic and create the content for the blog. I'll go and add it. Create the content for the blog. So basically, whatever thing I explain in my YouTube video, in that way only this blog will get generated. Okay. So both these things are done. Perfect. Here you can probably see I've also created my task and how easy it was, right? So finally, to run all these things, we'll also create one more file which is called as Creo.py, and that is where our execution will probably start. So here I'm going to write Creo.py. Okay. And this is where my execution is going to start. So for this, again, I will go ahead and import some important things like from Creo AI, import Creo, comma process. Since we are going to use sequential process, that is the reason we are using this. Then from agents, import the same thing. Let's see what all the things we imported. And from tools, we have to import all these things. Okay, so from agents, I don't require tool. From agents, I'm going to import this from tools or from task. From task, I'm going to import what all things we have to import from task. Let's see. Two things: research task, research task, and the other task is nothing but write task. Okay, so these two are imported. Now, in order to call this in a sequential manner, we will be using this Creo class. We will give our agents researcher and writer. So here we will go ahead and write blog researcher, blog writer. Okay. Then research task, write task is already there. So that is all my task name that I've actually defined. This is the most important parameter. Process is equal to sequential. So this basically says sequential task execution is default. Okay. I will also be showing you other processes as we go ahead. Okay. In the other video. Memory is equal to true, cache is equal to true, max RPM is equal to 100, and share underscore Creo is equal to true. So these are some of the default parameters that is got selected. Now let's start the task execution. So here I'm going to start the task execution process with enhanced feedback. Okay. So this will basically be my result is equal to Creo dot kickoff, and here I'm going to give my inputs. Inputs will be nothing but topic. Let's say one of the topic that I want to search, which is my most famous video, is nothing but between AI versus ML versus have the maximum view in this versus data science. Okay. Finally, I will go ahead and print the result. Okay. So this is how we kick off this entire thing. Now, as we kick off this Creo, it is going to call this. Here we are going to basically call this agent's task process sequential. So automatically we go to that particular references from that particular pages, and it is going to do the sequential execution. Now let me open my terminal. I hope now my terminal is ready. Now let me go ahead and run Python Creo.py. Now, once I execute this, it will start the execution. It will start exploring. It will first of all query, use this tool. Okay, one error is that OpenAPI key So guys, one error that we are specifically getting, it is asking for a key error OpenAI underscore API underscore key. Now let me make you understand what exactly is this error. So if I probably go to the documentation page over here, one thing is that whenever we want to implement any application with the help of multi-AI agents, we specifically require an LLM model, right? Integrated with our Creo AI application. Because see, over here, if I go with respect to agents, here we are telling it to do many tasks as such, right? Obviously, tools we are specifically using, but once we get the relevant information, we need to summarize it, we need to probably display it, we need to, based on a simple prompt, we need to make sure that the content is generated in that particular way. So by default, if I probably consider connecting to LLMs, Creo AI offers flexibility in connecting to various LLMs, including local model via Ollama and different APIs like Azure. It is compatible with all LangChain LLM components. So here you will be seeing multiple examples how you can probably connect the agent with the LLM models, because at the end of the day, all the LLM models needs to work along with the agent, because most of the research work is specifically done with the agent, right? Like a writer needs to probably write the entire blog, so obviously an LLM is required to summarize the entire blog. So here you can see that in one of the parameter in agent there is also something called as LLM. Indicates the large language model of the agent uses. By default, it uses GPT-4 model defined in the environment using this particular modeling. Now, what I'll do in this particular video, I'll show you with the help of OpenAI API key. Later on, as we go ahead, we will also be discussing with respect to various open source models like Ollama. Then you have Hugging Face and all, right? Now let's go ahead and do it with OpenAI. So for OpenAI, what I'm actually going to do, again, if you want to probably do it with any open source, right? You can again play with this over here in the Ollama integration. It just told you like what all keys you need to set, right? And based on that, it can actually work, and how all the step by step it is given over here. But let me just show you with the help of OpenAI over here. So I'll go to my agents. Okay, I'm specifically using LLM is equal to LLM. This parameter I try to set it up additionally. Now let me do one thing. Let me go ahead and create my LLM. Before that, I've already created my environment variable.env over here to explore the to basically explore all the to get the OpenAI API key itself. So what all parameters we specifically require? Here you can see I will just go ahead and write import OS. Okay, import OS. Now in this import OS, what I'm doing, I'm importing OpenAI API key, right? And this API key is basically coming from my env environment variable, which is having my OpenAI API key. And the second one is OpenAI underscore modeling, like which model I really want to use. Okay. Now one more thing, in order to import all these things, we have installed load underscore .env. So I'm also going to call this. So let me go back again to my agents. Okay, and I'm going to write from load underscore .env import load underscore .env. Okay, so here you can see load underscore .env, and I'm going to basically import things, right? So this looks absolutely fine. Here, sorry, it should be .env, not load underscore .env. Now we are basically we are calling all the variables from the environment variable. We are setting up OpenAI API and OpenAI underscore modeling. Now let me just go ahead and execute it, because this is the thing that is required, and after that we will be setting with our LLM in our agent, right? So LLM is equal to LLM. Here also we can go ahead and set it in the agent LLM underscore LLM. So now I think it should start doing our process and it should start working. So let me quickly go ahead and write Python Creo.py, and now you'll be seeing that it will start this entire process. Now again, let me repeat it. In our Creo, first of all, it will go and do the blog research from my YouTube video. Then it will give that information to the blog writer. This blog researcher is going to do the research task. This blog writer is going to do the right task, right? So here you can see now the processing of the videos has started. This will probably take a 1 minute time, and because it is around 4 to 5 minutes, 6 minutes video, it'll probably, I have asked for what is AI versus ML versus data science, and this will probably go to my video in my YouTube channel, explore the transcription, get all the relevant information, and then finally at the end of the day, you'll be able to see over here we will be getting one new file, new blog underscore post.md. So let's wait till then. I'll just pause the video. I think it'll take a 1 minute time, and then once it is executed, I will show you. So guys, finally you can see that the entire program has got executed, and this is the entire content of the amazing blog that is created for the video query that I had asked, right? So if you also go here and see, so this is your new blogging post, and this is the entire blog, right? Whatever things I've explained in the video, everything has basically put up in a good sentence in form of blog. Now I can directly use this, and I can even automate this if I'm probably creating a big amazing end-to-end project. This will also get automated automatically, that entire blog will also get created. So here is each and everything under the umbrella ML, DR, and data science. The words has been correct over here, and this is how it has worked, right? And if you probably see how much processing it probably took, it was hardly 1 minute of embedding. It has done embedding, many things it has done. Probably first of all, see, when we hit the query, it goes and search in the YouTube channel. Once it gets the video, then it removes, it takes out all the transcript. Then finally you'll be able to see that it has been able to create this entire content, right? So this in short is an amazing way of creating this, creating of agent task and tools. And here you can also see sequential processing is basically happening. Researchers doing one work, two agents are also communicating. Hello guys, so in this video we are going to discuss about something called as hybrid search, okay? And this kind of search specifically we use in our RAG applications also, right? So till now, if you are following all the modules, the RAG that we have specifically created, let's say that if I have documents, let's say if this is my documents, then what we do is that we try to divide these documents into chunk of documents. Let's say this is D1, this is D2, this is D3, like this. We usually divide into multiple chunk of documents, right? And this is D. Now after dividing all these documents into chunk of documents, then we specifically convert this into vectors, right? So here we are basically converting into embedding vectors. Then after we convert all this text to vectors, the next step is that we store all these vectors in some kind of vector database, right? So let's say one of the vector databases that we have already seen, vector database. We also say it as something called as vector store DB, right? Now, once this entire information is basically stored over here, right, it will be stored in the form of vectors, right? We will be having some kind of numbers over here itself, right? Now, when a user queries, whenever a user queries, right, over here, then what happens usually in this particular scenario, this particular query is also converted into vectors. And then a vector dense search or vector search is basically done. Vector search is basically done in this particular vector database. So once we have this particular vectors, we do a vector search from this particular vector database. And here, some of the algorithms, like over here, one of the algorithms that may take place over here for basically to match the exact vector search, we can actually use cosine similarity, right? And based on this cosine similarity check, we will be able to get the response, right? And once we get this response, we can combine this with our prompt template plus LLM model. And finally, we can summarize any information as my final output, right? So in this scenario, you'll be able to see that the kind of search that we are doing, right, the vector dense search, this search is basically called as semantic search. Semantic search. Semantic search basically means we are trying to find out the similar vectors from this particular vector database, and based on that, when that similarity search is done, we are able to get the response. And this kind of RAG, most of the RAG application uses this kind of search. And if I talk about vector databases like FIRES, Chroma, right? they have this entire features like this, right? But I really want to talk about one more amazing search mechanism, which is called as hybrid search. Okay, so here I have this hybrid search. Now inside this hybrid search, here we are just not focusing on only vector dense search mechanism, right? Here we specifically combine multiple search techniques, right? And what kind of techniques we will specifically apply over here? We'll be combining multiple search techniques. Now, specifically, if I really want to divide all this particular technique, one is the semantic search. The second one is something called as syntactic search. Okay. Now, I will talk more about it. What exactly are this kind of search, basically? So one is semantic search, one is syntactic search. Semantic search, specifically, we say it as a dense vector search. So here we are specifically trying to search elements that are similar, right? And obviously, when we're using this dense vector search, we basically are checking out the similar kind of content, right? If I probably say with respect to syntactic search, right? Or I can also say this as exact search. I can also say this as keyword search, right? Keyword search. And if I also want to probably provide some more names, like exact search and keyword search, and this usually happens with respect to a sparse, or I can also say this as sparse vector search. So here you could see in semantic search, I have a vector store, right, which has all the vectors embedded over here, right? So here all my text is basically converted into dense vectors, and this dense vector is basically stored in my vector store DB, right? In the case of syntactic search, you'll be able to see that we will be having sparse metrics. So all this text will basically be converted into sparse metrics. Now, if you remember, or if you know, right, what is sparse metrics and how do we get a sparse metrics? If you know about these techniques like one-hot encoding, bag of words, or TF-IDF, right? Whenever we try to use these techniques, we will be able to convert our text into sparse metrics. Now, when we say sparse metrics, that basically means there will be maximum numbers of zeros and ones, right? Wherever a specific word will be available in a sentence, that will be one and remaining all will be zeros, right? So this is basically called as a sparse metrics. And with the help of the sparse metrics, here we are just focusing on a specific keyword, like this keyword, right? Whatever keyword we are actually trying to search. And this sparse metrics also has some very important properties, because from this, we will be able to probably do the keyword search itself. And this is nothing but it can also be considered as an exact search. So in the case of hybrid search, it is just going to combine both this particular techniques, that is semantic search and syntactic search, or I can also say this as exact search or keyword search, right? It is just not going to be dependent on one of the search mechanism. And similarly, there are different kind of databases that are available. Just to show you as an example, like there's a database like Cassandra, right? We will be using a library called as Casio, right? And with the help of this Casio, you'll be able to see that we'll be able to access the Cassandra database. I will show this as we go ahead, okay? But right now, just try to understand over here what exactly hybrid search is doing, right? It is combining multiple search methodologies. And if I probably talk about in most of the e-commerce website and all, hybrid search is definitely implemented in the backend, okay? Now let's go ahead and see that how does a hybrid search work, okay? So here, we will go ahead and write how does hybrid search work. So let's say, in the case of hybrid search, what happens? Let's say if I have a specific documents. For all these documents, when we are storing this, in our vector database, let's say this is my vector database, okay? And this vector database supports both, right? What does it basically support? It supports vector search, dense vector search. Along with this, it also supports keyword search. It has both this particular property, right? Now, whenever I have this particular document inside this particular database or inside this particular vector store DB, these documents will also be converted into a sparse matrix, right? By using techniques like TF-IDF or bag of words. So this kind of embeddings, it will be converted and it will be stored inside this particular vector database. Along with that, for the same documents, we will also try to convert this into vectors, which will be my dense vectors. Dense vectors does not have maximum number of zeros or ones. Okay, that is the difference. And we will try to store this particular vectors inside this particular vector store DB. And again, here you can use different techniques. The techniques can be anything as you want, like we have seen, right? We have used different embedding techniques. We have used OpenAI embedding techniques. We have used Ollama embedding techniques, or if you want, Hugging Face embedding techniques. So by all these embedding techniques, we can convert our text into dense vectors and we can store this in this particular vector database. Now, the idea is very simple. Since we are storing this in both this particular format, sparse metrics and dense vector metrics, whenever a user puts up any kind of queries, now with respect to this particular query, I will be able to retrieve two different kind of result. Okay, one result will be something related to my exact match or exact search or keyword search. And with respect to this keyword search, let's say whatever results I'm getting, it will be my top K results, right? This will be based on this particular keyword search or exact search. So here, keyword search, I've written it downwards, right? So here you'll be able to see that whenever a user probably queries any information over here from this particular vector database, first of all, for the user query, again, their query will also be divided into two types. It will be converted into two types. One is the sparse vectors, and the other one is something like dense vectors, right? So both these vectors will be converted. Then based on the sparse vectors, here we are specifically going to get the keyword search, and here we are going to get the results, right? Let's say the top K results I'll be getting over here. Based on these dense vectors, I'm actually going to do the vector search, and again I'll be getting another results over here, right? Let's say this is my result one, top K result one, and this is my top K result two. Okay. Now top K result one and top K result two are specifically there. This is basically done on the vector search, which is nothing but it is a semantic search. This is basically a semantic search, similar kind of elements. And this is nothing but this is a keyword search, right? Based on the sparse vectors that we have actually taken. Now in hybrid search, what we do is that we combine both of them based on weightage. Okay. And then we finally get the final response. Now the question rises, how we're going to probably combine this particular result one and result two to weightage based on this information that we have got. And finally, when we get the response, we can then further combine this with our LLM model and summarize this entire data. Okay, that is something different. But still the question rises, how do we combine result one and result two, and how based on weightage we take our final result, right? Final result. And that is what we will be seeing in our next video. The technique is very simple. The technique name is something called as reciprocal rank fusion in hybrid search. Okay, in hybrid search. So this technique we will be discussing in our next video. which will be the core behind this particular hybrid search. But the idea is very simple. In hybrid search, we take a combination of two different things. We try to do the search based on semantic synthetic, which will be the combination of dense vector search and exact search or keyword search. Okay, so both this particular technique we basically use. So yes, so this was it. In the next video, we are going to discuss about the reciprocal rank fusion and hybrid search and how we can basically combine both these particular results based on some kind of weightage, right? When I say top k result 1, top k result 2, that I may get 5 results, right? Based on the keyword search, I may get 5 results based on the vector search, something like that, right? So yes, this was it. I'll see you in the next video. Thank you. So guys, now let's go ahead and proceed with the discussion with respect to reciprocal rank fusion and hybrid search. As I said,